Hi everyone, welcome to PrepFusion. So today we are going to start our digital communication system. Okay, so in digital communication system, first we are going to study about basic building blocks. So mostly we will be focusing on encoder and line coder. You will get to know what all building blocks are there. Transmitter channel would be there, receiver would be there. All those blocks on top level we are going to see, and then we are going to study about quantizer and then threshold detector. So everything, whatever that is necessary for your examination, that we are going to see. So this is just the first marathon. The second marathon will be depending on your response. So what I would be expecting, I would be expecting this much, that you would be giving 200 likes and 5k views in the next 7 days. This is what I would be expecting. If we achieve that, we can think of bringing another marathon as well. We have already brought random variable and random process. So if you want to watch this particular marathon, then first you need to watch random variable and random process. Then only you will be able to understand digital communication system. Without random variable and random process, there is nothing that you are going to understand in digital communication system. So the part of digital communication system will be very less, but the part of random variable and random process will be very high. So first watch these three marathons and then only you come here. So these are of 18 hours, and here you would see this is 11 hours. So this is the content of 29 hours, and this will be a 12 hour of marathon. So total 41 hours. So in this total 41 hour, you would see at least 5 marks of question would be coming, and these 5 marks will be deciding, because not everyone would be attempting these 5 marks, because people find random variable, random process and this topics, which is quantizer and threshold detector, they find it very difficult, and surely 5 marks of question would be coming and they will be deciding 5 marks. So if you want to achieve those 5 marks, you need to study in a good manner. So study this marathon for 12 hours, take your time, take breaks in between, complete it in 4 to 5 days, and then we can think of bringing another marathon as well. That will be based on digital communication system only. Okay then. So let's get started, and I would expect that you would be giving me this much from your side. Yeah, thank you. Hi everyone, welcome to PrepFusion. So today we are going to start digital communication system, one of the easiest chapter of your whole EC engineering. Okay. Needlessly, people find it difficult, but we will understand in a very easy manner. And we have already studied random variable and random process. So when we were studying random variable and random process, at that time it felt like complete mathematics, because there was no communication engineering involved, right? We were not studying communication there. Only it felt like, sir, we are kind of studying mathematics only, although at much higher level, but there was no concept of communication engineering involved, right? But now we are going to study digital communication system. So in this digital communication system, you would realize that there will be a very high usage of random variable and random process. So whatever the mathematical part that you are going to see, that will be based on whatever that we have already studied, random variable and random process. So if you don't study random variable, random process, then there is no meaning of digital communication system. You should drop this chapter here only. So first study random variable, random process, then only you come here. Okay. So let's get started. Let's understand a basic building block of any communication system, not just digital communication system, any communication system. So in any communication system, let's just say we two guys are talking. Okay, you and me are talking. So what I am doing, I am transmitting some message. I am transmitting some message to you, and you are receiving that message, right? So you are working as a receiver, I am working as a transmitter, but there is a lot of process involved. Like I am just saying it, my voice signal is not directly coming to you. There are a lot of process involved. It will be going through the mic, then it will be going into the PC. PC will process it, then I will upload this video on YouTube, then you will connect to the YouTube server, and then you will be playing this video on YouTube, and it will be coming to you. So a lot of process is involved in between. It's not that directly my voice is coming. So that's why this block diagram is there. What will happen is that the transmitter will receive some message information. It will receive some message information. Now inside the transmitter there will be some blocks: sampler, quantizer, encoder, line coder. What all are these blocks? We will understand about them. Okay, we will study about all those blocks. Now what this transmitter will do, this transmitter will convert this empty signal into some ST signal. Okay, sir, what is this ST signal? Everything will be clear. Now this ST signal will be traveling through a channel. This channel could be a wire or it could be air as well. Okay, it could be wireless or wired. So this channel could be wireless or wired. Basically communication can be done without the wire as well, it could be done with the wire as well. Like you are able to listen my voice. Is there any wire connected between you and me? Like is there any wire that is coming from my home to your home? No. Our voice is traveling through the air. Although there is wired communication as well, there is wired communication involved as well, and there is wireless communication involved as well. But on top level, if you see, it felt like that it is wirelessly coming to your home, right? I will take this example and you will understand that in this process that I am saying and you are listening, in this process wired communication is also there and wireless communication is also there. So based on the channel we say whether our communication is wireless or wired. Now in this channel there will be some noise, right? Every system that you design, it will be affected by some noise. So there will be some noise involved in this channel. So this channel will have some noise and that noise I am showing by NT. This is the random process of the noise. Okay, NT is the random process of the noise and ST is the deterministic signal. Although we will talk about everything. So now ST will be added with the noise. ST will be added with the noise and now it will be fed to the receiver. So now the receiver will process it and it will give you some final output YT. Now this YT output should be looking nearly like MT only. If this YT output signal is nearly looking like MT only, that means whatever that I sent, the same thing has been received. Let's just say there is some glitch in my voice. Let's just say there is some, your internet is not working perfectly. Then whatever that I am saying, that is not reaching to you perfectly. If whatever that I says, that reaches to you perfectly, that means this will be a reliable transmission. Okay. So message signal came, it passed through the transmitter. What is inside the transmitter? We don't know. We will understand that. Now this MT was converted into ST. ST was going through a channel. Then the receiver, what receiver received? ST plus NT. NT is the noise that was available in the channel. And now the receiver processed it. Whatever the effect of noise was there, the receiver will try to reduce the effect of noise. Whatever the noise that is available here, the receiver will try to reduce the effect of the noise and eventually it will try to have only ST. And then the next task it will do is that it will convert this ST into MT. Again let me repeat, transmitter converted this MT into ST, then ST was added with noise, receiver received ST plus NT, receiver will try to reduce this NT and it will try to convert this ST into MT. That would be the process this complete communication system will follow. And there could be two kind of channel, wireless or wired channel. Okay. So let me take an example. I am saying something. Now this voice audio signal, it is an analog signal. Okay. Whatever the voice that I am delivering, that is an analog signal. Now this analog signal is going into this mic. Now in this mic there will be some blocks. So this mic is not working like a receiver. This mic is working like a transmitter only. The job of this mic is to transmit my voice into the laptop. Are you able to understand this point? So this mic is not a receiver here. I am the message signal. I am giving, my mouth is giving the message signal. Now that is going into this mic. So mic is working as a transmitter here. It will transmit my voice to the laptop through a wire. Now whatever the audio signal that I am having, MT, let's just say I am talking hello. So my computer cannot understand hello. Computer can only understand 0 and 1. Computer works on binary. So the job of this computer is that it can understand only 0 and 1. Okay. And whatever this channel is there, let's just say this wire, this is the wire of the mic. So this wire cannot understand 0 and 1. This wire can understand pulses, electrical pulses. I can send some electrical signal, plus 5 volt, minus 5 volt. So this wire can take plus 5 volt and minus 5 volt. So what will happen is that I will say some message signal, I will say something. Now what this mic will do? What this mic will do, inside this there will be a lot of blocks. Those blocks will convert this MT signal into ST signal. So this is like some pulses. ST signal will be some pulses. Okay. And those pulses will be traveling through the wire and it will be reaching to my computer. Now this computer will be working as a receiver. So now these pulses are traveling through the wire. So this is the example of wired communication. Is that clear to you? Now in these pulses what will happen is that there will be some noise also will be added. Now in the receiver there will be some blocks which will try to reduce the noise. Okay. And now this ST pulse will be reaching to the computer. Now computer will say that I cannot understand these electrical pulses. Plus 5 volt, minus 5 volt, I cannot understand that. What I can understand? I can understand only 0 and 1. So in the receiver only there will be some blocks which will convert this ST into 0 and 1. And now the computer will be able to process it and he will be converting this 0 and 1 into my voice again. So I sent my voice, okay. By the transmitter this voice was converted into some ST signal. okay, some pulses. These pulses are traveling through the wire. Okay, so this wire is working as a channel now, or you can call it medium. Now this wire is connected to my PC. PC says that I cannot understand these pulses, I need 0 and 1. Along with that, from the wire there will be some noise component will also be added. So in the receiver there will be some blocks which will try to reduce the noise, and there will be some blocks which will try to convert these electrical pulses into 0 and 1. And now the computer will be able to process those 0 and 1, and now the job of this computer would be that I will process 0 and 1 and output I will give as my voice signal only. Is that clear to you? Is the flow clear to you? So this was the example of wired communication. All good. Now what is wireless communication? Now this computer has my voice, right? This computer is having my voice. Now it has stored my voice. Now what I will do, the voice has been stored in terms of some video. Along, it is having video as well, it is having some audio as well. So that has been stored in this laptop. Now what I will do, I will upload this video to the YouTube server. I will upload this video which is having my audio as well. I will upload it to the YouTube server. Now what you will do, at your home you will connect to Wi-Fi, and then you will go to the YouTube server. You will log into YouTube, and now your Wi-Fi will be connecting you to the YouTube server. And just as you click on the video, just as you click on this particular video, now what will happen, my voice will be received to you. So from the YouTube server to your PC, from the YouTube server to your PC, whatever the transmission is happening, that transmission is wireless transmission. Are you able to understand this point? Because there is no direct wire, wire is involved, right? You are not connected to this wire. I am connected to this wire through my PC is connected to this wire through my voice. You are not connected to this wire. Still you are able to hear my voice. That means here there was wired communication, and from the YouTube server to your home, or from the YouTube server to your PC, that was the example of wireless communication. So there would be two kind of communication, wired communication and wireless communication. Okay, this is just the basics we are understanding, nothing else. All these will not be asked in the examination. Just you need to know that what all blocks should be there. Now if you have already studied, then you would be able to relate now that what we are actually going to understand. Because the problem with communication system is that people will understand everything, they will be able to solve all the questions, but they will not even realize that what they have studied. So now you will have a clear idea that first I need to convert this empty into ST. ST will be added with the noise, then it will be going to the receiver, and eventually I will receive empty. Now this is clear to you, and there could be two kind of medium, wireless or wired. So this wireless, if our medium or if our channel is wireless, then it is known as band pass communication. Okay, then it is known as band pass communication. What is the meaning of band pass? We will see, don't worry. And if the channel is wired, then it is known as baseband communication. Okay, so in digital communication system we need to study two kind of communication system that are band pass communication system and baseband communication system. Why it is known as band pass, why it is known as baseband, everything we will study. Okay, so that's it. We have seen the general block of a digital communication system. Let's move ahead. Some basic prerequisites we are going to see. We will see those prerequisites, and then we will go to this transmitter block, that what is there inside this block. What is there inside this block? All these things we need to study. But first there are some basic prerequisites. The first prerequisite is, do you know what is the meaning of bandwidth of a signal? If you have studied signal system, then you would know what is the meaning of bandwidth of a signal. So bandwidth of the signal is defined as the maximum positive frequency minus the minimum positive frequency. Whenever I talk about the bandwidth, my focus should be towards the frequency, and in the frequency only positive frequency. What I am saying, whenever I talk about the bandwidth, my focus will be towards the frequency. And which frequency? Positive frequency. So highest positive frequency minus lowest positive frequency, that would be known as bandwidth. So this I have written here. Yeah, so bandwidth of the signal is defined as highest positive frequency minus highest negative, minus lowest positive frequency. Okay, so let's understand by this example. So there is a time domain signal M1T. There is this time domain signal M1T whose frequency spectrum is looking like M1F. What I did, I find out the Fourier transform, and now I can draw the frequency spectrum. So there was a time domain signal. I don't know how it is looking like with respect to time, but I know that how it looks like with respect to frequency. So this time domain signal is having a frequency spectrum which looks something like this. Now they are asking me what is the bandwidth for this particular M1T signal. They can ask you the bandwidth of M1T signal. So what you will do, first you will go to the frequency domain, and there you will see what is the highest positive frequency, 5K, and what is the lowest positive frequency, 0. So 5 kilohertz is the bandwidth. Highest positive frequency having non-zero amplitude, surely having non-zero amplitude, having non-zero amplitude, having non-zero amplitude. Lowest positive frequency having non-zero amplitude. Why I wrote down having non-zero amplitude? That means someone can say that sir, highest frequency could be infinity. Highest positive frequency sir could be infinity, but non-zero amplitude. At 5K you are having zero amplitude, but just before 5K you are having non-zero amplitude. So highest positive frequency which is having non-zero amplitude, that is 5K, and highest positive frequency which is having non-zero amplitude, that is 0. So 5K minus 0, that is the bandwidth. So this is the bandwidth. Bandwidth is 5 kilohertz. Okay. So whenever you talk about bandwidth, you only look at the positive frequency. So whenever I talk about the bandwidth, I will only look at the positive frequencies. So highest positive frequency is 10 kilohertz, right? Highest positive frequency with non-zero amplitude. So here amplitude is non-zero, right? So highest positive frequency with non-zero amplitude is 10K minus highest minus lowest minus lowest positive frequency with non-zero amplitude, that is 0. So answer would be 10 kilohertz, right? So this will be the bandwidth. This bandwidth will be 10 kilohertz. Now someone will say that sir, in between it became 0. So don't worry about that. In between it became 0. Formula says highest positive frequency minus lowest positive frequency. So highest positive frequency minus lowest positive frequency, 10 kilohertz. What is the bandwidth here? For M3F, what will be the bandwidth? What is the highest positive frequency? So this kind of spectrum is there. It is going till infinity. It is going till infinity. So highest positive frequency is infinity minus what is the lowest positive frequency? 0. So what is the bandwidth? So ideally bandwidth is infinity. That's for sure. Bandwidth is infinity. But let's just say this part is F1. This I am calling as, this point is F1. Now I am saying that bandwidth of the main lobe, bandwidth considering the main lobe only. What do you mean by main lobe? So this is your main lobe, these are the side lobes. Basically most of the information will be contained here only, no? Because this is the highest part. Rest all parts are very low, right? These parts are very low. So most of the information will be contained here only. So if I don't care about these guys, then what will be my highest positive frequency? That would be F1. And what will be my lowest positive frequency? That would be 0. So in future if I say main lobe bandwidth is F1, so at that time you should not be surprised, you should know what I am talking about. What I would say, main lobe bandwidth is F1. I will make this kind of waveform and I will say main lobe bandwidth is F1. You would be able to understand what I am talking about. All good? All fine? Now what about this guy? Again frequency spectrum is given. So what will be the bandwidth? What is the highest positive frequency? FM. What is the lowest positive frequency? 0. So what will be the bandwidth? FM. Right? Highest positive frequency minus lowest positive frequency. What about this thing? Highest positive frequency having non-zero amplitude, 6K. Lowest positive frequency having non-zero amplitude, 2K. 4 kilohertz. Here what will be the bandwidth? Highest positive frequency having non-zero amplitude, infinity, right? At infinity as well you are having non-zero amplitude. Minus lowest positive frequency having non-zero amplitude, 2K. Infinity minus 2K would be infinity only. Here highest positive frequency having non-zero amplitude was infinity. Lowest positive frequency having non-zero amplitude was 0. So infinity was the answer. Here FM, here 4 kilohertz, here infinity again, right? Because highest positive frequency was infinity. So this is the bandwidth here, infinity. It is going till, what is the bandwidth here? This is the bandwidth here, 4 kilohertz. What is the bandwidth here? This is the bandwidth here, FM. What is the bandwidth here? Ideally bandwidth is infinity, but if I only talk about the main lobe, then this is the bandwidth, F1. Here, this is the bandwidth 10 kilohertz, this is the bandwidth 5 kilohertz. What about this one? Sir, this is the bandwidth. This is the time domain signal, no? Not a frequency domain signal. This is a time domain signal. So what is our task? First you convert it into the frequency domain, right? So what I need to find? I need to find its frequency spectrum. What does that mean? I need to find its Fourier transform. So what it is? It is a rectangular function. So can I write it down in this manner? Now signal system knowledge will be used here. A rect t minus center upon time width. So it would be A rect t by 6. What will be its Fourier transform? That would be A tau sampling of omega tau by 2. So that would be 6A sampling of 3 omega. But we are talking about f domain, then I can convert it into 6 pi f. So this will be the Fourier transform. Okay. So how this came, now it's your headache, because I told you before studying signal system you can never study communication system. Without studying signal system you can never study communication system, right? So this kind of waveform you will get, sampling waveform. I don't care about the amplitude, I only care about the frequency. So M6F versus F. Okay. So sampling waveform goes something like this, right? This much basic knowledge of a signal system has to be there. Now where is the first crossover? First crossover will be at 1 by 6. When this will become 0? When f is equals to 1 by 6. So this will be 1 by 6, right? What this will be? This will be 2 by 6. The next will be 3 by 6. And this we are talking in hertz because this was in second. So this will be in hertz. So what should be the, ideally what should be the bandwidth? Sir, it will keep on going like this, sir. And at infinity it will have non-zero amplitude, and at lowest frequency is 0. So sir, bandwidth is infinity, right? But if I talk about the main lobe bandwidth of the main lobe, what is that? 1 by 6 hertz, right? So from now onwards you will take care of one thing. Here what was the pulse width? Pulse width is 6. So pulse width in time domain. Pulse width in time domain, okay? If you just take the reciprocal of this pulse width, it will become the main lobe bandwidth. Pulse width was 6. If I just take the reciprocal, what I will get? I will get my main lobe bandwidth in case of rectangular function. Is that okay for you or not? In the time domain, I was having a rectangular function. The pulse width was 6. I just took the reciprocal. I got my first zero crossover. This is known as zero crossover, or you can call it main lobe bandwidth. That is 1 by 6. Okay. I am going to use it somewhere. In communication system, I am going to use this line somewhere. At that time, I will directly ask you, the width is TB. There I will say the width is TB. So what will be my main lobe bandwidth? You will say, sir, it will be 1 by TB, which can be written as RB. Okay, although we will see all these points. Main lobe, here what I will say, pulse width is 6. So main lobe bandwidth will be 1 by 6. What will be the bandwidth? This will be the bandwidth, or this will be the bandwidth? No. What is this? This is your time domain signal, right? So from time domain, what you need to do? You need to go to the frequency domain. From time domain, where I need to go? I need to go to the frequency domain. So what will be its frequency domain representation? So what is this signal? This signal is 5 sync t by 3. Say yes or no. You agree to this point? 5 sync t by 3. Yeah. Yeah, surely. So I can write this down as 5 pi t by 3 divided by pi t by 3. So what will be its frequency domain representation? That would be, I told you, focus on this part. So it will be like a rectangular, because you can see that from time domain, in frequency domain it was sync. So in frequency domain, if it is sync, now if this becomes time domain, then in the frequency domain it will be rectangular. So it will be like a rectangular, but what will be these points? That is our matter of concern. Our matter of concern is these points. M7 of F versus F. So what will be these points? So I told you this you will get at pi by 3. Pi by 3 means 1 by 6, right? So this will be minus 1 by 6, this will be plus 1 by 6. Okay. Basically pi by 3, right? Sin 80 by pi t. This is what I told you to remember. Forget about the amplitude. Amplitude here it will be 15, but I don't care about the amplitude. I only care about these points where it is ending. So focus on A. What is A? Pi by 3. This is in omega. So if I talk about f, that would be pi by 3 divided by 2 pi. So it would be 1 by 6, right? Very simple thing. So this will be plus 1 by 6, this will be minus 1 by 6. So what will be the bandwidth? What will be this bandwidth? This bandwidth will become 1 by 6. Again, what is the pulse width? What is the pulse width in time domain? Again, this is not the pulse width. Pulse width should be, if someone says that what is the pulse width, then you would say, sir, it is infinity actually. But if I talk about only the main lobe, so main lobe pulse width is 6. Then what is the bandwidth you are getting? 1 by 6. Sync function in time domain. Main lobe width is 6. In the frequency domain, what is the bandwidth you are getting? 1 by 6. Rect function in time domain, main lobe width is 6. In the frequency domain, what is the bandwidth you are getting? 1 by 6. Now those who have studied communication system previously, okay, those who have already studied it, those who did not study don't care about this, but those who have already studied it, you would know there are two kind of pulse shaping: rect pulse shaping and sync pulse shaping. In rect pulse shaping, you would say that, sir, bandwidth requirement is RB, and in sync pulse shaping, you used to say that, sir, bandwidth requirement is RB by 2. What do you think? Is it happening here? If I say this width is TB, then what will be the zero crossover here? 1 by TB. What will be the bandwidth? 1 by TB. If I say that this pulse width is TB, then what will be the bandwidth requirement? That will also be RB. Are you able to understand? Those who have already studied. As of now, you don't even know what is bandwidth. Those who did not study communication system before, they don't even know what is bandwidth. But those who have already studied, from them I am asking. You used to say that if I am using rectangular pulse shaping, then my bandwidth would be RB. And if I am using sync pulse shaping, my bandwidth is RB by 2. But here, what do you see? There, what we used to do is that we used to start rectangular pulse from 0. But we used to start sync pulse from minus TB to plus TB. So actually the width would become 2 TB. And here the width was TB. So if the width is becoming 2 TB, then you would used to say that bandwidth requirement is RB by 2. But I would take the pulse width to be TB only, no? Why would I take the pulse width to be 2 TB? Why would I take pulse width to be 2 TB? Why I would take 2 TB? Here I am taking TB pulse width. Why I can take 2 TB pulse width here? So in case of rectangular, you can never take 2 TB pulse width, but in case of sync, you can take 2 TB pulse width. And still, the transmission will be reliable. So a very, very important point which I have seen at every place taught wrong. Like you would never get to know that why in the sync I can use 2 TB pulse width, why in the pulse I can use only TB pulse width. For the sync, you can use 2 TB pulse width, but for the rect, you can only use TB pulse width. Why so? So that point in the end of the communication system we are going to discuss. Okay. So we used to write down RB by 2, that is correct. But here we are using pulse width to be 2 TB and here we are using pulse width to be TB only. Okay. So very, very important point which we are going to discuss in the end of the communication system. Okay. When I teach you inter-symbol interference, at that time I will tell you that even if you take the sync pulse for 2 TB bandwidth, still the reliable transmission will take place and there will be no inter-symbol interference. But if you take rectangular pulse with 2 TB pulse width, then the reliable transmission will not take place. There will be inter-symbol interference. We will discuss that, but yeah, this is a very good point which I wanted to discuss because when I was a student, I was always confused in this particular point. But as an educator, I have figured out where there is an error. So that error we are going to discuss in the last of communication system. Okay. So as of now, what you need to remember that, sir, in the time domain, if pulse width is TB, then in the frequency domain, my bandwidth will be 1 by TB. So this thing I have written here. in the time domain, whether it is a rectangular pulse, what this is known as rectangular pulse, okay, and what this is known as, although it is not like a pulse because it is going from 0 to infinity, right, it will keep on going. Here it has become 0 after TB, it has become 0 if I say this point is 0 and if I say this point is TB. So after TB it has become 0 and before 0 as well it was 0, so you can call it pulse. But here sync is going for infinity time, so you cannot call it pulse. But if I only talk about the main lobe width, then I can call it sync pulse, okay. So this is my sync pulse. So if my main lobe width is TB, then what will be this point? This point will be 1 by TB. So if I talk about my bandwidth of main lobe, what I will say? So that would be equals to 1 by TB. And in the sync pulse, if my main lobe width is 2 TB, then what will be this point? This point will be 1 by 2 TB. Here you can see that if this was 6, this point was 1 by 6. So if, just a second, if this was 6, this was 1 by 6. So if it is 2 TB, then it would be 1 by 2 TB. So what will be the bandwidth? This will be the bandwidth here and this will be the bandwidth here. So what will be the bandwidth here? Bandwidth of, here main lobe I don't need to write because pulse shape we are getting. So bandwidth is 1 by 2 TB. But important part is, this is the important part. Here you are having 2 TB and here you are having TB. So when you do the rectangular pulse transmission, at that time you will use the width to be TB only, and when you do the sync pulse transmission, at that time you will use the width to be 2 TB. Okay. Now there is something called baseband signal and bandpass signal. So as of now, what we understood? First we understood the basic meaning of this communication system. Then we saw the meaning of bandwidth. In bandwidth, we just got to know that first we need to convert the frequency. First we need to get the frequency spectrum. Then highest positive frequency minus lowest positive frequency. Both should be having non-zero amplitude. So 10K, 5K. All the examples we saw. Then this was the example of time domain. So we need to convert it into the frequency domain. From the frequency domain, now I can get to know that what will be my bandwidth. Same goes here as well. From time domain to frequency domain. Important part was, whatever the main lobe width I see here, reciprocal of that is coming to my bandwidth, and whatever the pulse width I see here, reciprocal of that is coming to my main lobe bandwidth. Okay, and this conclusion I have written down here. So this is the summary of whatever that we have already studied. Next we need to study about what is baseband signal and what is bandpass signal. We have already seen it in a signal system, but here also we will see it. What is the meaning of baseband signal? So here the lowest frequency component will be 0. That's it. Basically, this frequency spectrum is centered around 0 Hz. If I call this is FM and this is minus FM, and this point will be 0. So lowest positive frequency component is 0. But here if you see the frequency spectrum, so here lowest positive frequency component is something else, right? It is not 0. So if I call this point as FC, so this I am calling as FC plus FM and this I am calling as FC minus FM. Here what is the bandwidth? FM only. Here what is the bandwidth? 2FM, right? What is the bandwidth? Bandwidth is highest positive frequency component minus lowest positive frequency component. What that would be? FC plus FM minus FC plus FM, 2FM. So what is the bandwidth? Bandwidth is 2FM. Here what is the bandwidth? FM. Okay. So forget about the bandwidth, just talk about the center. Okay. So here your frequency spectrum is centered around 0, but here your frequency spectrum is centered around some other frequency component, that is FC, and usually we call it carrier. Okay, so this FC is known as carrier frequency. Why it is known as carrier frequency, that we will see in analog communication. Okay, in analog communication you will understand why it is known as carrier frequency. Okay, so very simple thing. Okay, frequency spectrum is centered around FC and frequency spectrum is centered around 0. Well and good. Yeah, so this is your baseband signal, baseband, and this is your bandpass signal. Now, how would you convert a baseband signal into bandpass signal? What I am saying, how would you convert a baseband signal into bandpass signal? So what you will do is that you will multiply baseband signal to a high frequency signal. So what will happen? In time domain, what I am doing? Multiplying a baseband signal to a high frequency signal in time domain. Okay, so in time domain I am doing the multiplication. So what will be your xt? Your xt would be simply mt multiply with cos 2 pi fct. So can I write it down in this manner? mt multiply with e to the power j 2 pi fct plus e to the power minus j 2 pi fct divided by 2. So this 2 I am putting here. Okay, divided by 2 would come, this 2 I have put here. Now this is your xt. So what would be your x of f? My x of f will simply be, if mt is having a Fourier transform of mf, then mt e to the power j 2 pi fct will have a Fourier transform of m of f minus fc plus m of f plus fc divided by 2, right? So let's just say I don't know what was my mt, but I know that what was my mf, like what was the frequency spectrum of this mt, what was the Fourier transform of this mt, that I know, that was mf. So can I draw xf now? Xf is mf of shifted by fc, right shifted by fc and left shifted by fc, and the amplitude is divided by 2. I don't care about the amplitude, I only care about the frequency. So mf right shifted by fc and left shifted by fc. Right shifted by fc and left shifted by fc. Okay, so this point would become minus fc plus fm. If this was fm, this was fm, so fc, this point would become fc plus fm, and this point would become fc minus fm. Now this point is just negative of this, so minus, or you can say that this is fm ahead of minus fc, so this point will become minus fc plus fm, and what this point would become minus fc minus fm, because this is fm behind of minus fc. So minus fc minus fm, minus fc plus fm, fc plus fm, fc minus fm. So what was this? This was your baseband signal, and what this has become? This has become your band pass signal. So if you are having a baseband signal and you just multiply it with some high frequency cosinusoid or sinusoid, then it would become a band pass signal. That's it. Okay, so these are the prerequisites that I wanted to teach. First we saw about bandwidth. In the bandwidth we saw one good conclusion. Then we talk about baseband signal and band pass signal, and from the baseband signal how would I go to the band pass signal, that also we have seen. Okay, now let's get back to our, okay, yeah, another thing we are going to see, that is wired transmission and wireless transmission. So I told you there could be two kind of transmission, one could be wired, other could be wireless, right? That means between the transmitter and the receiver, if wire is connected, then it is known as wired transmission, and if wire is not connected, in between there is a air, then it is known as wireless transmission. Okay, well and good. So what will happen is that transmitter will have some empty signal, it will convert it to ST, right? This channel will have some noise, it will receive ST plus NT, and you will receive, at the output you will receive empty signal again. Now let's just say this ST signal is having a frequency spectrum somewhat like this. Okay, having a frequency spectrum somewhat like this. This is 5 kilohertz, this is minus 5 kilohertz. This is the frequency spectrum of ST, frequency spectrum of ST. Okay, now wired channel, this is a channel, so it is like a LTI system only. No, this wire is like a LTI system, the wire that is connected to this mic, this is like LTI system only. Okay, so it will be like a LTI system, it will be having some impulse response HT, and this impulse response will have some frequency response of H of f. And usually wired channel are low pass channels. What do I mean by that? This HF is somewhat like this. The frequency response of this HF is somewhat like this. What I am saying is that this wired channel is nothing but a LTI system only. And if it is a LTI system, that means it is having some impulse response HT. That means it will have some frequency response of H of f. Is that clear to you? It will have some frequency response of H of f. Now usually this frequency response will be like a low pass. Okay, it is like a low pass filter only. What do you mean by low pass filter? That means it will pass only this much frequency component. So it will be like a low pass filter only. Now let's just say this point is 3K and this point is minus 3K. Now what will happen? This S of f will be passed through this H of f, and here you will receive some component, right? This S of f will be passed through H of f, and then you will get some output here. Now what will happen is that this frequency is 3K and this frequency is 5K. So what this filter will do? This filter will pass only this much component only, no? So your complete message signal is not being transmitted. Here this was the message signal. This message signal only was converted into ST. Now ST wanted to pass through HT. But when I saw the frequency response of both of them, SF was there till 5 kHz. That means the bandwidth of S of f was 5 kHz. And the bandwidth of your filter was, or your bandwidth of your channel was 3 kHz only. Then what will happen is that it will terminate this much part from 3K to 5K, whatever the part was there, that information will not be transmitted. That information will not be transmitted. So if this was ST, here you are not getting ST. Here you are getting something else. So what does that mean? That means that if this 3K was actually equals to 6K and this minus 3K was actually equals to minus 6K, then what would have happened? Whatever the information was there, complete information would have been transmitted, because this is 6K, no? This point is 6K and this is 5K only. So bandwidth of your channel is more than the bandwidth of your ST signal, right? So bandwidth of channel for distortion free transmission. What is the meaning of distortion free? That means complete information is transmitted. So bandwidth of your channel should be greater than the bandwidth of this. ST is known as symbol. Why it is known as symbol, I will tell you. So as of now I am just writing bandwidth of the symbol. Okay, this ST is known as symbol. Why it is known as symbol, we will talk about that. So did you understand this point? Okay, if you want a distortion free transmission, then what should have happened? That the bandwidth of your low pass channel, the wired channel will be usually low pass only. So bandwidth of your low pass channel should be more than the bandwidth of the symbol. Okay. Now you just answer me one thing. Which kind of signals you will like to transmit via wide channel? Baseband or band pass? You have two options. Which kind of signals you will like to transmit through wide channel? Baseband signal you will pass or band pass signal you will pass? Baseband, right? Because this is your baseband signal, no? What is your band pass signal? This is your band pass signal. That means this was already a low pass. This was already a low pass channel. Let's just say this was 5 kHz and this point was 10 kHz and this point was 20 kHz. Let's just say this is the scenario. And now this wide channel is low pass. Now this is the scenario I am having, 6K minus 6K. So what will happen? This information can clearly pass, but this information which is there between 10K to 20K, so what will happen is that it will completely terminate this information. This channel will completely terminate this information. Why so? Because channel is giving you zero response between 10K to 20K. So this channel cannot pass any frequency component which is there between 10K to 20K. So band pass signal will not even be transmitted, but baseband signal will be transmitted. So, so through wired channel, which kind of signal you would like to transmit? Baseband or band pass? Baseband, right? So if you go to the first page, now if I go to the first page, wired channel was known as baseband communication. If I am using the wired channel, then my communication system will be known as baseband communication system. Did you understand this point? Why baseband communication system? Because through the wired channel, I can only transmit the baseband signals only. I can pass band pass as well, right? I can pass band pass as well. There is no certainty, right? How you can pass band pass? Let's just say this was my band pass signal, 10K, 20K, and my filter, my channel was somewhat like this. It is having the bandwidth of 60 kHz. So it will be able to transmit this information as well. 10K, 20K will also be able to transmit. But usually what I would prefer, this will be a low pass channel with a lower cutoff frequency. So I would prefer that I would pass baseband signals through the wired channel. Okay. So what I have written there, what I have written here is that in this slide I have written that usually baseband signals are transmitted through wired channel. Usually. Why usually? Because band pass can also pass if your wired channel is having very higher bandwidth. But if it is having low bandwidth, then only baseband signals can pass. Okay, so bandwidth of the channel should be greater than the bandwidth of signal. So everything that I have explained, you can write down in the space that you are having. You might be studying from lecture notes only. You might be having the printout of this lecture note, so you can write down something here if you want to write down, or you can write down here as well. Okay, you have enough space, so whatever that I explained, you can write it down. I am not writing down anything. Just this much theory is required, which you can understand when you revise it. Okay. What about the wireless transmission? What is the meaning of wireless transmission? That means the transmission will be done through air. Okay, transmission will be done through air. That means you need to transmit electromagnetic wave, EM wave. If you have studied EMFT, then you would know what I am talking about. If you did not study EMFT, then also it is fine. What I need to do, I need to transmit EM wave through air. If I am transmitting, that means I need to transmit EM wave, and EM waves are transmitted through antenna. Okay, EM waves are transmitted through antenna. So this is known as your transmitting antenna. Transmitting, I will just write down in short, otherwise it will go very. Transmitting antenna, and this is known as receiving antenna. Okay. Now there is a constraint on the size of antenna. The constraint on the size of antenna is that the length of antenna is inversely proportional to the frequency of the signal that is applied to it. What I mean to say is that transmitter will be getting some empty signal, it will be converting into ST. Now this ST is having the frequency response of, let's just say, somewhat like this, minus 5 kilohertz, 5 kilohertz. Now if I want to transmit 4 kilohertz of information, whatever the information that I am having, if I want to transmit this information, then the size of antenna will be proportional to 1 by 4 kilohertz. If I want to transmit the information which is there at 0 kilohertz, what I am saying, if I want to transmit the information which is there at 0 kilohertz, then what will be the length of antenna? 1 by 0. That would be infinity. So you need to use the infinite size of antenna, and you cannot create infinite length antenna, right? So if lower frequency is there, that means the length of antenna should be very high. Is that clear to you? That means the length of antenna would depend on the frequency component that is present in S of t. So in S of t, if I am having low frequency component present, then the length of antenna would be infinity, which is not possible. But if your S of t is a band pass signal, what was this? This was the baseband signal. But if your S of t is band pass signal, then what will be the lower frequency component? Let's just say this is 10K. So your length will be proportional to 1 by 10K. So this is the maximum length you would require, which is inversely proportional to 10K, or you can say proportional to 1 by 10K. Okay. So lower the frequency, higher the length of antenna. Higher the frequency, lower the length of antenna. So what has been written here? Length of antenna is inversely proportional to, or proportional to, you can say 1 by lowest frequency component of the message signal, or you can say symbol. In place of message signal, you could have written down symbol as well, because this ST is symbol actually, not message. Message signal is here. So this is what has been written. So what does that mean? What you will prefer? You will prefer band pass signal to be transmitted via wireless channel. If you want baseband signal to be transmitted through this antenna, what does that mean? That means the length of antenna should be infinity. But keeping the length of antenna infinity is not possible for us. So what we will do? We will convert the baseband signal into band pass. If I want to transmit any information through antenna only, and let's just say I am having baseband signal only, so what I would do? I would take this baseband signal, I will multiply with high frequency carrier, I will convert it into band pass signal, and then I will transmit it through antenna. So band pass signals are transmitted through wireless medium. Very simple thing, very straightforward thing. Yeah, sorry for the interruption. So did you understand these points? Okay, so let's revise from here. Baseband signal, band pass signal, you would know lowest frequency component is 0, lowest frequency component would be somewhat around some higher frequency component, right? And then how would I convert a baseband signal into band pass signal? That also you understood. then wired transmission and wireless transmission. If I am doing the wired transmission, what does that mean? The bandwidth of that wired channel should be greater than the bandwidth of the symbol, right? Or you can write down message signal here as well. So bandwidth of channel should be greater than the bandwidth of the symbol. Now if symbol is having very high bandwidth, that means the bandwidth of the channel should be very high, but channels are usually low pass. So here I am writing usually the channels are low pass channel. That means they will not be having much higher bandwidth. That means they will not be able to pass the band pass signal. So they will be able to pass baseband signal. So usually baseband signals are transmitted through wired channel. Talking about the wireless channel, so here the matter of concern will be the height of antenna. Height of antenna is inversely proportional to the lowest frequency component present in message signal. So if lowest frequency component is 0, then the length of antenna will be infinity. That means baseband signal you cannot pass. So what you will be able to transmit? You will be able to transmit band pass signal, because in the band pass signal the lowest frequency component is actually very high, right? Lowest frequency component will be actually very high. So if you want to transmit this information reliably, then you can use the antenna. So if I want to do the wireless transmission, that means if I want to do the transmission via air, or if I want to do the transmission via electromagnetic wave, then what I have to do? I have to use the band pass signal. And what if I want to transmit a baseband signal only? So first I will convert the baseband signal into band pass signal, and then I will be able to transmit it. So based on that, you get to know two kind of communication system. One is baseband communication system, other one is band pass communication system. So those block diagrams are made here. So I am only talking about the receiver block. Okay. So this kind of communication system we saw, right? Transmitter, wired channel and receiver. So now I am talking about the transmitter block. So in transmitter, what all things would be connected? So in the transmitter, sampler would be there, quantizer would be there, encoder would be there, and line coder would be there. So one by one, we need to study about each of the block. First, we will study about sampler, then quantizer, then encoder, and then line coder. And after that, what will be happening here? After that, what I will get? I will get the channel. After that, what I will get? I will get the wired channel. If I talk about baseband digital communication system. Now, what is the meaning of sampler, sir? What is quantizer? Everything we will study. Okay. So this will be your MT, and MT will pass through sampler, quantizer, encoder, line coder. Eventually you will get ST. Okay. Similar thing will happen here. MT will be passed through sampler, quantizer, encoder, line coder. Here you will get ST, but now I need to do wireless transmission, right? Now what I need to do? I need to do the wireless transmission. That means I will connect an antenna here. I need to do the wireless transmission. So what I need to do? Whatever the pulse that I am getting here, I need to multiply this pulse with high frequency sinusoid or cosinusoid. And just as I do this, if I multiply this ST pulse with high frequency sinusoid or cosinusoid, then what will happen? Here what I will get? I will get a band pass signal, and I will be able to transmit it via air as well using the antenna. Okay. So this is your block of band pass digital communication system. So the difference between baseband and band pass is clear to you or not? So if I am able to understand baseband digital communication system, is there anything which I cannot understand in band pass communication system? No. Everything you know. There is nothing different. Baseband, band pass, quite similar. Only difference is whatever the symbol that you are getting here, that should be multiplied with a high frequency carrier. That's it. Rest all the blocks are same. Antenna, do you need to study about antenna? No. Antenna we study in EMFT, right? So regarding the channel, only matter of concern will be noise. So noise will be available in the wired channel as well. Noise will be available in the wireless channel as well. So only matter of concern will be noise. So you need to study about noise. So noise will be same in wired as well. It will be same in the wireless as well. So when I need to study about noise, I don't need to care about whether I am studying about baseband or band pass, right? There will be only a few points which will be different between baseband and band pass. So what we are going to do is that first we are going to study our complete baseband communication system, and then we will study band pass communication system. But if baseband communication system is, let's just say it is taking X hour, then band pass communication system will take X by 5 hours only, because you would know the meaning of every block. So now what is my target? My target would be to understand the meaning of sampler, quantizer, encoder and line coder. So in this lecture, what we are going to do? We are going to understand the meaning of all these blocks on surface level. Okay, that what they are actually doing, how from MT, how we are getting ST. So that we are going to understand in this lecture only on surface level. You already know the meaning of this block, right? This block is there just to convert your baseband signal into band pass. So this block I don't need to study now. Only these 4 blocks I need to study. So in this lecture we are going to study all these blocks on surface level. We will study sampler on surface level. We will study quantizer on surface level. Whatever that is required in encoder, completely we will study. Whatever that is required in line coder, completely we will study. So these 2 blocks we will study on in depth only. But depth of these 2 blocks we will study in further lectures. Are you able to understand this point? So first I need to understand that how my communication system is working. And then I will go to one by one. I will go to sampler, I will go to quantizer, encoder and line coder. In this lecture only you will understand everything about encoder and line coder as well. Is the path clear to you? So now next, what is the matter of concern? Next matter of concern would be that, sir, what is the meaning of sampling? What is the meaning of quantization? What is the meaning of encoding? What is the meaning of line coding? Okay, so let's talk about sampling. That we will talk after a break. But I hope you already have studied signal system, so you should know the meaning of sampling. I hope that. I hope you have studied signal system, so you already know the meaning of sampling. Then we will see the meaning of quantization, what kind of output we will get, what is happening. All these things we will study. So separately we will talk about sampler, then separately we will talk about quantizer, then separately we will talk about encoder, then separately we will talk about line coder, and then we will combine all of them. Okay, so this will be the flow. First sampler separate, quantizer separate, encoder separate, line coder separate, and then combine all of them. All good? So we will get started, but I need to take a break. I will take a break. You can also drink some water, and then we will come back, and in a very great enthusiasm we will start studying about sampler. Okay, yeah, welcome back. So now we need to study about sampler. So what is a sampler circuit? So sampler is nothing but a switch. Okay, what is sampler? Sampler is nothing but it's like a switch only, which is being closed at a particular time. What I am saying is that this switch is being closed after every 2 seconds. What does that mean? That after every 2 seconds you are closing this switch, and at the input of this switch you are applying this time domain waveform. This is a continuous time waveform. What do you mean by continuous time? Continuous time means it is defined at all the time. If I ask you what is the value of mt at t equals to 0 second, you will be able to tell. What is the value of mt at t equals to 0.01 second, you will be able to tell, sir, this will be the value. What is the value of mt at t equals to 1 second, sir, this will be the value. What is the value of mt at t equals to 3 seconds, sir, this will be the value. What is the value of mt at t equals to 6 seconds, this is the value. So it is defined from minus infinity to plus infinity. It is defined for all the time from minus infinity to plus infinity. So it is a continuous time waveform. Now what I am doing is that I am applying this waveform to the input of this switch. Now what this switch will do? Let's just say this switch was closed at t equals to 0 second. So whatever the value you are having at t equals to 0 second, whatever the value of mt you are having at t equals to 0 second, it will map that value at the output of the sampler. What it will do? It will be, the switch will be closing after every 2 seconds. So what I am saying is that let's just say this switch is closed at t equals to 0 second. So whatever the value of mt at t equals to 0 second that you are having, that value will be mapped at the output of the sampler. So let's just say this value is some m of 0. So what you will get here? You will get m of 0 at the output. What you will get? You will get m of 0 at the output. M of 0. Now the switch is closed at t equals to 0 second, right? T equals to 0 second. Now I am saying that it is being closed after every 2 seconds. That means next time when it will be closed. It will be closed at t equals to 2 second, right? This was t equals to 0 second. Now it will be closed at t equals to 2 second. So here I am drawing m of n versus t only. In a signal system we used to draw m of n versus n. But now I am drawing m of n versus t. That means at t equals to 2 second, whatever the value this signal is having, it will be mapped here. So whatever the value this signal is having, it will be mapped at the output. So this is the input and this is the output that you are receiving. Okay. So sample output you are receiving. That would be m of 2. This output would be m of 2. So can I write it down as m sampled t? What I am writing? M sampled t. That means now what I am doing? First sample I am calculating at t equals to 0. Second sample I am calculating at t equals to 2. Now at the output, looking at the output waveform, if I ask you what is the value of MST, what is the value of MST at t equals to 1 second? What you will say? Sir, I don't know. Because I know only at 0 and then 2, and then next what I would know? I would get to know the value at t equals to 4 second. The next value it will be mapped at t equals to 4 second. So basically this switch is being closed at every 2 seconds. First it was closed at 0, then it was closed at 2, then it was closed at 4. M of 4. Next it will be closed at 6. Okay, then it will be closed at 8 second. So in that manner we are going. Similar thing can happen in the negative direction as well. If I am saying that the switch was closed at t equals to 0 second, that means it was closed at t equals to minus 2 second as well, right? It was closed at t equals to minus 2 second as well. Okay, then it was closed at t equals to minus 4 second as well. So this was the meaning of sampling. It is like a photograph. Like let's just say I am moving my hand like this. I am moving my hand like this. Now you are clicking the photograph in a very quicker manner. You are not taking the video. You are clicking the photograph. I am moving my hand and you are clicking the photograph. You are not taking the video. So let's just say when my hand was like this, you clicked one photo. Then my hand was like this, you clicked one photo. Then my hand became like this, you clicked one photo. Then it became like this, you clicked one photo. And then it became like this, you clicked one more photo. Now if you keep those photos in one run only, what I mean to say is that you clicked this photo, this photo, this photo, this photo, and then you are running these photos. So what it will feel like that? It will feel like a video, right? It will feel like a video. Now the more photos you click, the better the video would be. What I am saying, I was moving my hand like this. You started clicking the photo, one photo, second photo, third photo, fourth photo, fifth photo, sixth photo. Now you are doing the slide show. What you are doing? Slide show. That means you are putting all these photos in a row and then you are clicking on the time button. So what will happen? It will look like a video only. Now if you have clicked more photos, that means if you have taken more samples, then the video will be better. Are you able to understand this point? So if I join these points, then what does it look like? Doesn't it look like the same waveform that we had? What I am saying, if I am joining these points like this, so isn't it looking like a similar kind of this waveform only, right? So this is the meaning of sampling. Okay, so what this 2 is known as, I am saying that I am closing the switch after every 2n second, right? So similarly I can write down, I am closing the switch after every n ts second. So this ts is known as sampling time period. Okay, what this ts is known as? Sampling time period. Okay, and this 1 by ts is shown by fs. Okay, 1 by ts is shown by fs. Better write down tsa. Okay, tsa is known as sampling time period. What I am writing down, tsa is known as sampling time period. So this 1 by tsa I will be showing by fs, and this fs is known as sampling frequency. Okay, well and good. Minus 42046 second, and this was in second. So this was the sampling circuit. But usually communication system, what they do is that they use sample and hold circuit. What I am saying, in place of using sampler, the name will be written as sampler only, but actually they will be using sample and hold circuit. What does that mean? That means that let's just say I calculated a value at t equals to 0. My switch was being closed at t equals to 0. That means I calculated a sample at t equals to 0. Next sample I am going to calculate at t equals to 2 second, right? Next sample I am going to calculate at t equals to 2 second. So what it will do, let's just say first sample was calculated. This was your m of 0. Now it knows that next sample will be calculated at t equals to 2 second. So whatever the value it calculated at t equals to 0, the same value it will carry till t equals to 2 seconds. Now at t equals to 2 seconds, it will calculate another sample. So this sample will be m of 2. Now it knows that the next sample will be calculated at t equals to 4 seconds. So whatever the sample it calculated at t equals to 2 seconds, it will carry that sample, and then at 4 seconds it will calculate another sample. That would be m of 4. Now it knows that next sample will be calculated at t equals to 6 seconds. So till t equals to 6 seconds, it will carry this sample only, but at t equals to 6 seconds, it will calculate another sample, and the same process will keep on going. So it's like sampling and then hold, sampling, then hold, sample, hold, sample, hold, sample, hold, sample, hold. Are you getting this point? So usually what communication system uses is that they will use sample and hold circuit. So whatever the sampling that we studied in a signal system, it is like the same sampling only, but here we will be holding the value. In a signal system, what I used to say is that if you are going from continuous time and you are passing this signal to a sampler, then it would become a discrete time signal. But here I am doing time versus time only. Are you able to understand this point? So if I am saying that this is continuous time, this is also continuous time, although I know that it is becoming like a discrete time only, although I can understand that it has become a discrete time signal. Are you able to understand what is the meaning of continuous time, discrete time? In signal system we have studied it. I know that it is calculating the sample at 0, 2 second, 4 second, 6 second, 8 second, minus 2 second, minus 4 second. But whatever the sample it calculates, it will carry that sample till t equals to 2 seconds. So if I ask you what is the value of your output signal at t equals to 1 second, if I ask you what is the value of your output signal at t equals to 1 second, what you will say? Sir, it is equals to m of 0 only. In signal system, if I used to ask you what is the value of your output signal at t equals to 1 second, you would say, sir, it is undefined, it is not even defined. But if I am using the sample and hold circuit, what does that mean? That whatever the sample it calculated at t equals to 0 second, it will carry that sample till m equals to 2. So if I ask you at t equals to 1, if I ask you what is the value of your sampled signal at t equals to 1 second, you will say that, sir, it is equals to m of 0 only, because it is using sample and hold circuit. Is that clear to you or not? So sampled signal at t equals to 1 second is having m of 0 value only, although it is not being sampled at t equals to 1, but still it is having that value, because sample and hold, sample and hold, sample and hold, sample and hold. This is the process that is going on. Is that thing clear to you? So whatever the sampling that we have already studied in signal system, the same sampling is there. Only thing you need to take care is that communication system will be using sample and hold circuit, although in theory, in textbook, everywhere only the sampler would be written. But you need to make sure that value will still be defined at all the points. It will be defined at all the time intervals. If I ask you the value of sample signal at t equals to 0 seconds, still you will be able to tell. If I ask you the value of sample signal at t equals to 0.25 second, then also you will be able to tell. If I ask you the value of sample signal at t equals to 0.5 second, then also you will be able to tell. If I ask you the value of sample signal at t equals to 4 second, then also you will be able to tell. Because we are using sample and hold circuit, whatever the value is being sampled, that is being held in the signal. Is that clear to you? And you already know, if I sample a random process, if a random process is being sampled at a particular time instant, if a random process is being sampled at a particular time instant, let's just say the time instant is t only, or t1. I am sampling this random process at time instant t equals to t1. So what I will get? X of t1. And what this will be known as? This will be your random variable, not random process, right? This will become a random variable. Say yes or no. Do you agree to this point? Surely you agree to this point, right? So this I can show by X only. So a random process, if a random process is sampled at any time instant, it would become a random variable. Okay. So this was the basic meaning of sampler. In-depth discussion of sampling we will do. Don't worry about that. So basic meaning you have understood. First the message signal will come and it will be made somewhat like this. And in a better manner you would say that the sample signal will look somewhat like this. Is that clear to you? Now this sample signal will be going to the quantization. Now sir, this signal and this signal is different. Yeah, this is different. We are studying all the blocks separately. We have studied sampling block. Now forget about this. We are studying quantization block now. So it will have a different kind of input. In the end, what we will do, we will combine all of them. So when we are combining all of them, at that time we will take only one kind of input. Here I have taken separate input. I am studying quantization, I will take separate input. In line coder, in encoder, I will take separate input. So don't worry about these inputs. Input could be different. We are just understanding the meaning of sampling and quantization. Now we will understand the meaning of quantization. So what this quantization will do? Now for the quantizer, I have defined two things. Step size is 2 volt and minimum decision threshold is minus 5 volt. What does that mean? So what this sampler was doing? The sampler was playing with the time window, right? Sampler was playing with the time axis. So now this quantizer will play with the amplitude axis. So what it will do? Now you let me know from where to where input values are varying. What is the range of input values? From minus 5 to plus 5, right? The range of input value is there from minus 5 to plus 5. So minimum value is minus 5. Now they are saying that step size is 2. What does that mean? Minus 5 plus 2, what that would be? Minus 3 volt. So at the input of the quantizer, if any of the values is coming between minus 3 to if any of the value is coming between minus 5 to minus 3, then the quantizer will map that value to its midpoint, and that midpoint will be minus 4. Whatever the value is coming between minus 5 to minus 3, that value will be mapped to minus 4. Let's just say at the input of the quantizer minus 4.9 is coming. What will be the output? Minus 4. If minus 4.6 is coming, what will be the output? Minus 4. If minus 3.7 is coming, what will be the output? Minus 4. If the value is between minus 5 to minus 3, it will be mapped to minus 4. How did you find out this will be minus 3? Because step size is 2. What is the meaning of step size? That how much step it is taking. The lowest decision threshold, that means the lowest it will start taking the decision from minus 5. So from minus 5 to minus 3, that means a step of 2 it is taking. This is a step of 2 volt. Now again it will take a step of 2 volt. That means if the values are coming between minus 3 to minus 1, if the values are coming between minus 3 to minus 1, then it will map it to the midpoint, that would be minus 2. So if any value is coming at the input of the quantizer, if any value is there between minus 3 to minus 1, then the output will be minus 2 volt. Let's just say the value is minus 2.7. What will be the output? Minus 2 volt. If the value is minus 1.7, what will be the output? Minus 2 volt. Is that clear to you? Okay. So meaning of step size is also clear. And minimum decision threshold or minus 5, that means you need to start from minus 5. Minus 5 to minus 3, minus 3 to minus 1, then minus 1 to plus 1. And sir, why it is mapping to minus 2? It can map to any value. It would be written in the question. Here what we are using? We are using midpoint mapping. So it should have been given in the question that you are using midpoint mapping. What is the meaning of midpoint mapping? That means whatever the midpoint is there, it will map it to that value. Let's just say there is a range from minus 6 to minus 3. So where it will map? It will map it to the mid value. Mid value will be minus 4.5. Are you able to understand this point? Okay. So mapping would be given, or they would tell that at what value it will map. So here we are using midpoint mapping. Okay. So here I will write down midpoint mapping we are using. Midpoint mapping. If the values are coming between minus 1 to plus 1, then where it will map? It will map it to 0. If the value is coming between 1 to 3 volt, then where it will map? It will map it to 2 volt. And if the values are coming between 3 to 5, where it will map? It will map it to 4 volt. Is that clear to you? Okay. So if this input waveform is given, can you draw the output waveform? Did you understand the meaning of step size? This is the step size. That means the minimum window, minimum amplitude window in which quantizer is taking a decision. Quantizer is like a decision maker only, no? That what is the minimum window in which a quantizer is making a decision? That is known as step size. Okay. So it will start making a decision from minus 5. Minus 5 to minus 3. Whatever the value comes, map to minus 4. Minus 3 to minus 1. Whatever the value comes, map it to minus 2. Minus 1 to plus 1. Whatever the value comes, map it to 0. Plus 1 to plus 3. map to 2, plus 3 2 plus 5 map it to 4. So if this is the input, what will be the output? So here I have shown the input, you draw the output on your own, starting with t equals to minus 10 second, and at minus 6 second minus 3 volt will occur, because this is a slope is constant. What is the slope is 20 by 10, so slope is 2, so plus 2 slope you are having. So at minus 10 if you are having minus 5 volt, then at minus 6 you will have minus 3 volt, at minus 2 you will have minus 1 volt. That is very simple, right? So let's just say this value is minus 3 volt, this time is minus 6, and this value is minus 3 volt. Okay, so between minus 6 to between minus 10 to minus 6 second, whatever the values are coming, all the values will be mapped to minus 4. All the values will be mapped to minus 4. So this point is minus 4. Now next decision will be taken as minus 1 volt, right? So this point is minus 2 second. So between minus 6 to minus 2 second, between minus 6 to minus 2 second, what is happening? Minus 3 to minus 1 volt is coming. So whatever the values which are there between minus 3 to minus 1, that will be mapped to minus 2 volt. That will be mapped to minus 2 volt. Right? Now the next decision will be taken at 1 volt, right? So whatever the values are coming between minus 1 to 1 volt, whatever the values are coming between minus 1 to 1 volt, all the values will be mapped to 0. All the values will be mapped to 0. Is that clear to you? This was minus 2, this is 0. Now between 2 to 4, next would be 2 to 6 actually. This is 6 second, and this value will be 3 volt. Forget about this 2.5, it will create needless confusion. Yeah, so whatever the values are there between 1 volt to 3 volt, whatever the values are there between 1 volt to 3 volt, all the values will be mapped to plus 2 volt. All the values will be mapped to plus 2 volt. And whatever the values are there between 3 to 5 volt, all the values will be mapped to 4 volt. Okay, this was your 2 volt, this was your 4 volt, right? And after that, what is this value? This value is actually 2.5 volt. So if the value is 2.5 volt, if the value is 2.5 volt, where it will be mapped? It will be mapped to 2. Are you able to understand this point? This was your 2 second, this was your 6 second, this was your 10 second. After 10 second, the value was 2.5 volt. And if the value is 2.5 volt, where it will be mapped? If the value is 2.5 volt, then it will be mapped to 2 volt. So it is mapped to 2 volt. Okay. And before that, before minus 10, the value is 0. Here the value is 0 volt. So if the value is 0 volt, where it will be mapped? It will be mapped to 0 only. So when the value is 0 volt, it will be mapped to 0 only. Okay. So this is your quantized output. So when this signal is going through a quantizer, this is your quantized, this is going through a quantizer, and this is your quantized output. Okay. And here you can see that what is the jump? What is the step size? 2 volt. What is this jump? 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 2 volt. Right? So this jump is known as step size. So what is your step size? Your step size is 2 volt. Okay. Well and good. And decision threshold starting with minus 5. Now there are some terms related to quantizer. First term is dynamic range. Okay, dynamic range. So input is varying from minus 5 to plus 5 volt. So this is known as dynamic range of the input. So what will be the dynamic range of the input? Maximum voltage minus the minimum voltage. That would be 10. So this is the dynamic range of the input. So what is the dynamic range of input? V max, or I should write down X max minus X min. So whatever the value input can have as maximum minus minimum value of input. Maximum value of input minus minimum value of input. Here what was the dynamic range? Dynamic range was 10. You don't need to see here, nothing. What is the minimum value it can have? What is the maximum value it can have? 5 minus of 5, 10. Dynamic range is 10. Okay. Second is number of levels. So how many levels are there? Between minus 5 to minus 3, this is known as one level. This is your level 1. This is your level 2. This is your level 3. This is your level 4. And this is your level 5. So how many levels are there? 5 levels are there. And how can you find out these levels? How can you find out these levels? So these levels will be equals to whatever the dynamic range you are having divided by the step size. What did I write down? Dynamic range divided by the step size. What you are getting? 5 only. And it is pretty obvious as well. Input is varying from minus 5 to plus 5. That means it has a variation of 10 volt. After every 2 volt, you are taking the decision. That means how many decision you are taking, like how many blocks will be there, how many levels will be there. 1 level, 2 level, 3 level, 4 level, 5 level. So number of levels will be 5. So how can you can get it? Dynamic range divided by step size. So formula of step size is coming out to be dynamic range divided by the number of levels. So let me tell you one thing. Whenever you design a quantizer, whenever you tell a designer that you need to design a quantizer such that, so which value you will give? You will give him only the step size. So for a quantizer, step size is fixed. A quantizer is designed based on the step size. Okay. And sometimes they call it resolution as well. Resolution. Okay. But mostly in our communication system, they would use the word step size. So for any quantizer, any kind of quantizer you would see, always the resolution or step size will be fixed. This is not varying. What can vary? Number of levels can vary, input can vary, dynamic range can vary, but quantizer is always designed with respect to the step size. Okay. So for a quantizer, always the step size will be fixed. This thing is fixed. No one can change it. Okay. So from here, what is the formula of step size you are getting? Dynamic range divided by the number of levels. So let's see what I have written. Number of quantization level. So what will be the formula of number of quantization level? That would be dynamic range divided by the step size. So what I am writing? Dynamic range divided by step size. Okay, let's write down here what was our dynamic range. Dynamic range was 10. So dynamic range was 10 volt divided by 2 volt. So number of levels were 5. Volt to volt get cancelled out, 10 by 2 is 5. Okay. Now step size of quantizer is given by delta, that would be equals to dynamic range divided by the number of levels, that can be shown by L. Okay. So let's remove all these things. Now let's understand the next term, that is known as quantization error. What does that mean? This was your quantizer, right? This was your quantizer. Now I know that if my values are between minus 5 to minus 3 volt, then it will be mapped to minus 4 volt, right? So if I apply minus 5 here, what I will get? Minus 4 here. So the user applied minus 5 volt, but actually he is getting minus 4 volt. So what he will say? That there is an error of 1 volt. I applied minus 5, but I am getting minus 4. So there is an error of minus 1 volt. That means this value is 1 more than this. This value is minus 4 is 1 volt is more than this. Sir, here you are getting minus 1. Minus 1 plus 1, whatever you say doesn't matter. The error is whatever the value that you are applying minus whatever the value that you are getting. This is the applied value and this is the quantized value. Now if someone applies minus 3 volt, what output he will get? If the input is there between minus 5 to minus 3, it will be mapped to minus 4. What he will say? I applied minus 3, but I am getting minus 4. There is an error of 1 volt. So the error is between plus minus 1. If someone is applying, let's just say minus 3.5 volt, what he will get? minus 4 volt only, right? If someone is applying minus 3.5 volt, he will get minus 4 only. What is the error? Minus 3.5 minus 4. What is the error? Minus 0.5. Error would be minus 0.5. So error would be there between plus 1 to minus 1, or better I should say it would be there between minus 1 to plus 1. Okay, so isn't it equals to whatever the value that you apply minus the quantized value? So this is known as your quantization error. Okay, so I will make a better diagram now. I will make a better diagram now. So if I am applying x, the quantizer is mapping this value of x to x q. So quantized value of x. So quantization error is given by x minus x q. Is that clear to you? Very simple thing, very straightforward. Like these are just aptitude, nothing else. Okay, these terms are important related to quantizer. That's why we are studying it. As of now, this is the meaning of quantizer, that this particular waveform has been made somewhat like this. Now there is something called uniform quantization and a non-uniform quantization. So let's see an example, you will be able to understand. So what this example is saying, again the values are varying between minus 5 to plus 5. There is a random variable which is taking the values between minus 5 to plus 5. Minus 5 to plus 5. Now what does the quantizer minus 5 to plus 5? Now what is quantizer doing? Quantizer is saying that for an input between minus 5 to minus 3, the output will be minus 4. The output will be minus 4. If the input is there between minus 3 to minus 1, then the output will be minus 2. This is what your quantizer is saying. So what you are saying, this was the value of your input x and this is your quantized value, right? Next, if the input is there between minus 1 to 3, then the output value is plus 1. Minus 1 to 3. Actually, this would be a big gap. Minus 1 to 3. So the output will be plus 1. And if the input value is between 3 to 5, then the output will be plus 4. Again, here as well, midpoint mapping is used. It is just mapping it to the midpoint. What is the midpoint of 3 to 5? That will be 4. What is the midpoint of 3 and minus 1? That will be 1. What is the midpoint of minus 3 minus 1? That would be minus 2. Midpoint mapping is used. But what is the step size here? Step size here is 2. What is the step size here? 2. What is the step size here? 4. And what is the step size here? 2. So this step size and this step size is same. But if one of the step size is different, then it will be known as non-uniform quantizer. So when we were discussing this particular thing, when we were discussing this particular example, when the input values are there between minus 5 to minus 3, minus 3 to minus 1, minus 1 to 1, 1 to 3, 3 to 5. So it was a case of a uniform quantizer. So if this delta is fixed and it is uniform, then it is known as uniform quantizer. Otherwise, it is known as non-uniform quantizer. So this delta is fixed, but it could be uniform or it could be non-uniform. So whatever the formula that you have written here, these formulas are there. These formulas are true only for the uniform quantization, right? Because for the non-uniform quantization, you can never define a step size. Someone will say step size is 2, someone will say step size is 4. You can never define a step size. And if I try to find out the value of step size, what I will say? How many levels are there? Level 1, this was your level 1, this was your level 2, this was your level 3, and this was your level 4. Someone will say 4 levels are there. What is the dynamic range? 10. So step size is 2.5. But step size is not 2.5, it is 2, 2, 4, 2. So no formula is working here. So don't mug up the formula. These formulas are not to mug up. These are like class 10th 11th thing, right? Very basic thing, very basic aptitude it is. Dynamic range divided by the number of levels, that will give you step size, very simple thing. But that step size has to be uniform. So this step size is uniform. Then only I am writing down this formula. But this quantization error will always work. This formula will always work. Like whatever the value, what I am saying, quantization error. This was your quantizer. If I am applying the voltage to be minus 3.5, or let's say if I am applying the voltage to be minus 5, where it is mapped? It is mapped to minus 4. What is the quantization error? Minus 1. that is fine. So what I am doing, x minus x cube. The same thing I can apply in this range as well. What does that mean is that, let's just say if I am applying the input value to be -1, where it will be mapped? It will be mapped to +1. What is the quantization error? -1, -1. The quantization error will be -2. So what I am doing, whatever the input value was there and where it is quantized, where it is mapped, x minus x cube. Okay, so everywhere you can apply this formula, x minus x cube. Okay, that is fine. So just in the questions it will be mentioned that we are using a uniform quantizer. We are using a non-uniform quantizer. What does that mean? If they are saying non-uniform quantizer, that means the step size is not uniform. And if they are saying uniform quantizer, that means the step size is uniform. Is that clear to you? Very basic things, very basic meaning. Okay, so this is the diagram. You understood the meaning of a non-uniform quantizer as well, and you understood the meaning of a uniform quantizer as well. Okay, so uniform quantizer, step size is same for all the intervals. Non-uniform quantizer means step size is varying across the interval. So till this point in this discussion of 30 minutes, nearly you are learning nothing, right? Everything you already know, very basic things. M of t was there with respect to time. What you are doing sampling. That means you are closing the switch at a particular time window, but you are using sample and hold. So whatever the value that at t equals to 0 I am getting, the next sample I will be calculating at t equals to 2 seconds. That means between 0 to 2 I will hold that value. Then between 2 to 4 I will hold that value. Between 4 to 6 I will hold that value. In that manner, sampling and holding it. After that, there is a quantizer. Let's put all these things here. Yeah. After that, we are studying about quantizer. So sampling was there with respect to the time. So quantizer is there with respect to the amplitude. Quantizer always care about the amplitude. That's it. So quantizer is caring about the amplitude. So if the signal, if the amplitude is there between -5 to -3, it is mapping it to a particular value, that is -4, using the midpoint mapping. If nothing is mentioned, this is the by default we take midpoint mapping. Okay, if nothing is mentioned. Otherwise, they will tell that where you are mapping it. Next lecture will be based on quantization only. So there, in some of the questions, I will tell you where the values are mapped. So if values are mapped to a particular value, then it will be mentioned. Okay. And if it is not mentioned, then you will use midpoint mapping. That means in a particular level where you will map the value, at the midpoint you will map the value. Okay, so here I could see that values are varying between -5 to -3, then it is mapped to -4. Values are varying between -3 to -1, mapped to -2. Values are varying between -1 to +1, value mapped to 0. Values are varying between 1 to 3 volt, mapped to 2. Values are varying between 3 to 5 volt, mapped to 4. The value is 2.5 itself. So if the value is 2.5, then it will be mapped to +2. Okay, so this is the meaning of quantization. There are some formula, nothing to remember, nothing to mug up. Step size would be equals to dynamic range divided by the number of levels, which is very simple thing, right? So, and quantization error is x minus x cube. Okay, quantization error is whatever the input that you are applying minus wherever you are mapping it. And then we understood the meaning of uniform and non-uniform quantizer. Here the step size is uniform, that means uniform quantizer. If the step size is not uniform, then non-uniform quantizer. Now let's understand the meaning of encoder. So at the input of the encoder, what will be applied? Some particular voltages will be applied. Let's just say at the input of this encoder, I am applying plus 2.5 volt and minus 2.5 volt. Now a very important line I am going to say, very important line. Okay. At a time, only one voltage will be applied. I am saying that at the input of the encoder, two kind of voltage can come, plus 2.5 and minus 2.5. But at a time, only one voltage would be there. So better let me make it somewhat like this. That two kind of voltages can be applied, but at a time only one of the voltage would come. Either plus 2.5 would come or minus 2.5 would come. It's not that both will be coming at the same time. No. Either plus 2.5 would come or minus 2.5 would come. If let's just say plus 2.5 is coming, if plus 2.5 is coming. So now the job of this encoder is to define a particular bit to this plus 2.5 volt. So if he is saying that I am defining plus 2.5 volt by bit 1, I am mapping plus 2.5 to bit 1, then minus 2.5 volt will be mapped to bit 0. Say yes or no. So using only one bit, you can define a particular voltage. Here you will be saying that sir I am using 2 bit. No. No, for defining one kind of voltage, for defining 2.5 volt, how many bits you are using? Only one bit. For defining minus 2.5 volt, how many bits you are using? Only one bit. So here it will be written that number of bits used are 1 only. Someone will say, sir, we are using bit 1 as well, bit 0 as well. But I told you at a time only one signal would come. So at a time if plus 2.55 volt is coming, so encoder will give the output of bit 1. That's it. If minus 2.5 volt is coming, then encoder will give the output of bit 0. That's it. So at a time it is producing only one bit. Is that clear to you? Let's understand more. Let's see more example. It will be more clear to you. So let's keep this example aside. Let's see this example first. Okay, let's see this example first. So although I have made the diagram like this, but I know one thing, that all the inputs will not be applied at the same time. What will happen? The inputs will come one by one, right? Inputs will come one by one. So first, let's just say 5 volt is coming. Let's just say 5 volt is coming. 5 volt is coming. Now someone would say that, sir, you define 5 volt by bit 1. Okay, plus 5 volt came and encoder is defining this plus 5 by bit 1. Then plus 3 came. Now this encoder is defining this plus 3 by bit 0. Now minus 1 would come. How encoder will define it? By bit 1. If it is defining it by bit 1, then it would be equals to minus 5, then it would be equals to plus 5. But plus 5 and minus 1 are different. That means it cannot define it by bit 1. If it says that I will define it by bit 0, then these two guys are same. But minus 1 and minus 3 are different. Then it cannot define it by bit 0 as well. So now encoder cannot define this minus 1. So what encoder will do? Encoder will say that I am defining plus 5 by 1 bit. That means I am defining plus 5 by 2 bits. Now I will define plus 3 by 10, or it can define by any bit. I don't care, like it could be 00 as well, I don't care. It could be 01 as well, it could be 10, I don't care. I am just saying that it is defining plus 5 by 11. It is defining plus 3 by 10. Then how it can define minus 1? So it can define minus 1 by 00, or it can define it by 01. That means all these voltage levels, all these voltages should be defined by the separate kind of bits. That means all of them should have a different picture. If plus 5 is represented by 11, then plus 3 should be represented by 10, and minus 1 should be represented by 00. So here how many bits this guy needs to use? 2 bits. At a time it needs to produce 2 bits. Is that clear to you or not? Let's see more examples. Let's see more examples. Plus 5 minus 3, plus 5 plus 3 minus 3 minus 5. How many bits it will have to use? 4. Right? Because if this guy is saying, sorry, 2 bits only, no? Plus 5 can be represented by, let's just say plus 5 is represented by 00. There is no certainty that plus 5 should be represented by 11 only. No, nothing. Plus 3 is represented by 01. Minus 3 is represented by 10, and minus 5 is represented by 11. That's it. So how many bits you need to use? Only 2 bits. Here how many bits it will have to use? Let's just say plus 5 is 00. This is 01. This is 10, and this is 11. Now minus 4 will be represented by what? You cannot use 00, you cannot use 010, you cannot use 010, sorry, you cannot use 10, you cannot use 11. So what you will have to do? You will have to introduce another bit. So plus 5 is represented by 000, plus 4 is represented by 001, plus 2 is represented by 010, minus 2 is represented by 011. So now I can represent my minus 4 by 101, or whatever you want to represent. I don't care. So 101 or 100, whatever you want to represent, it's up to you. So I am representing by 101. So how many bits it have to use? 3. Here how many bits it will have to use? So 1, 2, 3, 4, 5, 6, 7, 8. So it will have to use 3 bits. Because with the help of 2 bits, how many combinations you can generate? 4. With the help of 3 bits, how many combinations you can generate? 8. So with the help of n bits, how many combinations you can generate? 2 to the power n. Is that okay for you? So will you be able to understand without mugging up? Will you be able to understand that how many bits will be required in the encoder? Say yes or no. Will you be able to understand? Surely you will be able to understand. Okay, all fine. Let's see the encoder output, that how the output of the encoder will look like. So what they are saying, an encoder produces bit 1 when the applied voltage is plus 5. When the applied voltage is plus 5, it will produce the bit 1, and it will produce the bit 0 when the applied input is minus 5. Okay, when the applied input is plus 5, it will produce the bit 1. When the applied input is minus 5, it will produce the bit 0. For the given waveform, determine the output of the encoder. So this is your encoder, and this is your input. So at t equals to 0 second, what the encoder will see? Encoder will see that, sir, plus 5 is applied. If plus 5 is applied, I will give my output to be 1. At t equals to 1 second, what the encoder would see? Encoder would see that, sir, minus 5 is applied. I will give my output to be 0. At t equals to 2 second, what encoder would see? That, sir, plus 5 is applied. I will give my output to be 1. Then between 3 to 4, I will give my output to be 1. Okay. Then between 4 to 5, I will give my output to be 0. Between 5 to 6, I will give my output to be 1. Between 6 to 7, 0. 7 to 8, 0. And then again 1. Sir, why I made this opposite? Like why I made this in this direction? So what encoder will be doing? Encoder will be producing the output. Let's just say this is the encoder, and this is the input of the encoder. Okay. This is the input of the encoder, and this is the output of the encoder. So plus 5 came, 1 went out. Minus 5 came, 0 went out. So 1 went out, this 1 went out, then again 0 went out. So serially it is producing the output. Are you able to understand this point? Serially the outputs are being produced. That's why I wrote down in the opposite manner. This was the first output. This was delivered at t equals to 0 second. The next output was delivered at t equals to 1 second. This output was delivered at t equals to 2 seconds. This output was delivered at t equals to 3 seconds. This was delivered at t equals to 4 seconds. Are you able to understand this point? So serially it will be producing the output. No, like it's like from a room some guy is getting out. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So serially 9 guys will be getting out of it. From the room 9 guys will be getting out. So first guy would go, then second guy would go, then third guy would go. So the first guy would be way ahead, right? It will be in the front. So that's why I wrote in the opposite manner. So always I will be writing down in the opposite manner only, because from the encoder the outputs are getting out. Is that clear to you? So whenever you read from this direction. Okay. Although it is not important for the examination, in the examination it will not be written like this. They will give this theory, that's it. So when you solve the problem, you will solve in this manner, that 1 is getting out, 0 is getting out, 1 is getting out. And if you have studied the shift registers in digital electronics, then you would be able to understand more, right? Because there I gave the example as well, example of rooms, if you remember. Well and good. So this kind of output you will be getting. So at the input of the encoder, you give a voltage waveform, and output is being converted in terms of bits, in terms of 1 0 1 1 1 0 1 1 1. Right? At the input of the encoder, plus 5 volt was given, but at the output what you are getting, 1 0 1 1 0 1 0 0 1. This is the output that you are getting. Let's do it for this n equals to 2 bit. This is a small n, not capital N. Okay. So let's just say that when plus 5 volt is applied, it will be mapping it to 1 1. When plus 3 volt is applied, it will be mapping it to 1 0. And when minus 1 is applied, it will be mapping it to 0 1. Is that okay for you? This would be given, or you can take it on your own. Okay. So first plus 5 volt will be applied. So what will be the output? 1 1. Then plus 1 will be applied. Then what will be the output? Sir, 1 0. Or it would be 0 1, no? So 0 1, in that manner you write down. First 0 bit will go out, then 1 bit will go out. Don't care about that. Sir, 1 0 is a, sir, 1 0 would come or 0 1 would come. So first 0 bit will go out, then 1 bit will go out. So you will be getting confused. So better I will write down 0 0 here. Better I write down 0 0 here. Okay. Like this is not the matter of concern. The matter of concern is that some bits will be getting out. That's it. This is the matter of concern. When plus 5 volt was applied, 1 1 is getting out. Then when plus plus 1 is not even there. Okay, this is plus 1, this is plus 1. Okay, let's take this as plus 1. So when plus 1 is applied, you are getting 0 0. Then again plus 5 is applied, you will be getting 1 1. Then plus 3 is applied, then first 0 will go out, then 1 will go out. It is not a matter of concern. You can write down 1 0 as well. Here you can write down 1 0 as well. Okay, don't worry about that. First 0 will go going out, then 1 is going out, or you write down first 1 is going out, then 0 is going out. Don't worry about that. Then plus 5, that means again 1 1. Then what is this? 1, that means 0 0. Then what is this? 3, that means 0 1. And then this is again 1, that means 0 0. So this will be the output. So basically output is represented in terms of bits. But tell me one thing, this 1 1 was produced at t equals to 0 second. This 1 1 was produced at t equals to 0 second. This 0 0 was produced at t equals to 1 second. This 1 1 was produced at again t equals to 2 second. This 1 0 was produced at t equals to 3 second. This was produced at t equals to 4 second. This was produced at t equals to 5 second. This was produced at t equals to 6 second, and this was produced at t equals to 7 second. This is something very important. Why it is important, you will understand later on. But as of now, you just understand that when n was equals to 2, so it was producing 2 bits in the same time. Previously, it was producing 1 bit in 1 second, right? Between 0 to at 0 second, this bit 1 was produced. So at 1 second, this bit 0 is produced. At 2 second, this bit 1 is produced. That means in 1 second, only 1 bit is being produced. But here in 1 second, 2 bits are being produced. Very important thing. Why it is important, later on we will understand. And some formula we will be getting. But as of now, are you able to understand the meaning of encoder? Encoder is nothing. Encoder is just taking some voltage levels, plus 5, minus 5, plus 5, minus 5. It will take some voltage levels and it will give you an encoded output, encoded in terms of bits. Now it depends how many number of bits it will have to take. Okay, well and good. Now yeah, that's the thing that we will have to use 2 bits, 3 bits here and 3 bits here, right? Now you need to find out the value of n. So what I have done, here I am having a 3-level quantizer. What does that mean? That means at the output you will be having 3 kind of voltages. What I mean to say is that if you see this example of a quantizer, if you see this example of quantizer, what was the level? How many levels were there? 5 levels were there. If 5 levels were there, that means I was having 5 kind of output. This was a 5-level quantizer. Based on the input range, this was a 5-level quantizer. So at the output, I was having 5 kind of voltage. So if I am saying I am using a 3-level quantizer, that means at the output I will have 3 kind of voltages. It could be plus 1, 0 and minus 1. So how many bits you will have to use? 2 bits, right? Because 3 levels are there, so I will have to use 2 bits. Here 5-level quantizer I am using. That means I will have 5 kind of output. It could be plus 3, plus 1, plus 3, plus 1, 0, minus 1 and minus 3. So here you are having 5 kind of outputs. So for representing this 5 kind of output, how many bits you will have to use? 3 bits. For representing these 8 kind of outputs, how many bits you will have to use? 3 bits. For representing these L levels, how many bits you will have to use? Can I write down L is less than or equals to 2 to the power n? Do you agree to this thing or not? Here what is the value of L? Value of L is 5. 5 is less than 2 to the power 3, or it could be equal as well. But 5 is less than 2 to the power 3. Here what is the value of a level? That is 3. 3 is less than 2 to the power 2. Here what is the value of L? That is 8. 8 is equals to 2 to the power 3. So what do you understand? This n value is, so L is less than equals to 2 to the power n. Will you be able to remember this thing or not? L is less than or equals to 2 to the power n. People usually remember L is equals to 2 to the power n. Doesn't make any sense. L is less than or equals to 2 to the power n. If number of levels are 5, then how many bits you will have to use? 2 to the power 3 bits you will have to use. Sorry, number of bits you will have to use will be 3. But total combination you will have to use 8. Although out of these 8 combination, only 5 will be used. 3 combination will be wasted. But still, the minimum number of bits you have to use will be 3. So L would be always less than or equals to 2 to the power n. Okay. So always remember this thing. And very easily you will be able to remember. You will just think, okay, L equals to 5. That means 5 levels I am producing. How many bits I will have to use? 3. So 2 to the power 3 will be 8. So 5 is less than 8. That means L should be less than or equals to 2 to the power n. Very simple thing, very straightforward. Okay, very straightforward. All good, all fine. So L less than or equals to 2 to the power n. That another formula you have understood, where L represent the quantization, number of quantization levels. Number of quantization levels, and n represent number of bits. Okay, all good, all fine. Let's understand about line coder. So at the input of the line coder, what will be the input? The input of the line coder will be a bit stream. What I am calling it? Bit stream. And at a time only one bit would come. Like this bit stream will be at the input. At the input of the line coder, you will be having this bit stream, that 1 is coming, 0 0 is coming, 1 is coming, 0 1 0 0. These things are coming. Now line coder is having something in it that it can choose how many bits it will operate at a time. What I am saying, the line coder will be saying that I will operate only one bit at a time. That means no matter whatever the bit string is applied, this bit string has been applied to the input of the quantizer. So quantizer will say that I will consider only one bit at a time. That means first I will consider this bit, then I will consider this bit, then I will consider this bit, then I will consider this bit. So if it is considering one bit at a time, then the value of capital N is 1. That means it is considering one bit at a time. So at the input of the line coder, effectively either 1 would come or 0 would come. Is that okay for you? What I am saying? Line coder is saying that I will consider only one bit at a time. So effectively at a time either 1 would come or 0 would come. Now line coder will say that I will convert this 1 into plus 5 volt and I will convert this 0 into minus 5 volt. Is that clear to you or not? But it is not necessary that it will convert it into plus 5. It can convert it into plus 1 as well. And it can convert it into minus 1 as well. This is just an example I am telling. Or what can happen? It can convert it into plus 3 volt, let's just say, and it is converting this bit 1 into 0 volt only. It is representing bit 1 by plus 3 volt and it is representing 0 by 0 volt. It is representing 1 by plus 5 volt. It is representing 0 by minus 5 volt. For the case of capital N equals to 1, that means it is considering 1 bit at a time. What if it considers 2 bit at a time? Forget about this. Yeah. What if it considers 2 bit at a time? So what is the applied input? 1 1 0 0 0 1 0 0 1 1 1 0 0 0. So what it is doing? It is considering 2 bit at a time. So effectively at the input of the quantizer, what can come? 0 0 can come, 0 1 can come, 1 0 can come, and 1 1 can come. So how many outputs it can generate? It can generate 4 kind of outputs. What I am saying, it can generate 4 kind of outputs. Line coder is taking effectively 2 bits into the action. That means at a time it will consider 2 bits. So it is considering 0 0. So with respect to 0 0, the line coder can say that I will produce the output to be minus 3 volt. Then what will come? 1 0 would come. It will read it in the opposite direction, so it will read it as 0 1. So what is coming? 0 1 is coming. And now this line coder is saying that I will represent this 0 1 by minus 1 volt. Then what will come? 1 1 will come. It will say that I will represent this 1 1 by plus 3 volt. And then 1 0 would come. It will say that I will represent this 1 0 by 1 0 by plus 1 volt. So n is capital N is equals to 2. What does that mean? That means the line coder is considering 2 bit at a time. The line coder is considering 2 bit at a time. So if it is considering 2 bit at a time, how many kind of symbols it is generating? 4 symbols. These are known as symbols. These are also symbols only. When it was considering 1 bit at a time, how many symbols it was generating? 2 symbols. This is known as symbol. Okay, 2 symbols. 2 symbols. 2 symbols. Okay, and now how many symbols it is generating? 4 symbols it is generating. 4 symbols it is generating. So when n was equals to 2, it is generating 4 symbols. When n is equals to 3, how many symbols it will generate? So it will take 3 bits at a time. It will take 3 bits at a time. So 0 0 0, it can take 0 1 0, it can take 0 0 1, it can take 0 1 0, it can take 0 1 1, it can take 1 0 0, it can take 1 0 1, it can take 1 1 0, it can take 1 1 1. Let's just say this it is representing by plus 4 volt. Okay, this it is representing by plus 3 volt, this it is representing by plus 2 volt, this it is representing by plus 1 volt, this is representing by minus 1 volt, this it is representing by minus 2 volt, this it is representing by minus 3 volt, and this it is representing by minus 4 volt. How many symbols are there? 8 symbols are there. Okay, so if it is generating 4 symbols, then it is known as 4 array scheme. Okay, if it is generating 8 symbols, then it is known as 8 array scheme. If it is generating 2 symbols, then it is known as binary scheme. Okay, so for here what is written? Number of symbols generated. If I am saying that number of symbols generated are capital M, what I am saying? Number of symbols generated are capital M. What does that mean? That means I am using M array scheme. M array scheme. And the code word length. What is the meaning of code word length? Here the code word length will be 3. This capital N is the code word length. So code word length is N. So what will be the relation between M and N? So M will be equals to 2 to the power N, and N will be equals to log 2M. Do you agree to this point or not? If it is taking 3 bit at a time, then it can generate 8 symbols. That means it will be known as 8 array scheme. If it is taking 2 bits at a time, then it can generate 4 symbols. It is known as 4 array scheme. Value of N capital N was 2. Value of capital N was 3. 3 symbols, sorry, code word length is 3, then 8 array scheme. Code word length is 2, then 4 array scheme. Code word length is 1, code word length is 1, then 2 array scheme. Okay, so if M array scheme is there, that means code word length is capital N. So what will be the relation between capital M and capital N? That would be M equals to 2 to the power N. So in your brain, the diagram should be clear. No formula you will mug up. If the diagram is clear, everything is clear. Code word length. Okay, code word length, it will take 1 bit at a time. It can generate 2 symbols. Binary scheme. Code word length is 2. It can generate 4 symbols. 4 array scheme. Code word length is 3. It can generate 8 symbols. That means 8 array scheme. Okay. Now there will be somewhat written NRZ scheme. Okay, in some questions you will see NRZ rectangular pulse it will generate. What you will see, the line coder is generating NRZ rectangular pulse, or it can say the line coder is generating RZ rectangular pulse. What is the meaning of RZ? What is the meaning of NRZ? So NRZ means non return to 0. Okay, what does NRZ mean? Non return to 0, and RZ means return to 0. So if I say in NRZ scheme 1 is represented, bit 1 is represented by plus 5 volt, then bit 0 will be represented by, then your bit 0 will be represented by minus 5 volt. Okay, because it is non return to 0, it is not returning to 0. From plus 5 to it is going to minus 5. Okay, and what does this return to 0 means? Return to 0 means if bit 1 is represented by plus 5, then bit 0 will be represented by 0. So sir, only these two kind of schemes are possible, NRZ and RZ? No, any kind of scheme is possible. This line coder can say that, sir, I will represent 1 by this graph and I will represent 0 by this graph. This can also happen, but these are famous names. If it is representing 1 by this graph and 0 by this graph, then it will be mentioned in the question that it is representing 1 by this graph and 0 by this graph. It will be mentioned in the question. But in the question, if they are saying NRZ rectangular pulse, it will generate. So on your own, it should click to you NRZ non return to 0. Then 1 is plus 5 and bit 0 is minus 5. Now this minus 5 is also not important. Better I should write down plus A volt, plus A and minus A. Okay, here I will write down plus A and 0, plus A and 0. So value could be anything, but this will be bipolar. That means plus A and minus A, but this will be unipolar, plus A and 0. Okay, here negative sign would not come. So because these are the famous names, no, that's why I am saying NRZ, RZ. And mostly in the question they will not use directly NRZ or RZ. They will mention that with respect to bit 1 this kind of pulse is transmitted, with respect to bit 0 this kind of pulse is transmitted. Most probably this will be mentioned. Anything can happen. No, what it can say? It can say that, sir, for bit 1 I will produce this kind of sinusoid wave. For bit 1 I will produce this kind of a sinusoid wave, and for bit 0 I will produce 0 only. For bit 0 I will produce 0 only. This can also happen. So if these kind of things are happening, they will mention it, that your line coder is generating this kind of sinusoid wave for bit 1, and for bit 0 it is generating 0 volt. So it will be mentioned. But in some of the older question you would see that they have directly mentioned NRZ rectangular pulse this line coder is generating. So it should be known plus 5, minus 5, return to 0, plus 5 and 0. Okay. So let's draw the output of the line coder. Now I have mentioned bit interval is equals to 2 seconds. What does this bit interval mean? That means this bit is there for 2 seconds. This bit is also there for 2 seconds. This bit is also there for 2 seconds. That means this bit 1 is there between 0 to 2 seconds. This bit 0 is there between 2 to 4 seconds. This bit 1 is there between 4 to 6 seconds. This bit 1 will be there between 6 to 8 seconds. This is the meaning of bit interval. Is that okay for you? Bit interval I am representing by TB. Bit interval is 2 seconds. That means at the input of this NRZ line coder, for the first 2 seconds bit 1 is coming. So if bit 1 is represented NRZ non return to 0, that means plus 5 and minus 5. So I am saying that bit 1 is represented by plus 5. Okay, plus A I am saying, and bit 0 is represented by minus A. So at the input of the line coder, at t equals to 0, bit 1 will come. So what it will do, it will generate plus A voltage. It will generate a pulse of plus A voltage. But what would be the duration of this pulse? So this bit 1 was there for 2 seconds, so duration of this pulse will also be 2 seconds. Then this bit 0 was there for 2 seconds, then after that it started at t equals to 0, then it will end at t equals to 2. Then next bit is 0, next bit is 0. So it will generate a pulse of minus A volt. It will generate a pulse of minus A volt. What will be this duration? This duration will again be 2 seconds. But this bit 0 is coming into action at t equals to 2 seconds. And this will be there till t equals to 4 seconds. Then at t equals to 4 seconds, again bit 1 came into action. And it is considering 1 bit at a time, right? So at t equals to 4 seconds, again this bit 1 came into action. That means it will generate plus A. So basically what this line coder is doing, it is generating a pulses. The bit 1 came, sorry guys, yeah. Bit 1 came, it generated a pulse of 2 seconds. Then bit 0 came, it generated a pulse of 2 seconds. Bit 1 came, it generated a pulse of plus A amplitude for 2 seconds. Then again bit 1 will come, it will again generate a pulse. So it is sending pulses, right? Are you able to understand this point? From the line coder, what will get out? One pulse will get out, then another pulse will get out, then another pulse will get out. So it's not like a time domain signal, it is like a pulses. This line coder will be throwing out the pulses. And if you remember the first page, there I said ST signal, pulses, these are these pulses only. Although we will understand, we will put all the blocks together. When we put all the blocks together, you will understand what is actually happening. But are you able to understand the last block? This last block is generating some pulses. This bit interval is very important. This pulse will also be there for 2 seconds. Then the next pulse will also be there for 2 seconds. So started at 0, 2 seconds, then from 2 to 4, then 4 to 6, then 6 to 8 plus A. This is also 2 seconds. Then 8 to 10 and so on. In that manner it is generating the pulse. So this kind of output you will get. So at the output I cannot make a time domain signal. I will just tell that pulses are generated. Plus A volt, minus A volt, plus A volt, plus A volt. These kind of pulses are generated. Is that okay for you? Okay. So this is your line coder. It is taking 1 bit at a time. So whatever the bit interval was there, this is known as symbol time duration, TS. So here symbol time duration is equals to the bit rate. Sorry, not bit rate, bit interval. Symbol time duration is equals to the bit interval. So you can say symbol duration is equals to a bit interval. These are the symbols only, no? These are the symbols. So it is generating two kind of symbols. If I am calling this as S1T, I can call this as S2T. So first it will generate S1T, then it will generate S2T, then it will again generate S1T, again it will generate S1T, then it will generate S2T, then again it will generate S1T, then S2T, then again S2T, then S1T. This I will call as S1T. So two kind of symbols are there, S1T and S2T. So this was actually your S1T and this was your actually your S2T. Here TS is equals to TB, but I should not keep it in the box. In this case, TS is equals to TB. This symbol duration is equals to the bit interval. But if it is taking 2 bit at a time, if it is taking 2 bit at a time, so 1 bit is coming for, let's just say bit interval TB is equals to 2 seconds. Again this interval is 2 seconds. So 1 bit is coming for 2 seconds. Okay, listen to my words very carefully, very important point. 1 bit is coming for 2 seconds. But what this line coder will say, I will take 2 bits into action. That means it will be taking 0 and 0. These 2 bits into action. This bit is coming for 2 seconds. That means it is coming from 0 to 2 seconds. And this bit is also coming for 2 seconds. That means it is coming from 2 seconds to 4 seconds. And both of these bits combined will be mapped to minus 3 volt. That means you will be getting a pulse of minus 3 volt for how much duration? For 4 seconds, no? That means this minus 3 volt will be there for 2 TB interval. And this is equals to your symbol interval or symbol duration. So here your symbol duration is equals to 2 TB. Again think about it, use your brain. Bits are coming, every bit is coming after every 2 seconds. Every bit is coming after every 2 seconds. This bit came, next bit will come at 2 seconds. That means 00 bits are there for 4 seconds. These 00 bits are there for 4 seconds. Now what line coder will say? I will take 2 bits into action. And with respect to this 00 bit, I am generating a voltage of -3 volt. I am generating a pulse of -3 volt. So these 2 bits were there for 2 TB duration, or you can say for 4 seconds. That means the symbol duration will be equal to 2 TB. In the previous case, the symbol duration was equal to TB because n was equal to 1. Now the symbol duration is becoming equal to 2 TB. And if n is equal to capital N, then the symbol duration would become equal to n TB. In this example, what will happen? Bit interval. What is the meaning of bit interval? What is the meaning of this bit interval? What is the meaning of this bit interval? I will write down. The meaning of bit interval is 1 bit is there for how much second? 1 bit is there for how much second? So bit interval is TB, that means bit 0 is there for TB second, again bit 0 is there for TB second. Line coder is considering 2 bit at a time. That means it is having a window of 4 seconds, no? So it will generate a pulse of 4 seconds, or you can say a pulse of 2 TB second. In this case, if I say the bit duration is 3 seconds, let's just say the bit duration is 3 seconds. That means bit 1 is there for 3 seconds, bit 0 will be there for another 3 seconds, bit 1 will be there for another 3 seconds. Now this line coder is saying that I will take 3 bits into action all together. So this was there for 3 seconds, this was there for 3 seconds, and this was there for 3 seconds. So total 9 seconds. So it will generate a pulse of 9 seconds. With respect to 101, it is generating a pulse of -2 volt. It is generating a pulse of -2 volt. For how much second? For 9 seconds. So your symbol duration, TS. What is TS? TS is the symbol duration. TS is known as symbol duration. Is becoming equals to 2 TB. That's why here in this case, if you remember in this case when we were studying about sampling, so there I wrote down NTSA. Why TSA? Because people will be getting confused between this TS and the other TS. But this TS and the other TS has no relation. This is different TS, the other TS is different. That is the symbol duration, and this is the sampling time period. Both are different. That's why I am putting this as TSA, sampling time period, and that is the symbol duration. This is your symbol duration. So TS is equals to NTB, another important formula we are getting. Okay. So you understand the meaning of bit interval as well. You understand the meaning of a symbol duration as well. Everything is clear. So should I explain it again, or let's first see what all things I can remove. This thing could be there. These things I can remove. And this point is also clear to you. So everything is clear to you. So we will put everything together, but let me summarize whatever that we have studied in this 1.1 hour and 15 minutes. So what we have studied, started with sampling. It will be doing the sampling in the time domain, right? At every time instant it will be taking a sample, then it will be holding it till the next time instant. Quantization is related with the amplitude. It will define some particular levels. Whatever the input range is there, it will have a certain step size. If it is fixed, it is known as uniform. If it is not fixed, it is known as non-uniform. Okay, so if it is having a fixed step size, that means it will take a certain intervals, or you can call it certain levels, and in those levels it will map whatever the values are coming to a certain particular value. From -5 to -3 is mapped to -4. So this is the meaning of quantizer, right? and we have understood these formulas. We understood the meaning of uniform and non-uniform quantizer as well. Then we studied about encoder. At the input of the encoder, this small n and the capital N, this small n and this capital N, which capital N? This capital N, they are having no relation, okay? This capital N and this small n, they are having no relation, okay? No relation between capital N and small n, no relation, okay? So what this encoder was doing? This encoder, at the input of the encoder, some voltage levels would come. That would come from quantizer only. So some voltage level would come. What the encoder will do? At a time, only one voltage level would come. It will it will map these levels to particular bits. If plus 2.5 volt is coming, it is mapping it to 1, and if minus 2.5 volt is coming, it is mapping it to 0. Same goes, then this kind of output we are getting. If levels are 3, then I will have to use 2 bits. If levels are 4, then also I will have to use 2 bits. If levels are 5, I will have to use 3 bits. If levels are 8, I will have to use 3 bits. So from there I got a formula of L is less than equals to 2 to the power n. Then coming to the line coder, what line coder would do? Line coder will consider some bits at a time. So at the input of the line coder, you will get a bit stream. So input of the line coder will be a bit stream. Line coder is saying that I am considering one bit at a time. What does that mean? That means it will take into action one bit. It could be bit 1 or it could be bit 0. Bit 1 is represented by plus 5, bit 0 could be represented by minus 5. If it is an RZ scheme, that means non return to zeros, plus 5, minus 5. If it is RZ scheme, then plus 5 and 0. Okay, it can take 2 bits into action as well. If it is taking 2 bits into action at a time, if it is taking 2 bits into action at a time, that means effectively it can have 4 combinations: 0 0, 0 1, 1 0, 1 1. So 4 combinations it is having. So with respect to 0 0, it can produce plus a. With respect to this is the example of n equals to 1 bit only. This is the example of n equals to 2 bits. So with respect to 0 0, it can generate minus 3. With respect to 0 1, it can generate minus 1. With respect to 1 1, it can generate plus 3. And with respect to 1 0, it can generate plus 1. Now what is the relation between symbol duration and the bit duration or bit interval? So what is the meaning of bit interval? For how much duration one bit is there into the action. For how much duration one bit is there into the action. Now if the line coder is taking 2 bits into the action at a time, together if it is taking 2 bits into the action, what does that mean? That means it will take 2 plus 2, 4 seconds, or you can say TB plus TB, 2 TB seconds. So symbol duration would become 2 TB. So TS would be equal to 2 TB. And if it is taking n bit at a time, then the symbol duration will become n TB. Okay. And based on the number of symbols it generates, the scheme is known as M array scheme. If it is generating 8 symbols, it is known as 8 array scheme. If it is generating 4 symbols, it is known as 4 array scheme. If it is generating 2 symbols, then it is known as 2 array scheme. Okay. Well and good. So what is the relation between capital M and small and capital M and capital N? So capital M would be equals to 2 to the power n. You know, you don't need to mug it up. Very easily you can write down this formula. Okay. So this is all about our 4 blocks: sampler, quantizer, encoder and line coder. All good, all fine. Now we will put it all together. First we will pass this particular signal is there, empty is there. I will pass it to the sampler. I will see what output I will get. Then I will pass it to the quantizer, and in that manner we will proceed. Let's see what kind of output we will get, and just we need to put it all together and we will see what we are actually transmitting. Okay, the transmitter block is completed. We will just see that what we are actually transmitting. This was my message signal, but how it will be transmitted? It will be transmitted in terms of pulses, that I already know, because I know that channel can only take pulses. Channel can only take pulses. So it will be transmitted as a pulses, and it has been certain here as well. Why is that so? Because I know that last block will be line coder and the output of the line coder is nothing but pulses only. So let's put it all together and see what do we get at the output. Okay. But let me pause the video, drink some water, and then we will come back and we will analyze it again. Now you can do the analysis on your own, because everything you know everything about every single block. Okay. Yeah. So let me pause the video and then I will come back. Yeah, welcome back guys. So we need to put it all together, right? So sampler would be there, quantizer would be there, encoder would be there, and line coder would be there. We will put it all together and we will see what is the final output that we are getting, and then we will see the receiver block, right? So you know how to do the sampling. What is the sampling frequency here? Sampling frequency is given as 0.5 hertz. So what will be the sampling time period? Just reciprocal of that. I hope you know these much basic thing. Okay, sampling time period. This much basic you might have studied in your signal system. So sampling time period, that I will be denoting by TSA, because there will be something called symbol duration. So symbol duration and sampling time period both are separate things. Just you take the reciprocal, it would be 2 seconds. That means after every 2 seconds you will be collecting the sample. So let's just say first sample I am calculating at 0. Then second sample I will be calculating at t equals to 2 seconds. Then at t equals to 4 seconds. Then at t equals to 6 seconds. Then at t equals to 8. Then at t equals to 10. Then at t equals to 12. Then 14. In that manner I will keep on calculating the sample, right? So value of first sample will be 0. Then this sample value would be, this time would be 6. So this sample value will be 2. Then this sample value will be 4. Then this sample value will be 6. Then again 4. Then 2. Then 0. Then minus 2. Minus 4. Minus 6. Minus 2. Minus 4. Minus 6. Right? So these samples value we will calculate. I hope that is clear to you. So what kind of waveform you will get? This kind of waveform you will get. But actually we are using sample and hold circuit. So you sampled 0 value at t equals to 0, but it will be holding till t equals to 2 seconds. Then you sampled 2 value at t equals to 2, but it will be holding till t equals to 4 seconds, right? So sample and hold would be there. Sampled 4 value is sampled and it will be holding. Sampled and hold, and then next value sampled is 4, sampled and hold, sampled again and then hold, then again sampled, sampled value is 0, then again hold, again sampled, again hold. Now next what we are using? We are using a quantizer. Quantizer with the step size of 1.6 and the minimum threshold is there at minus 6 volt. So minimum threshold is there at minus 6 volt. So you can make this particular line that I have already made. Which line? This particular line you can already make, because what is the maximum value? Maximum value is 6, and what is the minimum value? Minus 6. So what is the dynamic range? Dynamic range is there from minus 6 to plus 6, right? Now the step size is 1.6. That means starting from minus 6 plus 1.6 plus 1.6 plus 1.6 plus 1.6. So these are your levels. Now what we will use? We will use the midpoint mapping. So values between minus 6 and minus 4.4, where that will be mapped? The step size is 1.6. So minus 6 plus 0.8. So it will be mapped at, where it will be mapped? It will be mapped at minus 5.2. Just the midpoint, right? Then it will be mapped at 2.8 plus 0.8, that would be minus 3.6. Then in that manner you know that where all the values will be mapped, right? This will be minus 2. Where it will be mapped? This will be minus 0.4. This will be 1.2. This will be mapped at 2.8. This will be mapped at 4.4, and this will be mapped at 6, right? So 0 value, 0, where will be 0? Here 0 will be there. No, 0 will be on this side. So 0 value will be mapped at minus 0.4, right? Then 2 value will lie in which range? 2 value will lie in this range. So 2 will be mapped at 2.8. Then 4. Actually someone will say that sir 2 is at the boundary, right? 2 is at the boundary. So sir I don't know where it will be mapped. So for the boundary we usually take the next one. Okay, 2 is at the boundary. No, I am asking where 2 will be mapped. But you are saying that sir 2 is at the boundary. So I cannot tell where it will be mapped. So someone will say that sir I will map it to 1.2. Someone will say that sir I will map it to 2.8. So it will be mentioned in the problem that where boundaries value should be mapped. But we are taking that it will be mapped to 2.8. Okay, whatever that is there at the boundary, which is not particularly defined. So 2 will lie either in this level or it can lie in this level. So it will be mentioned in the problem. I am saying that it is lying in this level. So I will map value 2 with 2.8. Then I will map value 4 with 4.4. Then I will map value 6 with 6 only. Then again in this manner I will map the values. So this kind of waveform we will get. 0 maps to minus 0.4, then 2.8, 4.4, 6, 4.4, 2.8. In that manner values are mapped. Now it will be fed to the encoder. So encoder will receive how many kind of level, how many kind of voltages. Encoder can receive minus 0.4, encoder can receive 2.8, encoder can receive 4.4, it can receive 6, it can receive minus 2, it can receive minus 3.6, it can receive minus 5.2. Basically, how many levels were there? 1, 2, 3, 4, 5, 6, 7, 8. So 8 kind of inputs could be there at the encoder. But at a time only one voltage would come, right? Between 0 to 2 second only 0.4 would come. Between 0 to 2 second only minus 0.4 would come. Between 2 to 4 second only 2.8 would come. Between 4 to 6 second only 4.4 will come. But it will have 8 kind of input. It will have 8 levels. So for defining 8 levels, how many bits will be required? 3 bits will be required. So what it can do is that it can put minus 5.2 as 0, 0, 0, minus 3.6 as 0, 0, 1, minus 2 as 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. So now when minus 0.4 would come, so what will be the output it will give? 0, 1, 1. So 0, 1, 1. Because it will generate the output serially. So first it will throw 0, then it will throw 1, then it will throw 1. So I am writing down in this direction. Next what will come? Next 2.8 would come. So 2.8 it will throw 1, 0, 1. Next what will come? 4.4 would come. It will throw 1, 1, 0. Next what will come? 6 will come. So it will throw 1, 1, 1. So in that manner it will keep on generating the bits. So here number of bits required were 3. Right? Now let's see something interesting. Now these 3 bits were generated in how much time? These three bit which are 0, 1, 1, 0, 1, 1 are corresponding to this minus 0.4, and this minus 0.4 voltage is there for 2 seconds. This window is 2 seconds, and this is equals to your sampling time period. Basically, how did we start? First it was sampled, then every sampled value was being defined with respect to a particular level. Every sampled value, whatever the values that you are getting here, every sampled value was defined with respect to a particular level, and the time window for every sampled value, was 2 seconds, which is equals to the sampling time period. Do you agree to this point? Right? Now with respect to the every quantized value, now this is your quantized value, this was your sampled value, every sampled value was quantized. Now with respect to every quantized value, what you are delivering? You are delivering some bits. Now how many bits you will deliver? That depends on this n. From here, from this scenario, I will get to know that my small n is equals to 3. That means with respect to minus 0.4, I am delivering 3 bits, and these 3 bits are getting a window of 2 seconds. Right? So one bit will get how much window? This 0 bit will get how much window? 3 bits are being generated. Let's just say there is a source. Let's just assume I am having 3 cricket balls in my hand. So what I am doing, I am throwing the balls serially. So one ball I am throwing, second ball I am throwing, and 3 ball I am throwing. Then the third ball I am throwing. So I am saying that I have thrown these 3 balls in 4 seconds. That means for throwing one ball, how much time I took? 3 balls have been thrown in 4 seconds. So for throwing one ball, how much time I took? 4 by 3 seconds. Similarly, this source, this encoder needs to generate 3 bits in 2 seconds. That means 1 bit was generated in how much time? 2 by 3 seconds. Are you able to understand this point? And what this 2 by 3 second would be known as? This 2 by 3 second would be known as bit interval, right? What it would be known as? Bit interval. So bit interval is not defined like, sir, for 3 bits. No, bit interval will always be defined for 1 bit. That 1 bit is generated for how much time? 2 by 3 seconds. So bit interval here is equals to 2 by 3 second. And what was your sampling time period? What I should do is that I should put it down here. This was your output. I'm just keeping it in a box. Fine. And then I'm writing this particular thing. TB is the bit interval. And what was your TSA, sampling time period? That was equals to 2 seconds. So can I write down a relation that your sampling time period or I can write down your bit interval would be equals to sampling time period divided by n. Is that okay for you or not? Your bit interval is equals to sampling time period divided by n. Because what is your sampling time period? It is the time for which one sample will be generated. One sample will be generated. It is the time for which one sample is generated. Now each sample will be quantized and that will be thrown to the encoder. Each sample will be quantized and it will be applied as an input to the encoder. Now encoder has to see the number of levels. Based on the number of levels, it will decide how many bits I need to use. Now let's just say my encoder is using n bits. Okay. So in TSA second, it will generate n bits. So one bit will be generated in how much time? TSA by n. N bits are generated in TSA second. So one bit will be generated in TSA by n seconds. And one bit is generated in how much time? What that is known as? That is known as bit interval. So this I showed by these notation and here I showed it by the example. A very, very important formula is coming. TSA by n is equals to TB, but we will not remember in this manner. We will remember in some other manner. So if I just take the reciprocal here, 1 by TB. If I just take the reciprocal, that would become 1 by TB and here it would become n by, what I am doing, I am just taking the reciprocal. 2 is equals to 2. Array, 2 is equals to 2. So can I do the reciprocal on both of the side? Yeah. 1 by 2 would be equals to 1 by 2 as well. So TB is equals to TSA by n. So can I do 1 by TB equals to 1 by TSA? Now 1 by TB is known as RB. Okay. 1 by TB is known as RB. And 1 by TSA you already know, that is FS. What is this RB? This RB is known as bit rate. Okay. Bit rate. So it should be always there in your mind, RB equals to NFS. RB equals to NFS. But how this formula came, that should also be there in your mind, because I will frame some problem where this formula might not work. Because I told you one thing, this encoder will generate the bits serially. Encoder is generating the bits serially. That means if it needs to generate 3 bit, then it will generate 1 bit, then second bit and third bit. So this encoder needed to generate 3 bits in 2 seconds. 3 bits in 2 seconds. Right? So 2 by 3 second for 1 bit, 2 by 3 second for the other bit, and 2 by 3 second for the third bit. So 1 bit was getting 2 by 3 second. So here your bit interval was 2 by 3 second. And if you need to find out the bit rate, then just take the reciprocal. So RB equals to NFS. This is you need to remember. Don't remember this one, TB equals to TSA by n, nothing. RB equals to NFS. But mark this thing, encoder is generating serial output. Very, very important thing. By default, it will always generate a serial output. But in the problem, if I write down specifically that it is generating parallel output, then the scenes will be different. Now, sir, what is this parallel output? We will talk about it. But if you have studied shift register in digital electronics, then you already know there are two kinds of output, serial output and parallel output. So there has been one gate question in instrumentation question paper. There the output was generated parallelly. From the encoder only, output was generated parallelly, not serially. So there this RB equals to NFS was not working. There you had to think. So we will see that question. But always remember RB equals to NFS in case of digital communication system by default. Unless they are mentioning parallel output. But here output is serial. Okay. And the concept is also clear. RB equals to NFS, how it came, that is also clear. Right. So let's go to the next block. What will be the next block? Next block will be line coder. Now line encoder is fed with this input, right? Because this is the output of the encoder. Now whatever the output of the encoder is there, that will be fed to the input of the line encoder, right? Now input of the, now what line encoder would do? Line encoder is saying that I will consider one bit at a time. Now there is no relation in this capital N and small n, okay? It's not that, sir, if it was generating 3 bit at a time, so it should consider 3 bit at a time. No. Line encoder is separate, this guy is separate, okay? There is no relation. Now what will be the output of the line encoder? First, what it is doing, it is considering one bit at a time. So first 0 bit will come. If 0 bit is coming, then what it will generate? Return to 0. Return to 0 line encoder it is. So for bit 1, what it will generate? It will generate 0 output. For again, what is coming? Again, bit 1 is coming. For bit 0, it is generating 0 volt output. For bit 1, it will generate 5 volt output. Then again, bit 1 is coming, then it will generate 5 volt output. Now, for how much time this bit was there? For TB duration, right? For how much time this bit was there? For TB duration. How much time this bit was there? TB duration. Let's just say operation started at t equals to 0. Operation started at t equals to 0. So what will be the length of this particular thing? From 0 to TB. What will be the length of this particular thing? That means this pulse will be generated for TB time interval. This pulse will also be generated for TB time interval, and this pulse will also be generated for TB time interval. But operation started at t equals to 0. So from 0 to TB, 0 volt will be generated. From TB to 2 TB, 5 volt will be generated. From 2 TB to 3 TB, again 5 volt will be generated. Then from 3 TB to 4 TB, again 5 volt will be generated. 3 TB to 4 TB, again 5 volt will be generated. Then between 4 TB to 5 TB, 0 volt will be generated. So in that manner, what it is doing? It is throwing some pulses, right? 0 volt pulse, then 5 volt pulse, 5 volt pulse, 5 volt pulse, then again 0 volt pulse. So for every TB duration, it is throwing some pulses, right? Now, and do you remember another thing? What do you remember? If it was taking 2 bit at a time, if it was, and how many symbols are there? Let me know how many symbols it is generating. Sir, 1, 2, 3, 4, 5. 5 symbols it is generating. No, it is generating only 2 kind of symbols. No, 5 volt or 0. 5 volt or 0. So this is your 2 array scheme, right? No one will say, sir, that sir, it is 5 array scheme. No, 5 array, it is not 5 array. If it is taking 1 bit at a time, that means either it will take 0 or it will take 1. So with respect to 0, it is generating 0 volt. With respect to 1, it is generating 5 volt. So only 2 kind of symbol it is generating. So what it is? It is your 2 array scheme, right? It is 2 array scheme only. But if it was m array scheme, then complete theory I have given. What all things we developed for m array scheme? For m array scheme, we got to know that m is equals to 2 to the power capital N, right? Along with that, there is something called symbol duration. What? Symbol duration. Symbol duration. Ts is equals to what? N into TB. N into bit duration. Why is that so? Let's just say it was taking 2 bit at a time. That means n value would have been 2. If it was taking 2 bit at a time, that means if with respect to 1 0, let's just say it is generating plus 3 volt. Then for how much time it would have generated it? For 2 TB time. What I am saying, if it was taking 2 bit at a time, that means it would have generated a symbol with respect to 1 0. Here it has generated only 2 symbols, but if n was equals to 2, then it would have generated 4 symbols. Now with respect to 1 0, generated symbol is plus 3 volt. So this plus 3 volt would be there for 2 TB time, right? TB for this one, TB for this one. So this would have been there for 2 TB time. And if it is taking n bit into action at a time, if it is taking n bit into action at a time, then your symbol duration will be equals to n into TB, right? So this also we have already seen. Complete good enough time I have already spent on this formula, Ts equals to n TB. Okay, usually people will mug it up, but we are doing our level best to understand the formula. Here also I can do the same thing. 1 by Ts is equals to 1 by n TB. right? Just I am taking the reciprocal. So 1 by Ts would be Rs, 1 by Tb would be Rb. Rb is bit rate. What is Rs? Symbol rate. Okay. So Rs is known as symbol rate, or other name is baud rate. Okay. Sometimes they call it baud rate. Baud rate. Okay. Symbol rate or baud rate. So either you remember Rs equals to Rb by N, or you remember Ts equals to Ntb. But don't mug up. Things should be clear in your mind that what is happening. Rb equals to NFS. If it is there, if it is stuck in your mind, it is fine. Rb equals to NFS. Okay. And how this formula came, that should also be clear to you. Sir, one sample was generated for 2 seconds. Now now small n was 3. That means for one quantized value, I need to use 3 bits. For one quantized value, I need to use 3 bits. That means in 2 seconds, I will be generating 3 bits. That means 1 bit will be there for 2 by 3 seconds. That means sampling time period divided by the number of bits. So TSA divided by small n would be equals to TB. So RB equals to NFS. So RB equals to NFS should be there in your mind. Now Rs equals to NRB. No, RB by N. But again, if you mug up, you may mess it up. But if you remember the concept, okay, capital N, if it is taking 3 bit into action at a time, 3 bit into action at a time, what does that mean? That means the symbol duration will be equals to 3TB. That means TS is equals to NTB. From there, I can derive Rs equals to RB by N. Okay, usually these formulas are just written. In a lot of notes, you would just find out that this is the formula, that's it. But the concept should be clear so that in digital communication, you will never feel that we are mugging up the things. Hardly 3 to 4 formula I will ask you to remember, and with those 3 to 4 formula, you will be able to solve all the questions. So we are not going to mug up the digital communication, okay? We are going to understand it. So let's give a quick review that what all things are happening. Empty was there, it was sampled, then we got a sample time domain signal which was fed to the quantizer. It gave you a quantized output. Then it was fed to a encoder. Encoder was using some number of bits. Then it gave you some bit output like this. Some bit output like this. Okay. So each bit was having some duration TB. So from here we got the relation RB equals to NFS. Right. So this formula we got to know. And this sampler was having a sampling frequency of Fs. The sampler was having a sampling frequency of Fs. Now this line coder was having something called capital N. This is known as code word length, and this small n is known as number of bits. I hope you know all these kind of things. RB is bit rate, Fs is sampling frequency, small n number of bits, capital N code word length, right? So now it is taking n bit into action. What it is doing? It is taking n bit into action and it is generating some pulses. These pulses are known as symbols, right? It can generate any kind of pulses. So it will generate some pulses. These pulses are known as symbols, right? Now what will be the symbol duration? So symbol duration Ts would be equals to, for this only I am writing down the formula. So symbol duration would be equals to NTB, right? Ts equals to NTB, because it is more intuitive, right? Ts equals to NTB, you can easily remember it. Symbol duration, okay, the symbol duration, number of bits taken. So Ts equals to NTB. From here, if someone asks you symbol rate, that would be RB by N. RB by N. Okay, and then it will be fed to the channel, and then there will be receiver. So we did not study about receiver block, but this was our transmitter block. Although we need to study in depth about sampling, we need to study in depth about quantization. Whatever that you need to study about encoder, that you have already studied. Whatever that you need to study about line coder, that you have already studied. But in depth discussion of these blocks are required, that we are going to see. And then it will be then it will be fed to the channel, and then it will be taken by the receiver. Okay, so this is a quick review. Now these pulses are generated, right? What is being generated by the line coder? Pulses are being generated, and these pulses will be carried by the channel and it will be fed to the receiver. So pulses are being generated. Now how these pulses were generated? Empty came and it was coded. It was encoded as bits, and if it was encoded as bits, and then the pulses are generated. So pulse was coded. Okay, pulse was generated, it was coded, and your empty signal has been modulated into, what I am saying, your empty signal has been modulated into pulses. Basically, if you are changing the property of any signal, that is known as modulation. That's it. Changing the property of any signal is known as modulation. So empty was a time domain signal which has been converted into pulses, or you can say empty was modulated into the pulses. So there is a modulation as well. So this particular scheme is known as pulse code modulation. Pulse coded modulation. So whatever that we studied till now, that was known as pulse code modulation. Okay, pulse code modulation. So this is your PCM scheme. Although names are not important, but in the questions if it is written PCM scheme. So what is the meaning of PCM scheme? Pulse code modulation. Okay, PCM means pulse code modulation. Somewhere you can write down, although this page is completely filled. So you can write down here, PCM full form is pulse code modulation. Why it is known as pulse code modulation? Because empty was coded as bits and bits were converted into pulses. So empty was effectively modulated, which was a time domain signal. Empty being a time domain signal has been modulated into pulses. So this is known as pulse code modulation. Okay, so every concept, every single block diagram is clear to you. Let's see some questions now. Okay, very simple question. Now, if you have just a basic idea of sampling, then you would know what is Nyquist rate. So Nyquist rate, Fs, what is the meaning of Nyquist rate? Nyquist rate is simply 2 into Fm. Nyquist rate is nothing. What is Nyquist rate? Nyquist rate is 2 into maximum frequency component of signal. That is your Nyquist rate. Okay. Now what they are saying, the signal is sampled. What is the maximum frequency component? Here maximum frequency component is 4 kilohertz. What is the meaning of band limited? Let's just say my MT was having a frequency response of somewhat like this. It was having a frequency response of somewhat like this. Okay, this was the frequency response. It was going till infinity. Here it was going till minus infinity. Now you know that most of the information is contained here only. Here very less information is there. Here also very less information is there. So what I will do? I will apply a low pass filter. Actually here when you see this block, MT is not directly fed. First you will check the frequency response of MT. You got to know that it is spread till infinity. But I don't want to process this much of frequencies. If I want to process from 0 to infinity, that means I need to process infinite frequencies. That means I would require a very high speed circuit, which is very tough to design. Then I got to know that most of the information is contained here only. So what I would do, I will apply a low pass filter and I will cancel all these frequencies. That means I have band limited my M of t, or you can say M of f or M of t. That means my frequency response of MT, or you can say frequency spectrum of MT has been band limited. So if it is band limited, then what kind of frequency spectrum you will get? This kind of frequency spectrum you will get. And here the maximum frequency component is 4 kilohertz. This is what they are saying. Okay. So meaning of band limitation is clear to you. Band limited. The frequency band is limited because the rest of the band was not containing much of information. Or you just think that this kind of frequency response I was having, where maximum frequency component was 4 kilohertz. Basically they are telling this is the maximum frequency component. F of m, that is equal to 4 kilohertz. So this is the meaning of band limited. I will not write down all these things, like in some page you can write it down. I will leave a blank page for you guys. Okay, let's make a blank page. So whatever that I am telling in brief, you can write down on this blank page. I am leaving it for you. You can write down anything that you want to write down. Here I wrote down anything, or whatever you feel like writing, you can write it down here. Okay, blank page is there. You can write down the concept of band limiting as well if you want to write it down. So Fm equals to 4 kilohertz, Nyquist rate is given. Now what is the meaning of this? The signal is sampled at 200% above the Nyquist rate. Let us say I am getting 50 marks and you are getting 100 marks. What does that mean? You have got 100% more marks than me. Right? Are you able to understand this point? 100% more marks than me. If I am getting 50 marks and I am saying that you have got 200% more marks than me, what does that mean? That means you would have surely got 200 marks. In the course price there is a 10% hike, although it never happens. In the course there is a 10% hike. If the course price was 50, then 10% hike is there. That means 50 into 10 by 100. What that would be? 5. That means now the course price will be 55. In the course there is a 100% hike. In course there is 100% hike. That means how much price will be increased? 50 rupees will be increased. So sampled at 200% above the Nyquist state. What is your Nyquist state? Nyquist state is 2fm. Nyquist state is 2fm. Now 200% of 2fm, what that would be? 200% of 2fm. That will be 4fm. Right? Are you able to understand this point? And it is sampled 200% above. That means what is my sampling frequency? 2fm plus 4fm. That is equals to 6fm. Did you understand this point or not? Sampling frequency is equals to 6fm. Did you understand? You must have studied sampling frequency is equals to fx equals to 2fm. This is the Nyquist rate. Sampling frequency is equals to Nyquist rate. But they are saying 200% above. 200% above. So what is the 200% of 2fm? That is 4fm. So 4fm above. 2fm was minimum required. Now we are doing oversampling. We are doing oversampling 200% above. That means we are sampling by 4fm more. So sampling frequency has become 6fm. Is that clear to you or not? Okay, I am not framing very straightforward question, but at least these much things should be clear to you. And we will study sampling, so don't worry about that. But I hope you already know this much thing, because signal system you have already studied. And in signal system, all these things we surely study. Very basic of sampling we all surely study, no matter from wherever you are studying. Fs equals to 6fm. So what is your sampling frequency? 24 kilohertz, right? Encoded using 8 array PCM system with 14 quantization level. Quantization levels are 14. At the input of the encoder, 14 quantization level will be fed. 14 levels will be fed. So how many bits will be required? 14 levels will be fed. Using 3 bit you can make 8 levels. Using 4 bit you can make 16 levels, right? Using 1 bit you can make 2 level. Using 2 bit you can make 4 level. Using 3 bit you can make 8 levels. Using 4 bit you can make 16 level. So how many bits will be required? 4. So number of bits are 4, right? Number of bits are 4. 8 array PCM. What does that mean? 8 kind of symbols will be generated. 8 kind of symbols will be generated. What does that mean? That means your line coder would have taken 3 bits at a time. 8 array PCM, that means capital M is equals to 8. I could have taught in this manner as well, that you apply this formula, that is equals to 8, n is coming out to be 3. 14, you apply this formula, log 2 14. From here you will get to know that integer value that is coming out to be 3 point something, that means n is equals to 4 you need to take. But this is not a good way, no. You need to understand. Formula, forget about it. L is less than equals to 2 to the power n. In that manner, if I had said that 14 is less than equals to 2 to the power n, then what will be the value of n? N value will be 4. You apply this formula, n equals to 4, then capital N value will be 3. Then what do you remember? RB equals to NFS. Apply the formula. RS equals to apply the formula. Doesn't make any sense. Just think about it. What this question is saying. PCM system we are using, 14 quantization levels are there. That means encoder will be fed with the 14 levels. That means number of bits required will be 4. Nyquist state, that means sampling frequency is given, that is 24 kilohertz. Or sampling frequency can be written as kilohertz, or better you can write down kilo samples per second. Okay, kilo samples per second. Kilohertz also you can write down, but kilo samples per second would be a better way of representing. Now they are saying that 8 array PCM they are using. 8 array PCM. What is the meaning of 8 array PCM? 8 array PCM, that means they are generating 8 symbols. If they are generating 8 symbols, that means line coder would have taken 3 bit at a time. No, line coder would have taken 3 bit at a time. If it is taking 3 bit at a time, then it can generate 000, 001, 010, 011, 100, 101, 101, 110, 111. So 8 symbols it can generate. That means capital N value is 3. Or you simply apply the formula m equals to 2 to the power n. M is 8. So from there you can get and capital N value is 3. But don't lie much on the formula. Better you should understand the concept, right? That's the thing. Sampling frequency, first question is done. Second one, find out number of bits per sample. Number of bits per sample. What they are asking? Small n. This is also done, no? Number of bits per sample. Right? This is small n only. Number of bits they are asking, that's it. What do you mean by per sample? This was one sample, no? This sample was quantized into some particular level. This 0 was quantized into minus 0.4. So this was one sample. This sample 0 became minus 0.4 and this minus 0.4 was generated by 001. Sorry, 011. What I am saying, let's just talk about this sample. What was this sample? This sample was 4. Sampled value was 4. It was quantized into 4.4 and this 4.4 was generated by 110. That means we required 3 bits. So we required 3 bits per sample. So for every sample we are requiring 3 bits. So they are just asking the number of bits. So they are asking number of bits per sample. So this question is also done. Answer of A is 24K. Answer of B is n equals to 4. Determine the bit rate. Bit rate. RB equals to NFS. So 24 into 4. What that would be? 96 kilo bits per second. Look, n was 4 samples. Sorry, 4 bit. N was 4 bit per sample, right? 4 bit per sample. What was your FS? FS was 24K samples per second. Did you understand the unit? Samples per second. What does that mean? Here what was the scenario? Here your sampling time period was 2 seconds. So in 2 seconds you are generating one sample. In 2 seconds you are generating one sample. So you are generating one sample in 2 seconds. That means what was your sampling frequency? 0.5 Hz. One sample in 2 seconds. So sample per second. That means in 1 second you are generating half sample. In 2 seconds you are generating one sample. That means in 1 second you are generating half sample. That's why your sampling frequency was 0.5 Hz. So that's why I can write down samples per second. So my sampling frequency is 24K samples per second. Now if I do RB equals to NFS. If I do RB equals to NFS. Then what will happen? Bit per sample will be multiplied with samples per second. So what you will be getting? Bits per second. That means in 1 second you are generating 96,000 bits. In 1 second you are generating 96,000 bits and you are able to relate everything for sure. Because our TB was equals to TSA by small n. Right? Whatever the sampled value was there, that was there for how much seconds? From here sampling frequency is there, you can just take the reciprocal. So sampled value was there for 1 by 24K second. For this much second, one sampled value was there. Right? For this much second, one sample value was there. Okay. Now each sampled value was represented by 4 bits. Each sampled value was represented by 4 bits. What does that mean? 1 bit will be represented by this much time divided by 4. So this is the time 1 bit was there. 1 bit was there for 1 by 24 into 4. For this much time 1 bit was there. So what will be your bit rate? Just reciprocal of that. Or just remember RB equals to NFS. I am just talking about the unit kilobits per second. In 1 second you are generating 24 into 10 to, sorry, in 1 second you are generating 96 into 10 to the power 3 bits. These many bits are generated in 1 second. If encoded data is transmitted using as a 8 array signal, over the channel, then determine the symbol rate. Determine the symbol rate. RS, that would be equals to RB by capital N. So 96 divided by 8. Sorry, 96 divided by 3. Really sorry guys. 96 divided by 3. Because 8 array scheme is there. 8 array scheme is there. That means it is taking 3 bit at a time. If it is taking 3 bit at a time, then what you will see, that our symbol duration will be equals to 3 TB. That means symbol rate would be equals to RB by 3. RB by 3. 96 by 3. What that would be? 32 kilo symbols per second. Okay. 32 kilo symbols per second. Now this symbols per second is known as baud. So 32 kilo baud. This can also be mentioned in the answer. Symbol per second, one symbol per second is known as baud. Where do I write down? Here I am writing down. One symbol per second is equals to 1 baud. Okay. So all the information, whatever that we previously studied, it is just the question that can be asked from here. That's it. From this concept, whatever that we studied, this is just the problem that can be asked. Just we are applying the formula, nothing else. First, we saw that sampling frequency. What is our sampling frequency? 200% above the Nyquist rate. 200% above. That means 4 FM above. So total Nyquist rate. So total sampling frequency would have been 6 FM. So sampling frequency is 24 kilo samples per second. In 1 second, we are calculating 24 kilo samples, right? Now you know that 14 quantization levels are there. What does that mean? That means at the encoder, input of the encoder can have 14 different kind of inputs. That means it needs to use 4 bits. So it needs to use 4 bit to represent one sample. That means 4 bits per sample. Value of small n is 4 bits per sample. Now what about the bit rate? Bit rate is RB equals to NFS. Then what about the symbol rate? Symbol rate is RB divided by capital N. So RB value 96 divided by capital N. So answer would be 32 kilo symbols per second. Is that clear to you? Formula we remember. Along with that, we also know how to derive the formula as well. RB equals to NFS we remember. RS equals to RB by N also we remember. But we will not depend much on the mugging up part. We will be focusing much on understanding part, right? And understanding is completely clear that how RB equals to NFS came, how RS equals to RB by capital N came. What is the meaning of small n? What is the meaning of capital N? What is the meaning of sampling frequency? Everything is crystal clear, right? And there is no relation between small n and capital N. It would depend how many symbols you are generating. Okay, so here small n was 4, capital N was 3. So number of symbols generated, that would be associated with capital N, and number of bits required, that will be associated with small n, right? So here 8 symbols were generated. That means capital N value was 3. To generate 8 symbols, you need to take 3 bit into action, and one symbol will be getting 3 TB interval, right? All these things are crystal clear. Everything is absolutely clear. Let's see this question. A message signal has a highest frequency component of 7628 Hz. It is sampled at Nyquist rate. So what is the sampling frequency? Fs equals to 2 FM. So 2 into 62 samples per second. In 1 second, we are generating this much sample. The signal is sampled at Nyquist rate. Each sample is quantized into 256 levels. Each sample is quantized into 256 level. What does that mean? At the input of the encoder, 256 levels would come. And for having 256 levels, number of levels are 256. So L is less than equals to 2 to the power n. So 256 is less than equals to 2 to the power n. That means how many number of bits? Number of bits would be 8. So 8 bits will be required to represent one sample. So 8 bits per sample. Each sample is, how many bits would be required to store a 6-minute performance of the signal? Okay. So sampling frequency is this much. 2 into, let's call it FM only. So sampling frequency is 2 FM. So that means it is generating 2 FM samples per second. So in 6 minutes, how many samples will be generated? In 6 minutes, in 6 minutes, number of samples generated is equals to 2 into these many samples per second multiply with 6 minutes. In 6 minutes, there will be 360 seconds, right? So these many samples will be generated in 6 minutes. Now each sample is requiring 8 bits. So how many bits will be required? So what will be the answer? Bits required. In 6 minutes, how many samples will be generated? This was the sampling frequency. In 1 second, this much samples are generated. These many samples are generated. So in 6 minutes, how many samples will be generated? 6 into 60, that means this is the 360 seconds. 6 minutes equals to 360 seconds, right? 6 minutes equals to 360 seconds. So in 360 seconds, these many samples will be generated. If these many samples are generated in 360 seconds and one sample is requiring 8 bits, so bits required would be 8 bits are required for one sample. Then how many samples I am having? I am having this much samples. If you just know the units, then also you will be able to solve the problem. Sample to sample is getting cancelled out. What you are getting? This much bits will be required. So what will be the answer? 2 into, answer will be 2 into 7628 into 360 into 8. So roughly around 4.39 into 10 to the power 7 bits. That's the answer. Okay, here also I could have written 4.39 into 10 to the power 7 bits. This is the answer. These many bits will be required. To store a 6-minute performance of the signal, I need to require these many bits. You would know that, sir, video size is 2 GB. What is the meaning of GB? Gigabyte. Kilobyte means 10 to the power 1. Right? Am I correct? Kilo means not 10 to the power 1. Now you will not say, sir, it is 10 to the power 3. Kilo means not 10 to the power 3. Kilo is known as how many? 10 to the power 3. Yeah. So in terms of computer, kilo means known as 10 to the power 10. Sorry, 2 to the power 10. That means to store 1 kilobyte. What is the meaning of byte? Byte means 8 bits. So to store 8 into 10 to the power 3 bits, how many address lines will be required? These kind of questions can be asked in COA. Okay, forget about it. But you would see there is a size of a video, that this video is of 2 GB, 2 gigabyte. This video is of 1 gigabyte. So that size is coming from here only. Okay, so number of bits required, how many bits you are getting here? So if I represent 10 to the power 6 by mega, so 43.9 megabyte. So to store the 6-minute performance of this signal, you would require this much of memory. This much of memory size, 43.9 megabyte. This much of a memory size you will require. Okay, this much space you would require to store the 6-minute performance of this particular signal, of this particular message signal. Okay, not byte. Sorry guys, it is bits only. So if you want to represent in byte, so 1 byte is equals to 8 bits. So divided by 8. So this many bytes, this many megabytes would be required. Okay, 1 byte is equals to 8 bits. 1 byte. Okay, 1 byte is equals to 8 bits. So 1 bit would be 1 by 8 byte. So if these many bits are there, that means 43.9 divided by 8 megabyte. This much space would be required. Okay, this much space would be required to store the 6 minute performance. Although all these concepts are of COA, in communication system only this much would be required for you. And one question we are surely going to see in the third lecture, where what I would do is that I will combine the concept of a communication system and computer organization. Okay, but that would be there in our third lecture, I guess. So did you understand how many bits are required? 4.39 into 10 to the power 7 bits. A sinusoid signal is sampled at 8 kHz. It is quantized using 3-level uniform quantizer. Find out the bit rate of the PCM signal. So first let's find out the bit rate. 3-level uniform quantizer. So number of bits required would be 2. How 2 bits will be required, that should be clear to you. Sampled at 8 kHz. So Fs is equals to 8 kHz. Bit rate they are asking, Rb equals to NFS. 8 kHz, or better write down 8 kilo samples per second. 8 kilo samples per second. And these are 2 bits per sample. So Rb equals to NFS. Kilo sample will get cancelled out, 16. Answer is 16 kilo bits per second. Here also did I need to calculate Rb? No. So Rb equals to 16 kilo bits per second. That means your system is generating 16 kilo bits per second, right? Bit rate we have found out. Now in the PCM system, the quantization levels are increased from 3 to 8. So this was the first scenario. If quantization levels are increased from 3 to 8, so here how many bits are required? 2 bit, right? And here how many bits will be required? 3 bits. Are you able to understand this point? If levels were 2, what is the formula of level? If levels were 3, then n equals to 2 would work. Here n equals to 2 would work. But if levels are 8, then n equals to 3 would work. So what will be your number of bits per sample? So if at the input of the encoder 8 samples are coming, the number of bits will be 8 bits per sample, right? They are not changing the sampling frequency. They are just asking what will be the change in the relative bit rate, right? So Fs is same. So what will be your Rb? Rb is 3 into 8. That would be 3 into 8. That would be 24. Rb equals to 3 into 8k. 8 kilohertz is there, no? 24 kilobits per second. So how much increase is there? 50%. From 16 to 24, how much increase is there? 24 minus 16 divided by 16. 8 by 16, that would be 50%. So what is the answer? 50% increase. Okay. 50% increase. Bit rate is increased by 50%. Right? Or should I keep it? Now in the C, what they are saying, from 8 to 12, quantization levels are changed from 8 to 12. So how many bits will be required for this one? N equals to 3. How many bits will be required for this one? N equals to 3 only, right? Say yes or no? No, sorry. Not N equals to 3. 4. Sorry guys. Here you would require 4 bits. Here you would require 4 bits. Right? So how many bits will be required? 12 is less than equals to 2 to the power n. So n equals to 4 bits will be required. Right? 3 bits will not work. 4 bits will be required. So n equals to 4 bits per sample. So Rb equals to NFS. $32. How many percentage increase is there from here to here? 25% increased, right? 25% increased. Why 25%? Because what will be the 25% of 24? That would be 1 by 4. That means 24 into 1 by 4, that would be 8. Sorry, 6. How many percentage increase is there? 32 minus 24 divided by 24. So what that would be? 6, 8 by 24. So 33.33. Okay, so 33.33% increased. Now if there was a question from n equals to 12, number of quantization levels are increased from 12 to 15. Let's just say I am asking number of quantization levels are increased from 12 to 15. So what will be the percentage change in the bit rate? 0% change would be there, no? Because number of bits are still the same. Here how many bits will be required? 4 bits will be required. And here how many bits will be required? 4 bits will be required. In both of the cases, number of bits required are same. Sampling frequency is same. That means my bit rate will also be same. And if bit rate is same, what does that mean? There is no change in the bit rate. So here I did not frame the question smartly. From 3 to 8, from 8 to 12 we go. We should have gone from 12 to 14 or 12 to 15 as well. Just we need to focus on number of bits required. Here number of bits required were 2. Here number of bits required were 3. Here number of bits required were 4. Right? And percentage increase you can find out from here. At first it was increased by 50%. From 24 to you went to 32. That means you are increasing by 8. That means 1/3 you are increasing. That means 33% you are increasing. 33.33% you are increasing. All good. Everything is absolutely fine. Right? Everything is clear to you. Let's go to the next question. A multi-level digital system sends one of the 20 possible levels over the channel every 0.6 milliseconds. Find out the number of bits corresponding to each level. So 20 possible levels are there. 20 possible levels are there. That means L should be less than equals to 2 to the power n. So n would be 5, right? With respect to 4 bits you can represent 16 level. With respect to 5 bit you can represent 32 level. So n will be equals to 5. So number of bits corresponding to each level would be 5, or each sample also you can say bits per sample or bits per level, because each sample will be represented by one level, no? So bits per sample or bits per level you can write down. So n equals to 5. Bit rate. So what they are saying, a multi-level digital system sends one of the 20 possible levels over the channel every 0.6 millisecond. That means in every 0.6 millisecond one level is generated. What do you think what this is? This is your sampling time period. Let's go to this example. In every 2 seconds, one new level was generated. From 0 to 2, it was generated minus 0.4. From 2 to 4, so in every 2 seconds, one new level was coming. This was another level, another level, another level, another level, another level. So in every 2 seconds, another new level was coming. So at the input, what is happening? At the input of the quantizer, or you can say at the input of the encoder, what is happening? In every 0.6 millisecond, in every 0.6 millisecond, a new level is being generated. Are you able to understand this point? So what it is given? This is given as your sampling time period, right? 0.6 millisecond is sampling time period. So what will be your Fs? Fs will be 10 to the power 3 divided by 0.6. That's it, kilo samples per second by kilo. 10 to the power 3 samples per second, no? 1 by 0.6 into 10 to the power 3, so 10 to the power 3 is going upward, samples per second. So what will be your bit rate? So this was the answer of first question. Answer of second question, RB equals to NFS. So n is 5 into 10 to the power 3 divided by 0.6. So 5 divided by 0.6, 50 by 6. 50 by 6. So 8.33 kilobits per second, right? .33 kilobits per second. Baud rate. What is the meaning of baud rate? Baud rate is, here they are not giving capital N value, they haven't even given. Capital N value is not even given. So how would I find the baud rate? So RB equals to RS only, I should say. Or this question is not making any sense. Basically, I don't know how line coder is taking how many bits at a time. Line coder is considering how many bits at a time. I don't even know. So how can I find out the baud rate? For finding out the baud rate, I need to know line coder is taking how many bits at a time. So what they have mentioned, they have only mentioned the number of levels, and each level is being generated after 0.6 millisecond. That means they have given me the value of sampling frequency, right? 20 possible levels over the channel. Every 0.6 millisecond. Number of bits corresponding number of bit rate. So how would I find the baud rate? I will have to say it is equal to RB only. This is what I would say, right? So doesn't make any sense. Question is incomplete. So let's drop this one. So let's drop this C question. Okay, well and good. You solve this one on your own. Take your time, read the whole question and try solving it on your own. This kind of question only has been asked in GATE examination. So take your time and solve on your own. You can see parallel to serial converter. I will tell you what is the meaning of parallel to serial converter. So what is the meaning of parallel to serial converter? So data are fed parallelly. Let's just say there is a room. Okay, there is a room. In this room, this is a floor. In this floor, there are 3 rooms. Now what I will do, I will feed people parallelly. That means at the same time only. Let's just say at t equals to 2 seconds, all the guys will go in. But now I will take them out serially. That means first this guy will come out, then this guy will come out, and then this guy will come out. So parallel in, serial out. So parallel to serial converter. Okay, parallelly in, serially out. Parallel in, serial out. So parallel to serial converter. Is that okay for you? Data will get into it parallelly, but get out serially. Okay, so try this question on your own. We will surely see the solution. If you are not able to solve, then also it is fine. Let me take some break, drink some water, and then I will come back. Yeah, welcome back. So did you try this question? A full scale voltage of 1.4 volt, resolution of 0.2 volt. Resolution means step size. Okay, resolution is given. Resolution is 200 millivolt. That means it is nothing but the step size. Resolution is nothing but step size. Okay, and that is given as 200 millivolt, which is 0.2 volt. Yes, full scale voltage is given. That means dynamic range is given. Full scale voltage means dynamic range. Okay, full scale voltage. That means dynamic range is given, which is 1.4 volt. So from here, can I find out the number of levels? Basically, your quantizer is taking the value. Let's just say it is taking the value from 0 to 1.4. Then after every 0.2, you are defining one level. So this is one level. Then 0.4, this is another level. So what you will do? What will be the number of levels? Number of levels will simply be dynamic range divided by the step size. So number of levels will be 7. That means number of bits required would be 3. Right? Bandwidth is given. Quantizer input signal bandwidth is given, and next they are saying that it is sampled about 50% above the Nyquist rate. So what will be the sampling frequency? This is your Nyquist state. 50% of this, that would be FM. So sampling frequency will be 3 FM, and FM value is 50 megahertz. So what will be the answer? 1.5 giga samples per second, and this is 3 bits per sample. First question, you need to find out that data rate at the output of the encoder. RB equals to NFS. 1.5 into 3, 4.5 giga bits per second. That would be the answer. No. What do you see here? Is quantizer output is fed to the encoder. which produces binary parallel output data. By default, it should produce serial output data, but now it is producing binary parallel output data. What is the meaning of that? So there was this encoder. At the input of the encoder, 7 levels are there. That means this encoder needs to use 3 bits. Let's just say any quantized value, or you can call it sample. So any quantized value is coming. Let's just say quantized value is 0.1 volt. Now this 0.1 volt will be encoded as 001, or let's call it 101. This 0.1 will be encoded as 101. So encoder has to give the output as 101. So previously what we were saying, that it will give the output as 101, right? Now this sample was there. Let's just say this sample was there for 2 seconds. If this sample was there for 2 seconds, now it needs to generate 3 bit. That means every bit will be getting 2 by 3 seconds. This is what we were saying. That means bit duration was equals to the sampling time period divided by 3. This was the scenario, and from there you got the formula RB equals to 3fs, right? But now what is happening? The bits are generated parallelly. Bits are being generated parallelly. What does that mean is that now what is the scenario is, let's just say applied input is 0.1 volt. 0.1 volt. Now this 0.1 volt, I know that it will be encoded as 101, and it will be using 3 bits. But all the bits will be produced parallelly. That means it will have 3 outputs. Each output will be representing 1 bit. That means it will generate 1, 0, 1 at a time only. Is that clear to you or not? So this 0.1 volt was there for 2 seconds. So this each bit is also there for 2 seconds. No, let's just say I was having 3 cricket balls in my hand, and I dropped all the balls at the same time only. That means all the balls will get the same time of falling down time. Basically this bit will also get the attention of 2 seconds. This bit will also get the attention of 2 seconds, and this bit will also get the attention of 2 seconds. All are having the same span. Just as 0.1 volt came, the encoder know that I need to generate 101. By default, it needs to generate 101 serially. First it will generate 1, then 0, and then 1. But now it is generating parallelly. So this 0.1 volt was there for 2 seconds. Then this every bit is also there for 2 seconds. So this bit will also be there for 2 seconds. This bit will also be there for 2 seconds, and this bit will also be there for 2 seconds. So what does that mean? Bit duration has equals to become sampling time period. So RB is equals to Fs. So in the first question they are saying that you are giving binary parallel output data. So for the first one, what would be the answer? RB would be equals to Fs only. So answer would be 1.5 gigabits per second. That would be the answer of first one. Is that clear to you or not? So did you understand the meaning of parallel output? By default, this is the condition of by default. But in the question, if they are specifically mentioning that output is parallelly produced, then you would know what will be my bit rate. Now what they are saying, this parallel data is then converted into a bit stream using parallel to serial converter. So this parallel data has been converted into serially, right? Now whatever this parallel data was taken, what I mean to say is that every bit was there for 2 seconds, right? This was your parallel output. Now what will happen is that this parallel output is fed to parallel in serial out, parallel in and serial out, parallel in serial out, parallel in serial out converter. So 101 is coming for every 2 seconds. Now all these will come at a time. Now in 2 seconds of window you need to generate 101. In 2 seconds of window you need to generate 101 serially. In 2 seconds of window. That means this 101 will be generated in 2 seconds. and that will be generated serially. So every bit will get how much time? 2 by 3 seconds. So basically this is our same case, how this encoder used to generate, but this encoder was different. It generated the output parallelly, but then we used another block. This block was generating output serially. So parallel in, serial out, right? So these bits were there for 2 seconds. Now in 2 seconds again these bits will be generated 101. So in 2 seconds you are having in the window of 2 seconds you are having 3 bits. That means 1 bit will be generated in 2 by 3 seconds. So for the second case your answer would be RB equals to NFS, right? Because here what will be your bit duration? Your bit duration will be this thing, right? So RB equals to NFS. What is the value of N? N value is 3. So 3 into 1.5, that would be 4.5 gigabits per sample. So always notice in the examination, you always need to notice that if they are talking about digital communication system, here is there anything mentioned about digital communication system? Is this problem telling you that we are talking about any digital communication system? No, it could be any block. What kind of block is there? I don't know. It is not a digital communication system. It is a general system, right? In this general system, there would be sampler, there would be quantizer, there would be encoder. That's it. This is the general system we are having. But if they talk about digital communication system, then by default you will say that the bits will be generated serially. Okay. So at that time you don't need to think that sir parallel will be there or serial will be there. Should I apply the formula of RB equals to FS or RB equals to NFS? So RB equals to NFS only when serial bits are generated, and don't mug it up. You are not going to mug it up, right? All good. So this question also have been solved. So we have seen that transmitter block now. We have solved the problems as well, and this is a blank page for you. You can write down anything you want to write down. And we have seen the transmitter block, sampler, quantizer, encoder, line coder, and it will be going to the channel. So empty was there, it has been converted into the pulses. So empty will be fed to the channel as a pulses. Now the job of this channel is to, whatever the pulses are there, these pulses should be sent to the receiver. This is the job of this channel. But what channel will do? Channel will introduce some noise. These pulses are there, channel will introduce some noise. So at the receiver, what will be received? Pulses plus the noise. Okay. So let's see the receiver block. So this was our transmitter side. We already know. All these things we already know. This is our channel. So after the line coder, what we are generating? We are generating the pulses, right? We are generating the pulses. Now these pulses will be going to the channel, and in the channel, what will be added? In the channel, noise will be added. So what will be added? I am making an adder like this. So noise will be added. So noise will be a random process. It could be Gaussian random process or any kind of random process. So this is a random process. And these are the signals, right? These are the deterministic signal. This is like a signal only, no? A signal of a volt which is there between 0 to TB. Or better I should write down 0 to TS, because any kind of a scheme you can use. If you are using 8 array scheme, then TS would be equals to 3 TB. So these things you already know. So 8 volt is there, sorry, A volt is there for 0 to TS time. That means it is like a time domain signal, and those time domain signals are known as deterministic signal. So this is your deterministic signal. Deterministic signal. And noise will be a random process. Okay, noise will be a random process. It will be added. So here what will be reaching? Here ST plus NT will be reaching. Now this block is known as receiving filter. Receiving filter. After that there will be a sampler which will be sampling at every NTS, and then there will be, what is the job of everything I will tell you. Then there will be something called threshold detector. Okay, threshold detector, and it will have some detection value. Okay, and then there will be decoder, and then there will be a low pass filter, and eventually we will get our final output, received output I should say. So how I should represent it? I will not represent it by YT. I am just representing it by output. Okay, So then we will receive our final output, which should be looking like empty only. Now what is the job of these two guys? So these two guys will try to reduce the effect of the noise. How they will reduce, that is a very big concern, and we are going to study about these two blocks separately. We will study threshold detector and then we will study receiving filter. Like roughly around 12 to 13 hours we are going to spend only these two blocks, and 90% of the questions from digital communication are framed only in these two blocks or on these two blocks. So these four blocks combined will take your 90% of a communication system. Okay, in this lecture only we will understand about decoder. In this lecture only we will understand about low pass filter. They are very simple, no questions can be framed from here, but you just need to know the working, that's it. Like here you need to know the working, and then you need to know two formula, RV equals to NFS and RS equals to RB by N. These two formula you need to know, and how these formula came, that also you need to know. So here what is the job of this receiving filter, this sampler and this threshold detector? They will try to reduce the effect of the noise. Along with that, what is this ST? ST is a pulse, right? ST is a pulse. So what will be the job? It will try to reduce the noise. Along with that, whatever the pulse that has been generated, that should be encoded into bits. Here encoder was getting some quantized value, and what it gave as the output? Encoder gave as the output some bits, right? It was getting some quantized value and it gave the output as some bits, and these bits were converted into symbols, right? Or you can say pulses. Why we converted into the pulses? Because channel cannot understand 0 1, channel can only understand the pulses. So these pulses are now traveling, these pulses have reached here. Now when it reached here, some noise was also added. So the job of this receiving filter and threshold detector would be to reduce the noise, also to convert this pulse into bit stream. So decoder would be fed with some bit stream. Is that okay for you? Is that understandable to you? Again let me repeat, started from here, sampled value, quantized value, encoder was doing, encoder versus decoder, encoder decoder, output of encoder was 010 bit stream. So input of the decoder will be bit stream. So what do you think, what decoder will give you as the output? Encoder was taking quantized value, giving you bit output. Decoder is taking bit input, will give you quantized signal. Now sir, how these two guys will convert this ST plus NT into bit stream? What I am saying, sir, how these two guys will convert this ST plus NT into bit stream? This is known as bit stream. Okay, so how these bits will be converted, that we will study in the further lectures. As of now I cannot tell you. In the further lecture we will study it, don't worry about that. But as of now, in this lecture, what you need to understand, that somehow these two guys have reduced the effect of the noise. Also they have converted this ST into these bits only, although they will not be able to succeed, right? Like let's just say there are 20 lakhs bits are coming, these bits are 0 1 0 1 1 0 1 0. So at the output of this guys, here this encoder generated bits in this manner, but the output here will not be same as this one. Some bits will be corrupted. Let's just say this bit was supposed to be 1, but actually 0 will be received. All the bits cannot be perfect. If all the bits are perfect, then your system is 100% reliable. That means whatever we are sending, ditto same has been received, but it is not possible. Out of these 20 lakhs bits, some bits will be corrupted. How many bits will be corrupted, how to find how many bits will be corrupted, all these things we have to study. But as of now, the matter of concern is this ST plus NT. Effect of noise will be reduced by this receiving filter and threshold detector, and ST will be converted into the bits. That's it. Okay. And then it will be fed to the decoder. So what encoder was doing? Encoder was taking the quantized input and giving the bits as the output. So decoder will take bits as the input and will give quantized value as the output. And then there is this low pass filter. What is the job of this low pass filter? That also we will study. So let's see what will happen. So decoder will take these bits as the input. Sir, why we are not studying about these two blocks? We will study later on. They will require at least 10 to 12 hours. Only these two blocks. But as of now, we are just studying about decoder. From the decoder, no questions will be framed. So basically, decoder will take these bits as the input and will give quantized output. So what was our quantized output? This was our quantized output. As of now, we are assuming that whatever that was generated here, the same bits are generated here, although it is not possible, right? It is not practically possible that whatever the bits that encoder was generating, the same bits threshold detector will also generate. It is not practically possible because noise, effect of noise will also be there, no? So you cannot make 100% efficient digital communication system. 100% efficiency is a myth, right? So 100% efficient digital communication system you will not be able to make, right? So these bits 0, 1, 0, as of now we are assuming that the same kind of bits are generated. So if same kind of bits are generated, then what will be our quantized output? Our quantized output will be similar to this. Ditto same quantized output we will get, right? Because this quantized output was generating these bits, right? This quantized output was generating these bits. Now if these bits are fed to the decoder, then this decoder will generate this quantized output. Very simple thing, right? So we are assuming that we are having 100% of efficiency. So whatever that was generated at the transmitter side, the same thing has been generated at the receiver side as well. Now this particular waveform will be fed to the low pass filter. Low pass filter means RC low pass filter. So do you know the working of RC circuit? I hope you know the working of RC circuit. If I apply a step of 5 volt here, what this capacitor will try to do? It will try to reach to 5 volt. So basically capacitor always tries to copy the input. The job of capacitor is that it will try to copy the input. Now if the capacitor charging is slow, so then it will rise up like this, right? Slowly it will rise up. So almost linear. This is exponential. But if it is charging is if charging is slow, so you can say that it will be charging like this, linear, right? So capacitor will simply charge. It will charge whatever the input value has been applied. So input value that has been applied is minus 0.4. So first capacitor will try to charge to minus 0.4. Then capacitor will try to charge to 2.8. Then it will 2.8. Then it will try to charge to 4.4. Then it will try to charge to 6. Then it will try to charge to again this voltage till here. Then again it will try to charge to this potential. Basically, you know the working of RC circuit. Capacitor always tries to copy the input. So whatever the input has been applied, it is trying to copy the same kind of input. Started from here, it tried to go to minus 0.4, then tried to go to 6, then tried to go to minus 5.2, and then tried to whatever the waveform is going. Basically, charging will be taking place. Here, actually exponential charging would be there, then this charging would be there, then this charging would be there, then this kind of charging would be there, then this discharging, then this discharging, again discharging, again discharging, again discharging, again discharging, then charging, and then charging. So this kind of waveform we will be getting. And if you make it more smooth, then this kind of waveform you will be getting. So eventually what you are getting, eventually you are getting whatever that was applied, almost whatever that was applied. This kind of triangular waveform was applied. And here at the output what you are getting, almost this kind of waveform. So this is your final output. After that you are not doing anything. This is your final output, which is looking almost like empty. Okay, so this waveform that I have drawn, this is your final output, which is looking almost like empty. So in this lecture, within so within 10 minutes you will be able to revise the lecture. In this lecture, what we studied: sampler, quantizer, encoder, line coder. Right? Empty was converted into the pulses. Empty, first it was sampled, then it was quantized, then quantized, it was encoded into some bits. Now these bits were converted into pulses. These pulses will be traveling through the channel. Some noise will be added. Now the job of this receiving filter and this threshold detector would be to reduce the effect of noise as much as they can. So they try to reduce the effect of this noise. Along with that, they converted these pulses into the bits. Now these bits are fed to the decoder. So decoder is just the opposite process of encoder. Encoder was getting the quantized value. Encoder was getting the quantized value, and it was giving the number of bits. Sorry, I should not say number of bits. It was converting this quantized value in the bits. Now decoder will take bits and it will convert these bits into the quantized value. How it will convert, that is not a matter of concern. So this is how it will be converting. So whatever the quantized value that we got here, the same kind of quantized value we are getting here as well. And then there will be RC low pass filter. So what is the job of the filter? What is the job of the capacitor? Capacitor will always try to copy the input. Whatever the input that has been applied, it will try to copy the input. So first it will try to go to 0.4, then it will try to go to 2.8, then it will try to go to 4.4, then it will try to go to 6, then 4.4 again, then 2.8, then again minus 0.4, then again minus 2, minus 3.6, minus 5.2, then again charging minus 3.6. In that manner it will try to go. So you can see that same kind of triangular waveform we are getting. So whatever the message information was applied, the same message information have been received. So this was your digital communication system on top level. So in this lecture, we have discussed about encoder in detail, line coder in detail, decoder in detail, and low pass filter in detail. So whatever the detail was necessary for these blocks, that has been discussed. What we need to study now? Sampling, quantizer, receiving filter, threshold detector, and channel. So this we have written. What we need to study? Sampling, quantization, threshold detector, receiving filter, and channel bandwidth requirement. Along with that, we will see some miscellaneous topic as well. Miscellaneous. Okay. Like here what we studied, this was the PCM scheme, right? We have studied about a PCM scheme. But when we go to band pass communication system, in band pass communication system, there will be a multiplier as well. Do you remember this concept? I told you the baseband signal cannot be transmitted through the air because they are having lowest frequency component of 0 Hz. If lowest frequency component is 0 Hz, then the length of antenna would be infinity, which is not practically possible. So what we need to do? We need to multiply with some carrier so that we increase our lowest frequency component so that we can transmit it via wireless medium, or you can say we can transmit it via air. So based on that, we were having two kind of communication, baseband and band pass. So in the band pass digital communication system, what will be different? Only here there will be multiplier, rest all things will be ditto same. What will be different? Only here there will be multiplier, rest all the things will be ditto completely same. Okay. So first we will study everything for baseband, everything we will study for baseband, and then we will convert it into band pass. So for baseband, like roughly around 20 to 25 hours if we are spending, then for band pass we will spend only 3 to 4 hours. Okay, because whatever that we study in baseband, the same will be applied in band pass, only minute difference would be there. That difference we need to understand. That's it. Okay, so sampling, quantization, threshold detector, receiving filter, channel bandwidth requirement, or this is known as inter-symbol interference. So this topic is known as ISI. ISI, that's it. There is nothing difference. Okay, ISI, that's it, nothing else. So channel bandwidth requirement, and then we will see some miscellaneous topics. So this should be our flow. At the end of every lecture, I will be telling you this flow again and again. At the end of every lecture, again and again this flow will be discussed. Now next target would be that, sir, we understand sampling. Now in signal system, we have already understood sampling in great detail. So whatever the questions that can be framed from sampling, that has been discussed in this topic, which has been uploaded on YouTube. So you go LTI system analog filter sampling and type it on YouTube, and you will get the complete information of sampling. And believe me guys, in the past 10 years, there has not been a single question paper where the question from sampling is not asked. In 2024, it came for 6 marks. In 2025 as well, it came for 4 marks. Like every year, the question from sampling is fixed, 100% it will come. And even if you have already studied it, I would recommend going through this video once. Analog filter, LTI system and sampling, you will just love it. There are a lot of new things that you are going to learn. Sampling is not done with respect to only the impulse train. If you have already studied, then I am telling. You would have already studied it using the impulse train only. But any kind of periodic signal can do the sampling. Any kind of periodic signal can do the sampling. Impulse train is not necessary. Usually we do it with impulse train. But any kind of periodic signal can do it. So there we will use the concept of Fourier series coefficient. From Fourier series coefficient, we will derive our impulse train, or for any kind of impulse train, we will derive our CN expression. From there, we will derive our frequency spectrum. Then we will multiply in the time domain. It will be convolved in the frequency domain. We will get the clones. But the clone at omega equals to 0 will be having the same amplitude, but all the clones might be having lesser amplitudes. and from that clone we will apply a low pass filter and we will get our message signal again. So that thing we are going to see in this particular lecture. Again, repeating it doesn't make any sense. So you go to this video and study it. Okay, if you have already studied communication signal system from my end only, then there is no need to study it again. You have already studied it, so you can just revise your notes. From those notes only some questions will be framed. Next task would be, in the next lecture we are going to study quantization. This would be our next lecture. Next lecture will be completely based on quantization. From there, the next lecture will be based on threshold detector. After that, the next lecture will be based on receiving filter. There are two kinds of receiving filters. Okay, one is meshed filter. This is known as meshed filter, and other one is correlator based receivers, or you can call it correlator based filters. Those two we need to discuss. So here I would require two videos, then some concept of I will try to introduce the concept of band pass communication. Okay, once we study all these 4 blocks, then before going to the channel we will try to introduce the concept of band pass communication, and then we will combine both of them and we will study about channel bandwidth requirement or ISI, and then whatever the miscellaneous topics are left, that we will see. So this would be our flow. Sampling we have already studied, right? So next video will be based on quantization. Okay then, yeah, thank you very much. If you found it helpful, you can share it with your friends, and you can like this video. Yeah, thank you. Hi everyone, welcome to PrepFusion. So in this video we are going to cover quantization. Basic concept we have already seen. It's just that we need to see the depth, what kind of questions can be asked, and how to analyze a quantizer circuit, that we need to see. So basic concept are already done, right? Basic concept of quantization has been already done in the previous video. So if you are looking only for the quantization, that means previous video also you need to watch. Their basic concept, basic meaning of quantization we have already studied. Let's see some basic prerequisite which we have already studied in our random variables. So let's just say x is a random variable, and I ask you what is the power of x, power of a random variable x. What you will say? Sir, it would be equals to expectation of x square, and that would be equals to minus infinity to infinity x square fx of x dot dx, where fx is PDF of a random variable x. So this much basics you already know, right? Another thing you know, what do you know? Let's just say I define another random variable y, which is a function of x. Y is a function of x, and now I ask you to calculate the power of y. So what you will do? Sir, minus infinity to infinity y square fy of y dot dy. But now I am not having the PDF of y. I am having the PDF of x, I am not having the PDF of y. So what I will do? In place of y, I am gonna put a gx. In place of y, I am gonna put a gx. In place of y, I am going to put a gx. So it would be g square x, right? Now since this has become a function of x, so now I can put the PDF of x as well. So this much basics we have already seen. How all these things came, everything we have already seen, right? So PDF of y, the function y, the random variable y was a function of x. The random variable y was a function of random variable x. Now if I need to find out the power of y, I am not having the PDF of y, so what I will do? In place of y, I will put a gx. And if here this function is of x, then I can put the PDF of x. So expectation of y square would be given as g square x fx of x dot dx. So this much basics we have already seen. Now we need to study about quantization noise power. What is the meaning of quantization noise power? So have you studied about quantization error? Yes, quantization error I already know. So quantization noise power is simply power of quantization error. Okay, the simple meaning is whatever the quantization error you are having, define that as a random variable and then find out the power. Let me repeat it again. Quantization noise power is nothing but the power of quantization noise error. Sorry, quantization error. I should not say quantization noise error. Power of quantization error. Okay. So what is quantization noise power? Whatever the quantization error that you are getting, you just need to calculate the power of that. That's it. Now let's just say this was the quantizer. This was my quantizer. I am applying a random variable x as the input to the quantizer. Random variable x is the input and whose PDF is fx of x. Okay. This is the random variable x which is the input, and PDF of random variable x is fx of x. It has been applied to the input of the quantizer. So what it will do? The quantizer will map the value of random variable x to a certain value, that could be x of q. The random variable x will be mapped to a certain value, that would be x of q. So what will be your quantization error? So I am representing my quantization error by a random variable y. So random variable y would be given as whatever the input that you have applied minus mapped value of random variable x. So this much things we have already seen in the previous video. Quantization error is given by whatever the value that you have applied minus the mapped value x minus xq. Now I ask you to find out the quantization noise power. So what you will say? Sir, quantization noise power is nothing but the power of quantization error. Power of quantization error. So what is my quantization error? That is y. So I need to calculate the power of quantization error. Power of quantization error. What that would be equivalent to? Minus infinity to infinity y square fy of y dot dy. Now if I am given this PDF, then it is fine. That means if I am given the PDF of quantization noise error, what is this? This is the PDF of quantization noise error. PDF of quantization noise error. If this is given, then I can calculate it. But usually in the examination, PDF of random variable x would be given. Now I know that y is a function of x. Y is a function of x. That can be written as x minus xq. In place of y, I can put x minus xq. And since this is a function of x, so now I can put the PDF of x. That's it. So this is the thing we need to calculate. Now the whole lecture will be based on this first slide only. The whole lecture will be based only on this slide. That's it. You need to find out the quantization error and then you need to find out its power. That's it. These kind of questions will be asked in your examination. Let's understand more by a problem. So a very simple question. At the input of the quantizer, you are applying a random variable x which has been mapped to xq. Okay. So PDF of random variable x is given as fx of x, which is already given. So what is x? X is a uniformly distributed random variable between 0 to 5. So distribution is uniform and this is the graph of fx of x. What you need to find? Midpoint mapping is used. You need to find out the quantization noise power. What does that mean? That means your random variable x is taking the value between 0 to 5. This random variable x is taking the values between 0 to 5. Now whatever the value it takes, it will be mapped to the midpoint. It will be mapped to the midpoint. That means it will be mapped to 2.5. Let's just say random variable x takes the value 1. So at the input you are applying 1, at the output you will get 2.5. If it is taking the value 2, output will be 2.5. If it is taking the value 4, output will be 2.5. So what will be your quantization error? Quantization error. That would be defined by random variable y. That would be equals to x minus xq. And x is a simple random variable. It will be mapped to 2.5. So value of xq is 2.5. Did you understand this point or not? Whatever the value that you are applying, that will be mapped to 2.5. That will be mapped to midpoint, that would be 2.5. Right? So here you are getting the PDF of error. You are not getting the PDF of error. You are defining a random variable y which is representing quantization error, and that is given by x minus 2.5. What you need to find out? Quantization noise power. Quantization noise power. Okay. Quantization noise power I need to find. That would be expectation of y square. That would be equivalent to minus infinity to infinity y square fy of y dot dy. But I know that my y is a function of x. My y is a function of x. So y is equals to x minus 2.5. Y is equals to x minus 2.5 whole square. Now since this is a function of x, so here also I will write down the function of x only. Now what is fx of x? Fx of x is 1 by 5 between 0 to 5. So from here onwards you already know how to proceed because everything we have studied in our random variables. So that's why I said that if you don't study random variable, random process, there is no meaning of a digital communication system. Without a random variable, random process, there is no digital communication system. So x minus 2.5 whole square divided by 5 dot dx, you are going to solve it. What you are going to get? 1 by 15 x minus 2.5 whole cube divided by 3. So calculation you can do on your own. You don't need to see my calculation. 2.5 whole cube into 2. This would be the answer you will be getting. Okay, this would be the answer you will be getting. 2.5 whole cube into 2 divided by 15. So 2.083. 2.0833. Power, since it is power, I can represent by watt. So this is the answer. Okay, quantization noise power. Well and good. What was the step size here? Step size. If I ask you what was the step size? So step size was 5. What was the step size? Step size. What was step size? 5. Because one threshold was there at 0, another threshold was there at 5. So what was the step size? Step size was 5. Okay. If you had just done delta square by 12, now sir, from where this came, I will tell you. But if you have just applied this formula, delta square by 12, you would get the correct answer. What is the value of delta? What was the step size? That was 5. So 25 by 12. If you calculate 25 by 12, you will get the same thing. So how this formula came, sir? Delta square by 12, that we will see. And when you can apply this formula, that also we are going to see. So this is the kind of conclusion you can say that again the same scenario is there. I am having a quantizer, input will be a random variable, and you will get some quantized value at the output. Okay, and this is your quantizer. The PDF of this random variable is given, which is uniformly distributed between 0 to delta. And what will be the step size here? That will be delta only, and where you will be mapping it? At the midpoint. So another scenario is uniformly distributed random variable, along with that midpoint mapping. Midpoint mapping. Two things are there, right? Midpoint mapping is also there. So where it will be mapped? It will be mapped to delta by 2. So what will be the error? Error will be x minus delta by 2, right? Whatever the random variable that you are applying, it will be mapped to delta by 2. So x minus delta by 2. If I need to find out the quantization noise power, can you do it? Yes, sir. X will be taking the value between. Basically, I am directly writing down this tab now, because I know that my y will be x minus delta by 2. So in place of y, what I am putting? X minus delta by 2 whole square. Fx of x. What is fx of x? That is 1 by delta dot dx. And value of x is going from 0 to delta. There you go. So you can solve this, right? 1 by delta. When you do the integration here, so power 3 would come, divided by 3 would come, 0 to delta would come, right? So 1 by 3 delta, delta by 2, so delta cube by delta cube by 8. And then if you put 0, the same thing will come. If you put 0 here, then there will be negative sign, so minus minus will become positive. Mathematical calculation you can do, right? I hope you can do this mathematical calculation. If you cannot do it, then I don't think you are going in the right direction. So what will be the answer you will be getting? Delta square by 12. So the formula for quantization noise power is coming out to be delta square by 12, which should be there in your mind. But along with that, condition should also be there. Uniform PDF and midpoint mapping. Uniform PDF and midpoint mapping. So whatever the step size that you are going to see, now we will see some questions where step size could also be different. Like here, only one level we were considering. I should not say one level, it was actually, yeah, one level only. So we were considering only one level here, from 0 to delta. Now it may happen that they can consider different levels. In one problem only, they can consider different levels. So whatever the level that you are considering, let's just say I am considering a level from A to B. So between A to B, I will see the PDF. If it is uniform, then I can apply this formula. If it is not uniform, then I cannot apply this formula. And, and how will you apply the formula? Everything we will see. But as of now, if you have already studied this topic and you have remembered one formula, that quantization noise power is delta square by 12, then you are mistaken, right? Because the formula works only for uniform PDF with midpoint mapping, right? Let's solve this question. So here our same thing is there, random variable x having the PDF of fx of x, values will be mapped to x of q. Decision thresholds are there at -3, -1, +1 and +3, and midpoint mapping we will be using because it is not mentioned, so we will use midpoint mapping only. So basically your x can take the values between -3 to +3. First thing is that it can take the values between -3 to +3, -3 to +3, okay. And where are the decision threshold? -3 +3, -1 +1, -1 +1, right? Now where this value will be mapped? Between -3 to -1, value will be mapped to -2. Where the value will be mapped? Value will be mapped to 0, and next value will be mapped to 2. Let's not apply any formula, let's directly solve it. How would I solve it? So what is my quantization noise? That is simply x minus x cube. But here this is being mapped to -2, this is being mapped to 0, and this is being mapped to 2. So how will I find out this particular thing? So can you define your y? Y will actually be, if I give the definition of y, so y will be actually x plus 2 when x is actually going between -3 to -1. Is that okay for you? Did you understand what did I write down? When x is between -3 to -1, when x is between -3 to -1, at that time what is our x of q? That is -2, right? Your x of q is equals to, x of q can take three kind of values, -2, 0 and 2. When it will take -2? When your x is between -3 to -1. When x is between -3 to -1. When it can take 0? When x is between -1 to +1. And when it can take 2? When x is between 1 to 3. Okay, well and good, very simple thing, very straightforward. So similarly, what will be your random variable y? Your random variable y, which is your quantization error. So that would be x plus 2. If your x is between -3 to -1, it would be x only when your x is between -1 to +1, and it would be equals to x minus 2 when your x is between 1 to 3. All good? Okay. So expectation of y square would be given by what? -infinity to infinity y square fy of y dot dy. Now I have defined my y in 3 regions. But what I am going to do? I am going to replace y with x. So let's just say if I am replacing y with x plus 2, that means which region I am talking about? I am talking about -3 to -1. So if I am replacing y with x plus 2, here what I can write down? I can write down the PDF of x, along with the dx I can write down. So limit of x will go from -3 to -1, plus limit of x can go from -1 to +1 if I am replacing y with x only, fx of x dot dx, plus, and then limit can go from 1 to 3 if I can replace y with x minus 2 whole square, fx of x dot dx. Okay, so what I am going to do? -3 to -1, x plus 2 whole square as it is. What is the value of fx of x? What is the value of fx of x between -3 to -1? That is 1/8 plus -1 to 1. What is the value of fx of x between -1 to 1? Between -1 to 1, it is 1/4 plus between 1 to 3, x minus 2 whole square. What is the value? That is 1/8 dot dx. Can you solve this integration? You can solve this integration, you will get the answer. Now in the examination, you can directly write down this step. You will not have to do this much of thing. Directly you will think, no, that okay, random variable x will be mapped to -2. So x minus -2, x plus 2 whole square, fx of x dot dx, limit going from -3 to -1. Then -1 to 1, it will be mapped to 0. So y will be equals to x. So directly you can write down this step, and then you need to solve the integration. You will get the answer, but let's understand a method 2 as well. What do we remember? What do we remember? For uniform PDF, of step size delta, quantization noise power was equals to delta square by 12. This formula we remember. For a uniform PDF of step size delta, quantization noise power is delta square by 12. Here we were having -3 to -1, -1 to +1, and 1 to 3. -3, this is +3, then -1 can come here, then +1 can come here. If I talk about this particular region, between -3 to -1, between -3 to -1, the PDF was uniform? Yes, PDF was uniform. And what was the amplitude? Amplitude was 1 by 8. Amplitude was 1 by 8. So in this region, what was the step size? Step size was 2. In this region, step size was 2. So if I need to find out the quantization noise power, can I apply the formula of delta square by 12? Yes sir, surely you can apply. But in this example, what was the total area here? This total area was 1, right? This total area was 1. Now you are taking this step size, for how much area? For this much area only, no? This area is 1 by 8 into 2. So this area is 1 by 8 into 2. What that would be? 1 by 4. So you will have to multiply with the area as well. And let's just say this step size was delta 1. I am not sure what was the step size, and I am not sure what was the area as well. So this step size could be anything. Here step size is 2. I am putting this as delta 1. Who knows, next step size could be different, right? Next step size could be different as well, no? So I am putting this step size as delta 1, which is equals to 2. The values I will put later on. But delta 1 step size for area A1. So then the error, quantization noise error, would be given by delta 1 square by 12 into A1. You can see the same thing is happening here. The same thing is happening here. You will get the same answer. Whatever the answer that you are getting here, the same answer you will get when you solve this particular thing. Here I directly write down that quantization noise power will be delta square by 12, but actually area was also multiplied here. Area was 1. The area of complete PDF will surely be 1 only, no? That I already know. But here when I am taking the values between -3 to -1, the area is not 1, area is 1 by 4. Now between -1 to +1, between -1 to +1, what was the amplitude? 1 by 4. PDF is uniform. Matter of concern is that between -1 to +1, PDF has to be uniform. If PDF is uniform, my job is done. I know the formula delta square by 12. I know the step size as well. Luckily here as well the step size was same, but still I will denote it as delta 2. This step size and this step size might be different, but I don't care about this step size now. I only care about one thing, that between -1 to 1, at all the points I should have the same amplitude. That means my PDF should be uniform between -1 to 1. Is it there? Yes. So what I will say, sir, whatever the step size is there, divided by 12, multiply with the area. What is the area here? That area will be A2. Between 1 to 3, again it is uniform. Let's just say between 1 to 3, I'm just taking another hypothetical condition, that when the random variable x is taking value between 1 to 3, the PDF was somewhat like this. Would you call it uniform? You will say that, sir, from here to here it is uniform, but from here to here it is also uniform. But collectively it is not uniform, no? Are you able to understand this point? Actually our PDF was this one. This was our PDF. If you see the structure, this was our PDF. This was our PDF. But what we saw in the step size, when I am considering, when I am taking this step size of 2, I am supposed to take the step size of 2. When I am taking the step size of 2, in that particular step size, I need my PDF to be uniform. Am I getting that? Yes. If someone asks you, is this uniform PDF? You will say absolutely not. This is not a uniform PDF. But if someone asks you, if I am having a uniform PDF between -3 to -1, then you will say yes, you will have a uniform PDF, but the area is not 1. Area is 1 by 4. So always take care of the area as well. If someone asks you between -1 to 1, am I having the uniform PDF? You will say uniform amplitude you are having, but area is not 1. Area is A2. For the given question between 1 to 3 as well, area you are having A3, but PDF is again uniform. Okay, and this amplitude was 1 by 8. So again you can apply the formula. Here I will also take that my step size is delta 3. So delta is 3 square by 12 into E3. But if I give you a hypothetical condition that this is your step size, this is your step size, can you apply the formula of delta square by 12 multiply with area? No. The PDF is not uniform. No. For the complete step size, when you work between 1 to 3, you should have only one amplitude. When I was working from 0 to delta, I was only having one amplitude, that was 1 by delta. When I was working from 0 to 5, I was only having one amplitude, that was 1 by 5. So in any kind of PDF, for the step size, for one step size, if you are moving, you should have a uniform value. If you are not having uniform value, that means you cannot apply this formula. So here what I need to do? Here what I would have to do? I will see where the mapping is done. Mapping is done at 2. So what I will do? Sir, x minus 2 whole square fx of x dot dx value goes from 1 to 3. Then I will have to break this in it. 1 to 2 x minus 2 whole square fx of x. Between 1 to 2 fx of x value is, let's just say 1 by 2, and sorry, let's just say it is 1 by 4 and it is 1 by 2. So then I will have to put the value of fx of x, and then between 2 to 3 I will have to put the values of fx of x. Here I have to break the integration, no, because fx of x is not having a certain value. Between 1 to 2 it is having different value, between 2 to 3 it is having different value. So I am just telling that when you can apply the formula. Are you able to understand this point? So blindly never ever apply this formula delta square by 12. And how to apply this formula, that also I am telling. Okay. So all this in rough you can write down somewhere, but you understood this scenario. And this step size need not to be uniform, right? Although this was the example of a uniform quantization, but even if the step size was different, then also I was fine. My matter of concern is in the whole step size, my PDF should be uniform. In the whole step size, PDF should be uniform. That is my matter of concern that I am getting. So I can apply this formula, but I will never ever forget to multiply with area as well. So what is the step size? 2. 2 square by 12. What that would be? 4 divided by 12, that would be 1 by 3. Area is 1 by 4. Here what is the area? What is the value of A2? A2 is 1 by 4 into 2, that would be 1 by 2, and this value will be 1 by 4. What is the step size? 2 only. So 2 square by 12, what that would be? 1 by 3. Area is 1 by 2 plus 1 by 3. Area is 1 by 4. So what is the answer you will get? 1 by 3 only. Okay. So quantization noise power is 1 by 3. That is the answer. And you can solve this integration. You will get the same thing. You can solve this integration. Okay. So shall I solve it for you? Can I just solve this step? If I just solve this step, what I am getting? 8 divided by 12. That would be 2 by 3. Is that so? No, let me see. X cube by 12. 1 cube, that would be 2. Yeah. So 2 by 12 I will be getting. If I solve this particular thing, I will be getting 2 by 12. If you solve this integration, if you solve this particular integration, you will be getting 2 by 12. That is equals to 1 by 6. So the middle step should give me 1 by 6. Is it giving me 1 by 6? Yes, it is giving me 1 by 6. Okay. If you solve this particular integration, it will give you 1 by 12 for sure. This particular integration will give you 1 by 12. You can do it on your own. For sure it will give you 1 by 12. And this will also give you 1 by 12. So 1 by 12 plus 1 by 6 plus 1 by 12 will come out to be 1 by 3 only. So did you understand when to apply the formula and when not to apply the formula? Did you understand it or not? So first I should frame another question. Okay, what I am doing is that I will frame another question just to test your knowledge that whether you have understood to apply the formula or not. So let me frame another question. Yeah, better I will pause the video and frame this question. Why I should take your, why I should waste your time. So I will pause the video and I will frame this question. Then you can solve it. Yeah. So this is the question. Question. Is it question or is it question? When I ask Google, it says it is question. But I have seen people saying question. Whatever it is, I will try to say question. So let's solve this question. So a random variable x will be applied to the quantizer having a uniform step size of 2, and PDF is mentioned. You need to find out the quantization noise power. Okay. So what would be the general way? Like if I don't want to mug up any formula, nothing. If I just want to solve by the concept, so what I will say, sir, input random variable is taking values between -2 to 2. Step size is there. Step size is of 2. So between the values between -2 to 0, values between -2 to 0, because it is having a step size of 2, and minimum threshold should also be mentioned. Okay, minimum threshold value should also be mentioned. Minimum threshold being -2. Okay, so starting from -2 with the step size of 2, that means whatever the value are there between -2 to 0, that will be mapped to -1. It will be mapped to -1, and this value will be mapped to +1. So sir, I could have solved very easily in this manner, that my quantization noise power would have been equals to, sir, x minus -1, that means x plus 1 whole square dot fx of x. So between -2 to 0, between -2 to 0, all the values are mapped to -1. So between -2 to 0, x plus 1 whole square, this is my y. What is my y? Y is x minus x cube. So that would be equivalent to x plus 1 or x minus 1. When it would be x plus 1? When x is taking value between, -2 to 0, and when x is taking value between 0 to 2, then it would be x minus 1. So I can do this, sir, x plus 1 whole square fx of x is 1 by 8 dot dx plus minus plus 0 to 2, y is taking value this thing, dot fx of x dot dx. Let's put fx of x here as well. But the definition of fx of x is changing between 0 to 1 and 1 to 2, right? Because fx of x is 5 by 8 between 0 to 1, and it is 1 by 8 between 1 to 2. So what will be your quantization noise power? Going from -2 to 0, x plus 1 whole square, fx of x is 1 by 8 dot dx plus 0 to 1, 0 to 1, 0 to 1, x minus 1 whole square, 5 by 8. Why I am breaking down like this? Because I know that fx is changing its definition, plus 1 to 2, 1 to 2, 1 to 2, the definition is 1 by 8. Definition is 1 by 8. So if you solve this, what you are going to get? 1 by 24 x plus 1 whole cube divided by 3. So 8 is already there, 1 by 24. If you put 0, 1, then plus 1. Okay, well and good. Did you understand what I did here? Right? Or did I do the calculation error? X plus 1 whole cube divided by 3, that would be 24 minus 2 to 0, you need to put 1 cube minus of minus 1 cube. So 2 by 24, yeah, fine. Plus 5 by 8, 5 by 24 it would be, because x minus 1 to the power 3 divided by 3, 5 by 24. Put 1 here, that would be 0, and then put 0 here, that would be 1. So 5 by 24 would come. Here what will happen? Sir, 1 by 24. 1 by 24. Put 2, you will get 1, and then put 1, you will get 0. So 1 by 24. This will be 1 by 24. Right? Yeah. So what you are getting? 2 plus 5 plus 2 plus 5 plus 1. What that would be? 8 by 24. Am I doing something wrong, or 8 by 24? So that's it. This is the answer, or you can just 1 by 3. Is this the correct answer? Am I doing any calculation mistake? Basically here matter of concern will be calculation, nothing else. Whatever that we should have written, we have already written. X plus 1 whole cube, sorry, x plus 1 whole square divided by 1 by 8 minus 2 to 0, x minus 1 x minus 1 whole square fx of x, then 5 by 8 and 1 by 8, 5 by 8 and 1 by 8. So 5 by 8 power 3, if I put 1, that would be 2. If I put 1, that would be gone. If I put 2, yeah. So 5 by 24, 1 by 8, 1 by 24. So x cube 1 by 1, okay, 1 by 24, and here 2 by 24. 5 plus 2 plus 1, 1 by 3 we are getting. So this is the method 1 I could have solved very easily. But if I want to apply the formula, what I would have done? Sir, I know that minus 2 to 2. Between minus 2 to 0, between minus 2 to 0, 1 by 8. This is my step size as well. What is my step size? Step size is uniform. Here the step size is 2. And this would be my next step size. So in this step size, what I'm in this step size, what I'm getting? I'm getting a uniform PDF. Right? In this step size, I'm getting a uniform PDF between 0 to 1. But in 0 to 2, what I'm getting? I'm not getting uniform PDF, because between 0 to 1 it is 5 by 8, and between 1 to 2 it is 1 by 8. This is your 1 by 8, this is your 5 by 8, and this is your 1 by 8. So between minus 2 to 0, you are getting uniform PDF. So if you find out quantization, noise power, then you can apply the formula here. Delta square by 12 into area. What will be the area? 1 by 8 into 2. That area will be 1 by 4. Okay, what is the value of delta? Delta value is 2. So 4, 1 by 12, basically you will be getting 1 by 12. Yeah, you are getting the same thing. But here if I come, in this step size, in this particular range, when x is going between 0 to 2, PDF is not uniform. So now here I cannot apply the formula. Here I will have to apply this particular thing only. Are you able to understand this point? So what I am going to do is that from 0 to 1, or basically I will say that from 0 to 2 it will be mapped to x minus 1 whole square fx of x dot dx, and then I can open it. How will I open it? In this manner you will open it. So you will get the same answer only. Is that okay for you? You can check the calculation, but the concept is clear, right? Because fx of x is changing the definition. My major concern is in whatever the step size I am applying this formula, the definition should not be changed. When I go from 0 to 2, the definition is changing. 5 by 8, 1 by 8. If the definition is changing, I cannot apply the formula. I can say, sir, step size is delta square by 12. And will you say, sir, multiply by this area? Doesn't make any sense. The formula came for a uniform PDF. The delta square by 12, this delta square by 12 came for the uniform PDF. When I was working from 0 to delta, my PDF was uniform, that was 1 by delta. But when I am working from 0 to 2, when I am moving from 0 to 2, my PDF is not uniform. It is once 5 by 8, another time it is 1 by 8. So that is an issue for me. So I will have to go by my general trend. General trend says that whatever your noise, so whatever your error is there, find out that error and then find out its power. So between 0 to 2, my error was x minus 1. So x minus 1 whole square fx of x dot dx, then it is changing the definition 5 by 8 and 1 by 8. In that manner it is changing the definition. You can solve the integration and you will get the answer. Very simple, very straightforward. You would be able to solve all the questions if it is coming in your examination. Say yes or no, right? So everything is easy only. So you will get the same answer here, 1 by 3. Now solve this problem, and here I have written that don't find out the final result, just write down the equation of noise power. Just write down the equation, because because calculation will be complex. If you find out the final result, the calculation will be complex. So what is happening here? The random variable x is taking value between -1 to 3. Decision thresholds are also given. So let's make it here. Random variable x is taking values between -1 to 3. Decision thresholds are also given. Okay. So where it will be mapped? This will be mapped to -1 by 2. This will be mapped to midpoint mapping will be used. This will be mapped to 1, and this will be mapped to 2.5. Okay. So quantization noise power I need to find. What I will do? -1 to 0. Here what is the equation? What is the equation of fx of x? Fx of x is slope is positive, right? Here fx of x is equals to 1 by 3 only. Here step size is not uniform, right? Here step size is 1. Here what is the step size? Here step size is 2. And here what is the step size? Here step size is 1. Right? And is this PDF uniform? No. Is this PDF uniform? No. Is this PDF uniform? Yes. Along with that, our step size is also 2. So when you are moving from 0 to 2, you see a constant, you see a uniform PDF. And if you see the uniform PDF, you can apply the formula. What will be this area? This area will be 2 by 3. So this area is actually 2 by 3. This area is 2 by 3. So for this much area, you can apply the formula of delta square by 12. Although we will see that, but let's write down the equation. Now what is the equation for this one? What is the equation of fx of x for this one? That would be equals to, slope is negative, that is -1 by 6. Sorry, -1 by 3. And at 3 you are getting 0. So -1 by 3 plus 1. So minus x by 3 plus 1. Right? Yeah, correct. So this will be the equation. So -1 to 0, it will be mapped to -1 to 0, it will be mapped to -1 by 2. What is the definition of fx of x? Definition of fx of x is x plus 1 divided by 3 dot dx plus between 0 to 2, where it will be mapped? It will be mapped to 1. What is the definition of fx of x? That is 1 by 3 dot dx plus between 2 to 3, where it will be mapped to 2.5. And what is the definition of fx of x? Definition of fx of x is 1 minus x by 3 dot dx. And you can solve this and you will get your final answer. But interesting point here is that I can directly tell the value of this integration. What the value of this integration would be equivalent to? The value of this integration would be equals to delta square by 12 into the area, that is 2 by 3. So 4 into 2 divided by 12 into 3. So this will be 2 by 9. So this value will come out to be 2 by 9. Okay. you can solve this integration, you will get to know that this value is actually coming out to be 2 by 9 only. Why is that so? Why I can apply this formula? Because between 0 to 2 I am having a uniform PDF. Between 0 to 2 I am having a uniform PDF with the amplitude of 1 by 3. Amplitude is what? 1 by 3. And what will be the area? Area is 1 by 3 into 2, that would be 2 by 3. So here I can apply the formula. So mostly 99% chances are there that considering the question paper of recent years, like the level of examination has gone up, so very rarely you will be able to apply the formula. You will have to go by this concept only. But if you just want to reduce the calculation, like if you solve this particular thing as well, it will not take much time, right? I don't think it will take much of the time. You can solve this x minus 1 whole cube divided by 3, 1 by 9, then put 2 here, put 0 here. So 2 by 9, yes, you are getting 2 by 9. So formula and all these kind of things can be used in your PSU examination or ESE examination. But considering the GATE examination, I don't think you will be able to solve the questions or any problem using the formula. Okay. You try solving this question. I need to take a break, okay, because I am having the cough, so I need to take a break. You try solving this problem. This is one of the best problem of quantization. It was actually during my attempt in GATE 2022, and this was the first question that I saw on the screen, and I was not able to solve it. I did not get it correct in the examination. Okay. So calculation will be a bit complex here. Calculation will be a bit complex. So try solving it, but calculation will be going a bit complex because you can see that linear waveform you are having. If you are having linear waveform, that means this kind of thing you will be getting, and if you are getting this kind of thing, that means you will have to solve the integration. Okay, so try solving it. If you are not able to solve, then also it is fine. We will solve it. Okay, so let me take a break and then I will come back. Yeah, so did you try this problem? What is written? Let's read the question. Consider a real valued source whose samples are independent and identically distributed random variable with probability density function fx as shown in the figure below. So there is a random variable x. Effectively, you can say that there is a random variable x which is fed to a quantizer whose PDF is given, right? So random variable x is not uniform. It is taking the values between -2 to 1. Between -2 to 0, it is triangular. Between 0 to 1, it is uniform, right? Consider a 1-bit quantizer that maps positive value to the value alpha. So all the positive values are mapped to the value alpha and all the negative values are mapped to the value beta. Okay. So if I take this diagram, all the positive values are mapped to alpha and all the negative values are mapped to beta. Okay, well and good. Now you need to find out the value of alpha and beta in a manner that quantization noise is minimum, or what they are saying, that minimize the mean square value of quantization error. Mean square value of quantization error is known as quantization noise power. So you need to find out the value of alpha and beta in a manner that quantization noise power is minimum. Is that clear to you? Okay, so this is our question or question, whatever it is. So a random variable x is fed to a quantizer. It will be mapped to a value x q bar, or not q bar, x q. Well and good, question is clear to you. Okay. So what will be your quantization noise power? Can you write down the expression of quantization noise power? Or you can say mean square value of quantization error. What that would be? Sir, -2 to 0 x minus beta whole square fx of x. Now how did I get this value 1 by 2? This value was not given. How it is 1 by 2? Very simple. What do you know? Minus infinity to infinity fx of x dot dx should be equals to 1. So this should have been solved. At least this much part you should be comfortable. So what will be this area? This area will be, let's just say this value is alpha. This peak value is alpha. So area will be alpha plus half into base into height. So that should be equals to 1. So what will be the value of alpha? Alpha will be 1 by 2. So that value you should be able to find out. So peak value is 1 by 2. This value is 1 by 2. Okay. So what will be the equation of this line? So fx of x would be 1 by 4x plus 1 by 2, right? So this equation we already know. So here I will put, sir, calculation will be complex. Yeah, it will be complex. Calculation is complex. I cannot do anything about it. And this question has come in the GATE examination. So yeah, complex calculation they are asking. Dot dx, right? So these kind of problems where you see that, sir, calculation is going to be complex. So better you should be solving these problems with patience. Don't solve it in the beginning of the question paper. In the beginning of the question paper, you will not be having the patience. So solve it in the end, right? You know everything about this particular problem. I'm pretty sure you know everything. But still, when you solve this particular part, it will be a bit hectic for you, right? 0 to 1, x minus alpha whole square. What is your fx of x? That is 1 by 2 only. Dot dx. Okay. So this is your quantization noise power. I am denoting it by capital N. What you need to do? You need to find out the value of alpha in a manner that this expression is minimum. You need to find out the value of beta in a manner that this expression will give you the minimum results. This is what you need to do. So sir, we will differentiate this n. Yes, you need to differentiate this n. Basically, if there is a function fx of x, something x square plus 2x plus 3. If you need to find out the minimum value of this fx, what do? You will differentiate it with respect to x, then you will put it equals to 0, then you will get the value of x, and then you will put this value in this expression. That would be the minimum or maximum value of fx of x, right? So differentiate and then put equals to 0. Which value I need to find? Here I needed to find the value of x. That's why I differentiated with respect to x. Here I needed to find the value of beta, and here I needed to find the value of alpha. So I will differentiate with respect to beta. So this particular expression will be differentiated with respect to beta, not with respect to x. Okay, people don't know any concept, they will blindly differentiate with respect to x. What I need to find? I need to find the value of beta such that this is minimum. Integration is done with respect to x. So you solve this integration, whatever the result that you get, then that result should be differentiated with respect to beta. And from there you will get the value of beta. So did you understand the step? First you differentiate with respect to x. This is just mathematics. Communication concept is clear here. This is the concept of communication that is done. Now I am explaining the mathematics. That this is the expression of x. You will get, if you solve this integration, you will get expression of x in terms of beta as well. Now you need to find out the value of beta such that this particular expression is minimum. That means you will differentiate the function with respect to beta. Here I need to find out the value of x such that this expression is minimum or maximum. So I differentiated with respect to x. So similarly I will differentiate with respect to beta here and with respect to alpha here. Okay. So first let's do this calculation. I will denote this as n of alpha. I will solve this particular expression and then I will differentiate it with respect to alpha and I will get the value of alpha. So what I am saying, my n of alpha is 0 to 1 x minus alpha whole square divided by 2 dx. So 1 by 2 and then cube will be done. So this will be 1 by 6. So x minus alpha whole cube 0 to 1. So 1 by 6, 1 minus alpha whole cube and here alpha cube. Is that okay for you? You can do the calculation. I will put 1 here, 1 minus alpha whole cube minus 0 minus alpha whole cube, that would be plus alpha whole cube because minus sign will come out. So this is your n of alpha. Now this is in the this expression you are getting in terms of alpha only. Now what you need to do? You need to find out the value of alpha such such that this expression is minimum. So what you need to do? This thing you need to do, right? So differentiation and then put equals to 0. 3 into 1 minus alpha square into minus 1 plus 3 alpha square should be equals to 0. So what you are getting? 3 and 3 will get cancelled out. 1 minus alpha would be equals to alpha. So value of alpha is coming out to be 1 by 2. So here if alpha is 1 by 2, then the quantization noise error will be minimum, right? So do the same thing for this particular expression as well. I will pause the video. I need to again drink some water because again I am having the cough. So you solve this particular thing, whatever that I have done here. You write down this expression. First solve First put the limit of x and then differentiate with respect to beta. You will get the value of beta. Calculation will be complex. Okay, so take your time and solve it. Yeah, so did you try this one? Now what we need to put? Now I need to find n of beta. So my n of beta is this particular expression that I can simply copy, right? Yeah. So this is your n of beta. Now I will solve it with respect to x, I will differentiate with respect to x and then I will put the limit, I will get expression in terms of beta and then I will differentiate it. This is my task, right? So I can open it first. First I will open it, minus 2 to 0, x square plus beta square minus 2 beta x divided into x plus 2 dot dx divided by 4, right? And then I will multiply all the terms, x square multiply with x, x square multiply with 2, beta square multiply with beta square multiply with x, beta square multiply with 2, minus 2 beta x multiply with x, minus 2 beta x multiply with 2. Okay, and then I will integrate and put the limit, right? So all these things I have already done here. So you can check back the calculation. Okay, you can check the calculation. All the calculation you can check. Just I am integrating it. Okay, slowly you need to proceed, just don't rush in. Okay, if you rush in, you will not be able to do the calculation in a good manner. So slowly, step by step you proceed, so that you would be able to check back your calculation as well. So if I proceed in this manner, I am able to check the calculation as well, that everything I have done correctly, right? So in that manner you proceed and then put the limit, and n beta expression you will be getting, and then you differentiate with respect to beta and put it that equals to 0. Beta value is coming out to be minus 2 by 3. So when beta is equals to minus 2 by 3, then this expression would be minimum. Now sir, it could be maximum as well. You can check, right? Beta equals to minus 2 by 3. Now what could be the range of beta? Range of beta could be between minus 2 to 0. And what could be the range of alpha? What I mean to say is that alpha should be belonging to 0 to 1 and beta should be belonging to minus 2 to 0. So beta value is minus 2 by 3. So you put this beta value into this particular answer and calculate the noise power. Then you put the value of beta equals to minus 2 and then calculate the noise power. You will get to know that the noise power at beta equals to minus 2 is more than the noise power at beta equals to minus 2 by 3. Basically at beta equals to minus 2 by 3, sir, whenever you differentiate and put equals to 0, it could be minimum as well, it could be maximum as well. So sir, how do we define whether it is minimum or maximum? So in the examination you are not going to check it, right? In the examination you got beta equals to minus 2 by 3, then you would know that you have to trust on the process that surely it would be minimum only. Surely here the error would be minimum. You will not put this value here and you are going to check it. No. At beta equals to minus 2 by 3, then noise power would be minimum only. And here as well at alpha equals to 1 by 2, the noise power would be minimum only. Because just think about it, if I map the value to 1 or if I map the value to 0, then what will happen here? X square into 1 by 2, because I am mapping the value to 0. Alpha is 0. So x square into 1 by 2 dot dx, 0 to 1. Isn't it equals to the signal power only? Basically, what is this expression? This is equals to expectation of x square only. Although it is our noise power, but noise power is coming out to be equals to the message power. This power and noise power both are equal. That means this is actually the maximum power. So whenever you want the noise power to be maximum, you will map at the boundary points. Between 0 to 1, every value will be mapped to 1, or between 0 to 1, every value will be mapped to 0. So if you want the maximum power, maximum noise power, if you want this expression to be maximum, then you will map at the boundary. Because if I map at the boundary, then my signal power would become equals to the noise power. But I want the power to be minimum. I want the quantization noise error to be minimum. So if I want it to be minimum, then I will map somewhere in between. So it is pretty obvious that if your PDF is uniform, then you will map at the middle point only, no? If your PDF is uniform, then you will map at the middle point only. Why is that so, sir? Why is that so? Isn't it pretty obvious? Because if I am mapping it at the middle point only, then you would say that it is at the same distance from 0 and at the same distance from 1. But PDF has to be uniform. if it is non-uniform like this, if it is non-uniform, the way it is going from -2 to 0, it is linear. So if PDF is not uniform, then you will say that, sir, what if I map it right in the middle? What if I map it to -1? You will say that, sir, -1 is near to -2 and it is near to 0 as well, same distance. But probability of taking the values between -2 to -1 is lesser than the probability of taking values between -1 to 0. That means mapping should be done near to 0. So that's why the point came out to be -2/3. Look, all these points we are going to discuss in information theory. In the information theory, the quantizer will again come back. It will do a cameo. Okay. In movies, some people do the cameo, no? So it will do a cameo in entropy, or you can say it will do the cameo in information theory. So when we study information theory, all these points will again come. As of now, I am just giving a trailer that what is about to happen or how you can think. The PDF is uniform here, so mapping should be done at the midpoint only. Why is that so? Because 1/2 is near to 0, it is near to 1 as well. If I map it to 1/4, then 1/4 will be nearer to 0, but it will be farther from 1. So you need to map at the midpoint. And here another thing is that probability of taking the value, probability of random variable x taking the value from 0 to 1/2 is equals to the probability of random variable x taking the value between 1/2 to 1. So those probabilities are equal. If those probabilities are equal, then midpoint mapping is fine. But here if I had mapped to -1, then what would be the issue for me? Then the issue would have been that, sir, this -1 is nearer to -2 and same goes for 0 as well, it is nearer to 0 as well. But the probability of random variable x taking the value between -2 to 1 is lesser than the probability of random variable x taking value between -1 to 0. Because this particular probability is more and this particular probability is lesser. So midpoint mapping here I will not be preferring, right? So that's the point. All these points will again come back, don't worry about that. But as of now, you have understood the analysis, how I would have done with respect to mathematics. So this is how I would have done with respect to mathematics. The value of alpha such that the noise power is minimum is coming out to be 1/2, and the value of beta such that noise power is minimum, that is coming out to be -2/3. What you need to find? Alpha star minus beta star. So alpha star is the value of alpha only, beta star is the value of beta only. So what would be your alpha minus beta? So your final answer would simply be 1/2 minus of -2/3. So it would be 1.16. So that would be the final answer. Okay. Calculation was complex here. There is nothing we can do about it. Let's go to the next one. There is a simple point. There is a simple note. In the question, if this is written that this decision threshold of quantizer are chosen so that it will maximize the entropy of the quantized output. Now, sir, what is this entropy? We don't know. We will study about it in the information theory. Okay. But as of now, in the PYQs or in this lecture, if this particular statement is written that decision threshold of the quantizer, there will be a quantizer, right? There will be a quantizer. In the quantizer, there will be an input and there will be output. So input will have a dynamic range. Let's just say the dynamic range of input is between A to B. Okay. And it will have some decision threshold as well, right? The quantizer will have some decision thresholds as well, and final output will be quantized at x of q, right? So they have chosen the decision levels in a manner that, or decision threshold in a manner that the quantized output will have the maximized entropy. But you don't know the meaning of entropy. So if this statement is written, then how would you solve the problem? That I will tell you. Or what could be written? It could be written that quantizer is designed assuming equiprobable occurrence of all quantization level. What does that mean? Just think about it. Designed assuming equiprobable occurrence of all quantization level. Let's just say my dynamic range of x is between A to B, and this is a 3-level quantizer. What I am assuming, this is a 3-level quantizer. That means I need to make 3 level here. So let's just say this value is alpha, this value is beta. So 3 levels are there. This is your level 1, this is your level 2, this is your level 3. Step size could be different, okay. This is having a step size of delta 1, this is having a step size of delta 2, and this is having a step size of delta 3. So what is the meaning of equiprobable occurrence of all quantization level? That means probability is such that random variable x taking value between a to alpha should be equals to probability such that random variable x taking value between alpha to beta should be equals to probability of random variable x taking value between beta to b. That means all the levels are having equal probabilities. All the levels a to alpha, alpha to beta, beta to b. All the levels are having equal probability. That is the meaning of equiprobable occurrence of all quantization level. A to alpha, alpha to beta, beta to b. Equiprobable occurrence of all quantization level. Is that clear to you? All good? All fine? So this statement is written, if this particular thing is happening, then entropy will also be maximized. What I am saying, if this particular thing is happening, then this particular thing will also happen. So in the examination, any of the statement could be written. We will talk about this statement when we study information theory, because quantizer will again come back when we study about information theory. So we will talk about this point in the information theory. Here, understanding this point is very easy, right? What is the meaning of this point? Let's just say our input is taking the value, or our input is having a dynamic range between A to B, and the quantizer is having 3 level. Quantizer is using 3 level to quantize this random variable. That means there will be another decision thresholds, alpha and beta, right? Equiprobable occurrence of all quantization level. There are 3 levels, L1, L2, L3. So level L1 is there between A to alpha, level L2 is there between alpha to beta, and level L3 is there between beta to B. Equiprobable means probability of random variable x taking the value between A to alpha should be equals to probability of random variable x taking value between alpha to beta should be equals to probability of random variable x taking value between beta to b. All good? All fine? Right? Another thing is there are two kind of quantizers, mid-trade and mid-rise. No one will ask you what is mid-trade, no one will ask you what is mid-rise, but in the examination, if these words are written that we are using mid-trade quantizer, so you should not be getting confused. To solve a particular problem, it will not be used. What I am saying, to solve a particular problem, the concept of mid-trade quantizer or concept of mid-rise quantizer will not be used. But you just need to know the meaning. So let's understand the meaning of mid-trade and a mid-rise quantizer. So forget about this slide. Let's come here. So there is a random variable x which is fed to a quantizer which is having a decision thresholds of -2, 0, 2, +4 and -4. And random variable x is having a dynamic range from -4 to +4. We are using what we are using? We are using midpoint mapping. So it will be mapped to -3, -1, +1 and 3. Here what will be the mapping? It will be mapped to -2, it will be mapped to 0 and it will be mapped to 2. Okay, -2, 0, 2, -1, -3, -1, 1 and 3. So this was the value of x and this was the quantized value. This was the value of x, this was the quantized value, right? Now if one of the quantized value is 0, if one of the quantized value is 0, then it is known as mid-trade quantization, mid-trade quantizer. And if one of the decision threshold is 0, if one of the decision threshold is 0, then it is known as mid-rise quantization, mid-rise quantizer. Do you understand? To solve a particular problem, it will not be used. Just in the examination, if mid-rise is written, mid-rise quantizer is written or mid-trade quantizer is written, then you should be knowing the meaning of both of them. That's it. Okay, nothing else. So both are uniform quantizer. First thing is that both are uniform. That means both will have the same, both will have the uniform step size. So here step size is of 2, again 2, again 2, again 2. So both will have uniform step size. Here as well, the step size is 2, step size is 2 and so on. So both are the case of uniform quantization. What is the meaning of if one of the quantized value is 0? If one of the quantized value is 0, then it is known as mid trade. Okay, and if one of the decision threshold is 0, then it is known as mid rise. In the examination, in some problems, these statement would be written. That what is written? A symmetric 3-level mid trade quantizer is designed assuming equiprobable occurrence of all quantization level. So you know the meaning of a mid trade quantizer here. Okay, so here they did not tell what kind of mapping they are using. What I am saying here, they did not tell whether you are using a midpoint mapping or not. So by default we take midpoint mapping, right? But here as well you can get to know that if it is mid trade quantizer, if it is a mid trade quantizer, that means one of the mapped value will be 0. If it is mid trade quantizer, then one of the mapped value will be 0. So surely here 0 value will be mapped. That I am pretty sure that this will be my one of the quantized value. So let's not make in this diagram. So what they are saying, it should be designed assuming equiprobable occurrence of all quantization level. This is what they are saying. Equiprobable occurrence of all quantization level. Now what all are the quantization level? It should be given in the problem. So actually this is a gate problem only, so it was given. They said that this is region 1, this is region 2. This was given in the problem, okay? And this is region 3. So quantization levels are, this is one quantization level, this is other quantization level, and this is your third quantization level. Okay, well and good. Now what they are saying, equiprobable occurrence of all quantization level. What does that mean? That means if this is my quantizer and applied value is x and quantized value is xq, quantizer applied value is x, quantized value is xq. So this value x should be there in a manner that probability of random variable x taking value between -3 to -a should be equals to probability of random variable x taking the value between -a to +a, -a to +a, and then from a to 3. These should be equal. This is what they are saying. So let's check that. This is 1 by 4, this is 1 by 8. So what will be the probability such that random variable x is taking value between -3 to -a? So forget about that. First let's check this probability. What will be this probability? So this length is 2a and this length is 1 by 4. So 2a into 1 by 4. So this value will be 2a into 1 by 4. Right? Now from a to 3. Sir, what is this length? So this length is 3 minus a. This length is 3 minus a. But I don't need to consider 3 minus a. First I need to consider this much length. Basically I need to find out the area, that's it. I need to find out the area from a to 3. This is what I need to do. So this length is 1 minus a multiplied with 1 by 4. So 1 minus a multiplied with 1 by 4 plus. So this length is 2. 2 multiplied with 1 by 8. 2 multiplied with 1 by 8. So this will be 1 by 4 as well. So what you are getting? 2a by 4 is equals to 2 minus a divided by 4. So what is the value of a you are getting? A is equals to 2 by 3. So value of a you are getting as 2 by 3. So what do you understand? At the input of the quantizer, this is my random variable x. Random variable. This is my random variable x, which is having a dynamic range of -3 to +3. Dynamic range of -3 to +3. And quantization levels are there at -a and +a as well. Sorry, quantization, I should not say quantization level, I should say quantization threshold. Quantization thresholds are there at -a, +a. Okay, the question is incomplete. They said that these are the three regions. From there, what do you understand? That -a would be one of the quantization level. Sorry, -a would be one of the quantization threshold, and +a will also be one of the quantization threshold. So this is the scenario. This would be -a and this would be +a. So this would be -2 by 3, -2 by 3, and this would be 2 by 3. All good? All fine? Okay. Next, what they are asking, find out the value of A. Find out the quantization noise power for the region between minus A to A. For the region between minus A to A. For the region between minus A to A. Are we having uniform PDF? Between minus A to A. If I ask you between minus 3 to plus 3, are you having uniform PDF? Answer would be no. If I ask you between minus 3 to minus A, between minus 3 to minus A, are you having uniform PDF? No. Sir, PDF is here uniform and then some different value. So this is also not uniform. If in this region I would have asked you what is the quantization noise power, then you would have to apply the conventional formula. You would find out the mapped value, which will be midpoint mapping. So midpoint mapping you would have find out, then x minus whatever the mapped value is there, whole square, fx of x, then fx of x you need to break down in two limits, between minus 3 to minus 1 and between minus 1 to minus a. Between minus 3 to minus 1, this fx value will be 1 by 8, after that it will be 1 by 4. So in that manner you needed to solve. But what they are asking between minus a to a. Here the PDF is uniform. Mapped value, you know that mapping will be done at x equals to 0, but I don't care about that. Wherever the mapping is done, I don't care about that. I only know that PDF is uniform, so I can apply my formula. Delta square by 12 into area. And what will be your step size? That you can directly see. Step size will be 4 by 3. 4 by 3. And what will be this much area? So this is 1 by 4. So 1 by 4 into 4 by 3, or that would be, area will be 1 by 3. Here the area will be 1 by 3. So this was the answer of first question. Answer of second problem will be, quantization noise power would be delta square by 12 into area. So what is the value of delta? 4 by 3 ka 4 by 3 whole square divided by 12 into area is 1 by 3. Okay. So I will use the calculator and write down the final answer. Okay. So let me do the calculation. So answer is coming out to be 0.05. Okay. So this question is done. So you understood the meaning of equiparable occurrence of all quantization level. This was the level 1, level 2, level 3. That means all should be occurring with equal probability. That means random variable x taking the value between minus 3 to minus a, whatever the probability is there, that should be same such that random variable x is taking value between minus a to plus a, and that should be the same such that random variable x is taking value between a to 3. Equiprobable occurrence of all quantization level. Or they could have written that entropy is maximized. Okay, the quantizer output entropy is maximized. If quantizer output entropy is maximized, that means equiparable occurrence of all quantization level. And you also know the meaning of mid-trade quantizer as well. Okay, one of the mapped value will be at 0, which is not a matter of concern for solving this particular question. Yeah, it is a matter of concern. Why it is a matter of concern? Because this formula is applicable only for midpoint mapping, no? And you know that between minus 2 by 3 to plus 2 by 3, where the value will be mapped? Value will be mapped to 0, that's for sure. And from here you got to know that midpoint mapping is used. Actually, to solve this problem, there is a use of mid-trade quantizer. Why there is a use of mid-trade quantizer? Because you know that in mid-trade quantizer, one of the quantized value will be 0 for sure. One of the quantized value will be 0 for sure. So I know that 0 is my quantized value. If 0 is your quantized value, what does that mean? That means that between minus a to a, midpoint mapping has been used. And if midpoint mapping has been used, then I can apply this formula. Okay, so here we did not take midpoint mapping by default. By default, midpoint mapping was not taken. It was actually solved with respect to the question, because in the problem they have mentioned mid-trade quantizer. Okay, all good. Before solving the next problem, just revise something that we have already studied in random variable, but you might have forgot it. So if your random variable x was having triangular distribution with taking value between minus alpha to alpha with midpoint being 0. So what was the total power? That means what was the expectation of x square? What was the mean square value of x? You might have forgot the formula. It was alpha square by 6. Okay, but I will be using these formulas somewhere. That's why I am writing down alpha square by 6. And similarly, if your random variable x was uniformly distributed between minus alpha to alpha, then what was the total power? This I told you to remember, alpha square by 3. Okay. So for the triangular one as well, you will remember the formula now. This was for uniform. For uniform, I guess it would be easy for you to remember alpha square by 3. Just in the triangular, it will be half of that. Alpha square by 3 multiply with 1 by 2. So alpha square by 6. Okay. Let's solve the next question. Now in the next question, what you need to do? You need to find out the signal power to quantization noise power ratio. That means find out the signal power and find out the quantization noise power, and then you take the ratio. And it is known as SQNR. Signal power to quantization noise power ratio. Signal power to quantization noise power ratio. SQNR, very famous word. Okay, SQNR. So SQNR we need to find. So first let me know what will be the signal power. Signal power. Signal power I am denoting by S. What that would be? That would be alpha square by 3. Uniform distribution is there, alpha square by 3, that means 3 square by 3. So that would be equals to 3. 3 watt you can write down, whatever you want to write down. Quantization noise power. What do you mean by quantization noise power? Can you find out the quantization noise power for this one? Very simple, delta square by 12. Quantization noise power, right? Uniform distribution is there, midpoint, 3 level uniform quantizer. It is 3 level uniform quantizer. What does that mean? That means 3 levels would be there. Minus 3, 3. So 3 levels should be there. What does that mean? Minus 1 and 1. Uniform quantizer it is 2. Step size is 2. Step size is 2. And midpoint mapping you need to do. So this will be mapped to minus 2. This will be mapped to 0. And this will be mapped to 2. Midpoint mapping is used. Step size is also uniform. Everything is fine. What I need to find? I need to find quantization noise power. I know that between minus 3 to 3 I am having uniform PDF. Between minus 1 to 1 I am having uniform PDF. Between 1 to 3 I am having uniform PDF. So in all the 3 regions I am having uniform PDFs. Right? If I am having uniform PDFs, that means I can apply the formula. What is the formula? Formula says quantization noise power. So what does the formula say? Sir, delta square by 12, delta 1 square by 12, but actually you know that step size is same. Here I should have written delta 1 square by 12, then this area, delta 2 square by 12, then this area, delta 3 square by 12, then this area. But for all of them, step size is same, no? So delta square by 12, area A1, plus delta square by 12, area A2, plus delta square by 12, area A3. Now if I take delta square by 12 common, then let me know what will be the value of A1 plus A2 plus A3. What is A1? A1 is this area. Between minus 3 to minus 1. This will be the area A1. Between minus 1 to plus 1, this will be the area A2. And between 1 to 3, this will be the area A3. Okay, so A1 plus A2 plus A3 will be equals to 1. Right? So what will be the final answer? Final answer will be delta square by 12. And what is the value of delta? Delta value is 2. So 2, delta value is 2. So 4 divided by 12, it will be equals to 1 by 3. Okay, delta value is 2. 2 square divided by 12, 1 by 3. So what will be your SQNR? Signal power. What is the signal power? Signal power is 3. And what is the quantization noise power? That is 1 by 3. So SQNR is 9. So this is the answer in decimal. You can denote it in the dB as well. So if they are asking SQNR in dB, what you will do? You will take 10 log 10. Okay. So answer would be, so 10 log 10, 9. That would be the answer. So you can take the log and then 9 take log and then multiply with 10. So answer would be 9.54 dB. Okay. So this is your SQNR in dB and this is the decimal answer. Mostly they will be asking in dB. So answer would be 9.54 dB. Okay, well and good, very simple. An input to a 6-level quantizer has probability density function of fx of x as shown in the figure. The decision boundaries of the quantizer are chosen so as to maximize the entropy of the quantizer output. What does that mean? That means equiprobable occurrence of all the quantization level. Equiprobable occurrence of all the quantization level. This is the meaning of maximize the entropy of the quantizer output, right? And 6 level quantizer it is. What it is? 6 level quantizer it is. Okay. It is given that 3 consecutive decision thresholds are -1, 0, 1. So if it is a 6 level quantizer, let's just say if it was a 2 level quantizer, if it was a 2 level quantizer, or let's call it if it was a 3 level quantizer, then what would be your decision thresholds? -1, 1. So level 1, level 2, level 3, right? Considering uniform step size. If I am considering uniform step size, then basically if it is a 3 level quantizer, then decision thresholds are 4. 1, 2, 3, 4. If it is a 4 level quantizer, let us say it was A, it was B. So C, D, E. So there will be 5 decision threshold, level 1, level 2, level 3, level 4. So there will be 5 decision threshold. 1, 2, 3, 4, 5. 5 decision thresholds would be there, right? So if it is a 6 level quantizer, so how many decision thresholds will be there? 7 decision thresholds will be there, right? So one decision threshold is -1, another one is 0, another one is 1, and surely 2 decision threshold will be at boundary, -5 and +5. So now there will be one more decision threshold that will be coming somewhere in between -1 to -5 and somewhere in between 1 to 5. Let's just say that decision threshold is alpha and another decision threshold is beta. Is that clear to you or not? Decision thresholds are given which are -1, 0, 1. So another 2 will be the boundary points, -5 and 5. I need 7 decision threshold because level 1, level 2, level 3, level 4, level 5 and level 6. That means 2 more decision threshold will be there somewhere in between. Now I know one thing. What do I know? Maximize the entropy of quantizer output. What does that mean? That means equiprobable occurrence of all quantization level. Equiprobable occurrence of all quantization level. That means probability such that random variable x is taking value between -5 to alpha. Random variable x is taking value between -5 to alpha should be equals to this, right? Sorry, alpha to -1. If this is one of the quantization level and this is another quantization level, then probability of random variable x taking value between -5 to alpha and probability of random variable x taking value between alpha to -1 both should be equals to 0. Without doing the calculation, can you let me know the value of alpha? It would be -3, right? Very simple thing, no? I want this probability, I want this area to be equals to this area. Both are having the same amplitude, both are having the same length. That means I want this height to be equal as well. Sorry. Both are having the same height. The height is b. Both are having the same height. That means I want this length to be equal as well. That means alpha should be the midpoint of -5 and -1. What will be the midpoint of -5 and -1? That would be -3. Are you able to understand? Or you can apply the mathematics as well. But without even doing the calculation, you should be able to understand that alpha value will be -3 and beta value will be +3. What I mean to say is that what is this height? B. So probability such that random variable x is taking value between -5 to alpha. What that would be? That would be, sir, alpha minus of -5. That would be alpha plus 5. What this will be? This will be this length, alpha plus 5. And what will be this length? This length will be -1 minus alpha, and this length will be alpha plus 5. Multiply with b. So -1 minus alpha, multiply with b. So what will be the value of alpha? Alpha value will be minus 6. So this is the value of, alpha value will be minus 3. And beta value will be plus 3. So let's not do anything here. Very simple thing it was. So from here I will get to know that this is my alpha, which will come out to be minus 3, and this will come out to be plus 3. Okay, so decision boundaries we have, decision thresholds we have find out. So effectively our decision thresholds are minus 5, minus 3, minus 1, minus 5, minus 3, minus 1, 0, 1, 3, 5. Okay, these are our decision thresholds. We need to find out the value of A and B. What you will do? How will you find out the value of A and B? First thing is that you can use this relation. Another thing also you know. What do you know? That this total area would be equals to 1, right? What do I know? Since this is a PDF, so for any PDF, this relation I already know, no? Right? So this length is 4, 4 multiply with B, 4 multiply with B, plus again 4 multiply with B, plus 2 multiply with A would be equals to 1. That means 2A plus 8B equals to 1. So this is one relation we are getting, 2A plus 8B equals to 1. Very simple thing, 4 into B, 4 into B, 2 into A, and total area should be equals to 1. Now another thing I can use, what I can use? The probability of random variable x taking value between 0 to 1 would be equals to probability of random variable x taking value between 1 to 3. What I am saying, using this relation, what I can do? Probability of random variable x taking value between 1 to 3. 1, 2, 3. Basically, I need to include one relation which will take B as well and which will take A as well. Now, someone will say that, sir, if I apply this relation, that probability of random variable x taking value between 1 to 3 should be equals to probability of random variable x taking value between 3 to 5. So, both of the relation will come in terms of B only, no? So, this is not helpful for me. What I will do? I know that these are my quantization levels. One level, this is the one level, this is 2 level, this is 3 level, 4 level, 5 level, and 6 level. These are the 6 levels I am having. So I will pick this level and then I will pick this level and I will equate those probabilities. From there I can get another relation between A and B, and if I get another relation between A and B, my job will be done. So between 0 to 1, what will be the probability? Probability of random variable x taking value between 1 to 3 would be equals to probability of random variable x taking value between 0 to 1. A into 1, this would be A, and between 1 to 3, that would be 2B. So 2B would be equals to A. This is the another relation you are getting. 2B is equals to A, and another relation that you have, 2A equals to 8B. Sorry, 2A plus 8B equals to 1. 2A plus 8B equals to 1. So A is equals to 2B, A is equals to 2B, so this will be 4B. So 12B equals to 1. So B is equals to 1 by 12. A is equals to 1 by 12 into 2, what that would be? 1 by 6. So these are the values of A and B. So two equations we were having, we can solve those equations and we can get the value of A and B. Now assuming the reconstruction level of quantizer are using midpoint mapping of that decision boundaries, determine the ratio of signal power to the quantization power. So midpoint mapping they are using, you need to find out signal power to the quantization noise power. So first I will mark the value of A and B. A is 1 by 6, B is 1 by 12. So let's find out the signal power first. Is it a uniform PDF? No. Is it a uniform PDF? Between -5 to 5, is it a uniform PDF? Absolutely not. Right? So if it is not a uniform PDF, you need to find out the power of random variable x, then you have to go by the general formula. So let's go by the general formula. So what I need to find? I need to find out the signal power first. Signal power, that is equals to expectation of x square minus infinity to infinity x square fx of x dot dx minus 5 to minus 1 fx of x is having a certain value, that is 1 by 12. So what I can do? I can break the limit like this: minus 5 to minus 1 x square. What is the value of fx of x? Fx of x is 1 by 12 dot dx plus between minus 1 to plus 1, it is also having a certain value, that is 1 by 6. So I can break the limit like minus 1 to plus 1, right? X square fx of x will be 1 by 6 dot dx. So what I can do? Minus 1 to plus 1 x square fx of x is 1 by 6 dot dx, and then between 1 to 5 as well, I can do the same thing. Say yes or no. Is that okay for you? X square fx of x, that is 1 by 12 dot dx. This would be my signal power. Now can I write it down in this manner? 2 into minus 5 to minus 1 x square by 12 dot dx plus minus 1 to 0 x square by 6 dot dx. Is it fine? Minus 5 to minus 1, minus 1 to 0. Minus 5 to minus 1, minus 1 to 0. And then the same thing is happening this side as well. If you don't understand this step, it is fine. This is just mathematics. Minus 5 to minus 1, same thing is happening to 1 to 5 as well. Minus 1 to plus 1. So whatever that is happening between minus 1 to 0, the same thing is happening between 0 to 1 as well. So if you don't understand this step, it is absolutely fine. You can solve this integration. So we will solve this integration only. So what we will be getting? 1 by 36. Then we will be getting x cube. So 125 cube minus 5 cube will be 125 minus 1. So 125 minus 1. Just put the limit, nothing else. One by 36 x cube, if I put minus 5 to minus 1. Yeah, okay. So 125 minus 1, this is what you will be getting. Same thing you will be getting here as well. What about this one? 1 by 18 x cube, 1 cube minus 1 cube, that would be 2. You can do the calculation on your own, right? And this will also be 124 divided by 36. So what we are getting? 124 divided by 36 into 2 plus 2 by 18. 7. So signal power is coming out to be 7 watt or whatever it is. Okay, signal power is coming out to be 7. Right. Now I need to find out noise power. So for noise power, what I will do, again I will make my diagram. I will make my levels. So random variable x is taking value between minus 5 to plus 5. Minus 5 to minus 3 will be one level. Then minus 3 to minus 1 will be another level. Then from 0 to 1 will be another level. Then 1 to 3 will be another level. Then 3 to 5 will be another level. Now what is the step size here? Step size is 2. What is the step size here? 2. What is the step size here? 1. Here step size is 1. Here the step size is 2. And here the step size is 2. Right? PDF between minus 5 to minus 3. Uniform PDF between minus 3 to minus 1. Uniform PDF between minus 1 to 0. Uniform PDF between 0 to 1. Uniform PDF Between 1 to 3 uniform PDF, between 3 to 5 uniform PDF. Uniform PDF, uniform PDF, uniform PDF, uniform PDF, uniform PDF, and uniform PDF. 1 by 12, 1 by 12, 1 by 6, 1 by 6. So what will be your noise power? Noise power will be delta square by 12, delta square by 12, 4 by 12, delta is 2, 2 square by 12 into the area. What will be this area? 1 by 12 into 2. So this area will be 1 by 6. What will be this area? 1 by 6. What will be this area? 1 by 6. What will be this area? 1 by 6. What about this area? That will also be 1 by 6. Right? So delta square by 12 into 1 by 6. That will be happening for 4 times. So delta square by 12 into this area, that is 1 by 6. Delta square by 12 into this area, that is 1 by 6. Delta square by 12 into this area, that is 1 by 6. And delta square by 12 into this area, that is also 1 by 6. So it will be happening for the 4 times. Plus delta square by 12. Delta is 1. Delta square by 12 into this area. What is that? 1 by 6. That will be happening for 2 times. Right? Four by 18. Right? 1 by 3. 6 into 3. 18. Upper side 4. 1 by 36. 9 by 36. That will be 1 by 4. So noise power is coming out to be 1 by 4. This was your signal power. This was your noise power. So what will be your SQNR? Signal to noise ratio. So 7 divided by 1 by 4. That is equals to 28. And SQNR in dB, what that would be? 28 into 10. 14.47 dB. That will be the final answer. Okay, well and good. 28 and then in dB 10 log 28. 10 log 28, 14.47 dB. This is what you are getting. All fine. Very simple question. So whatever that we have studied till now, everything is used here. Are you able to understand this point? So these kind of questions can be asked in your examination, and very simple. Just if you have good enough concentration, then you will be able to solve these problems. Don't feel like that, sir, calculation is big. No. For finding out A and B value, you will be able to find out very easily. This alpha beta value, you will be able to find out very easily. And then this is just a very simple calculation. Signal power might take some time. This integration might take some time, but this will not take much time. Because here I know that midpoint mapping is used. So delta square by 12 into the area that I can apply. Let's go to next problem. A sinusoid signal with peak amplitude of AM is applied to a 3-bit uniform quantizer. Find SQNR. The question seems very incomplete, right? What they are saying, there is a quantizer which is a 3-bit quantizer. Sir, there is no meaning of bit in the quantizer, no. Encoder will have some bit. After the quantizer, what do you have? Sir, it will have some levels. Then encoder would be there, encoder would be having the bits. So basically this setup is quantizer plus encoder. A lot of time in the quantizer they will set up the number of bits. What does that mean? That means this setup is quantizer plus encoder. Is that okay for you or not? Okay. So L less than equals to 2 to the power n, that you need to take care. So this n is the number of bit which is used in the encoder. But you will understand L is less than equals to 2 to the power n. Okay. So L will be less than equals to 2 to the power n, that means 8. So there will be, this is your 8 level quantizer. Okay, 8 level quantizer it is. So what I was saying, there is a quantizer. At the input of the quantizer, a sinusoid is applied with peak amplitude of AM. So what is a sinusoid? This is a sinusoid, right? If peak amplitude is AM, then what this point would be? Minus AM. That means what is the dynamic range of the input? What is the dynamic range of the input? Dynamic range of the input is 2 AM, and that is applied at the input, and you will get some output. You need to find out the SQ and R. Can you let me know the signal power? Signal power will be AM square by 2. For a sinusoid, this is your sinusoid. What is the power of this sinusoid? And sinusoid should always be periodic. That means it will go from minus infinity to plus infinity. All these things we have seen in the signal system. So what is the power of a sinusoid? AM square by 2, right? Now what I need to find? Quantization noise power. How will I find it? The sinusoid is taking value between minus AM to plus AM. That means my input is taking value between minus AM to plus AM. That I know. Minus AM to plus AM. But is it taking the value uniformly or not uniformly? Do I know that? No. So any kind of question is there. In your gate examination, any kind of problem is there. If mapping is not mentioned, then you will take midpoint mapping. If mapping is not mentioned, you will always take a midpoint mapping. And if the distribution is not mentioned, then you will take uniform distribution. That means this sinusoid will be taking value between minus AM to plus AM uniformly. Is that okay for you or not? So I will consider uniform. What I will consider? I will consider uniform distribution. And midpoint mapping also I will use. So I can apply the formula of delta square by 12. 3-bit uniform quantizer we are using, that means number of levels will be 8. So what will be my step size? Step size would be equals to dynamic range divided by the number of levels. Dynamic range 2 AM divided by the number of levels 2 to the power n. Okay, 2 to the power n, and I am writing down. So what I am getting? 2 AM divided by 2 to the power n. This is what I am getting. So let's just say 8 levels I need to make. So 1 level, 2 level, 3 level, 4 level, 5 level, 6 level, 7 level, and 8 levels. And this point is, I am assuming as AM. So 8 levels I have made. But this is your delta I am getting. So delta step size here, delta step size here, delta step size here, delta step size here. Everywhere delta step size is there. And PDF I will take uniform, 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 and so on. So always I will take uniform PDF. So what will be my noise power? Noise power will be delta square by 12 area A1 plus delta square by 12 area A2 and so on. So in that manner what I will do? Delta square by 12 area A1 plus A2 plus A3 and so on, what that would be equivalent to? 1. So basically now I am using delta square by 12. This is my quantization noise power. Again the question is not making much sense. But these kind of questions you can find out in some of the previous gate year questions and in a lot of PSU examination. Whatever the level of gate examination is currently, based on the current level of gate examination, I don't think these kind of questions will be coming. These kind of problems will be coming in your examination based on the current level of gate examination. But as per the previous level, these kind of problems have also come, and it will not be any surprise if even in 2026 as well these kind of problems can come. Okay, so if they want to frame a very easy question just based on some formula, from here we will derive some formula. Okay, but I will tell you one thing, that that kind of formula is derived for which condition? For this condition, that uniform quantization is used, the PDF is uniform, and midpoint mapping is done. Then you can say that formula is applicable. Along with that, input is also sinusoid. So we will derive some formula, but in the examination, if you get the number of bits, if you just see that I am having number of bits given, that's it. You can apply that particular formula. Okay, so which formula, that I will tell you, but I am just telling that a lot of information is not given. And in the examination as well, it can happen that a lot of information might not be given. you have to consider certain things. Uniform PDF, midpoint mapping, all these I assumed, and I know that my noise power will be delta square by 12. What will be my delta square? Delta square would be 4am square divided by 2 to the power n, 2 to the power n whole square, 2 to the power n whole square. What that would be? 2 to the power 2n. What is 2 to the power 2n? That would be 4 to the power n, right? So noise power is coming out to be what is your delta? 4am square divided by 4 to the power n. Delta square divided by 12. SQNR, signal to noise power. Signal power divided by noise power. So what answer you are getting? 3 into 4 to the power n divided by 2. Again, don't mug it up. What you need to do? SQNR in dB. So 10 log 10, 1.5 into 4 to the power n. So can I write it down in this manner? 10 log 10, 1.5 plus 10 log 10, 4 to the power n. N can come outside, right? So 1.5 log 10 into 10, 1.76 plus 4 log 10 into 10, that would be 6.02. Effectively you can write down 1.76 plus 6n. This is your SQNR in dB. You will remember this answer, but again, what all conditions are there? Uniform quantization, uniform n bit quantization, okay, n bit quantization, sinusoid input with uniform PDF and midpoint mapping. So do you really think that GATE is going to ask these kind of questions? Based on today's level, based on the current level, I don't think they will be asking these kind of problems. But in a lot of PSU examination, what they will say, a quantizer, n bit quantizer is used, or they can give 8 bit quantizer is used with the sinusoid input. Find out the SQNR. 1.76 plus 6n, whatever the value of n is given, you put that value. Let's just say 8 is given, so 6 into 8 plus 1.76, 48 plus 1.76, 49.76 dB. That's it. This is your answer. Don't think anything that, sir, midpoint mapping is not given, uniform PDF is not given, sir, how do we solve it? Just remember this formula. Okay. Again, I don't think GATE should be asking these kind of problems, but PSUs can ask. All good? All fine? The core concept of quantization is clear to us. How to solve the problems, everything is clear to us. But just if these kind of problems are asked, we should be having the habit of solving these kind of problems. Again, focus on this part, n bit quantizer. Okay, n bit quantization. A random variable x is uniformly distributed and is applied to a 3-bit quantizer. Find SQNR in dB. Again, we will find out another formula. Random variable x is uniformly distributed between -am to +am. Uniform quantizer is given, 3-bit uniform quantizer is given. That means the number of levels will be 8, right? Number of levels will be 8. So 8 levels I can make. Uniform quantizer it is. So step size would be uniform. Again, midpoint mapping I will be using. what I will be doing, midpoint mapping I will be using. Okay, so signal power, what will be your signal power? For a uniformly distributed random variable, what is the signal power? Am square by 2, right? Signal power is Am square by 2. What do you think about noise power? Noise power. Uniform PDF, uniform PDF, uniform PDF, uniform PDF. What formula I will apply? So delta square by 12 into the area A1 plus delta square by 12 into the area A2 and so on. Delta square by 12 I will take common. A1 plus A2 plus A3. What I will get? 1. So your noise power is delta square by 12. Okay. So what is your step size? What is your step size? Dynamic range divided by the number of levels, 2 to the power n, right? So delta square by 12 would be 4 am square 4 to the power n into 12. So that would be am square by 3 into 4 to the power n. Big blunder from my side. Signal power will be am square by 3. Really sorry. For uniform PDF between minus am to am, right? For uniform PDF between minus alpha to alpha. Uniform PDF between minus alpha to alpha, power is alpha square by 3 and here it is alpha square by 6. So am square by 3 and this is coming out to be am square by 3 into 4 to the power n. So if I need to find out SQNR, what that would be? Am square by 3 divided by am square by 3 into 4 to the power n. What that would be equals to 4 to the power n. So SQNR in dB, that would be equivalent to 10 log 10 4 to the power n. So 10 log 10 4 to the power n, 10 log 10 4 to the power n is equals to 6.02 n. So what is your SQNR coming out to be? Approximately equals to 6n. So you need to take care of two kind of things. Sir, everything is same, just here the input was sinusoid and here the input was uniform. Input is sinusoid, value will be taken between minus am to am. Again I will have to consider uniform PDF only there. Basically from here to here, from here all the steps are same. Noise power is coming out to be the similar, delta square by 12. So noise power is coming out to be am square divided by 3 into 4 to the power n. Am square divided by 3 into 4 to the power n. So noise power is coming out to be same. Just problem is with the difference is there with the signal power. Signal power here is am square by 3 and here it was am square by 2. So where you are getting more signal power? In the sinusoid input. So answer would be 1.76 plus 6n and here it is only 6n. 6n dB. Okay, well and good. 1.76 plus 6n dB and here it is 6n dB. Okay, just 1 second guys, I need to turn off the network. So again I am saying in gate examination these kind of questions are not famous, but in PSU examination these kind of problems can come. So conclusion, for a sinusoid input fed to a n bit quantizer, SQNR is 1.76 plus 6n, and for uniform random variable input fed to a n bit quantizer, SQNR is 6n, both are in dB. So that would be the answer. Uniform quantizer they will mention, okay, uniform quantizer. That would be the answer. Again a very rough estimation, like a lot of estimation we have taken, uniform quantization we have taken, midpoint mapping we have taken. So a lot of things are there. Whatever the things that are there we have written down here. N bit uniform, n bit quantization, sinusoid input with uniform PDF, midpoint mapping is used. So after all these assumptions we are getting these expressions in dB. So try remembering it. Okay, all good, all fine. Now solve this question. A random variable x with uniform PDF is applied to a 3-level quantizer. Find SQNR in dB. And 3-level midpoint quantizer, whatever every assumption you need to take, and x is uniformly distributed between -6 to +6. Sir, SQNR formula is 6n. So now I need to find out the value of n. Sir, 3-level quantizer, that means n is equals to 2. Basically, to represent 2 level I need 1 bit, to represent 4 level I need 2 bits, to represent 8 level I need 3 bits. So to represent 3 level, how many bits I will be requiring? 2. So 6 into 2. So answer will be 12 dB. This and wrong. 3 level, n bit. So formula is there for n bit quantizer. In the examination, if n bit is mentioned, then only you can apply this formula. No, 3 levels are mentioned here. So signal power, what will be my signal power? According to this particular scenario, what will be the signal power? Sir, signal power will be 6 square by 3. This will be my signal power. And what will be my quantization noise power? Sir, noise power will be, sir, delta square by 12. But what is the value of delta here? 12 dynamic range divided by the number of levels. Now L is not equal to 2 to the power n here. No. Condition says L should be less than equal to 2 to the power n. But what is the formula of step size? I told you the formula of step size is dynamic range divided by the number of levels. So 12 divided by number of levels is 3. So that would be 4. If you are taking n equals to 2, then L is equals to, you are putting 4. But actually it is 3. So if n bit quantizer is mentioned, then only you will apply this formula. If number of levels are mentioned, then find out your dynamic range. Sorry, find out your step size. Step size is dynamic range divided by the number of levels, that would be 4. So delta square by 3, 4 square by, sorry, delta square by 12, 4 square by 12. So what will be your SQNR? 36 divided by 3, that would be 12, divided by 16 divided by 12. 144 divided by 16. 144 divided by 16, we are getting 9. SQNR we are getting equals to 9. But what we need to do, I need to represent in dB, so 10 log 10. So I am getting 9.54. So this will be the answer, 9.5 dB. Okay. So always take care, n bit. That's why here as well I said n bit, not levels. Okay. So from the level, don't find out the number of bits. If specifically number of bits are mentioned, 3-bit uniform quantizer, then only you will apply this formula. So if 3-bit quantizer is mentioned, that means they are using 8 level for sure. But if they are using 3 level, that means they are using 3 level only. Although number of bits required would be 4. Sorry, number of bits required would be 2. Here the value of n, if I ask you how many bits encoder would require, so you will say that, sir, encoder would require 2 bits. But for the analysis of quantizer, I will assume 3 levels only. The number of bits is not a matter of concern for me. Okay? Understood? Try solving this question. Random variable x uniformly distributed between -3 to 4. Positive values are mapped at +3 and negative values are mapped at -1. Find out the SQNR. Answer is also given. So no formula, nothing we will apply. Say yes or no. No formula, nothing, right? Uniform quantizer is given. It's not that always we will start applying the formula. It will be very rare case that I will apply this formula. Delta square by 12 directly. Because nothing is mentioned. Effectively, nothing is mentioned, right? So that's why I can apply the formula. Here also I did not apply the formula. In these two conditions only, I will apply the formula. That formula says 6n, here answer would be 18 and here answer would be 18 plus 1.76, that would be 19.76. So mostly I will solve by the pure concept. This was also pure concept and this will also I will solve by pure concept only. And here midpoint mapping is also not used. Your random variable x is taking value between -3 to 4. Now what they are saying, positive values are mapped at 3. That means if the value is there between 0 to 4, then these are mapped at 3. And if and negative values are mapped at -1, that means if the value is there between 0 to -3, then it is mapped at -1. Find out the SQNR. So can you tell me the signal power first? What will be your signal power? I don't remember, because this formula that I remember, alpha square by 3, that is there for minus alpha to alpha. If your PDF is uniform between minus alpha to alpha, then only this formula is applicable. But it is there between -3 to 4. So I need to find out the signal power as well. I need to find out your noise power as well. So what will be your signal power? You guys solve this problem. I am having a call, so I will come back. Solve this question. Yeah, so did you find out the signal power? So signal power we need to find out. So expectation of x square we need to find out, right? So -3 to 4 x square into fx of x. So what will be fx of x? That will be 1 by 7, right? Because it is uniformly distributed between -3 to 4. So amplitude will be 1 by 7. Very simple thing. So 1 by 21, x cube would be coming, 4 cube would be 64, and 3 cube will be 27, right? Cube of 3 will be 27, this will be 64. So 64 plus 27, 84 plus 7, that would be 91 divided by 21. 91 divided by 21. 91 divided by 21, 4.33. So this will be your signal power that is coming out to be. Okay. Now what I need to find? Noise power. So what will be my noise power? The expression of my noise power will simply be x taking the value between -3 to 0, value is mapped to -1, fx of x. What will be your fx of x? 1 by 7. This step should be solved, like this question should be solved by you. Otherwise, there is no meaning of studying, or there is no meaning of studying from me, right? Because if you are not able to solve this problem, that means either I failed or you failed. It might happen that I am failing, that you are not able to understand my content, or you have failed, that means you might not be concentrated enough. So one of us are failing, okay, either you or me. So you need to change your source of preparation if you are not able to solve this particular question. You can study from somewhere else as well. Everyone teaches very good, okay, don't worry about that. So but this question should be solved. So noise power, and every step whatever that I am writing, that should be clear to you. How I am writing this thing? What is this? This is your noise, this is your quantization error. So quantization error mapping to -1, x plus 1 whole square, fx of x, that is 1 by 7 dot dx, fx of x is 1 by 7 only, x minus 3 whole square dot dx. Then you solve this particular thing, 1 by 21, 1 by 21, x plus 1 whole cube. So you put 0 and then you put 8, 0, 1, 8, 9, it would be 9. Here I will be getting 9 plus 1 by 21 again, cube, that would be, if you put 0, if you put 4, what that would be 1, if you put 0, that would be 27. So this would be 28. Okay, just doing the calculation in a easy manner. So 21, 1, 4 minus 3 would be 1, and 0 minus 3, 9, 27, 28. Yeah. So 28 plus 9 divided by 21. 28 plus 9 divided by 21. So answer is coming out to be 1.76. So what will be your SQNR? 4.33 divided by 1.76. Reciprocal into 4.33. This is coming out to be 2.45, but I need to find out in dB. So log into 10. So 3.90. 3.90 dB. So this is your final answer. Here it is written 3.9 dB. This is your final answer. Very simple question, very straightforward. Just here midpoint mapping was not used. Till this point, in every equation we were taking midpoint mapping, but here midpoint mapping is not used. So x plus 1 whole square divided by 1 by 7, taking the limit from -3 to 0, and x minus 3 whole square divided by 7, taking the limit from 0 to 4. I could find out the signal power as well, I could find out the noise power as well, and I could get the answer. Right? Let's go to this question. Again, a very easy question. A uniform quantizer with step size delta is used to quantize a uniformly distributed input signal. Under midpoint mapping, each reconstruction level is normally placed at the midpoint of its quantization interval, like delta by 2, 3 delta by 2, and so on. Now suppose the reconstruction level are shifted by an additional offset of delta by 6. Determine the percentage change in the quantization noise power due to the shift of a reconstruction level. What do you understand by that? Let's just say there was an input which was having a dynamic range from A to B. Now it is fed to a quantizer which is having a step size of delta only. It is fed to a quantizer having a step size of delta. And then output will be quantized to some value. Quantizer having a step size of delta. Okay. So step size of delta is there. So what will be this point? This point will be A plus delta. What will be this point? This point will be A plus 2 delta. What will be this point? This point will be B minus delta. Basically step size is delta. So every level will be having a step size of delta. Every particular level will be having a step size of delta. Step size of delta. Step size of delta. Right? And midpoint mapping is used. Midpoint mapping is used. It will be mapped to. Now this step size is delta. And this point is A plus delta. So what will be the midpoint? Midpoint will be A plus delta by 2. This point will be A plus delta by 2. Are you able to understand this point? Basically, midpoint mapping is used, step size is delta, and uniformly distributed input is there. Uniformly distributed input is there. So what do you think? What is your quantization noise power? What will be your quantization noise power? That would be equals to N1, and that would be equals to delta square by 12. This will be your quantization noise power, delta square by 12. How did you get it? Uniform PDF, uniform step size, midpoint mapping. Delta square by 12 into area A1 plus area A2 plus area A3 and so on, it would be equals to 1 only. So delta square by 12, that would be the answer. Now what they are saying? They are saying that reconstruction levels are shifted by an additional offset of delta by 6. So previously mapping was done at A plus delta by 2. Now they are shifted by an additional offset of delta by 6. That means now the mapping will be done at delta by 2 plus delta by 6. Is that okay for you or not? So answer would be 2 delta by 3. Shifted by delta by 6. So delta by 2 is the midpoint plus delta by 6. So 4 delta by 6, what would be 4 delta by 6? That would be 2 delta by 3. So basically, if I take only one level, and let's just say this point I am calling 0. So what this point will be? Delta. I am taking only one level. Okay, I am taking only one level of step size delta. Previously the value was mapped here, delta by 2. But now the value is mapped at 2 delta by 3. Now sir, how do you know it is a positive offset? Sir, it could be negative offset as well. No, basically sir, delta by 2 minus delta by 6, because here they did not say positive offset, negative offset. They are just saying that shifted by delta by 6. Shifted towards the right hand side or left hand side, I don't know. So you can take this case as well, you will get the same answer. You can take this case as well, you will get the same answer. Okay. So here what you will do, this point will be delta by 3. So either you map it at delta by 3 or you map it at 2 delta by 3. In both of the cases, you will get the same answer. Don't worry about it. In case of uniform PDF, whether you map it to delta by 3 or you map it to 2 delta by 3, in both of the cases, you will get the same answer. I am solving by 2 delta by 3, you solve by delta by 3, you will get the same answer. Don't worry about it. Okay. So what will be your quantization noise power? N2. that would be n2. What is your n2? X minus 2 delta by 3 whole square. What will be your fx of x? Fx of x will be 1 by delta. Basically what I am doing, I am considering only one level. I am considering only one level. Now in this one level I know that my PDF is uniform. My PDF is uniform. Now if I consider only one level and I am considering that this is the dynamic range of the input and PDF is uniform, so what should be the amplitude here? That should be 1 by delta. If I say this complete area is 1, this complete area is 1. If I say the complete area is 1, this area is 1. And now I am saying that this particular thing is only fed to the quantizer. This thing is fed to the quantizer. This is what I am saying, that this particular input is fed to the quantizer. So what will be the output? Output will be quantized to a particular value and it will be quantized to 2 delta by 3. Input having a range between 0 to delta will be fed to a quantizer. Output will be quantized to 2 delta by 3. So what will be the amplitude? What will be your fx of x? That will be 1 by delta, no? Dot dx. And it is going from 0 to delta and mapped to 2 delta by 3. Okay. So what you will be getting? Similar thing you could have done. How did you get this delta square by 12? How did you get this delta by square? X minus delta by 2 whole square into 1 by delta dot dx 0 to delta. This is what you did and you got delta square by 12. Do you remember this thing? Similar thing I am doing here. X minus 2 delta by 3 whole square into 1 by delta dot dx from 0 to delta. Do you remember the derivation of this particular thing? If this step is confusing to you, then do you remember the derivation of delta square by 12? Yes sir, I remember the derivation. I assumed a uniform PDF between 0 to delta with the amplitude of 1 by delta and I mapped at the midpoint. Now the mapping is not at the midpoint, mapping is at 2 delta by 3, that's it. So x minus delta by 2, in place of that I need to put 2 delta by 3. My job is done, right? Three delta cube by 27. Okay, sorry. Delta cube by 27 minus 4 delta cube by 27. Yeah, calculation, only the calculation I am checking. If I put delta, then I will get if I put 0, then it is the cube. So 8 you will be getting here, not 4. So what is the 2 cube? 2 cube is 8, no? So 9 delta cube divided by 3 delta into 27. So delta square by 9. This is your n2 value. This is your quantization noise power. So when the mapping is done at 2 delta by 3, then this will be your quantization noise power. That is delta square by 9. In the previous case, it was delta square by 12. So what they are saying? Percentage change in the quantization noise power. Let's just say previously I had 100 rupees. Sorry, previously I had 50 rupees. Now I am having 100 rupees. So what is the percentage change? 100 minus 50 divided by 50. So 50 divided by 50, what we are getting? 100%. 50 divided by 50 into 100, percentage change I need to find. So 100% change is there. So previously I was getting 50 marks, now I am getting 100 marks. That means 100% improvement I have done. From 50 to 50 if you are getting, you have done 0% improvement. From 50 to 70 you are getting, so 70 minus 50 divided by 50. So 2 by 5, that means 40% improvement you have done, right? So n2 minus n1 divided by n1, percentage change, n2 minus n1 divided by n1 into 100%. So delta square by 9 minus delta square by 12 divided by delta square by 12 into 100%. So 1 by 9 minus 1 by 12 divided by 1 by 12. 4 minus 3, 1 by 12, answer would be 33.33%. Okay, so answer would be 33.33%. That would be the answer. It was a very simple question. Just the mapping was done from midpoint to some other point which was shifted by delta by 6. That means we did the mapping to 2 delta by 3. Well and good. So 33.33%, that's the final answer. Let's go to next question. So this kind of, you can treat it as a problem or you can treat it as a simple note. So what this question is saying, forget about this note. Okay, let's read the problem. So fx of x is given, random variable x is fed to a quantizer, PDF is given. It is, what kind of PDF we are having? We are having triangular PDF, right? So a quantizer uses midpoint mapping. It maps the value between -5 to -2.5 with the step size of 0.05 and maps the value between -2.5 to 0 with the step size of 0.01 and maps the value from 0 to 5 with the step size of 0.02. What does that mean? Our applied input is having a range of -5 to +5. This is your midpoint. So -5 to -2.5, then 0 to 5. Okay. So whatever the value is there between -5 to -2.5, the step size is 0.05. Step size is 0.05. That means 0.05 step size, 4.95. So this point will be -4.95. Step size is 0.05. Step size is 0.05. Okay, and then midpoint mapping is used, so somewhere in between it will be mapped. So what that point will be? -4.975, and then again 0.05. So this point will be -4.90. Again midpoint mapping is used. It will be mapped somewhere in between. So in that manner, what we are doing, we are using the midpoint mapping for this much of step size. So what I will do, sir, x minus mapping is done at 4.975 whole square, fx of x dot dx going from -5 to -9.45. So what is the expression of fx of x? Expression of fx of x from here I can find out. That would be, sir, 1 by 20 x plus 1 by 5. You agree to this point, right? Now here I will put the value of fx of x, then I will calculate this integral, and I will get the answer only for -5 to -9.45. Then again I will have to do -9.45 to -4.90. Where it will be mapped? It will be mapped somewhere in between. So that value will be 4.925 whole square fx of x dot dx. And again I will have to solve. In that manner I have to keep on doing it, because -2.5 to 0, different step size is there, right? Step size is 0.01, then step size is 0.02. So in that manner I need to keep on doing, and I will get the final answer. Not possible to do all this calculation. Do you notice a very good thing here? The step size is very small. That means for solving this particular expression, what is my matter of concern? My matter of concern is between -5 to -9.45, -4.95. What is my matter of concern? -5 to -4.95. What kind of PDF you are having? Triangular. But just tell me one thing, between -5 to -4.95, the PDF will be almost linear only, no? Let's just say I take one point and another point is just near to this. So isn't that nearly linear only? Let's just say at -5, what value you are having? 0. At -4.95, what value you will have? Put -4.95. Here put -4.95 divided by 20 plus 1 by 5. So let me do this calculation. 4.95 divided by 20 plus 0.2. So I am having minus 0. अरे यार ये माइनस कैसे आ गया? Slope is positive only. How I am getting minus? 9.45 divided by 20. Oh, it is 1 by 25, sorry. This is 1 by 25, right? This is 1 by 25. So 4.95 divided by 25 plus 0.2. So you are having 0.002. So at 4.95, let's just say this is minus 4.95. Although this point is very far, it will be very near to minus 5. And the amplitude that you are having, that is 0.002. That means you are increasing from 0 to 0.002. 0 to 0.002. These 2 points are very near only, no? These 2 points are very near only. So isn't it like a uniform PDF only? So this particular calculation, when I am moving from minus 5 to minus 4.95, in that particular range, a very minute change is there in the amplitude of fx of x. So since there is a very minute change in the amplitude, I can take it nearly uniform PDF. So if the step size is very small, but the PDF is not uniform, still you can consider uniform PDF. Still, uniform PDF can be considered. Why is that so? Why uniform PDF can be considered? Because the step size is very small. If the step size is very small, that means the change in fx of x will be very small. So the waveform will be almost linear. And if I consider the uniform PDF and midpoint mapping is used, I can apply the formula delta square by 12 into area A1 plus delta square by 12 into area A2 plus delta square by 12 into area A3 and so on. Are you able to understand this point or not? Is that clear to you or not? Okay. So let me remove this from here. Let's write it down in a good manner that between minus 5 to minus 2.5, if I find out the noise power, if I try to find out the noise power, then what I will have to do? I will take one step size x plus 4.975 whole square. What is my fx of x? Fx of x is x by 25 plus 1 by 5 dot dx. This calculation I will have to do, and then in the same manner I will have to do a lot of calculations. But you know that in this range PDF will be almost uniform, and since the PDF is almost uniform, then I can apply the formula of delta square by 12 into area A1 plus delta square by 12 into area A2 plus delta square by 12 into area A3. So delta square by 12 into area A1 plus A2 plus A3, what that would be? What this will be equivalent to? So range is going from minus 5 to minus 2.5. Range is going from minus 5 to, let's just say this point is minus 2.5. This point will be minus 2.5. So what I will do? First I will calculate the area. First I will calculate the area between minus 5 to minus 9.45. Then I will calculate the area between minus 4.95 to minus 4.90. Then I will calculate the area between minus 4.90 to minus 4.85. In that manner I will keep on adding up the area. So this area, this area, this area, all these area will keep on adding up, and eventually the total area will result in this much of area. Say yes or no, right? So at minus 2.5, what you will be getting? This will be 1 by 10. This point will be 1 by 10. So what will be this area? This area will be half into base into height. Area will be 1 by 8. So this area will be 1 by 8. Between minus 2.5 to 0, how much area you will get? That we will see, but as of now I got to know that this area is 1 by 8. So answer would be delta square by 12 into 1 by 8. So in that manner, three kind of levels. Although we are having a lot of levels, how many levels are there? If I consider between -5 to +5, between -5 to +5, how many total levels would be there? Basically, -5 to -2.5 with the step size of 0.05. -5 to -2.5 with the step size of 0.05. How many levels will be there? Dynamic range is 2.5, step size is 0.05. Dynamic range is 2.5, step size is 0.05. So 2.5 divided by 0.05. So number of levels will be 50. Between -2.5 to 0, between -2.5 to 0, what is our dynamic range? Dynamic range is 2.5 divided by number of level divided by step size. So 25 divided by step size, that would be 0.01. So sorry, 2.5 divided by 0.01. So number of levels will be 250. Right? This was an easy calculation. Needlessly, I am using calculator here. And between 0 to 5, step size, the range, dynamic range is 5 and step size is 0.02. Okay, so 5 divided by 0.02, that would be 250 as well. Right? So 250 levels here, 250 levels here, and 50 levels here. Total levels are 550. In the range between -5 to 5, total levels are 550. A lot of levels are there, that means step size is very, very small. So delta square by 12 into area A1, so this much area I will consider. Then delta square by 12, this much area I will consider. But here the step size is different, and here also the step size is different. So is that clear to you? Well and good. I hope you are understanding what we are doing. So what will be this particular area? This particular area you can calculate, but I know that this whole area will be 1. So this much area will be half. So half minus 1 by 8, what that would be? 3 by 8. So this particular area will be 3 by 8. This area will be 3 by 8. And what will be this much area? This area will be 1 by 2. So if I find out the total noise power, so that would be delta 1 square by 12 into area 1 by 8 plus delta 2 square by 12 into area 3 by 8 plus delta 3 square by 12 into area 1 by 2. So first step size is 0.05, then 0.01, then 0.02. So 0.05 whole square divided by 12 into 8. Delta 2 is 0.01, then 0.02. 0.01 whole square into 3 divided by 12 into 8 plus what will be delta 3? Delta 3 will be 0.02. 0.02 whole square divided by 12. 1 by 2, in place of 1 by 2 I am writing 4 by 8. Okay, in place of 1 by 2 I am writing 4 by 8. Why I am doing so? Because this will become, denominator will become same, right? Twelve into 8 is 96, right? Yeah. So 0.05 whole square will be, first let's do this calculation, 0.02 whole square into 4. So that would be 0. This will be 0.0025 plus that would be 0.0003, right? 0.01 whole square into 3. Yeah, and this would be 0.02 whole square into 4.0016. Plus 0.0025 plus 0.0003. 0.0044 divided by 96. 4.58 into 10 to the power minus 5. So this much noise you are having. This much noise power you are having. That means very low noise power you are having, right? This is very low. And why it is very low? Because a lot of quantization level you have put, no? If you have put so much of quantization level, that means there will be very less chance of error. If the values between -5 to -4.95 are mapped to -4.975, that means almost same value you are mapping, right? Even the -5 guy will be happy, even -9.5, even -4.95 guy will also be happy. That's why the quantization noise is very, very low. If this is your quantization noise, what they need to find? Quantization noise power they need to find, or I could have asked SQNR as well. So you find out SQNR as well. Also you need to find out SQNR as well. So what will be your signal power? What will be your signal power? So signal power would be, you can see that SQNR will also come very high. So signal power will be a square by 6, right? Since it is triangular PDF, so 5 square by 6, alpha square by 6. So 5 square by 6. So 25 by 6. So what will be your SQNR? So SQNR would be 25 by 6 divided by 4.58 into 10 to the power minus 5. By 6. So let's calculate directly in dB. Okay. So I'm getting 49.58 dB. So this much SQNR you are getting. Okay, 49.58 dB. There you go. This is done. So our complete discussion on quantization is done. Complete discussion on quantization. So this is how we started. Completely mathematics it is. Okay, it is nothing but mathematics. Only one slide was the discussion. That's it. After that we are solving problems only. This was a question. Then conclusion we saw delta square by 12. Then again the problem. Then again one more problem. Then again the question. Then again there is another problem. Then just for the sake of problem, if in the question if it is written that assuming equiprobable occurrence of all quantization level, what is the meaning of that? So if I know the meaning of that, if I know the meaning of mid-rate and mid-rise quantizer, then I can solve more problems. Then I kept on solving the problems, okay, questions. Then we developed two formula which are having a lot of conditions: uniform PDF, midpoint mapping, and a lot of conditions are there. Along with that, uniform quantization should also be there, n bit quantization is there. So 1.76 plus 6n, and here it is only 6n. Okay, and then we saw more questions, more problems we saw. Okay, and then in the end we saw that if your step size is very small, then you can consider almost the uniform PDF. Almost the PDF is uniform. So delta square by 12 into one particular area plus delta square by 12 into another particular area plus delta square by 12 into another particular area, and here delta values were also different. So from here we got the answer. Okay, and then signal power we already know, noise power also we already know. From there we got our SQNR in dB. Okay, well and good. So yeah, this was the discussion. So our discussion is done on quantization. We have already seen sampling in signal system, and in the first lecture we understood the meaning of digital communication system. Next we need to study about threshold detector. This will be our next matter of concern, threshold detector. Okay, a very, very important topic, very, very important topic. I don't think there would be any gate question paper where the problem from or where the questions from threshold detector is not coming. Again, here also the theory will be of 1 or 2 pages only. After that, questions and questions. Okay, so only we need to solve the questions or questions, I don't know. Let's solve the questions. So we just need to solve the questions, and theory will be of 1 or 2 pages only. Okay, and then we will study about receiving filter, then channel bandwidth and ISI, and then some miscellaneous concept will be there. In the miscellaneous concept, mostly we will see delta modulator or differential pulse code modulation and time division multiplexing. So these 3 topics we will have to see in miscellaneous concepts. Okay, we will study. Next we need to study about threshold detector. Okay, yeah. So let's meet in the next lecture. Thank you very much. Hi everyone, welcome back. So in this video we are going to study about threshold detector. So what is the use of threshold detector? Why do we apply it? What would be the input? What would be the output? Everything we are going to discuss. First we will do a quick revision of whatever that we have already studied. Then we will proceed into the threshold detector. First 20 and 30 minutes are very important. If you listen to my words very carefully, after that we are just going to solve the problems. That's it. The whole lecture will be based on the problem solving only. Just you need to listen to me for first 20-30 minutes very carefully. So let's revise something that we have already studied. If your x is Gaussian random variable having mean of mu and variance of sigma square, then first let me know what will be its PDF. So its PDF would be, sir, 1 by under root 2 pi sigma square e to the power minus x minus mu whole square upon 2 sigma square. So this you have to remember, there is no shortcut, nothing. You have to remember the PDF of Gaussian random variable. Now what is the probability such that random variable x is taking a value greater than a? So that probability will be, sir, q of a minus mu, q of a minus mu upon sigma, right? This will be the probability such that x is taking value greater than a in case of Gaussian random variable. And what will be the probability such that x is taking value lesser than a? That would be equals to, sir, 1 minus x greater than a. So that would be equals to 1 minus q of a minus mu upon sigma. Now this can be written as q of mu minus a upon sigma. Why is that so? Because q of minus x is equals to 1 minus qx. So this is written as q of x and this is your q of minus x. Basically if you multiply by negative sign here, what will happen? Mu minus a upon sigma, right? Very simple thing. So probability of x greater than a, this is what I will remember, that is q of a, whatever that is written here, a minus mu upon sigma. If they are asking me probability of x less than a, I will just invert them, mu minus a upon sigma, that's it. Or you just remember this particular expression, then from here to here you can come very easily. So this is something that you need to remember if you want to proceed in this lecture. Now another thing is there, let's just say there is a deterministic signal. Basically there is a time domain signal. If I sample this time domain signal at t equals to tb, what I will get? I will get a sample value, right, which is equals to alpha. This is my time domain signal. Let's just say this was t equals to 0, this was t equals to 2 tb. What is tb? Forget about it. I am just saying that if I am sampling this time domain signal at t equals to tb, what I will get? I will get a sample value. So this will be simply a value, right? It could be plus 1, it could be minus 1, it could be plus 5, it could be minus 5, it could be 0, it could be anything. Basically it will be a value, right? Now nt is a random process. Nt is a particular random process. If you are sampling this nt at t equals to tb, what you will get? Sir, n of tb. Now n of tb, can I write it down by capital N? Yes, I can. I am writing it down by capital N. What this n would be? What this capital N would be? It will be a sample value or it will be a random variable? It will be a random variable, right? This is a random process which is sampled at a particular time instant. So when you sample a random process at a particular time instant, what do you get? You get a random variable. So when I sample a deterministic signal, I get a sample point or sample value. But when I sample a random process, I get a random variable. All these things you already know, just that we have revised it. Let's talk about the threshold detector now. So again we will go by our block diagram. In the transmitter side, what we were having? We were having the line coder, right? What was the input of the line coder? Input of the line coder were some bits, right? Now what line coder was doing? Line coder was generating some pulses. So line coder could have generated plus 5 volt pulse. It could have generated minus 5 volt pulse, or it could have generated minus 3 volt pulse. It could have generated 0 volt pulse. Whatever it wants to generate, it will generate some pulses. Now these pulses will be traveling through the channel. Channel will be doing something with these pulses. But as of now, we are going to consider that whatever that was applied by the line coder, the same has reached here. Okay. What we are assuming, whatever that was applied by the line coder, the same waveform has reached to the filter. Along with that, in the channel there will be some noise. In the channel, there will be surely some noise. So channel will have some noise. So eventually what is reaching at the input of the filter? At the input of the filter, some pulse will be reaching. Along with that, noise will be reaching. Pulse plus noise. Now filter will also be doing something. But as of now, we are not studying about channel. As of now, we are not studying about filter. So let's just say there was some impulse response of the filter and this pulse was converted into this kind of waveform. What I am saying? This was a pulse which was transmitted by line coder. Channel would do something with this pulse, but I am assuming that channel is doing nothing with this pulse. This pulse is transmitted as it is. Along with that, there will be some noise in the channel, so noise will also be added. Now what this filter did, with respect to this pulse, it converted this pulse into this particular pulse. Let's just say this pulse was from 0 to TB, it is having amplitude of A. It has converted this pulse into this kind of pulse which is having an amplitude of alpha here. Sir, how will it convert this pulse into this pulse? We will understand that, don't worry. As of now, we are not studying about filter. First, we are studying about this particular block. Then we will come to this block. But as of now, you just understand that this pulse has been converted into this pulse by this filter. Now, what this was? This was a random process. And it will be wide sense stationary random process. It would be WSSRP. Okay? It would be a wide sense stationary random process. When you pass a WSSRP through a filter, what do you get? You get a WSSRP only. When a wide sense stationary random process is passed through a filter, at the output, what do you get? If you remember the concept, it will also be WSSRP only. So here also what I will be getting? I will be getting a random process which is wide sense stationary. Okay, so let's just say I am denoting that as N bar T. Now after the filter, what is there? There is a sampler. After the filter, there is a sampler which will be sampling this particular value at a time instant that is equal to TB. Forget about TB, you understand that it is sampling it at any time instant. So now what is this? This is a deterministic signal. And what is this? This is a random process. So what do you think? What will be the input of a threshold detector? Input of threshold detector I am representing by Y. So input of threshold detector will be one sample value plus a random variable of noise. Is that clear to you or not? This will be a random variable and this will be a sample value or sample point, whatever you want to tell. Is that clear to you or not? The input of threshold detector is clear to you or not? We started with line coder. Line coder generated some pulses. It was traveling through the channel. In the channel, some noise was added. We assumed that this pulse was completely transmitted here. Along with that, noise will also come. Now this pulse and noise is passing through the filter. Filter has converted this pulse into this triangular pulse. And noise has also been converted into some N bar T. So this filter has done something with the pulse and something with the noise as well. Okay, the job of this filter would be to reduce the effect of noise and to increase the effect of a sample. This is what this filter will do. We will understand how it will do it. Now after the filter, there is a sampler. So you are sampling this deterministic signal. What is this? This is a deterministic signal. This is simply a time domain signal. So this is a time domain signal, or a time domain signal is known as deterministic signal. So this is a deterministic signal which is sampled at a particular time instant. So a deterministic signal is sampled at a particular time instant. What you will get? You will get a sample value. And then there is a WSSRP. There is a wide sense stationary random process. If that is sampled at a particular time instant, what do you get? You get a random variable. So the input of the threshold detector is a sample value and a random variable. Now what is the name? The name is threshold detector. That means it will have a threshold value of lambda. This threshold detector will have a threshold value of lambda, and the output of threshold detector is given by y cap. So let's make the block diagram of only threshold detector. So what this threshold detector is saying, that I am having a threshold voltage of lambda, applied input is y, and the output is y bar. Okay, and the applied input is having a sample value and a random variable. What it is having? It is the summation of a sample value and a random variable. Now what this lambda is doing? This lambda will say that y bar will be equals to 1, or you will say y bar will be saying that bit 1 received if your y is greater than lambda. Basically, if the applied input is greater than lambda, then output it will be throwing with respect to bit 1. Okay, and if y is less than lambda, then output it will be throwing with respect to bit 0. So based on this y, this threshold detector will be making its choice, that if y is greater than lambda, then I will say bit 1 received. If y is less than lambda, then I will say bit 0 is received. Basically, literally it will give the 1 0 output. The threshold detector will give 1 0 output. What was the input? Input was, look, this was a sample value and this was a random variable. So let's just say sample value was 1. Okay, sample value was 1 plus capital M. What is this? Random variable. Random variable added with the constant value. What do you get? Random variable only, no? Let's just say PDF of this random variable was this. So can you draw the PDF of a random variable y? Yes, it will be shifted by 1. Linear transformation of random variable. Do you remember that topic? If the relation between y and x, if the relation between two random variables are linear, and if you know the PDF of one random variable, you can draw the PDF of other random variable as well. So similarly, here n is a random variable, s is a sample value, which will be a constant value only. So let's just say the constant value is 1. So if n is a random variable, then 1 plus n will also be a random variable. Along with that, if you know the PDF of n, then you can draw the PDF of y as well. Is that clear to you or not? Okay. So input was a random variable. Input to the threshold detector was a random variable. How it is a random variable, that is clear to you. But output is some bits. It will be some set of bits based on this y. If y is greater than lambda, it will throw output is 1. If y is less than lambda, it will throw output is bit 0. But there is another interesting thing. What is that thing? That thing is y will also be there as two kind of inputs. What I mean to say is that there are two kind of inputs for y. One would be y1 and one would be y0. Why is that so? Because from here you are sending two kind of pulses, no? One pulse would be there with respect to bit 1. Let's just say this was there with respect to bit 1. So I explained this whole scenario with respect to bit 1 only. What I am saying, I explained this whole scenario with respect to bit 1. The whole scenario could be explained with respect to bit 0 as well, no? So whatever that is happening with bit 1, the same thing is happening with the bit 0 as well. So let's just say this value was alpha. So y would be alpha plus capital N. So this was there with respect to bit 1. Similarly, let's just say here the same thing would happen, and for bit 0 this kind of waveform was generated, and let's just say this value was beta. So they could have written y equals to beta plus n. So that was with respect to bit 0. Are you able to understand this point? Basically, you will get two kind of sample, S1 and S0. S1 would be there with respect to bit 1 and S0 would be there with respect to bit 0. Very simple thing, very straightforward. So input will also be of two kind. When the sample value is S1 and when the sample value is S0. Now usually you will say that, sir, this noise is introduced by this channel. Noise is introduced by the channel, right? This noise is introduced by this channel. So noise should not be depending on this plus 5 and minus 5. But there are some kind of noise which can depend on these pulses as well. Basically, with respect to bit 1 transmission, there will be different kind of noise. With respect to bit 0 transmission, there will be different kind of noise. It can happen in some of the cases. So they can frame numerical problem saying that with respect to bit 1 different kind of noise was introduced, with respect to bit 0 different kind of noise was introduced. But in 90% of the questions, for both of these pulses, the noise will be same. But in the worst case, with respect to bit 1, they can say that noise PDF is N1, and with respect to bit 0, noise PDF is N0. This is also what they can say. But most probably N1 would be equals to N0 would be equals to N. Is that clear to you or not? So here what I will write down, Y1 equals to S1 plus N1 when bit 1 is transmitted. Bit 1 is transmitted. From here, if bit 1 is transmitted, plus 5 volt will go there. From the channel, nothing is happening, noise is added. Along with that, from filter, it has become something like this. It has become triangular, and when it is sampled, here you are getting S1 plus N. That means S1 plus N1 you are getting when bit 1 is transmitted, and here bit 0 is transmitted. So you see here I am writing transmitted, and here I have written down received. So the input of the threshold detector, although threshold detector is connected in the receiver side only, all this is receiver side. This complete setup is receiver side. Say yes or no. This complete setup is receiver side. Do you agree to this point? But the input of the threshold detector, I will be using bit 1 received, and at the output of the threshold detector, I will be using, at the input of the threshold detector, I will be using bit 1 transmitted, and at the output of the threshold detector, I will be using bit 1 received. Basically, here I will say transmitted, and here I will say received. Is that clear to you why I am saying so? Because it will start from here. Bit 1 transmitted, bit 1 transmitted, bit 1 transmitted, bit 1 transmitted. Went to the threshold detector, based on the threshold value, it gave the decision bit 1 received or bit 0 received. There could be error as well, right? How there could be error? Let's check that out. So let's just say this value lambda. So S1 plus N1 was greater than lambda. So what threshold detector will say? Threshold detector will say that bit 1 received. And what was transmitted? If your Y1 is equals to S1 plus N1, that means bit 1 was transmitted. And what threshold detector is saying? Bit 1 received. That means there is no error. Is that okay for you? Now if bit 1 was transmitted, okay, bit 1 was transmitted, but somehow this value got lesser than lambda. Let's just say I transmitted plus 5 volt, I transmitted plus 5 volt, but somehow the effect of noise was so much that let's just say this was your transmitted sample, this was your noise, both added, what you will get? Minus 5. And let's just say lambda value was set as 0. So lambda value was 0, the threshold value was 0. So what this threshold detector will receive? Sir, plus 5 minus 10, it will receive minus 5, which is less than 0. So what it will say? Bit 0 received. But actually bit 1 was transmitted. Bit 1 was transmitted, added with the noise, threshold detector was set at 0. So now the threshold detector will say that bit 0 is received, but actually it was bit 1 transmitted. Are you able to understand this point, what I am saying? So somehow because of the noise, let's just say S1 plus N1 is less than lambda. So what you will get? Bit 0 received. That means there is an error. Is that clear to you or not? Or what may happen? S0 plus N0. That means you are transmitting bit 0. You are transmitting bit 0. If S0 plus N0 is less than lambda, so what will be the output? Bit 0 received. And transmitted bit was also 0. That means no error. I hope everything is clear to you. Okay, I hope everything is making sense. And if you are listening to my words very carefully, then it is making sense. Otherwise, it will not make any sense. So S1 plus N1 is showing bit 1 transmitted. If it is greater than the threshold value, that means bit 1 received, I will get the signal. There is no error. If S1 plus N1, that means bit 1 is transmitted, which is less than the threshold value. That means I will get the output as bit 0 received. But actually bit 1 was transmitted. That means there is an error. S0 plus N0, what does that mean? Bit 0 transmitted, which is less than lambda. So what is the output of threshold detector I will receive? Threshold detector will say that, sir, bit 0 is received. 0 was transmitted, 0 is received, that means there is no error. And if S0 plus N0 is greater than lambda, so what will the output say? Sir, bit 1 received. But what was actually transmitted? Bit 0 was transmitted, that means there is an error. That means there is a chance of error at the output of your threshold detector. Output of the threshold detector will be connected to decoder and then it will be connected to low pass filter. So I know what decoder will do. Based on the received input, based on the received bit stream. So what is the output of threshold detector? It is a bit stream only, no? One sample would come, it will say whether bit 1 received or bit 0 received. So based on that it will generate 1 or 0. Let's just say next it is generating 0, then it is generating 1, then 0, 1, 0, 1. So in that manner it is generating a bit stream. And in the first lecture I told you the input of the decoder is nothing but a bit stream only. So input of the decoder is bit stream. What it will do? It will make the quantized value and from there low pass filter. The rest of the analysis you already know. But this threshold detector has some chances of error, right? So based on that there is a concept called probability of error. Probability of error. So how will you find out the probability of error? Probability of error. So probability of error would be given by, sir, bit 0 transmitted and bit 1 received, or probability such that bit 1 transmitted and bit 0 received. Do you know this much of mathematics? When there will be a probability of error, probability such that bit 0 is transmitted and bit 1 is received. 0 is transmitted and bit 1 is received. Or means addition. Or bit 1 is transmitted and bit 0 is received. Then there will be a chances of error. Now do you know this particular thing, that probability of A intersection B could be written as probability of A multiply with probability of B by A. Do you know this particular thing? I hope you know this particular thing. And I guess even in the basics of random variable random process we have seen this thing. Somewhere in the random variable random process we have seen this particular formula. So how will I read it? Probability of error would be, sir, bit 0 transmitted multiply with, when the bit 0 is transmitted, received bit is 1, or bit 1 is transmitted, when the bit 1 is transmitted, the received bit is 0. This is how I will read it. Probability of error is given by bit, probability of bit 0 transmitted multiply with bit 0 transmitted and received bit is 1, plus probability of bit 1 transmitted multiply with 1 transmitted but the received bit is 0. So this is how I will read it. A very important formula, you don't need to mug it up, it is very simple to write down, very simple. 0 transmitted, after transmitting 0 received bit is 1, plus 1 transmitted, after transmitting 1 received bit is 0. Very simple, very straightforward. Let's just take a very simple scenario. This was a line coder, this is your threshold detector. Okay, somewhere in between there would be a lot of blocks, right? There would be a lot of blocks. I am not caring about those blocks. Whatever the blocks are there, I don't care. I'm not having anything else, okay? This is just Wix. Wix Koli we are having. Don't take me wrong. Yeah. So what will be the input of line coder? it will be some bit string. Let's just say bit string was 1 0 1 1 0. This was the input of line coder. Now it will convert it into the pulses, then it will go through the channel, then there will be filter, and then the filter, in the filter noise and sample value both will be coming, and that will be applied to the threshold detector, and then there will be a threshold value lambda, and based on that it will be generating output. So input bit was 1 0 1 1 0, and let's just say output bit was 1 0 0 1 0. So applied bit, based on the message signal, you encoded it into 1 0 1 1 0. Received was 1 0 0 1 0. So what is the probability of error here? What is the probability of error here? Probability of error. So out of these 5 bits, 1 bit is corrupted. Which bit is corrupted? 1 is fine, 1 is fine, 0 is fine, 0 is fine. This was 1, but received was 0. So out of the 5 bits, 1 bit is corrupted. That means probability of error is 0.2. I am just telling the basic meaning. I hope you have understood the meaning of this whole analysis. I hope you have understood the meaning of this whole setup. So I told you first 25 to 30 minutes is very important, because I am just explaining the setup here. That what is the setup we have made and what we are actually trying to do. So starting from here, actually it should be taught in a manner that first I should teach filter, then I should teach threshold detector, then I should teach decoder, then I should teach low pass filter. But you will not be able to understand if I teach in this manner. That's why we are coming from the backward side. Decoder, low pass filter, then threshold detector, and then we will move to filter, and we will take everything into action together. And absolutely everything will be crystal clear to you. Okay. So now we are going to understand the working of threshold detector, that we have already understood. We will solve the problems on this, then you will be more comfortable with that. Okay, and in that manner we will proceed. So again, just summarizing what is happening. The input of the threshold detector will be a random variable which is consisting of a sample value and a noise random variable. Based on the input value and the threshold value that has been set up here, based on that the threshold detector will give two kind of output. It can say whether bit 1 received, or it can say whether 0 bit or bit 0 will be received. Now the applied input will also be of two kind. One will be with respect to bit 1, other one will be with respect to bit 0. Okay. So applied input could be S1 plus N1. What is N1? N1 is the noise. N1 is the noise random variable which has been transmitted with respect to bit 1, and N0 is the noise random variable which has been transmitted with respect to bit 0. So when bit 1 is transmitted, this will be the input. When bit 0 is transmitted, this will be the input. Now based on the applied input, the threshold detector will give you some output. If y is greater than lambda, then it will say bit 1 received. If y is less than lambda, it will say bit 0 received. Now if your S1 plus N1 is greater than lambda, S1 plus N1, what does that mean? That means you are transmitting bit 1. And if it is greater than lambda, that means bit 1 received, that is something that you will get, that means there is no error. But somehow if S1 plus N1 is less than lambda, actually you transmitted bit 1 but you have received bit 0, that means there is an error. Same goes for S0 plus N0 as well. Then we define a term which is known as probability of error. That is given by probability of 0 transmission multiply with such that bit 0 is transmitted but bit 1 is received, plus probability of bit 1 transmission multiply with such that bit 1 is transmitted but bit 0 is received. There you go. This is the whole concept, and based on that we will solve this particular question, and you will be able to understand everything. Just have some patience and you will be able to understand every single thing from this particular question, and after this question you will be able to solve all the problems. So people needlessly find this particular topic difficult. You will enjoy it in a great manner, and I don't think what it is written. Yeah, now this question makes sense. Yeah, so let's read the problem. Okay, so problem is saying that a binary source generates symbol x equals to -1 and +1. What do you think? What is these -1 and +1? So from here you can get to know that S1 value is +1 and S0 value is -1. One would have been with respect to bit 0, another one would have been with respect to bit 1, right? So these are the sample value or or symbols. I told you whatever the output that line coder is generating, those are known as symbol. So these are the sampled value of symbols -1 and +1, which are transmitted over a noisy channel. The channel will have some noise. The probability of transmitting bit 1 is equals to 0.8. What does that mean? What do you understand by this? Probability of bit 1 transmission is 0.8. That means line coder, or you can say this line coder is generating more pulses with respect to bit 1 and lesser pulses with respect to bit 0. Basically, pulses with respect to bit 1 are more. Let's just say if I consider this case only. So here what we will say? Probability of bit 1 transmission, what is that? 3/5. And probability of 0 transmission, what is that? 2/5. Because out of these 5 bits, bit 1 are 3/5 and bit 0 are 2/5. Say yes or no. Is that clear to you? Okay, well and good. So probability of bit 1 transmission, that means this probability is given as 0.8. That means probability such that symbol 1 is transmitted, that is 0.8. So what will be the probability such that symbol -1 is transmitted? That would be 0.2, right? Because two kind of symbol it is transmitting, no? 1 and -1. Now they are not saying that this is with respect to bit 1 and neither they are saying that this is with respect to bit 0. So you can assume anything. Surely I will assume that this is with respect to bit 1 and this is with respect to bit 0, because we are comfortable with 1 and 0 analysis, not with 1 and -1 analysis. So I will say this I will call as bit 1, this I will call as bit 0. Probability of bit 1 transmission is 0.8, so probability of bit 0 transmission is 0.2. Very simple. The input of the threshold detector is R is equals to X plus N. X would be the symbol, N would be the PDF of the noise. What is N? N is the PDF of the noise. So the PDF F of N, N of the noise N is shown. This is the PDF of noise has been shown. And input of the threshold detector is R. Input of the threshold detector is R equals to X plus N. But this R will have two kind of values that you already know. It will have R1, it will have R2. So R1, X. So they are showing symbols by X. Okay. So here I will write down X1 and X0. They are showing the symbol by X. So I am writing down X1 and X0. Okay. So this would be X1 plus, and with respect to both of the symbols, the noise PDF is same. They did not make two different kind of PDF. They are saying that with respect to both of the symbols, the noise PDF is same only. So X1 plus N and R0 I should write down. R0 would be X0 plus N. So this will show that bit 1 is transmitted and this will show that bit 0 is transmitted. Is that clear to you? Now we are having the threshold detector, which is having the input of R, and what is the output? It is shown by output. They are not showing by anything, they are just writing down output. So I am writing down the output by R cap, and this is the input, which is R. This is our threshold detector, and we are having lambda as the threshold value. So output says bit corresponding to +1 when R is greater than lambda and bit corresponding to -1 when R is less than lambda. This is what output is saying. So find out the probability of error if detection threshold, that means the value of lambda is 0.5. What does that mean? First case I am taking, value of lambda is 0.5. So your output R bar, it will say that bit 1 received if R is greater than 0.5, and it will say that bit 0 received when R is less than 0.5. Is that okay for you? Okay. Now this R1, okay, this R1 could be written as input of the threshold detector, which is R, such that bit 1 is transmitted. This is not R by 1. I am writing down the input R such that bit 1 is transmitted. And what is R0? The input R such that bit 0 is transmitted. So R by 0. This is how I am writing down. R1 is written down by R by 1, R0 is written down by R by 0. Do you understand? R1 is input of the threshold detector such that bit 1 is transmitted, R0 is input of the threshold detector such that bit 0 is transmitted. So don't think that there is lot of information, nothing. Every single thing you already know. We are just writing down a lot of things so that you will never get confused. So now till this point, all this theory, everything, whatever the question is saying, everything is clear to you. What you need to find? You need to find probability of error, which is equals to probability such that bit 1 is transmitted multiply with probability such that bit 0 received 1 transmitted, probability of 0 transmitted multiply with probability such that 0 transmitted with the 1 received. Okay, this value you already know 0.8 and this value you already know 0.2. What you need to find out? Probability such that 0 is received but 1 is transmitted. What you need to find out? Probability such that 0 received 1 transmitted. So just let me know when you will say bit 0 received. When your threshold detector will say bit 0 received. When this threshold detector will say bit 0 received. When the applied input is less than 0.5. Say yes or no. But now two kind of inputs are there, R1 and R0. Two kind of inputs are there, R1 and R0. Now this thing will come into action. First what I say, sir, threshold detector is saying bit 0 received. So R1 should be less than 0.5. Sorry, R should be less than 0.5. Now which R? There are two kind of R, no? One is R1. What is R1? Input such that bit 1 is transmitted. And what is R0? Input such that bit 0 is transmitted. So what is transmitted here? Probability such that bit 1 is transmitted but received bit is 0. So here what I will put? R such that bit 1 is transmitted. Is that clear to you or not? Probability of receiving 0 given that bit 1 is transmitted. So that means I know that what is transmitted. I know that bit 1 is transmitted. But what you are actually receiving? Here I know that bit 1 is transmitted. But actually what it is saying? Bit 0 received. So probability of receiving bit 0 given that bit 1 is transmitted. So probability of R should be less than 0.5. But which R? R1 or R0? It would be R1. Why R1? Because R1 says that input when bit 1 is transmitted. So R such that bit 1 is transmitted should be less than 0.5. So what is that R? That R is equals to x1 plus n. X1 plus n should be less than 0.5. What is x1? X1 is, what was your x1? X1 was 1. So 1 plus n should be less than 0.5. So probability of n taking value less than minus 0.5. So can you find out this particular thing? This PDF is given. This particular PDF is given to you. And what you need to find out? N taking value lesser than minus 0.5. Where is minus 0.5? This is minus 0.5. This is minus 0.5. What is the slope here? Slope is 1 by 4. So this would be 1 by 8. So 0.125. This point will be 0.375. You can find it out on your own. In any manner you can find it out. But I have find it out. This point will be 0.375. What you need to find? Probability of n taking value lesser than minus 0.5. That means this much area you need to find. Half into base into height. This will be the answer. Okay. So this is the answer of bit 0 received such that bit 1 was transmitted. So 1.5 into into 0.375 अरे यार 1.5 into 0.375 divided by 2. So 0.28125. One thing we have done now. First thing is done. Now probability of bit 1 received such that bit 0 is transmitted. So when you will receive 1, you will receive 1 when r is greater than 0.5. You will receive 1 when r is greater than 0.5. Now which r? Look here, right? The r when 0 is transmitted. So what is this saying? Probability of receiving 1 such that it is given that bit 0 is transmitted. So here I know that bit 0 is transmitted. So if I know that bit 0 is transmitted, that means here what I will put? R of 0. Very simple thing, right? So let's remove it. But you are understanding what kind of R you need to put. First you will see probability of 1 received. That means R should be greater than 0.5. Now which R? Probability of bit 1 received such that bit 0 is transmitted. Bit 0 is transmitted. Bit 0 is transmitted. That means the input is corresponding to 0 transmission, and that input is x naught plus n. What is x naught? X naught is -1. So -1 plus n should be greater than 0.5. So n should be greater than 1.5, right? N greater than 1.5. Where will be 1.5? 1.5 would be somewhere here. This would be your 1.5. What I need to find? I need to find this much of area, right? Slope is again 1 by 4. This was 0.375, 0.125. This point will be 0.125. So what the answer would be? Half into base. Base will be 0.5 into 0.125. So here we will get 0.5 into 0.125 divided by 2. 0.03125. So this was your probability of bit 1 received such that 0 was transmitted, and this was your bit 0 received such that 1 was transmitted. Okay, now I can find out the probability of error. So probability of error would be probability of 1 transmission multiply with 0 received such that 1 was transmitted, which is 0.28125 plus probability of 0 received multiply with 0 transmitted and 1 received. Sorry, this was the probability of 0 transmitted, not 0 received. This was the probability of 0 transmitted multiply with 1 received given that 0 is transmitted, which is 0.03125. 0.03125. So whatever the answer that you get, you can write it down into 0.2. So this will be 0.00625, and here 0.8 into 0.28125 plus 0.00625. 00625. Complete answer is coming out to be 0.23125. So this is the probability of error you are getting for the first case. This was the answer for the first case, which is lambda equals to 0.5. Now lambda equals to -0.5, you need to take -0.6, 1 and -1. So what I am going to do now, I am going to solve the problem with respect to lambda only. Now my threshold is nothing but lambda itself. Here I put the value of lambda equals to 0.5. No, now I'm going to put, in place of lambda, I'm going to put lambda only. So what I am saying, considering the threshold equals to, considering the decision threshold equals to lambda. Okay. So probability of one transmission, probability of zero transmission, they are not going to change. Probability of one transmission is given, that is 0.8, and probability of zero transmission is also given, that is 0.2. So these guys are not changing. What I need to find now, probability of zero received such that 1 is transmitted, that would be 0 received. When 0 will be received? When R is less than 0.5. And what is transmitted? 1 is transmitted. What does that mean? When 1 is transmitted, what was your R? R was 1 plus n. What was the value of R1? R1 was x1 plus n. x1 value is plus 1. So 1 plus n. So 1 plus n should be less than 0.5. Why I am putting 0.5? Sorry guys. The decision threshold is lambda only. The decision threshold is lambda. So n should be less than lambda minus 1. Okay. I am given the graph of f of n. Now based on all the values of lambda, you know that lambda value will be varying between minus 2 to 2. Do you understand this point? Like decision threshold will be somewhere in between, no? Or forget about it. Based on all the values given, just let me know where will be your lambda minus 1. It will be on this side or it will be on this side. Based on all the given values, where will be your lambda minus 1? So lambda minus 1 will be on this side only, right? Put any value, put 0.5. 0.5 minus 1, what that would be? Minus 0.5, it would be here only. Put minus 0.5, it would be here only. Put 1, it would be 0. So it would be this side only. So lambda value will be, lambda minus 1 will be this side only. So let's just say this is your lambda minus 1. This is your lambda minus 1. This is your lambda minus 1. Now what is the graph of ff1? F n of n, that was equals to 1 by 4n plus 0.5. Okay, and minus 1 by 4n plus 0.5. This graph is there when n is between minus 2 to 0, and this graph is there when n is between 0 to 2. So at n equals to lambda minus 1, when capital N is taking value lesser than lambda minus 1, basically I want this area. So when n is equals to lambda minus 1, so what will be this value? So here what you need to put? Lambda minus 1 you need to put. In this expression you need to put lambda minus 1. So what is the answer you will be getting? 1 by 4 lambda minus 1 plus 0.5. Are you able to understand this point? I am talking about this particular value. This particular value. What will be this particular value? So this particular value will be 1 by 4 lambda minus 1, 1 by 4 lambda minus 1 plus 0.5. So what will be this area? This area also you can find out. What will be this area? Half into base. What will be the base? Base will be lambda minus 1 minus 2. So base will be lambda plus 1. Base will be lambda plus 1. And what will be the height? Height will be this much. (0.5) would come or not? N equals to minus 2. Yeah, so height would be this much. 1 by 4 lambda minus 1 plus 0.5. Is that okay for you? Did you understand what I am doing? This is the probability of 0 received such that 1 was transmitted. I am just putting the decision threshold equals to lambda only. I have put that decision threshold equals to lambda. Okay. Now what I am supposed to find? The value of probability such that random variable n takes the value lesser than lambda minus 1. So I know that lambda minus 1 will be in the negative hand side. Now I need to find out this particular value. So I know that what is the slope? 1 by 4. So 1 by 4n plus 0.5. This will be the equation of f of n, right? Now at lambda minus 1, what value I will be getting? So in place of n, I need to put lambda minus 1, right? Is that clear to you? The similar thing we did in this analysis as well. I hope there is nothing tough for you. And in the examination, you will not have to solve in this manner. I am just building up the concept now. Problem solving skills also we will build up. Don't worry about that. In the examination, you will not have to do this much analysis. Okay, it would be simpler than this. Yeah. Now next, what I need to find? Probability such that 1 is received but 0 transmitted. So when 1 will be received? When r is greater than lambda but 0 is transmitted. So probability such that minus 1 plus n should be greater than lambda. Probability such that n is greater than lambda plus 1. You are given the PDF. Where will be lambda plus 1? Based on all the values, you would know that lambda plus 1 would be somewhere here. If this is your lambda plus 1, right, then this length I already know. I need to know this height. So what will be this height? Minus 1 by 4 into lambda plus 1 plus 0.5, right? All good. Just I am putting this one. Slope is negative minus 1 by 4. I hope you know how to write down these equations. These equations are very simple. You should be knowing how to write down these equations. So this point is lambda plus 1, this point is lambda plus 1, and this is the height. So what will be this area? What will be this area? So here I have written down the area. No, I have directly written down the area here only. So half into base. This base was lambda minus 1 minus 2. So similarly, what will be this base? What will be this length? That would be 2 minus lambda minus 1. That would be equals to 1 minus lambda. Okay. Half into base into height. Height is minus 1 by 4 lambda plus 1 plus 0.5. Bit 1 received such that 0 is transmitted. So what is the probability of error now? So probability of error would be probability of bit 1 transmission, probability of bit 1 transmission, which is 0.8, multiply with probability of 0 received such that 1 is transmitted. Probability of 0 received such that 1 is transmitted. So what that would be? 1 by 2 into lambda plus 1 multiply with 1 by 4 lambda minus 1 plus 0.5 plus 0.2 into probability of 0 transmission multiply with bit 1 received such that 0 is transmitted into 1 minus lambda plus 0.5. Okay. So what is the value of lambda? A lot of, this is the final answer, that's it. This is the final expression. This is the final expression of probability of error. Now with respect to different values we can find out. For the first one, again let's put the value of lambda equals to 0.5 only. Let's take the first case only, value of lambda is equals to 0.5. So I am taking the first case, value of lambda equals to 0.5. So what will be the probability of error? That would be 0.4 into 1.5 minus 1 by 4 plus 0.5. I'm just putting lambda equals to 0.5, nothing else. 0.1 into 0.5 minus 1.4 minus 1.5 divided by 4 plus 0.5. 0.1, 0.5. So this would be 0.125. So let's calculate all these values. 0.1 into 1.5 into 0.25. Sorry, 0.4 into 1.5 into 0.25. Some calculation error I am doing. Let me check it. Yeah, actually, so there was an error here. The error was this particular part, because when I am putting 0.5 here, what I will be getting? Minus 1 by 2. So this part would be minus 1 by 8. And if this is minus 1 by 8, then this would be minus 0.375. Minus 0.375. So when you put down the value, you will get the same answer, 0.23125. Okay. Also, this expression that I have written, it is not the best possible way of representing it. So I will just simplify it more. So what I will do, I will just copy this expression here. Just I am simplifying this probability of error expression, nothing else. So how I can simplify it? So what I can do, in place of this 0.5, what I am putting? 1 by 4. Sorry, 1 by 2. Now this 1 by 2 could be written as 2 by 4. Why I am doing so? Because I know that lambda minus 1 plus 2 would be lambda plus 1, and 4 I can take outside. Similarly here as well, I am putting this as 2 by 4. So 2 minus lambda minus 1. So 1 minus lambda it would be. So upper side I am getting 1 minus lambda. So basically you can write down probability of error expression 0.1 into lambda plus 1 whole square, right? 4 will come outside, 4 into 2, 8, 8 into 0.8, that would be 0.1, lambda plus 1, and here lambda minus 1 plus 2 would be lambda plus 1. So 0.1 into lambda plus 1 whole square plus this would be 0.1, and inside what you will be getting? 1 minus lambda. So 1 minus lambda whole square. This would be 0.1 divided by 4. So 0.1 divided by 4. 1 minus lambda whole square. So let me check if the expression is correct or not. Yeah. So this is the better way of representing probability of error. Okay, just a better way, nothing else. So I have already solved it in the rough notebook. So now here the expression is looking better. So if I am putting lambda equals to 0.5 here, so what answer I will get? Lambda equals to 0.5. I am getting the answer 0.23125, right? 0.23125. Similarly, I can put lambda equals to minus 0.5 as well. So if I am putting lambda equals to minus 0.5, what I will get? I need to take the calculator. Lambda equals to minus 0.5. You can do it on your own as well. So if I put minus 0.5, so it would be minus 0.5 square into 0.1. So 0.025 plus 1.5 square divided by 1.5 square divided by 4 into 0.1 plus 0.025. So 0.08125. Okay. So when you put this, you are getting 0.08125. Now I can put lambda equals to 1. So when I am putting lambda equals to 1 here, what I will get? This part will be gone. So this would be 2 square, that would be 4, so answer would be 0.4. And when I put lambda equals to -1, probability of error would be, this part would be gone, so this would be 2 square, this would be 0.1. And when I put lambda equals to -0.6, what answer you will get? -0.6. So that would be 0.4 square into 0.1. So that would be 0.016 plus, here it would be 1.6 square into 0.1 divided by 4. So 0.064. So what you are getting? 0.08. So what do you think, which of these are having minimum probability of error? For which value of lambda you are getting minimum probability of error? For this one, here this probability is minimum. And now you take any value of lambda. What I am saying, now you take any value of lambda, for all the values of lambda, at this particular lambda only you will get the probability of error to be minimum. What I mean to say is that your probability of error would be greater than or equals to 0.08. So minimum value will be 0.08 only, and that is coming out to be at lambda equals to -0.6. So this lambda is known as lambda optimum. Now sir, how I can find out this lambda optimum? Because in the examination what they will give the same setup and they will ask you at what value of lambda your probability of error would be minimum. So if I am given this expression, can I find out the value of lambda for which probability of error is minimum? What I am saying, the value of lambda for which probability of error is minimum. So that value of lambda is known as lambda optimum. Okay. So this is your probability of error. The expression of probability of error is given, which is this one. This is the expression of probability of error that is given. So you need to find out the value of lambda. So what you need to do? You need to differentiate it with respect to lambda and put that equals to 0. Differentiate with respect to lambda and put that equals to 0. So what you will do? What you will get? 0.2 lambda plus 1 minus 0.2 divided by 4 into 1 minus lambda is equals to 0. Okay. So what you are getting? 4 lambda plus 4 is equals to 1 minus lambda. So lambda equals to 0.6. So this is your lambda optimum. Right? Are you able to understand this point? Minus 0.6, actually it would be minus 0.6. So from here, lambda value is coming out to be minus 0.6. So value of lambda for which your probability of error would be minimum is known as lambda optimum. So what we did, we considered our decision threshold to be lambda only. Our decision threshold is lambda only. From there we derived all these expression and finally we got this answer. So sir, in all the questions you will do this in this manner, that noise PDF would be given, the input will be defined, and then you will assume a lambda equals to lambda optimum, and then you will derive all these things, then you will get this expression, and then you will differentiate, put that equals to 0. From there you will get the value of lambda optimum. Will you do all these kind of things in the examination? No, because it will be a very long process, no? So there is another process from where you can find out lambda optimum. What I am saying, there is another process from where you can find out lambda optimum. What is that process? So that let me tell you. Okay. So what you need to do, probability of zero transmission multiply with PDF of the input. What is our input here? This was our threshold detector. What was the input of the threshold detector? Input was R, right? Input was given as R. I don't know what was the expression of output, but I know that input was given as R. And it was having some threshold voltage as well. This was our threshold detector. So probability of zero transmission multiply with PDF of input such that 0 is transmitted. PDF of input such that 0 is transmitted, because input could be of two types. right? Input was there of two type. Here we have written it. Input was there of two type, such that 0 is transmitted, such that 1 is transmitted. 1 transmitted, 0 transmitted. That I represented by R1, this I represented by R0, but I am writing R when 1 is transmitted, R when 0 is transmitted. Okay. And since the PDF will be in terms of R, so axis will also be there in terms of R only. Then I need to equate this particular expression to probability of one transmission multiply with PDF of input such that one is transmitted. They do. As of now, you are not able to understand, sir, what you have written. Just when you equate all these kind of things, just when you equate both these two expressions, when you equate them, from here you can get the value of lambda optimum. How will you get it? Let me tell you. Don't worry about that. So probability of 0 transmission I already know. Probability of 1 transmission also I already know. What I need to make? I need to make the PDF of R when 0 is transmitted. So what is your R when 0 is transmitted? That is your minus 1 plus n. So this is a random variable. This is a constant value. This will also be a random variable. So if you have the PDF of n, if I know the PDF of n, can I draw the PDF of R such that 0 is transmitted? Surely you can do it. Why is that so? Because this is the case of a linear transformation. If this is the case of linear transformation, then I can surely draw the PDF of R such that 0 is transmitted. So I am given the PDF of noise. This is the PDF of noise. And don't feel like that, sir, there is too much information, these questions are tougher. Once you practice enough, like just this lecture will end. Just when this lecture will end, at that time you will say that, sir, I am completely comfortable in all these analysis. Okay, so you need to have some patience. That's it. Have some patience and you will be able to solve it. So this was the PDF of your noise. Now this PDF will be shifted by minus 1. So what will be the PDF of R such that 0 is transmitted? Shifted by minus 1. So n is taking value between minus 2 to 2. So R will take the value between, when n is minus 2, R will be minus 3. When n is plus 2, R will be minus 1. Sorry, plus 1. What I mean to say is that n is taking value between minus 2 to 2. Right? This is the value of n. So R will be taking the value, R when 0 is transmitted, that will take the value minus 2 minus 1, that would be minus 3. All these things we have seen in random variable. 2 minus 1, that would be 1. So it will take the value between minus 3 to 1. So basically you just need to shift it by minus 1, that's it. So it will take the value between minus 3 to 1. And peak value will be occurring at minus 1. PDF of random variable R such that 0 is transmitted. Now next what I need to do, random variable R such that 1 is transmitted. What that was? Sir, that was 1 plus n. Sir, this was your random variable. So sir, this will also be a random variable. And sir, this is the case of a linear transformation. So can I find out the PDF of R such that 1 is transmitted? Can you find out this PDF? Surely sir, surely I can find out this PDF. How would you make this PDF, sir? Just I need to shift it by 1. What you will say? Sir, if n is taking value between minus 2 to 2, so your input R such that 1 is transmitted, that will take the value. Where is the expression? This is the expression. So when n is minus 1, R will be, sorry, when n is minus 2, R will be minus 1. And when n is plus 2, R will be plus 3. So it would be there between minus 1 to 3. It would be there between minus 1 to 3. this point will be 1. Okay, so PDF of R such that 1 is transmitted. That would be like this. Now what was my task? My task was probability of 0 transmission. What this is? Probability of 0 transmission is equals to 0.2, right? And probability of 1 transmission is equals to 0.8. So multiply this graph by 0.2, multiply this graph by 0.2 and multiply this graph by 0.8. And if two graphs are equal, let's just say I say 2x plus 3 is equals to 5x plus 2. So what I can do? I can make the graph of 2x plus 3, right? I can make the graph of 2x plus 3 and then I can make the graph of minus 5x plus 2, minus 5x plus 2. So what I am making? Y versus x graph I am making. So I am making y equals to 2x plus 3 and I am making y equals to minus 5x plus 2, and wherever they are cutting, that will be the value of x. Say yes or no? Like if I need to solve this equation, you need to solve this equation such that you find out the value of x. So what I can do? I can make the graph of 2x plus 3, I can make the graph of minus 5x plus 2, and wherever they cut, there I will get the value of x. So similar thing, I am having two graphs. Wherever they are cutting, at whatever the value they are cutting, that value will be your lambda optimum. That's it. Are you able to understand this point, what I am saying? So first part would be that you multiply this particular graph by 0.2 and then you multiply this particular graph by 0.8 and then you make both of the graphs on one axis only. What I mean to say is that now what I am going to do, I am going to make both of these graphs on one axis only, but I will multiply the corresponding probabilities. What I am doing, multiplying probabilities and PDF of R. Probability multiply with the PDF of R. Okay, so this should be multiplied with the 0.2 because this should be multiplied with the probability of 0 transmission. So this should be multiplied with 0.2. So 0.5 into 0.2, what that would be? 0.1, right? So the same graph, just the peak amplitude will be 0.1. And let me mark out the point first. Minus 3, minus 1, plus 1 and plus 3. This is what I will be interested in. Minus 3, minus 1, plus 1 and plus 3. This is what I will be interested in. And so this graph was multiplied with 0.5 was multiplied with 0.2. So as of now you feel like that, sir, this is a long process because we are learning it. When you have the enough practice, then at that time it will not take much time. Okay, you will be able to solve it very quickly. You will not even make this graph, you will directly make this graph only. So this point will be 0.1. Well and good. Okay, this graph I have made, and then what I need to do, I need to multiply 0.5 with 0.8. So 0.5 multiplied with 0.8, what that would be? 0.4. Graph might look a bit different, but you would know that where they would cut. Here they would cut. So this point will be 0.4. What you need to find, you just need to find out the point where both of the graphs are cutting. So what I will do, I will write down the equation of this line and I will write down the equation of this particular line and I will equate both of them. Our job will be done, right? So what will be the equation of this line? So you can see the slope 0.4 divided by 2, that would be 0.2. Okay, and I am writing down in terms of lambda only. Okay, I'm writing down the equation of this line in terms of lambda. Forget about what is this axis, what is this axis. Forget about all these kind of things. I'm just writing down the equation of this line in terms of lambda. So what is the slope? Slope is 0.4 divided by 2. So 0.2 lambda plus, you know that at minus 1 it will throw 0. That means this should be minus or plus 0.2. This is the equation of this line. Can you write down the equation? First, what did I show? The slope is 0.4 divided by 2. The slope is 0.2. Then I know that at minus 1 it will throw 0. So at lambda equals to minus 1 it will throw 0. So yes, minus 0.2 plus 0.2. So that would be 0 only. And what is the equation of this line? The equation of this line would be 0.1 divided by 2 lambda. The slope is negative. So when I put 1 here, it will throw 0, right? When I put 1 here, it will throw 0. That means it should be 0.1 divided by 2. So equation of this line will be minus 0.1 divided by 2 lambda, because 0.1 divided by 2. So minus 0.1 divided by 2 into lambda, plus when lambda is equals to 1, when lambda equals to 1, this graph should throw 0. So here 0.1 divided by 2 should come. So now I need to equate both of them, because I need to find out this point. So 0.1 divided by 2 lambda plus 0.1 divided by 2 should be equals to 0.2 lambda plus 0.2. Okay. So what you are getting? This will go here and this will come here. So 0.15 would be equals to 0.25, right? But this will be negative. And from here, if you solve it, you are getting lambda equals to minus 0.6. So this is the value, lambda equals to minus 0.6, where both of the graphs are cutting. So this is your lambda optimum. So all these things you will not do this process that we have followed here, that first I find out the probability of error in terms of lambda, then differentiated and got the answer. No, this particular thing you are going to follow, a very, very important point. Although this is known as map criteria, but forget about what is the name. No one will ask you what is the name. Okay, so name and all we don't care. We only care about the process. Probability of 0 transmission multiply with the PDF of input such that 0 is transmitted equals to probability of 1 transmission multiply with the PDF of input such that 1 is transmitted. That's it. So just do this process, make the graph and get to know that where both of the graphs are cutting. Although in the examination you will not make these two graphs, right? You will already see this graph. Then what will happen is that, okay, you know that I need to shift this one by plus 1 and this by minus 1. So directly I will make this graph. And then what I will do, I will multiply with the corresponding probabilities. Don't forget this step, okay? Probability of 0 transmission, probability of 1 transmission. So I will multiply with the corresponding probabilities and I will get the intersecting point. And that answer would be minus 0.6. Is that okay for you? Okay. Now, what may happen is that in the examination or in the question paper, these graphs may be mentioned sometimes. Here what was mentioned? Noise PDF was mentioned. From noise PDF, we have got the graph of this guy and this guy. But in the examination, what may happen? These graphs might be mentioned. They will directly give you the PDF of input. They will not tell what is the noise. They will neither tell what is the symbol, noise, nothing they will tell. They will directly make this graph. They will directly make this graph. So let me tell you how this question could have been framed. What they could have done? They could have directly said that there is a threshold detector. Okay, they could have directly said that there is a threshold detector. Input is R. I am having lambda optimum and output I will decide. So how output will be decided, that they will already tell. So here I will just write down output. So how output will be decided? They will just say that it will be corresponding to bit 1 when R is greater than lambda, and when R is less than lambda, it will be corresponding to bit 0. Okay, so this is how they will define it. And then what they will say, PDF of R is given. And how they will make the PDF of R? This is how they will make the PDF of R. PDF of R is given. So This point is -1 only. This point is +1. This point is, what would be this value? Noise PDF was 0.5, right? This value will be 0.5. So this is the PDF of R. Okay. And then they will write down, this is corresponding to bit 0 and this is corresponding to bit 1. This is how they can ask the question. And then they can ask you, find out the probability of error. What they can ask you? Question. Find out probability of error for lambda optimum case. This thing they can ask you. Or what they can ask you, they can give you the value of lambda. So find out the probability of error such that lambda equals to 0. This time I am giving lambda is equals to 0. So what you will do, you will take out the graph, right? You can take out the graph. This graph you can take separately out, this graph you can take separately out, and lambda value you already know. So how will I solve this question? Now, if this particular question is coming in my examination, how will I solve it? I will not write down the equations. Like first thing I know that what will be my probability of error. First thing I will write down this particular thing. Probability of 0 transmission multiply with probability of 1 received such that 0 is transmitted plus probability of 1 transmission multiply with probability of 0 received such that 1 is transmitted. Okay. I know this particular thing. This particular thing will be 0.2 and this particular thing will be 0.8. Now my task would be probability of 1 received such that 0 is transmitted. This is something that I need to know. So I know that when 1 will be received, when 1 will be received, 1 will be received when R is greater than 0 because lambda is equal to 0, and when 0 will be received when R is less than 0. So what I need to find, 1 received such that 0 is transmitted. So 0 transmission PDF I need. What do I need? I need the PDF of input R such that 0 is transmitted. So can you make the PDF of input R? What I am saying, can you make the PDF of input R such that 0 is transmitted? From this question only. Forget about the previous question. This particular question is given now. This is a new question. This particular question is given. Threshold detector is there, lambda is there, R is there, output is there. PDF of R is given, PDF of input is given, corresponding to bit 0, corresponding to bit 1. How the threshold detector is behaving, that is given. Lambda value is given, that is 0. You need to find out the probability of error. So you will write down this particular expression. Probability of 0 transmission was also given, probability of 1 transmission was also given. Now the matter of concern will be probability such that 0 is transmitted but received bit is 1. So PDF of R, PDF of input such that 0 is transmitted, that would be this one. That would be this one. -3 to +1. -3 to +1. And this would be 0.5. Now what is my lambda optimum? This is my lambda optimum. Sorry, not optimum, I should not say lambda optimum. This is my lambda value. Lambda is equals to 0. Now I know that if my input is greater than 0, then I will receive 1. So what is my matter of concern now? Probability such that 1 is received and 0 is transmitted. So this is the PDF of 0 transmission. Now in this PDF, when I will receive 1, here I will receive 1 and here I will receive 0, because I know that if R is less than 0, if R is less than 0, then 0 received, and when R is greater than 0, then 1 received. So in this particular case, when you will get the error, you will get the error if your if your random variable r is taking value greater than 0. That means in this particular portion you will get the error. Do you agree to this point or not? So my matter of concern now will be this much area, that's it. So if this is 0.5, this was your -1. So this will be 0.25. So that would be half into base into height. So 0.125 you are getting. And similarly, similar thing you can do here. Now you have the PDF of input such that 1 is transmitted. That PDF you are already having. What will be that PDF? That PDF you can very easily draw from 1 to 3. Sorry, from -1 to 3, and peak value will be here. And this will be your 0.5. Okay. Now where is my lambda optimum? This is my, sorry, not optimum. I am again and again saying lambda optimum. No, this is your any random lambda value. It is not lambda optimum. So this is your lambda value, that is 0. Now this is the PDF of input such that 1 is transmitted. Now I know one thing. What do I know? I know that what I need to find, probability of probability of 0 received such that 1 is transmitted. This is what I need to find. So where I will go? I will go to the PDF of input such that 1 is transmitted. Now in this PDF, when I will receive 0, here I will receive 0, because if your r is less than lambda, then 0 will be received, and when r is greater than lambda, then 1 will be received. So I will go to the PDF of r such that 1 is transmitted. Now I need to see the condition when I will receive the 0. I will receive the 0 here. So again this area would also be half into base will be 1 into height would be 0.25 only. This area will also be 0.125. So what will be your probability of error? 0.2 into 0.125 plus 0.8 into 0.125. So the answer would be 0.125. That will be your probability of error. That's it. And you can verify it from this particular expression. Put 0 here. If I put 0, what I will be getting? Lambda is equals to 0. So 0.1 plus 0.1 by 4. क्या हो गया? Yeah, so same answer you are getting actually, 0.1 divided by 4 plus 0.1. So yeah, 0.125. So if you put lambda equals to 0 here, you are also getting 0.125. 0.125. This is your final answer, probability of error. So did you understand what kind of questions can be asked from this one problem we have discussed for 1 hour? In this 1 hour of discussion, we have understood everything about this particular lecture. Although this lecture will go on for next 2 to 3 hours as well, but whatever that can be asked has been discussed in this particular question only. So let's revise whatever that we have discussed in this particular question. So we know that two kind of symbols our source was generating, -1 +1. You know that it is a sample value. We are having a noise, we are having the PDF of the noise as well. We know the probability of 0 transmission, we know the probability of 1 transmission. Input is x plus n, that means input could be of two kind, -1 plus n and +1 plus n, right? -1 plus n will be with corresponding to bit 0 transmission, +1 plus n would be corresponding to bit 1 transmission, and then how the output will be behaving, that also is given. Okay, probability of error I need to find for these cases. So first I took lambda equals to 0.5 and then I find out the probability of error. How will I find out the probability of error? Very simple thing. Formula I already know. My matter of concern will be probability of 0 received such that 1 is transmitted and probability of 1 received such that 0 is transmitted. That would be the matter of concern. So I will look here, 1 transmitted. That means I need to go to the PDF of 1 transmission. So the PDF of R such that 1 is transmitted. PDF of R or random variable R such that 1 is transmitted. If that is less than 0.5, then my job will be done, and if it is greater than 0.5, then my job will be done. Then I will get the probability of error. Okay. Then now what I am doing, I am considering the threshold voltage to be lambda only. So any particular lambda you can get. So when I am considering the value of lambda, so what I can see, I am getting a probability of error expression in terms of lambda, although this was not a very good expression. So this is how I can reduce it. Okay, then I will put the value of lambda equals to minus 0.5, 0.5, 1, minus 1 and minus 0.6. I will get these values of probability of error, and probability of error was minimum when your lambda was equals to minus 0.6. Now how do you get this lambda equals to minus 0.6? When you differentiate your probability of error with respect to lambda. So from there I am getting my lambda equals to minus 0.6, and this lambda is known as lambda optimum. But this would be a very difficult task to do because it will involve a lot of calculation. Then we have developed another method, that is probability of 0 transmission multiply with the PDF of R such that 0 is transmitted should be equals to probability of 1 transmission multiply with the PDF of R such that 1 is transmitted. So for that what we will do, we will prefer making the graph. So here I have made the PDF of R such that 0 is transmitted, PDF of R such that 1 is transmitted. I will multiply it with the 0 transmission probability. I will multiply this with the 1 transmission probability. Then I will see where both of the graphs are cutting. The cutting point will be my lambda optimum. Okay, and the similar thing could have been asked. They could have given the PDF of R such that 0 is transmitted, PDF of R such that 1 is transmitted. So they could have given two kind of PDF. Then they could have given a particular value of lambda. So if they have given a particular value of lambda, then what I will do, I will separate both of the PDFs. Then I will say, if lambda is greater than 0, PDF of R such that bit 0 is transmitted, lambda greater than 0, then that would be the error, and PDF of R such that bit 1 is transmitted, PDF of R such that bit 1 is transmitted, so lambda less than 0 is an error for me. So this area I need to find, this area I need to find, and from there I will get the answer 0.125. So this is the conclusion of everything that we have studied. Based on that, you need to solve this question on your own. Very easily you will be able to solve, very easily. So a random variable x taking the value -1 and +1 with probabilities 0.2 and 0.8 respectively. It is transmitted across a channel which adds noise n at the channel output y equals to x plus n, where n is independent of x and uniformly distributed between the interval -2 to 2. So n is having uniform distribution between -2 to 2. So they have just talked about random variable n having uniform distribution between -2 to 2. The receiver will be making the decision based on this. So output is denoted by x bar. Usually we were denoting it by y bar, okay, or y cap, but they are denoting it by x cap. So if y is less than equals to alpha, what is alpha? Alpha is a threshold value, right? So when usually we denote a threshold value by lambda, but they are denoting by alpha. So when y is less than equals to alpha, -1, when y is greater than alpha, +1, where the threshold is chosen so as to minimize the probability of error. So what is this? They are choosing the value of alpha such that probability of error is minimum. That means they are talking about a lambda optimum, right? So find out the minimum probability of error. Along with that, you need to find out the lambda optimum value as well. Is that clear to you? Everything is crystal clear to you. So PDF of n I already know. Input I already know. What would be my input? If you want to make the diagram, you can make the diagram as well. So two kind of input would be there. Input such that 1 is transmitted, input such that 0 is transmitted. So input such that 1 is transmitted, that would be 1 plus n, and input such that 0 is transmitted, that would be -1 plus n. Now can you make the PDF of input such that 1 is transmitted? Let me know the PDF of input such that 1 is transmitted. That would be, sir, uniformly distributed between -1 to 3. How did you get it? Because it is 1 plus n. N is uniformly distributed between -2 to 2. So where your PDF of y will be distributed? So when n was taking value -2, y will take value -1. When n is taking value +2, y will take the value +3. So -1 to 3. And PDF of y such that 0 is transmitted, that will also be uniformly distributed between -3 to +1. Probability of 1 transmission is given as 0.8. Probability of 0 transmission is given as 0.2. What I need to find? I need to find lambda optimum. That means what I need to do? Sir, probability of 0 transmission multiply with PDF of y such that 0 is transmitted should be equals to probability of 1 transmission multiply with PDF of y such that 1 is transmitted. So PDF of y such that 1 is transmitted, that would be between -1 to 3. So I will make both of the graphs in one axis only now. Directly I am making the graph. So what I am making? PDF of y such that 1 is transmitted, that would be between uniformly distributed between -1 to 3. So this amplitude will be 1 by 4. Okay. So this is the PDF of y such that 1 is transmitted. But I know that I need to multiply it with the corresponding probability. So that would be 0.8. So what I am making actually, I am making probability multiply with probability of, probability multiply with PDF of y. So probability of one transmission multiply with PDF of y such that 1 is transmitted. So this thing I have already done, 1 by 4 into 0.8. Next what I need to make? Probability of zero transmission, PDF of zero transmission, PDF of input such that 0 is transmitted, multiply with the probability of zero transmission. So probability of zero transmission is 0.2, probability of zero transmission is 0.2, and what will be the input PDF? Input PDF such that 0 is transmitted, that would be between -3 to 1, amplitude being 1 by 4, and that will be multiplied with 0.2. Okay. -3 to 1. So it will be a bit lower. Why I multiply with 0.2, that is clear to you, right? This will be the PDF. This is the PDF of input such that 0 is transmitted. But I need to multiply with the probability as well. Probability of zero transmission. What that would be? That probability of zero transmission will be 0.2. So what will be this value? This value will be 1 by 4 into 0.2, and it is going from -3 to +1. So where both of the graphs are cutting? At this particular point, right? Where the both of the graphs are cutting, both of the graphs are cutting at this particular point, and here directly I can see that I don't even need to solve an equation. Directly I can see this will be my lambda optimum or alpha optimum, that is equals to -1. So my optimum threshold is -1. Okay. Now what you need to find? You need to find out the probability of error. Probability of error. What that would be equivalent to? Probability of zero transmission multiply with probability of one received such that 0 is transmitted plus probability of one transmission multiply with 0 received such that 1 is transmitted. Right? Now what guys can do is that they already know this value 0.2 and they already know this value 0.8. So what they can do is that now they can make the PDF of input such that 0 is transmitted. Basically they can make this PDF and they can make this PDF. Then they already know the value of lambda optimum -1, and from there they can solve it. So let's solve it by our conventional way. Our conventional way will say that I would make the PDF of y, such that 0 is transmitted and such that 1 is transmitted. So PDF of y such that 0 is transmitted, PDF of y such that 1 is transmitted. So 0 transmitted means -3 to -1. -3 to -1. Sorry, -3 to +1. Sorry, guys. Okay. And this particular PDF is between 1 to 3. Not 1 to 3, it is between -1 to 3. Right? This is between -1 to 3. From here I can see, no? -1 to 3, -3 to 1. So this is -3 to 1, -1 to 3. And what is the value of lambda optimum? Lambda optimum is -1. Okay. Now what you need to tell? Probability of one received such that 0 is transmitted. So what that would be? When you will receive one, when your input, which is y, that is greater than your lambda value is -1, when y is greater than -1. But which case you need to consider? When y is greater than -1, but which case of y you need to consider? You need to consider that case where 0 is transmitted. So probability is such that input is taking value greater than -1 such that 0 is transmitted. What that would be? I need to go to the PDF of y such that 0 is transmitted, and the input should be taking value greater than -1. So this value is -1. So this area, this is just the midpoint, so this area would be half. Probability of 0 received such that 1 is transmitted. Probability of when you will receive 0, when your y is greater than, sorry, when your y is less than -1. But where you will go? You will go to the PDF of one transmission. Probability of receiving 0, that would be what? Probability of receiving 0 would be equals to y less than -1, right? But condition is given that 1 is transmitted. That means y such that 1 is transmitted should be less than -1. How much area? 0 area, right? Area is 0. So what will be your probability of error? And this probability of error will be minimum. So I am writing minimum probability of error. So this probability of error will be minimum. So probability of 0 transmission, that is 0.2, multiply with 1/2, plus probability of 1 transmission, that is 0.8, multiply with 0. So answer would be 0.1. So that's the final answer. The probability of error minimum would be 0.1. Is that okay for you? So this is how I could have solved it. Now, can you notice one particular thing? What I need to find? This particular thing, and I need to find this particular thing. Can I directly solve it through this graph only? This is the graph of bit 0, and this is the graph of bit 1. This is the graph of bit 0, this is the graph of bit 1. So probability of receiving 1 such that 0 is transmitted. That means I will go to the PDF of 0. Now when I will receive 1, when my threshold value, when my input value is greater than this threshold value, probability of receiving 1 such that 0 is transmitted. So that means I will go to this particular PDF. Now in this PDF, where I will be having some issue, this is the PDF of 0 transmission. Problem will be if you are having greater value than the lambda optimum. Say yes or no. So this will be the area of the problem. Then I will go to the PDF of 1, and I will ask the PDF of 1 that where will be the problem. The problem will be if your lambda is taking, or if your r is taking value lesser than lambda. That means here will be the problem. But this area is 0. For this PDF, this area is 0. Although if you are not able to visualize from here, you can make separate graphs. And this is also a very good way of solving this problem, and surely you will get the correct answer. If I had been a student, I would prefer this method. But if you just want to solve using one graph only, so you have already made the graph of probability multiply with corresponding probability, probability multiply with some other probability. So whatever the area that I am getting here, that will be the final answer. So 1/4 into 0.2 into 2, that would be the final answer. Answer would be 0.1. Are you able to understand what I did here? My matter of concern is probability of 0 transmission multiply with probability of 1 received such that 0 is transmitted. So corresponding probability I have already multiplied, no? 0.2 and 0.8. Here what I would have done, 0.2 multiply with some probability, 0.8 multiply with some probability. So 0.2 and 0.8 are already being multiplied. So that I don't need to care. Now what I will do, I will go to the PDF of bit 0, I will ask him where is the issue. He will say here is the issue. I will go to the PDF of 1, I will ask him where is the issue. He will say here is the issue. But here there is no particular area, so that area is 0, but this area is non-zero. So that answer is 1 by 4 into 0.2 into 2. Answer would be 0.1. Again, in the examination, follow this method. It would be better. First find out the lambda optimum, then separate the PDF and get the answer. Okay, it was an easy question. You would be able to solve it. Very simple. Again, you can see the solution, and let's move to the next question. This is also a good question. You can try doing it on your own. A random variable x is taking two symbols, minus 0.5 to 0.5 is transmitted equiprobably. What does that mean? Equiprobably. That means they have given that probability of minus 0.5 transmission is equals to probability of 0.5 transmission is equals to 1 by 2. And the channel output is given by y equals to x plus 1. N is a conditional noise random variable defined as follow. What does that mean? When 0, this is corresponding to bit 0 and this is corresponding to bit 1. Okay. So when bit 0 is transmitted, then the noise is uniform, and when bit 1 is transmitted, then the noise is Gaussian, having 0 mean and variance 2. Output is defined when y is greater than alpha plus 0.5, when y is less than alpha minus 0.5. Okay, alpha is the threshold. Find out the probability of error when the detection threshold is 0.5, and you need to find out the optimum value of threshold and also find out the minimum probability of error. Okay, so this is the question. So you can write down y such that 1 is transmitted, y such that 0 is transmitted. So what I am doing, I am writing down y such that 1 is transmitted. What that would be? What is the value of x? 0.5 plus noise. So this I am putting down as n1. What is your n1? n1 is Gaussian. Your n1 is Gaussian random variable having 0 mean and variance 2, and PDF of y such that 0 is transmitted, that would be minus 0.5 plus n2, and n2 is uniformly distributed between minus 1 to 1. What they are asking probability of error such that detector threshold is 0.5 volt. So threshold value is given, lambda value is given, that is 0.5 volt. What you need to find? Probability of error. So probability of error would be probability of 0 transmission multiply with probability of 1 received such that 0 is transmitted plus probability of 1 transmission multiply with probability of 0 received such that 1 is transmitted. So probability of 1 received such that 0 is transmitted, that is my matter of concern, because probability of 0 transmission, probability of 1 transmission I already know. So probability of 1 received such that 0 is transmitted. So when you will receive 1? When your input y is greater than what? Greater than 0.5, because lambda value is given, that is 0.5. So at that time I will receive 1, but given condition is 0 transmitted. So y such that 0 is transmitted is given as minus 0.5. You can solve it by the graph as well. Okay, you make the graph of this particular thing, you make the graph of this particular thing. Graph means you make the PDF of y such that 0 is transmitted, you make the PDF of y such that 1 is transmitted, then you mark the lambda optimum just as you have marked the lambda optimum, and then you see where is the matter of concern, where is the probability of error you will be getting. So in that manner also you can solve. Okay, don't worry about that, we will solve by that method as well, don't worry. Okay, so minus 0.5 plus n2 should be greater than 0.5. So n2 should be greater than 1. What will be the answer? 0. n2 greater than 1. 0. n2 is taking value between minus 1 to 1, n2 greater than 1. Is it possible? No, right? So this value will be 0. Now next would be probability of 0 received such that 1 is transmitted. So when you will receive 0? When y is less than 0.5, given that 1 is transmitted. 0.5 plus n1 should be less than 0.5. So n1 should be less than 0. What will be the answer? N1 should be less than 0. Gaussian. Mean is 0. Variance is 2. N1 should be less than 0. What will be the probability? Half. Right? Probability will be half. So what will be the answer you will be getting? 0 transmission probability is 1 by 2. Multiply with 0 plus 1 by 2 multiply with probability of 0 received such that 1 is transmitted, that will be half. What will be the answer? 1 by 4. So that's the answer of first question. What could be the another method? You could have find out the PDF of y such that 1 is transmitted. Can you make the PDF of y such that 1 is transmitted? What I am saying? Make the PDF of y such that 1 is transmitted. So I am talking about y such that 1 is transmitted. So that is 0.5 plus n1. What is this? Gaussian. So this will also be Gaussian. Okay. What will be the mean? If this was having mean 0, so here the mean would be basically mean of y such that 1 is transmitted would be equals to mean of 0.5 plus mean of n1. So mean of n1 is 0, mean of 0.5 would be equals to 0.5 only. And what will be the variance? Variance would be equals to variance of 0.5 plus variance of n1. What will be the variance of a constant value? That would be 0. And variance of n1 was 2. Is that okay for you? Basically your Gaussian PDF, it will be shifted by 0.5. That's it. So can I make the PDF of y? Can I make the PDF of y such that 1 is transmitted? PDF of y such that 1 is transmitted. Okay. Now from here what I can find out? Probability of receiving 0 such that 1 is transmitted. So when you will receive 0? In this region, because this is my lambda optimum, right? Sorry, not lambda optimum, whatever the value of lambda they have given. So this is my lambda value. This is my lambda value that they have given. So I know that when I will receive 0, I will receive 0 when y is less than 0.5. Which y? Such that 1 is transmitted. So this is what I need to find. So I know that this particular area will be nothing but half. Okay. And similar thing you can do when y such that 0 is transmitted. That would be minus 0.5 plus n2. This is your uniformly distributed between minus 2 to 2. Sorry, minus 1 to 1. So this is your lambda value, right? So what they are asking, probability of 1 received such that 0 is transmitted. So probability of y taking value greater than 0.5. but such that 0 is transmitted. Y taking value greater than 0.5 such that 0 is transmitted. So y taking the value greater than 0.5, no probability, that probability will be 0. So this value I am having, this value I am having, then I can find out the probability of error, that would be 1 by 2 into 1 by 2, that would be 1 by 4. So this was your method 2, right? Very simple, very straightforward. Now let's go to the B part. What this B part is saying, determine the optimum threshold lambda that will minimize the probability of error. So optimum threshold I need to find. So what is the method? Sir, probability of 0 transmission multiply with probability of receiving 1 such that 0 is transmitted should be equated to probability of 1 transmission multiply with receiving 0 such that 1 is transmitted. Okay, that means I need to make the graph of array yaar, sorry guys, brainwash, not brainwash, brain fade, we call it brain fade. Probability of 0 transmission multiply with the PDF of y such that 0 is transmitted should be equated to probability of 1 transmission multiply with PDF of y such that 1 is transmitted. Okay, needlessly I was writing down the probability here, not probability, PDF, right? So 0 transmission probability is 1 by 2, this is also 1 by 2, so both can get cancelled out, 1 by 2 and 1 by 2 can get cancelled out. So from here what you are getting, 0 transmission is equals to PDF of 1 transmission, right? This you can do, right? This and this will get cancelled out. So just make the PDF of 0 transmission, make the PDF of y when 0 is transmitted, make the PDF of y when 1 is transmitted. So PDF of y when 1 is transmitted is this one. So let's make this PDF first. So this is your PDF of y when 0 is transmitted. So this PDF would be minus 1.5 to 0.5 with the amplitude of 1 by 2. Minus 1.5 to 0.5 with the amplitude of 1 by 2. With the amplitude of 1 by 2. Okay, but I am drawing probability multiply with the PDF. So again I will multiply with 1 by 2 because this is, let's not cut it, okay, let's not cut it, forget about it. So what I am doing, probability multiply with the PDF of input. So probability of 0 transmission multiply with the PDF of input such that 0 is transmitted, which is this one, right? All good? This I have made. Now what is my matter of concern? Probability of 1 transmission multiply with the PDF of input such that 1 is transmitted. So this is the PDF, but what will be this amplitude? What will be this amplitude? Do you remember the amplitude? 1 by under root 2 pi sigma square e to the power minus x minus mu upon whatever it is upon 2 sigma x square. So mu you will put here, this value will become 1. So amplitude is 1 upon under root 2 pi sigma square. So what is the value of sigma square? That is 2. So what will be the amplitude? 1 upon under root 4 pi. Whenever you make the graph, amplitude is very important. So this amplitude will be 1 upon under root 4 pi. Do you agree to this point? Because amplitude is 1 upon under root 2 pi sigma square. From there you are getting 1 upon under root 4 pi. Now let me know the value of 1 upon under root 4 pi. So 4 into pi, take the under root and do the reciprocal, that is 0.28. So this graph is going like this, and peak value it will achieve at 0.5 and that peak value is 0.8. So can you make the graph? This graph is going from minus infinity to plus infinity. Peak value it will achieve here, right? Peak value it will achieve here, and that value is 0.28. That value is 0.28. Also I will multiply with the corresponding probability as well. So 0.28 multiply with 0.5, that would be 0.14. So this was 0.28 0.25. So this will be 0.14. So 0.14 will be somewhere here. Are you able to understand this point? So where the graph will cut? That I am asking. The graph will cut at 0.5 only, no? Are you able to understand this point or not? So the graph will be going somewhat like this. Here this is the peak value. So the graph will be going somewhat like this. And this is the peak value that you are achieving. This value is 1 by 2 into 1 by under root 4 pi. That is coming out to be equals to 0.14. So where the graphs are cutting? The graphs are cutting at lambda equals to 0.5 only. So lambda optimum is coming out to be 0.5 only. So this lambda optimum, whatever the lambda optimum was given, whatever the value of lambda was given, that was lambda optimum only. Actually, they gave lambda optimum only. In the next question, we verified it. Okay. So in the next problem, in the problem 2, in B, we were supposed to find the value of lambda optimum. So how did I find out the value of lambda optimum? Probability of 0 transmission multiplied with the PDF of input such that 0 is transmitted should be equals to probability of 1 transmission multiplied with the PDF of input such that 1 is transmitted. So this is your corresponding to bit 0 and this is corresponding to bit 1. So PDF of input such that bit 1 is transmitted. PDF of input such that bit 1 is transmitted, that is this. Mean value 0.5 and Gaussian. Peak amplitude being 0.28 multiplied with the probability, it would be 0.14. Look, if I had blindly made the graph, then what I could have made? Sir, this is the PDF and the other PDF I could have made like this. Then I will go on solving the value and I will never get this particular value. You write down the equation. What you would have done? What you could have done is that, sir, this value is, I just need to equate both of them. So I know that probability of 0 transmission is 1 by 2 and PDF of phi. So PDF of phi is throwing 1 by 2 value only. Okay, this is 2. Yeah, this is 1 by 2 only. So PDF of y is throwing always 1 by 2 value. I just need to find out where both of them are cutting. So I just thought that here it will throw 1 by 2 value only. This graph is throwing 1 by 2 value only. And what value this graph will throw? So what I would have done is that 1 upon under root 2 pi sigma square value is 2. Then I would have got 1 upon under root 4 pi e to the power minus y minus, what is the value of mean, that is 0.5. So e to the power minus x minus mu upon 2 sigma square. So divided by 4. From here I would have tried to find out the value of y, or in place of y you can write down lambda optimum. In place of y you can write down lambda optimum. So from here I could have tried finding out the value of lambda optimum. Say yes or no. And that value, you solve this equation, it will be coming ln negative. Inside the ln some negative part would be coming. Inside log some negative part would be coming. Is that possible? No, it is not possible. Right? Inside log negative cannot come. So you cannot solve this equation actually. So from there what we would realize that if I make the graph in a good manner, I would realize that lambda optimum is coming out to be at 0.5 only. And what will be my minimum probability of error? My minimum probability of error would have been that I just find out here only, that was 1 by 4. So answer will be this only. Is that okay what I am saying? I hope you are able to relate or you are able to understand whatever that I am delivering here. So always make the graph with a good amount of patience. That where both of the graphs are cutting, that is my matter of concern. So always I will take care of amplitude and everything, and I will see where both of the graph cuts. So this is how I am getting the answer. Next, I guess we need to study about map criteria. So in the examination, what will happen? There will be something called map detector, or there will be something called ML detector. So we will come to this slide, but let's first see this question. This question was asked in GATE 2022 examination. One of the finest question of a threshold detector. Okay, came during my attempt only, and I still remember until the day of the final answer key. Everyone thought that just as the answer key came, everyone thought that they have given wrong answer, but actually it is a very good question. So let's understand it. What they have given, we are transmitting two bits XA and XB. Which is bit 1, which is bit 0, I don't know. We are transmitting two bits XA and XB. Okay. And the output of channel Y is the input of ML detector. What is this ML detector? We don't know. So we know that there is some threshold detector. We call it threshold detector. Now they are saying that this threshold detector is ML detector. Okay. This threshold detector is maximum likelihood detector. Conditional probability density function of Y given XA and XB are. That means probability of the input such that XA is transmitted, sorry, PDF of input such that XA is transmitted and PDF of input such that XB is transmitted, that is given. So our input is Y. They have written output of the channel, not the output of threshold detector, right? Output of the channel. Basically, this was line coder, then there was a channel, and then there was a filter, sampled value was there, and then there was threshold detector, right? This was your channel, this was your line coder. So line coder generated some pulses from the channel, some pulses would come, and now they are saying that filter is doing nothing. This is what they are assuming. So from the channel directly threshold detector is connected. This is what they are assuming. They are not considering the effect of filter. So output of the channel means input of a threshold detector, right? That would be Y. Input of the threshold detector is Y. Now we will have some lambda that we don't know. What is that lambda? And neither they have given how this threshold detector is working. What I mean to say is that in all the previous questions, in this question, what do you see? That when y is greater than lambda, it is 0.5. When y is less than lambda, it is minus 0.5. In this question as well, y is less than lambda, y is greater than lambda. In this question as well. Basically, how the threshold detector is working, that has been mentioned in all the problems. But in this particular question, how the threshold detector is working, that is not mentioned. But what is mentioned? ML detector, that is mentioned. So if ML detector is mentioned or map detector is mentioned, map means maximum a posteriori, maximum a posteriori, maximum a posteriori, okay, posteriori, maximum a posteriori, map detector, maximum a posteriori. So if map is mentioned or ML is mentioned, then how will you decide the working of threshold detector? That I am gonna tell now. If I just read out this particular thing, then you will not be able to understand. So let's understand by the question and then we will come here. Okay, let's understand by this particular question and then we will come here. So how the ML detector is working, that is not mentioned, so that we need to decide ourselves. One thing I know, that when ML detector is given, or map detector is given, both will be working on lambda optimum. So first task would be to find out the lambda optimum. Both guys will be working on lambda optimum. So first task would be to find out the lambda optimum. And how will you find out the lambda optimum? Probability of XA transmission multiply with XB received such that XA is transmitted equals to probability of XB transmission multiply with XA received such that XB is transmitted. Again probability I am writing down. What I am doing? I do this error again and again. Probability of XA transmission multiply with the PDF of input such that XA is transmitted equals to probability of XB transmission multiply with the PDF of input such that XB is transmitted. This is what I need to do. Now even they haven't given what is the probability of XA transmission, what is the probability of XB transmission. That means you don't know these values. So if ML criteria is given, ML detector is given, that means probability of bit 0 transmission, probability of 1 transmission is equals to 1 by 2. That means both are equiprobable in case of ML detector. So here, since ML detector is mentioned, you know that probability of XA transmission would be equals to probability of XB transmission, and that would be equals to half. So now I need to make the PDF of input such that XA is transmitted. PDF of input such that XA is transmitted, that is given. Can you make this graph? If you have studied signal system, you should be able to make this graph. How will you make this graph? A to the power minus y plus 1 into uy plus 1. How will you make this graph? In signal system, in basics of signal system, we have drawn this graph. A to the power minus y plus 1 into u of y plus 1. I told you y plus 1 here, y plus 1 here. So my first matter of concern will be e to the power minus y uy. So let's try making the graphs. So how will the graph of e to the power minus y uy would look like? This is how it will look like, right? But what I need to do, I need to left shift by 1. So how will I make the graph? The graph would look something like this. Left shift by 1. Okay. So this graph I have made. This is the graph of y such that XA is transmitted. But what I need to find? I need to find lambda optimum, because I know that ML will be working on, first thing is this, and second would be that it would be working on lambda optimum. So it would be working on lambda optimum, and if I need to find out the lambda optimum, what I need to do? Probability multiply with the input graph. Okay. Probability multiply with the PDF of input. So this was corresponding to XA, right? This was corresponding to XA. This was corresponding to XA. Now can you draw the graph of e to the power y minus 1 into 1 minus u of y minus 1? Surely I can draw, sir. E to the power y minus 1 into 1 minus u of y minus 1. Surely I can draw this graph. How will I draw this graph? So I can see e to the power y into 1 minus uy. What is 1 minus uy? That is u of minus y. So it is e to the power y u of minus y. This is the graph. E to the power y u of minus y, and then right shift by 1. So right shift by 1. So if I right shift by 1, then this is how the graph will get. Is that okay for you? In basics of signal, we have seen this graph. Whenever I say that if same operation is happening in y, then forget about that operation. So y minus 1 I will replace by y. Y minus 1 I will replace by y. So first I will try to make this graph which is equivalent to this particular graph, and then y is shifted by 1, right shifted by 1. So y is right shifted by 1. Okay. So this point was minus 1, this point was 1. And I need to multiply with the corresponding probabilities as well. So here what will be the amplitude? Amplitude will be 1, right? In this graph, if you put y equals to 1, what you will be getting? E to the power 0, and this would be y1, that would be 0 only. So this would be 1. This is simply making the graph, nothing else. So in both of the graphs, you know that this amplitude will be 1, but multiply with the corresponding probability, these amplitude will be 1 by 2. This is minus 1, this is plus 1. This is corresponding to XA, and this is corresponding to XB. What do you think? What is your lambda optimum? Where both of the graphs are cutting? Sir, here? No, graphs are cutting here. Actually, the graph is e to the power y minus 1 into 1 minus u of y minus 1. So this line is not there actually. This line is just saying that starting from infinity till plus 1 it was 0, and then at plus 1 it had some value, and then it is decreasing. Look, whenever I make the graph of ut like this, will you say that u of 0 is equals to 1? No, u of 0 is not defined. right? Whenever I make the graph of ut like this, u of 0 is not defined. What do you say? From minus infinity to 0 it was nothing, and then it gained some value 1. So similarly, from infinity to 1 it is nothing, then it is having some value 1, and then it is decreasing. So this is not the point where they are cutting. Actually this is not even there. Are you able to understand this point? Here the graph is not continuous. So if the graph is not continuous, you cannot say that sir this is also the point where they are cutting. They will cut only at one point, that is this middle point. And how do you define what will be that point? You could have simply said that sir 1 by 2 PDF, this PDF is given. So e to the power minus y plus 1 into u of y plus 1 should be equals to 1 by 2 e to the power y minus 1 into 1 minus u of y minus 1. So can you solve this equation? Yes, 1 by 2 and 1 by 2 will get cancelled out. If both of the graphs are cutting, that means both should be non-zero. So their impact is also gone. So from there, what do you understand? That minus y minus 1 should be equals to y minus 1. That means y has to be equals to 0. How their impact is gone? Because I am saying that if both of the graphs are cutting, that means if both of the graphs are equal, if both of the equations are equal, if both of the expressions are equal, what does that mean? Both should be non-zero. This particular part is there only to tell whether this expression is 0 or non-zero. So if both of the graphs are non-zero, that means both of the graphs are cutting somewhere. That means their impact is gone. So effectively my equation reduces to e to the power minus y plus 1 e to the power y minus 1. Just equate both of them. So minus y minus 1 is equals to y minus 1. So y is equals to 0. So this is how you can find it out, or from the graph as well. Very simple way you can find out. You can see the symmetry, and from the symmetry you can find out that this will be my lambda optimum. This is going to be my lambda optimum. This is my lambda optimum. But now the matter of concern will be that how this will make the decision, how the ML detector will make the decision, because decision they haven't told. In all other problems they have given the decisions, but this time they haven't given the decision. In the previous problem, always how the output is defined, that has been given, but now how will you define the output? How will you define the output? So I will define the output based on this graph. So whichever the graph is maximum, you will give the decision based on that graph. If I work from minus infinity, I will start working from minus infinity, I will go till plus infinity. So from minus infinity to minus 1, which graph is larger? From minus infinity to minus 1, which graph is larger? XB graph is larger. So decision will be based on XB. So let me write down the output, how the output will be decided. Whichever the graph is larger, which graph it is? Probability multiply with the PDF of input. So first I will make the graph of probability multiply with the PDF of input. Probability multiply with the PDF of input. Now if you are working from minus infinity to minus 1, here what I should write down? Input. I am just writing down input. Input is y, right? Input is y. So this would be y only, right? Because you are making the PDF of y, multiplying with the corresponding probability. So this will be y only. So when y is minus infinity to minus 1, which graph is larger? This graph is larger. This was corresponding to xb and this was corresponding to xa. So graph of xb is larger. So it will give the decision in terms of in the favor of xb. That means your threshold detector will say, that xb is received. xb is received in this region. Okay. Then between minus 1 to 0, between minus 1 to 0, which graph is larger? This graph or this graph? So this graph is larger, and this graph is corresponding to xa. Then between 0 to 1, between 0 to 1, which graph is larger? This graph or this graph? So this graph is larger, right? And that is corresponding to xb. And between 1 to infinity, which graph is larger? xa or sb? xa. So it would be corresponding to xa. So this is how it will make the decision. Is that okay for you or not? So both map and ML detector will work on lambda optimum. For the ML, the condition would be that both of the probabilities would be equiprobable. But in map, probabilities could be different. Okay, in map criteria, the probability could be different. In ML, both of the probability will be same. Okay, and how they will make the decision? Probability into PDF of input of the detector. They will make the decision based on probability into PDF of input of the detector, PDF of Y. So whichever that is maximum, the decision will be based on that particular bit. So here bit 0 is maximum, so decision will be bit 0 received, and here the decision would be bit 1 received. Do you understand this or not? So this is known as your map criteria, and when both of them are equal, at that time what you are getting? Lambda optimum. When both of them are equal, you are getting lambda optimum. Is that okay for you or not? So if this is maximum, then XB, and forget about this XA. So here XB was maximum, here XA was maximum, here again XB was maximum, and then again XA was maximum. So this is how it will be making the decision. And what is your lambda optimum? Your lambda optimum is 0. Now what I need to find out? I need to find out the probability of error. So what will be the formula of probability of error? That I have already written here. No. So probability of error would be probability of XA transmission multiply with probability of XB received such that XA is transmitted plus probability of XB transmission multiply with XA received such that XB is transmitted. So you solve this question on your own. I will take a break. Okay, solve this question on your own and let me know how much area you are finding out. Are you integrating from 1 to infinity, from 0 to infinity, from 0 to 1? Let's see what answer do you get. Okay, most of the guys would be getting the answer of 0.36, which is wrong. So again you see the solution, again you see the diagram, you see how threshold detector is behaving, and based on that you give your answer. Okay, so have some patience. This thing you already know 1 by 2, this thing you already know 1 by 2. You need to find out this one, you need to find out this one. Okay, so try doing it on your own. I want to see your answers. Let me take a break and then I will come back. Yeah, so did you try this one? So what we need to find? We need to find probability of XB received such that XA is transmitted, right? XB received such that XA is transmitted. So probability when XB will be received. So XB will be received in this case and in this case when Y is between minus infinity to minus 1 and when Y is between 0 to 1. When Y is between minus infinity to minus 1 or when Y is between 0 to 1, right? Okay, but given that XA is transmitted, given that XA is transmitted, given that XA is transmitted, right? So your PDF of Y between minus infinity to minus 1 such that XA is transmitted. Basically what this will be equivalent to? This will be equivalent to minus infinity to minus 1 PDF of Y such that basically I need to calculate the area, right? If I need to find out my random variable Y taking value between minus 1 to my random variable Y taking value between minus infinity to minus 1. So what I need to do? I need to find out the area of PDF of Y, right? So PDF of Y such that XA is transmitted between minus infinity to 1. So let me know between minus infinity to minus 1 such that XA is transmitted. What is this area? 0. This particular area is 0 plus between 0 to 1 Fy such that XA is transmitted dot dy. So how much is this area? So this area I can find out. between 0 to 1. This area I need to find out. Okay. So this was the expression given y of xa. So e to the power minus y plus 1 from 0 to 1, e to the power minus y plus 1, and this uy plus 1 would be 1 only, so I don't need to care about it, dot dy, dot dy. This is what I need to do. So answer would be e to the power minus 1, 0 to 1, e to the power minus y dy. So e to the power minus 1, 1 minus e to the power minus 1, right? Am I doing it correct? E to the power minus 1 is going outside, e to the power minus y, e to the power minus y dy, 0 to 1, e to the power minus y, then sign comes here, 1 to 0. Let's do it again. I guess something wrong I am doing. E to the power minus y from 1 to 0. So e to the power minus 1, 1 minus e to the power minus 1. I was doing correctly only, right? So what you are getting? Do we have the calculator? Minus 1 divided by e. Yeah, 0.23. 0.23. So value of this particular thing is coming out to be 0.23. Although I could have directly solved it. How I could have directly solved it? Look, I need to see this graph. I am looking at this graph. Okay. I am moving on XA. I am moving on XA. So when I am moving on XA, here XA is less than XB. Here XA is less than XB. That means decision will be done in favor of XB only. Right? Here XA is more than XB, decision will be done in the favor of XA only. Here in the next portion, XB is more than XA, decision will be done in favor of XB, but XA is enclosing some area. What I am saying, I am working on XA. When I am working on XA, at what time XB is received, at that time I need to worry. Let me repeat the statement. When I am working on XA, when I am working on XA, at what time XB will be received, at that time I need to think, right? At that time I need to pick some matter of concern. So when I am working on XA, this time XB will be received. So yes, this is a matter of concern, but XA is not enclosing any area. XA is enclosing zero area. So look, minus infinity to minus 1. This thing also came into action. I am just telling how I would have solved with respect to the graph. Whenever the map criteria question is coming or ML criteria question is coming, map or ML, then just by looking at the graph you can solve the problem. What you will do, I will work on the graph of XA. When I am working on the graph of XA, at what time XB is received, at that time I need to take that case into the probability of error. So I am working on XA. Now now XB is received. That means yes, this is my matter of concern, but area enclosed is 0. Now again I am working on XA and XA is received, no matter of concern. Now again I am working on XA. Now who is received? XB is received and XA is enclosing some area as well. So yes, this area will come into the probability of error. Now again I am working on XA. Again I am working on XA. Who is received? XA is received. That means this is not a matter of concern for me. Now let's do the same thing for XB. I am working on XB. Who is received? XA is received. That means yes, this is a matter of concern for me. I am working on XB, but XA is received. That means this is a matter of concern for me, right? But the area enclosed by XB is 0 here. Now I am working on XB. Who is received? XB is received, not a matter of concern. I am working on XB. Who is received? XA is received. So yes, this is a matter of concern and it is enclosing some area as well. Right? Now I am working on xb. Who is received? xb is received, not a matter of concern. So this much portion is a matter of concern for me. So this much portion will come into your final probability of error. Along with that, probability is also applied. What I mean to say is that when I need to calculate probability of error, at that time I need to multiply with the probability of 0 transmission, probability of 1 transmission. That also has been already applied. So this probability has been already multiplied. So I just need to calculate this area and my probability of error will be done. Although this is an exponential function, so I have to calculate the area by this analysis. But let's just say if it was triangular, if it was a triangular function, then I could have simply done half into base into height. Are you able to understand this point? I am not even finding lambda optimum. No matter wherever they are cutting, I don't care about that. I just know that what my map or ML criteria will say. The one which is maximum, that should be in the result. So first I will mark up the result that here xb will be received, here xa will be received, here xb will be received, here xa will be received. Okay, this is the graph of xa, xb, xa and xb. Now I will work on the graph. I will move on the graph and I will say what is my matter of concern. I am working on xb, xa is being received, matter of concern, but area enclosed is 0. Working on xb, xb is received, no matter of concern. Working on xb, xa is received, matter of concern. Working on xb, xb is received, no matter of concern. Now working on xa, xb is received, matter of concern, but area enclosed is 0. Working on xa, xa is received, no matter of concern. Working on xa, xb is received, area enclosed is non-zero, that means this is a matter of concern. Working on xa, xa is received, no matter of concern. That's it. Or you can do by this analysis as well. Simply write down the equations, then write down when your xb will be received such that xa is transmitted. Similar thing we can do again. What I need to find now? xa is received such that xb is transmitted. So when you will receive xa, when y is between -1 to 0 and when y is between 1 to infinity, when y is between -1 to 0 and when y is between 1 to infinity, but which condition? xb transmitted. Which condition? xb transmitted. Okay, so -1 to 0 fy of xb dot dy plus 1 to infinity fy of xb dot dy. So between 1 to infinity this is equals to 0 only. Between 1 to infinity fy of xb is 0 only, right? -1 to 0 fy of xb, that is given by e to the power y minus 1. This will be equals to 1 only, so this is not a matter of concern. I will just write down e to the power y minus 1. So e to the power y minus 1 dot dy. So e to the power minus 1 I will take outside, e to the power y 0. So e to the power minus 1 minus e to the power minus 1. What you are getting? 0.23. Now what will be your probability of error? That would be half into 0.23 plus half into 0.23. The answer would be 0.23. Now when this question came in 2022, what people did and what was the problem? Let's just say in the examination I would have given this question. I did not write down ML detector or anything. I just said that it is working on lambda optimum. Okay, this particular thing is working on lambda optimum. My threshold detector is working on lambda optimum and I have defined the output. Okay, let's just say this was given in the examination. I have defined the output in this manner, that xa will be received when xa will be received when your input is less than 0 and xb will be received, or here in place of 0 I will write down lambda optimum. Lambda optimum you will find out and that will come out to be 0 only, right? This I would have given. Let's just say this I would have given. That means after lambda optimum everything is for xb. and before lambda optimum everything is for XA. This kind of output I have defined. Let's just say if this was the question. Are you able to understand this point? There is a difference. If ML detector is given, then output will be defined based on whatever that is maximum. But what if someone has defined the output in this manner? What if this was given in the question? That when y is less than lambda optimum, you take XA. When y is greater than lambda optimum, you take XB. That means here you are saying XB is received, but here you are saying XA is received. But if this condition is defined, then you would say not XA but XB is received. If this condition is defined. But this condition is not defined. So what people did was they took lambda optimum and after that they took XB, before that they took XA, which is wrong, right? Because when ML detector is given, they will not give the definition of the output. You need to define the output, or the threshold detector will be giving the decision in a manner that probability multiplying with the PDF of the input, whatever that is maximum, that will come at the output. So actually they integrated from 0 to infinity. This function they integrated from 0 to infinity. So if you integrate from 0 to infinity, your answer will come out to be 0.36. But if we have written in this manner, then it would be easy for us to check out that which case we need to take. Otherwise, I have told you a method that whenever map or ML is written, whenever map criteria or ML criteria is written, what you need to do, just move on the graph. First find out probability, multiply with the PDF, keep on moving on the graph, whatever that is maximum, based on that you need to give the decision. And when you move on a particular graph, let's just say I am moving on a graph of XA, but decision is made in favor of XB, then I need to see the enclosed area that would come in my probability of error. So this is how I need to proceed. So is that okay for you? So if output is defined, that means they will not say it is ML or map. And if output is defined, then you have to go by the defined output only. But if they have given ML or map, then they will not define the output. You have to define the output. Okay. So this is the difference of map criteria or ML criteria. Is that okay for you? Let's solve a question based on map. In map, what will be the difference? The difference would be the probability of error would be different. Sorry, probability of 0 transmission and probability of 1 transmission would be different. So 0 transmission probability, you can see it is 1 by 3, and 1 transmission probability you can see it is 2 by 3. So that will be the only difference, right? PDF is given 4-bit 0 transmission, and so input is R here again. Okay, input is R. PDF is given for 0-bit 0 transmission, PDF is given for bit 1 transmission as well, right? So direct input PDF is given, it is working on map criteria. Map threshold detector is employed for the decision making, determine the probability of error. Okay, so first criteria would be that I need to find out a lambda optimum, right? So this point will be lambda optimum. Lambda optimum would be equals to 1. Is that so? Wrong, right? Why it is wrong? Because I am telling you, always you will forget multiplying with the probabilities. Because what will happen is that whenever you solve any PYQ or you solve any test series, in all of these cases, or even if you solve any kind of questions, in all of these cases, probability of 0 would be given as probability of 0 would be equals to probability of 1, that would be equals to 1 by 2. If both of the probabilities are equal, then even if you don't multiply by the corresponding probabilities, still your answer would be same. But if probabilities are not equal, then first you have to multiply with the probability, then the nature of these graphs will change, you know. This particular graph will be multiplied with 1 by 3, this particular graph will be multiplied with 2 by 3. So nature of this graph and this graph will change, the equation of this line and this line will change. So as of now they are cutting at 1, but if the slope is changing, everything will change, you know. So then they will cut at separate points. Are you able to understand this point? So always probability, corresponding probabilities of a bit transmission should be multiplied. And I am pretty sure you will be forgetting in the examination. They will give different probabilities and you will forget it. You will take 1 by 2, 1 by 2. The biggest concern in the problem of digital communication system would be the probability of 0 transmission, 1 transmission. I am not saying only for this particular topic. I am saying for all the topics. We will see next lecture or next to next lecture. There, every time I will say, always look at the probability of 0 transmission and 1 transmission. If they are saying equiprobable, that means question is very easy. You will be able to solve in a very quick manner. But if they are not saying equiprobable, then you have to put your efforts. So now I will have to multiply. Bit 0 will be multiplied with 1 by 3. This will be multiplied with 2 by 3. Right? So this amplitude will go down, this amplitude will go up, because 1 by 2 multiplied with 2 by 3, right? Although it will not go up from this, because 1 by 2 multiplied with 2 by 3, it would be 1 by 3. So it will come down, but this will come more down, right? Because 1 by 2 multiplied with 1 by 3 would be 1 by 6. So 1 by 2 multiplied with 2 by 3, that would be 1 by 3. So this amplitude will become 1 by 3, and 1 by 2 multiplied with 1 by 3, that this amplitude will become 1 by 6. So both of the amplitude will go down, but this will go more down and this will go lesser down. So can I make the PDF? Surely I can make the PDF. Probability multiplied with PDF of the input. Okay. So this I am making for bit 0 transmission, and this I am making for bit 1 transmission. Although this point would be 2 only, like peak would occur at 2 only. So this line is not that good. So this point would become 1 by 6, right? 1 by 2 multiplied with 1 by 3, this would become 1 by 6, and 1 by 2 multiplied with 2 by 3, this would become 1 by 3. Minus 2 to 2, 0 to 4. Okay, so you write down the, basically at this point I need to find out. So you write down the equation of this line, and you write down the equation of this line. Okay, and equate both of them, your job will be done. I will write down in terms of lambda. So what is the slope here? Minus 1 by 12. So minus 1 by 12 lambda plus 1 by 6. And here what is the slope? 1 by 6 lambda. Okay, and just equate both of them. Three lambda by 12 is equals to 1 by 6. So lambda is equals to 2 by 3. So this is your lambda optimum. Okay, this is your lambda optimum. So midpoint is 1, but it is not at 1, it is at 2 by 3. So lambda optimum you are getting at 2 by 3. Is that okay for you? Shall I tell the calculation again? This is the equation of line, this is the equation of line. Very simple, you can write down the equation of line. This will be lambda minus lambda by 12 plus 1 by 6. This comes here. Sorry, this goes here. What you will get? This is 2 lambda by 6. This is lambda by, sorry, 2 lambda by 12. This is lambda by 12. So 3 lambda by 12. This would be lambda by 4. 4 by 6 would be 2 by 3. So lambda optimum is 2 by 3. But what you need to find out? We need to find out the probability of error. So probability of error. So let me erase these equations. Okay. Now I told you if it is a map criteria, what I can do, I can move on the graph. So I am moving on this graph. So just let me know how the decision would be made. Let me know how that decisions would be made. So this is your lambda optimum. Here till this particular point, This guy is larger, right? This is corresponding to bit 0. So from -2 to 2 by 3, what will be the answer? Bit 0 received, right? Because this graph is larger. And after that, which graph is larger? This graph is larger. Because I told you in map criteria, whichever the graph is larger, based on that you make the decision. So this is the point where both of the graphs are cutting. So till this point, this graph is larger. After that, this graph is larger. So from 2 by 3 to 4, bit 1 received. So always before 2022, whichever the question came, whether it is on map criteria, whether it is on ML criteria, or whether output is defined, always the decision could be made based on 2 intervals only. But here the beauty of this question was 4 intervals were made. So very smartly this question was framed, that you have to make 4 intervals: xb, xa, again xb, again xa. But here what is happening? Bit 0 till this point, bit 0, after that bit 1. That's it. Now if I work on the graph of bit 0, if I move on the graph of bit 0, till this point no issue. But when I go here, just as till this point there was no issue, but just as I go on this portion, just as I go here, what will happen? I am working on the graph of bit 0, but the decision will be made based on the bit 1. That means this will be the matter of concern. And after that, decision will be made based on 1 only. So no need to worry about it. Now if I work, or if I move on the graph of bit 1, if I am moving on the graph of bit 1, till this point no issue, I am moving on the graph of bit 1, decision is made based on bit 1 only. But just as I go here, there will be a matter of concern. Why so? Because you are moving on the graph of bit 1, but the decision is made based on bit 0. So this area will be the matter of concern. So what will be your probability of error? 0 transmission multiply with 1 received, 0 transmitted, plus 1 transmission multiply with 0 received, 1 transmitted. So this probability I already know, 1 by 3. This probability I already know, 2 by 3. If I don't want to go by the graph, how I can write down? 1 received, 0 transmitted. So when you will receive 1, so I will receive 1 when y is between 2 by 3 to 4. When y is between 2 by 3 to 4. But given that 0 is transmitted. So between 2 by 3 to 4, wait a second. Yeah, between 2 by 3 to 4, given that 0 is transmitted. So how much area you need to find out? From 2 by 3 to 4, this much area you need to find out. So from 2 to 4 you are enclosing 0 area. So this much area I need to find out, right? But PDF of y you need to take such that 0 is transmitted. But this is what this is? This is your PDF of y multiplied with the probability. So I will not look at this, I will look at this particular graph. So wherever 2 by 3 is there, basically what I am saying, this is the graph of probability multiplied with the PDF. But what I need the graph of PDF only. So what is my graph of PDF only? So this is the graph of PDF only. Between -2 to 2 with amplitude being 1 by 2. And this is your 2 by 3. What is the slope here? Slope is 1 by 4. Right? Slope is 1 by 4. Minus 1 by 4. Slope is here, and you are increasing your amplitude by 2 by 3. So you will decay by 1 by 6. So 3 by 6 is decayed by 1 by 6. So this point will be 1 by 3. Right? Do you agree to this point? 1 by 6 with 3 by 2. 1 by 4, yeah. So this point will be 1 by 3. How did I get it? You can do the signal system course. In signal system course, I have taught these kind of things, or simple mathematics. You can write down the equation of this line and then put y equals to 2 by 3, you will get this value. So this particular value is 1 by 3. So you need to find out this much area. So how much area this would be? 1 by 2 into height 1 by 3 into base 2 minus 2 by 3. What that would be? 6 minus 2, 4 by 3, 2 by 9. Okay, 1 by 2, height 1 by 3 and base 2 minus 2 by 3, that would be 4 by 3. So answer would be 2 by 9. And next you need to find out, so 2 by 9 would be multiplied with 1 by 3. 2 by 9 would be multiplied with 1 by 3, you will be getting 2 by 27. And if you find out this area as well, you will get the same thing. How will you find out this particular area? Here you will find out this value. How will you find out this value? What is the slope? 1 by 12. You are decaying by 2 by 3. So your amplitude will decrease by 1 by 18. From 1 by 6 to you will decay down to 1. From 1 by 6 you are decreasing the amplitude by 1 by 18. So this amplitude will become 2 by 18. That means this value will be 1 by 9. This value here, this value will be 1 by 9. So what will be this area? Half into base 2 minus 2 by 3, that would be 4 by 3 into 1 by 9. 2 by 27. You are getting the same thing. Here also 1 by 3 multiply with 2 by 9. What you will be getting? 2 by 27. Okay, so if you solve by this particular analysis, then calculation will be much easy. Now you have find out this value, no, 1 by 9. Similarly, you can find out this area as well. This area will also be very easy. What that would be? Half into base 2 by 3 into height 1 by 9. And previous case you are getting 2 by 27. Here what you are getting? 1 by 27. So your answer will be 3 by 27. Answer will be 1 by 9. That's it. Answer done. Just on this graph, answer is done. But I will tell you all the methods. This method is clear to you. You just need to calculate the area. So now, if this graph is made, my matter of concern will be I need to find out this much of area. That's it. And now if I find out this 1 by 9 value, then how will I find out the area? I could have find out in this manner as well. Half into, this is the base, into height. Height is 1 by 9. So answer is 1 by 9. That's it. I just needed to find out this point. And once I have got that lambda equals to 2 by 3, this is my lambda optimum. So in any of the equation I can put lambda. So if I put lambda equals to 2 by 3 in this equation, what I am getting? Lambda by 6. In place of lambda you need to put 2 by 3. So what you are getting? 2 by 18. That means 1 by 9. So the point where they are cutting, that is 1 by 9. That's it. So the points are 2 by 3 and 1 by 9. So 2 by 3 on x axis, 1 by 9 on the y axis. So if I know this point now, I only need to find out this much area. My answer will be done. If you don't want to go by this method, then this is the conventional method that we are following. This is complete conventional method. Here I need to make the graphs and everything. So in that manner we can proceed. Okay. When your 0 will be received. So 0 will be received when it is between -2 to 2 by 3. So map criteria questions are actually very easy. Needlessly people find it difficult. If map criteria is given, then it is more easier for you, right? It is easier. So again I will have to consider the PDF of y when 1 is transmitted. This is the PDF. From 0 to 4. And this amplitude is 1 by 2. Yeah, amplitude is 1 by 2. So between -2 to 2 by 3. So where I will get 2 by 3? 2 by 3 would be somewhere here. Okay, and this point was 2. So 1 by 4 was the slope into 2 by 3. So 1 by 6. This value is 1 by 6. Okay. So what will be the answer? Half into base into height. 1 by 80. So probability of error would be 1 by 3 into 2 by 9 plus 2 by 3 into 1 by 18. So 2 by 27 plus 1 by 27. 3 by 27, 1 by 9. So this is the answer. Okay, so this is your probability of error. Or how you could have find it out, just you need to find out this point, that would be 1 by 9. So from here area would be equals to half into base into height. So if you are not much confident in mathematics, then I would say not to go with this kind of approach, go with this approach. If you are much comfortable with the mathematics, you will just find out the point where they are cutting, just you have find out, then put the value in one of the equation, either in this equation or in this equation, you have find out this point as well. Now you just need to move on the graph. Okay, so what this lambda optimum will say, before this everything in terms of bit 0, after this everything in terms of bit 1, but always move on the graph. This graph is saying, what this graph is saying, this graph is saying that if I am larger, decision will be made based on me only. But if I am larger, decision will be made based on me only. But if I am moving on this graph, here this is the matter of concern, and if I am moving on this graph, here this is the matter of concern, right? But this was actually a very good problem. This was actually a very good problem, because here first xb, this was larger, then xa, this was larger, here xa and here xb. So if I am moving on the graph of xa, till this point everything was fine, although this was a matter of concern, but xb was already larger, so this was a matter of concern, but area enclosed was 0. Here this is not a matter of concern. What people did when this question came, that this is a matter of concern, but no, this is not a matter of concern. Here you are working on the graph of xa and xa is larger, not a matter of concern. So only this much portion was a matter of concern, but people actually took this much portion and got 0.36 as the answer, which was wrong. I also did the same mistake. Okay, but even at that time, a lot of people who solved the question paper, they also did the same mistake. Okay, okay, it happens. I am not saying that it would not happen. It can happen to everyone. So just saying that, yeah, error may happen, but always take care that if you go step by step. Here, if I wanted to show some smartness there in the examination, if I try being smart, then I might end up doing the error. But if I go step by step, just if I write down the output in this manner, then I would, or at least I denote in the graph everything, whatever that I am making, I will denote in the graph. Okay, this will make the decision on xa, xb, xa, xb. So if I am denoting everything, then yes, my job will be done there. Then I would not do any mistake. I would know that I need to calculate this much of area, and there I will only calculate this much of area because I know that this is symmetric, the area would be same here. So when I would have calculated the area, I would have got 0.23. My job would have been done, right? 0.23 into 1 by 2 I would get, because already probability is multiplied here. So just whenever you solve the problem of a threshold detector, always keep on making the graph, always keep on writing down everything, whatever that you are doing. Like here you should not be doing that, sir, I will be doing this question in a hurry. No, have patience, write down everything and solve it. If you solve by the patience, then there is no one who can stop you from getting 2 marks. Otherwise you can do some errors. Okay, so let's stop in this video. More points we are going to see. In the next video we are going to see a special case where the noise will be Gaussian. The analysis is ditto same. Okay, analysis will be ditto same. Just if the noise is Gaussian, that is a very special case. Why it is a special case? Because in the further lecture, always our noise will be Gaussian only. In the further lecture, our noise will be Gaussian only, and 90% chances are there that in the examination noise will also be given Gaussian. It would be white noise having 0 mean and variance of n0 by 2, white Gaussian noise. Okay, so that's why for Gaussian noise we will solve it separately and we will develop some formula. Those 2 to 3 formula we need to remember. I will also tell you how you can remember those formula, don't worry about that. And then we will see till this point what we are seeing: bit 1, bit 0, only 2 symbols, right? Bit 1, bit 0, xa, xb. Here bit 1, bit 0, minus 0.5 plus 0.5, here minus 1 plus 1. So only 2 symbols are there. What if more than 2 symbols are there? How will you solve it? So that thing also we are going to see in the next lecture. So let's stop it here. This was the video of a threshold detector part 1. Part 2 will also come. We will just carry forward from here. Okay, so nothing new we are going to learn. Whatever the concept that we have studied here, the same concept we are going to carry forward in the next video. Okay, so let's meet in the next video. Thank you very much. Yeah, welcome back. So we will continue our discussion on threshold detector. So now we are going to take a special case where our noise will be Gaussian. Okay. So it is nothing different. The way you are solving the problems, in the same way you will solve the questions. It's just that noise will be Gaussian this time. Sir, why we are dealing it in a separate manner? Because we can develop some formula here, and in the further cases, mostly our noise will be Gaussian only. So if mostly our noise will be Gaussian only, so we can develop some formula and we can use those formula directly. So two formula we are going to develop, those formula you need to remember, that's it. So noise will be Gaussian, x will be a symbol, so this will also be a Gaussian random variable only, right? So y will also be a Gaussian random variable. So there is no particular theory, it is just that applied input would be Gaussian this time. So let's solve a question, let's solve a problem. So what is given? You can solve it on your own. Just I am telling you one thing, that when you try to solve this B problem, then the calculation will be a bit complex. So you don't need to solve that particular calculation. Directly I have written down the answer of lambda optimum, that is 0.327. So the calculation will be a bit complex here. So if you are trying this question on your own, then when you come to section B, at that time if you feel like that calculation is going complex, at that time you need to stop. You will get the lambda optimum value. Okay, so let's read the question and let's try solving it now. So probabilities, line coder is transmitting +1 and -1. Probability of -1 being 3/4, +1 being 1/4. Channel output means input of the threshold, right? Input of the threshold detector is x plus n, -1 plus n, and +1 plus n. But noise are different. In case of -1, noise is Gaussian, having a mean of -0.5 and variance of 0.8. In case of +1, noise is again Gaussian, having a mean of 0.7 and a variance of 1.2. How the threshold detector is working? If y is greater than alpha, then +1. If y is less than alpha, then -1. If your alpha is 0.5, then find out the probability of error, and then in the next one, you need to consider map criteria. Based on the map criteria, you need to tell probability of error. All good, all fine. Very simple question. What I need to find? Let's take the first case. I need to find the probability of error. The probability of 0 transmission multiply with 1 received, 0 is transmitted, plus probability of 1 transmission multiply with 0 received, 1 transmitted, right? So 0 transmission probability 3/4, 1/4. But what is my matter of concern? My matter of concern would be probability of 1 received such that 0 is transmitted. So when will you receive 1? When your y is greater than 0.5, right? Alpha value is 0.5. When your y is greater than 0.5. But given condition that when 0 is transmitted. So what is your y when 0 is transmitted? So now my matter of concern will be to find out y such that 0 is transmitted. So when 0 is transmitted, you need to find out y. So when 0 is transmitted, symbol is -1. And what is the noise? Noise is this n1, okay, or I can call it n0. What is n0? N0 is what is n0? N0 is this n, okay. So n0 is normally distributed, having a mean of -0.5 and a variance of 0.8. So if this is Gaussian, then this will also be Gaussian. Now you know that what will be the answer of this one. In case of a Gaussian case, probability of x greater than a, q of a minus mu divided by sigma. So q of 0.5 minus mu of y, okay, what I am saying, mu of y such that 0 is transmitted, that is given by mu1. What that would be equivalent to? Here you take the expectation, that would be -1. Expectation of n naught, what is that? -0.5. What that would be? -1.5. So that I am putting as mu naught, not mu1, mu naught, divided by sigma, and sigma I am putting as sigma naught. So what will be your sigma? Sigma square such that 0 is transmitted. That means variance of input such that 0 is transmitted. What that would be? Variance of a constant value, 0. that would be equivalent to variance of n naught square. What that is equivalent to 0.8. So that would be 0.8. Okay, so this is variance square, that is 0.8. So what will be your variance equals to? So, and this I am calling equals to sigma naught, right? This I am calling equals to sigma naught square. So what will be your sigma naught value? Under root 0.8. Very simple thing. Basically, I need to comment on random variable y such that 0 is transmitted. So I am commenting on that. If you know this is having a mean of minus 0.5, then the total mean will become minus 1.5. If it is having a variance of 0.8, then minus 1 will have no variance. So y will also have 0.8 variance. So this will be under root 0.8. In the examination, you don't need to write down this step. Just by looking at the problem, you will be able to know that what will be the variance, what will be your mean, right? So answer would be, here I will put minus 1.5, so it will become positive. So 2 divided by under root 0.8. There you go. So this will be the probability of 1 receiving such that 0 is transmitted. Now probability of 0 received such that 1 is transmitted. So when you will receive 0? When y is less than 0.5, or here you can write down when 1 is transmitted. Okay. So next calculation I need to do here. This calculation you should be able to do on your own. So your random variable y such that 1 is transmitted would be equals to what? 1 plus n naught, right? Here I am not writing n naught, here I am writing n1. What is your n1? n1 is Gaussian random variable normally distributed with the mean of 0.7 and variance of 1.2. So here mu y such that 1 is transmitted, that would be equals to mu 1 plus 0.7, that would be equals to 1.7. And now variance of y such that 1 is transmitted. So 1 will have no variance, only the variance of n1 will be considered, that I will be putting as sigma n1 square, that would be equals to 1.2. Okay. So I remember the formula for this particular thing. When I need to write down the formula for this particular thing, what I need to do? 1 minus x greater than a, right? So 1 minus q, 0.5 minus mu 1. What is the value of mu 1? 1.7. Mu 1 value is 1.7, right? Divided by sigma 1, that would be under root 1.2. So what will be the answer you will be getting? Q of 1 minus q of minus x. What that would be equivalent to? Q of x. So here negative value you will be getting, negative value is 1.2. 0.5 minus 1.7, that would be minus 1.2, but there is 1 minus sign, so it would be plus 1.2, and 1.2 divided by under root 1.2, that would be under root 1.2. Is that clear to you or not? Every single thing is clear to you. So this value we have find out, and this value we have find out. Now I just need to find out the probability of error. So probability of error, probability of zero transmission is 3 by 4, 1 by 4. Okay, so answer would be 3 by 4 q of receiving 1 such that 0 is transmitted. So it would be 40. Can you write it down in a better manner? So it can be written as under root 4 by 0.8. So this can be written as under root 5. Do you agree to this point? Right? 20 divided by 40 divided by 8. Yeah, under root 5. That's 1 by 4 q of under root 1.2. This is the answer of first question. Very simple, very straightforward. The way we were solving all the problems, in the same manner we have solved this particular question. Sir, do we are we deriving any formula here? No, because here everything is different. So this is the worst case in the examination. This is the worst case the question can be coming. That with respect to one transmission, noise is different. With respect to zero transmission, noise is different. One transmission probability is different than zero transmission probability. So these probabilities are also not equal. This is also different. So this is the worst possible case that can be asked in the examination, which will require all the calculation. Okay, and now we are going to find out lambda optimum. So at that time as well, it will be the worst case. Okay, in the examination, most probably best case would come. So best case we will solve later on. If we are comfortable with the worst case, then surely we can solve the best case as well. That would be very simple. So first I am taking the worst case only. This is the worst case the question can be asked, because when you go to the lambda optimum, you will find out that calculation of lambda optimum will become very difficult. Although you can do the calculation, I have done it, right? So you can do the calculation, but it will take some time. It will take a lot of time. So in the examination, I don't think they will be asking this kind of calculation. Okay, so yeah, let's get started. We need to find out lambda optimum. You know what is the process of finding lambda optimum, right? What is the process? The process says probability of zero transmission multiply with the PDF of input such that zero is transmitted should be equals to probability of one transmission multiply with the PDF of input such that one is transmitted. I need to equate both of them, right? So this is 3 by 4, this is 1 by 4. Do I know the PDF of y such that 0 is transmitted? Do I need the PDF of y such that 1 is transmitted? Do I know the PDF? Surely I know the PDF, no? What is your y such that 0 is transmitted? So that is equals to minus 1 plus n naught. So n naught is a Gaussian random variable with this mean and this variance, minus 0.5 and 0.8. So what was the mean of y? Mean of y was minus 1.5 and what was the variance? 0.8. So basically your y when 0 is transmitted would become a Gaussian random variable only with mean of minus 1.5 and variance of 0.8, right? So can you write down PDF of y such that 0 is transmitted? That would be equals to 1 upon under root 2 pi sigma square 2 pi 0.8. So that would be 1.6 pi a to the power minus y minus of 1.5 upon 2 sigma square. Okay. For one transmission, 1 plus n naught, not n naught, and 1 I will write down. Normally distributed. What was the mean? Mean was 1.7 and variance was 1.2. So PDF of y such that 1 is transmitted. 1 upon under root 2 pi sigma square. So 2 into 1.2, that would be 2.4 pi a to the power minus y minus y minus mu. What is the value of mu? Mu value is 1.7 divided by 2 sigma square, that would be 2.4. So this is another calculation. Now what I need to do? I just need to multiply with the corresponding probabilities and equate them. So 3 by 4 will be multiplied with 1 by under root 1.6 pi e to the power minus y plus 1.5 whole square divided by 1.6 should be equated to 1 by 4 into 1 upon under root 2.4 pi e to the power minus y minus 1.7 whole square divided by 2.4. Again a very difficult calculation. You just need to equate both of them. From there you will get the value of y, because y is only the variable. That would be equals to lambda optimum, and that is coming out to be 0.327. Sir, this calculation how we will do in the examination? It will not come. This kind of rough calculation in the examination will not come. If it is coming, drop it. Okay, because very difficult, right? Like you will take the constant part aside, then you will take the log, and then you will have to solve this equation y plus 1.5 whole square divided by 1.6 plus y minus 1.7 whole square divided by 2.4. So 1.6, 2.4, again very difficult, although I have solved it, but yeah, still examination will not ask you this particular thing. So answer will come out to be 0.327 volt or whatever you want to call it. After that I need to add a page. So what I need to find now? Probability of error, but this will be the minimum probability of error, right? This will be your minimum probability of error. That would be equals to 0 transmission, 1 received, 0 transmitted, plus 1 transmission, 0 received, 1 transmitted. So 3 by 4, 1 by 4 we already know. Probability of 1 received such that 0 is transmitted, that would be equals to, when you will receive 1, given that 0 is transmitted, should be greater than 0.327. I am doing the calculation fast because it's been a lot of time. Like, you should be able to do all these calculation now. X greater than a, 0.327 minus mu n. What is the value of minus mu naught. What is the value of mu naught? That is 1.5 divided by sigma, right? What is the value of sigma? Under root 0.8. So similar calculation, whatever the calculation that you have done, 0.5 minus mu, that is 1.5. In place of 0.5, what I need to put? 0.327. That's it. Rest all the calculation is same. Okay. And what about this one? 0 received, 1 transmitted. When you will receive 0? When this is the condition. But given that 1 is transmitted. So what will be the answer? I am directly writing it down. I told you Px less than A. Although I remember the formula of Px greater than A, but if I am writing down the expression of Px less than A, what I can do? Mu minus A upon sigma. Because I know that it would happen 1 minus q, A minus mu divided by sigma. And I know that 1 minus q of x is equals to q of minus x. So just take the negative of this. So mu minus A upon sigma. So I am directly writing it down. What is the value of mu here? 1.7. Right? 1.7 minus A. What is the value of A? 0.327 divided by sigma under root 1.2. So these are the things we are getting. So answer would be minimum probability of error. That would be equals to, probability of 0 transmission is 3 by 4 q of, let's solve it. .04 plus 1 by 4 q of 1.25. There you go. This is your minimum probability of error. So worst case we have solved now. That here everything was different. Every single thing was different. Like nothing was equal. Even this probability was not equal. Even the noise was different for both of the cases. With respect to -1 transmission, different. With respect to +1 transmission, different. Okay. Let's solve this case. Again the same question is there. -1, 1 is transmitted. Probability of -1 transmission is P0 transmitted. Like this is the notation of probability of -1 transmission. This is the notation of +1 transmission. Basically -1 transmission means that you are transmitting bit 0 and +1 transmission means that you are transmitting bit 1. Okay. Noise is this time same. Noise PDF is this time same for both of them, having a mean of mu n and variance of sigma n square. Input of the threshold detector is x plus n. Now you know that what will be your y. Y will be of two kind, such that 0 is transmitted. That would be equals to -1 plus n, and your y would be such that 1 is transmitted. That would be 1 plus n. So what will be the expectation of y such that 0 is transmitted? That would be -1 plus, expectation of -1 will be -1 only, plus expectation of n, that would be mu n, and that would be equals to mu naught. And what will be the expectation here? 1 plus expectation of n, that is equals to mu1, and that is given as mu1. Okay, so we are given the expectation of y such that 0 is transmitted as mu naught, expectation of y such that 1 is transmitted as mu1. Okay, this is given. Next we can find out the variance as well. Here I am finding out variance. So variance of y such that 0 is transmitted, that would be equals to variance of n. So variance of n I am putting as sigma square only. Let's put it as sigma square. So variance of n is equals to sigma square, and variance of y such that 1 is transmitted, that would also be equals to, because 1 and minus 1 will not have any variance, they will have 0 variance. Sigma n square, that is equals to sigma square only. So these two things also we have find out, because we will be using it somewhere, right? Now what is our target? Our target is to find lambda optimum. So for finding lambda optimum and corresponding probability of error, that means this will be minimum probability of error only. This probability of error will be minimum only. So we will find out lambda optimum. So how will you find out lambda optimum? You know the process, right? What is the process? Should be multiply with PDF of y such that 0 is transmitted, 1 transmitted, multiply with the PDF of y such that 1 is transmitted. So this I will keep as it is, this I will keep as it is. For now, for writing down purpose only, I am calling this as P naught and I am calling this as P1. Okay, just for writing down purpose. Now can you write down the PDF of y such that 0 is transmitted? Can you write down the PDF of y such that 1 is transmitted? Surely you can write down, right? What will be your PDF of y such that 0 is transmitted? That would be 1 upon under root 2 pi. What is the PDF of, what is the variance of y such that 0 is transmitted? That is equals to sigma square e to the power minus y minus, what is the mean? Mean is mu naught divided by 2 sigma square. PDF of y such that 1 is transmitted, 1 upon under root 2 pi sigma square, because variance is sigma only, e to the power. Now you can see that calculation will be a bit easier, because sigma is same, no? Mean could be different, mu naught, mu1, mean is different, I don't care, but sigma should be the same. If sigma is same, then I am happy. Sigma of y such that 0 is transmitted, sigma of y such that 1 is transmitted, that I needed to be the same. If that is same, then you can see that this and this will get cancelled out, 2 sigma square, calculation would be a bit easier now, right? So for making the calculation easier only, this is what we are doing, and in 99% of the cases, you will always get the same sigma. For both of the noise, sigma would be the same. If variance is same, so y will also have the variance same, be it the condition of 0 transmission or 1 transmission. If that is the case, then our job is done. Probability of 0 transmission I am putting as 0, just for the derivation purpose. This is just a derivation only, this is nothing but derivation. Okay, I just framed the derivation as a problem. So I framed it as a question. Okay, nothing else, question or question, whatever it is. E to the power minus y minus mu naught whole square divided by 2 sigma square P1 1 upon under root 2 pi sigma square e to the power minus y minus mu1 whole square 2 sigma square. So this and this is getting cancelled out. This can go here. Okay, so better I will write down P1 by P naught. Well, let's write down P naught by P1 only. So let's keep it here. P naught by P1 would be equals to e to the power exponential power. So can I write it down in this manner? Exponential. Let's just say e to the power x is written, so it can be written as exponential of x. Okay, because a lot of terms would be there, no? So e to the power x can be written as exponential of x. So this is how I am writing down exponential. In the exponential, this term would go here. This is P naught by P1. This term would go downward. So upper side it would become positive. So y minus mu naught whole square upon 2 sigma square minus y minus mu1 whole square upon 2 sigma square. Okay. So this is your exponential a square plus b square minus 2 mu naught y minus y square plus just the negative sign is there, no? So a square plus b square 2 mu n by divided by 2 sigma square. P naught by P1. Okay, so what you are getting? Mu naught square minus mu 1 square minus 2y mu naught minus mu 1 is equals to, just a 1 second, yeah, just having some cough, that's why I had to pause it. So yeah, we were doing the derivation. So 2 sigma square goes here and this exponential goes as ln P naught by P1, right? So I am interested in finding out the value of y. So what I can do? So mu naught square minus mu 1 square can be written down as a square minus b square and then this particular part can come here, right? So that would be minus 2 sigma square ln P naught by P1 minus 2 sigma square ln P naught by P1 and here 2y mu naught minus mu 1. Okay, now I can see that I can divide mu naught by mu naught minus mu 1 in left hand side and right hand side. Basically I am taking this as downward. So what will happen? So mu naught plus mu 1 and I am taking 2 downward as well. 2 also goes downward. So mu naught plus mu 1 by 2 minus sigma square mu naught minus mu 1 ln P naught by P1. This is the value of y you are getting. So finally y is equals to lambda optimum only, no? So now I am writing down the formula of final lambda optimum. That will come out to be mu naught plus mu 1 by 2 plus sigma square mu 1 minus mu naught ln probability of 0 transmission divided by probability of 1 transmission. Okay. Look, expression you have to remember, there is no shortcut, but you will be getting confused in which part. Like you will remember it now, mu naught plus mu 1 divided by 2 plus sigma square upon mu 1 minus mu naught ln P naught by P1. You will remember it now, but later on when you start writing it down. So what you will do, sir, this part is very easy, I will be able to write down. Plus, sir, sigma square. Now you will be thinking that, sir, 2 will come or not? Sigma square divided by 2 will come or not? This would be there in your mind. I am pretty sure. Here you have divided by 2, so this will come, that sir 2 will come or not? It will not come. In any formula 2 will come only once, that's it. Mu naught plus mu 1 divided by 2, 2 will come only once. Now the doubt would be that, sir, first mu naught would come or first mu 1 would come? So anything you can write down. First let us say I am writing down mu 1. So mu 1 minus mu naught ln. Now here I will think whether P naught would come or P1 would come. So first here what you have written down? Mu 1. So first here P naught would come and then P1 would come. If I had written down opposite, let us say here I would have written mu naught mu 1. Now you are saying that, sir, formula is going wrong? No. What I would do? Sir, here first what I have written? Mu naught. So here P1 divided by P naught. That means probability of 1 transmission divided by 0 transmission. Basically if I invert this, then what will happen? One negative sign will come outward. If negative sign is coming outward, that can be compensated here. Mu naught minus mu 1. Are you able to understand this point? So whatever that you have written first, opposite would come here. And 2 will come only once. I am just telling where you will be having the doubt. I can just simply tell the formula and proceed. But I know that people will be forgetting the formula. So they will be easily able to write down that, sir, this is the arithmetic mean of the means. This is arithmetic mean of mean. Right? Mu naught is the mean, mu 1 is the mean. Mu naught plus mu 1 divided by 2. This you will surely remember. Then after that what will come? There you will be having the doubt. So plus sigma square. So divided by 2 will come or not? No, already 2 has come, it will not come. Now sir, mu1 will come first or mu0 will come first? Anything you can write down. Mu0 minus mu1 you can write down, mu1 minus mu0 you can write down. ln. Sir, first I have written 1 here, so here I will write down 0. If I had written 0 first here, here I will write down 1. That's it. So this is how you can remember the formula of lambda optimum. Now you need to find out probability of error. What I need to, and here what is mu0, what is mu1, so everything should be written. What is your mu0? Mu0 is the expectation of y such that 0 is transmitted. What is mu1? Expectation of y such that 1 is transmitted. And what is this sigma square? Sigma square was the variance of noise. Along with that it was the variance of y such that 0 is transmitted. Along with that it was the variance of y such that 1 is transmitted. Okay, so these things should be clear. So everything is related with y. Everything is related with the input. Nothing is related with the noise. Luckily here y transmission, sorry, 0 transmission, 1 transmission and noise variance are becoming equal. So if these are equal, then you can apply this formula. That's it. Here also sir, I could have applied this formula in this question. No, variance were different. Variance were 0.8 and 1.2. So here the matter of concern was variance only. If they were same, I could have applied this formula. Now probability of error you can find out on your own. There is no formula for probability of error. Basically, this expression we have find out. Now I need to find out probability of error. So 0 transmission, 1 received such that 0 is transmitted, plus 1 transmission, 0 received such that 1 is transmitted. So this probability I don't know, I will just put 0 transmission, 1 received such that y of 0 transmission greater than lambda optimum, right, plus 1 transmission, probability of y less than lambda optimum. Okay, so what will be the answer? Q of lambda optimum minus mean of y such that 0 is transmitted, that is mu0, divided by variance of y such that 0 is transmitted, that is equals to sigma. Here just opposite thing would come. First mean would come. Why mean is coming? Everything I have explained 2 to 3 times, right? Because it is lesser than sign. So first mean would come, then lambda optimum would come, and then divided by sigma. So are you going to mug up this formula? Absolutely not. I will first find out lambda optimum, and based on that I will write down this particular thing. Okay. So I am not going to mug up this formula that probability of error minimum would be equals to probability of 0 transmission, 1 transmission, nothing. No, nothing like that. So I am not going to remember this formula. Only formula that I am going to remember is this one. Now in the second case what they are saying, again the same thing I need to find out, but now 0 transmission and 1 transmission probabilities are equal. Okay, so now this will be an even better case that they are equal. So if they are equal, then what will be the value of lambda optimum? Can you let me know? If both of these are equal, then ln1 will be equal to 0. This part will go to 0. So anything multiplied with 0 will be 0 only. So lambda optimum will be coming out to be mu0 plus mu1 divided by 2. And what will be your minimum probability of error? So probability of 0 transmission, if both are equal, that means both will be equal to 1 by 2 only, no? Because 2 bits are being transmitted. So both will be equal to 1 by 2. So here what I will write down 1 by 2. What is your lambda optimum? Lambda optimum is mu0 plus mu1 divided by 2 minus mu0 divided by sigma plus 1 by 2 q of mu1 minus mu0 plus mu1 divided by 2 divided by sigma. So what you are getting? Mu1 minus mu0. Can you solve this one? Mu1 minus mu0 divided by mu naught by 2, mu 1 by 2 and minus mu naught by 2. So mu 1 minus mu naught by 2 sigma plus 1 by 2 q of, here again the same thing we are getting, because 2 mu minus mu naught minus mu 1. So mu 1 minus mu naught divided by 2 sigma. So what is the minimum probability of error you are getting? So probability of error minimum q of mu 1 minus mu naught upon 2 sigma. So this formula also I will remember. Okay, this is also very important. So only this formula I need to remember and this formula I need to remember, then my job is done. Lambda optimum is mu naught plus mu 1 divided by 2 plus sigma square mu 1 minus mu naught ln p naught by p1. Now I know that both probabilities will be equal. So lambda optimum will be simply the mean mu naught plus mu 1 divided by 2. Now if both probabilities are equal, then this formula is also there. Q of mu 1 minus mu naught divided by 2 sigma. Okay, mu 1 minus mu naught divided by 2 sigma. This formula is also there. What is mu 1? What is mu naught? Mu 1 is expectation of y such that 0 is transmitted. No, such that 1 is transmitted. Mu 2 is expectation of y such that 0 is transmitted, not mu 2, it is mu naught. And what is sigma or sigma square you say? So what is your sigma square? Sigma square will be variance of noise or variance of y such that 0 is transmitted, variance of y such that 1 is transmitted. And this formula is applicable only when probability of 0 transmission is equals to probability of 1 transmission is equals to 1 by 2. So always remember that I remember the formula of minimum probability of error, but that will come only for the case of p naught equals to p1 equals to 1 by 2. Along with that, variance should also be same. For the 0 transmission and for the 1 transmission, variance should also be the same. Most of the times this condition would be given only that 0 transmission and 1 transmission are equal. If both are not equal, then I will go here, I will find out lambda optimum and then I will do the mathematics, I will find out probability of minimum probability of error. But if both are not equal, then this is the scenario, and if both are equal, then this is the scenario. Lambda optimum very easily I can find out, and from there minimum probability of error also I can very easily find out. Q of mu 1 minus mu naught upon 2 sigma. All good? All fine? Okay. So what is the conclusion? Gaussian noise having same variance for both of the symbols is given. Y is equals to x plus 1. Sorry, y is equals to x plus n. So this is mu naught, this is mu 1, and variance of y such that 0 is transmitted, variance of y such that 1 is transmitted, and variance of noise are equal to sigma square. Then the value of lambda optimum and probability of 0 transmission and 1 transmission would also have been given. So value of lambda optimum would be mu 1 plus mu naught divided by 2 plus sigma square. Only one time 2 would come, so divided by 2 will not come. Mu 1 minus mu naught ln, first I have written mu 1 here, so here I will write down probability of 0 transmission divided by probability of 1 transmission. This is your lambda optimum. And if they are asking minimum probability of error, then you can find out minimum probability of error as well by the basic method. Okay, so this formula we are not mugging it up. By the basic method I can find out minimum probability of error as well. Now if probability of 0 transmission is equals to probability of 1 transmission, then what will be your lambda optimum? Lambda optimum will simply be mu 1 plus mu naught divided by 2. And what will be your minimum probability of error? That was coming out to be mu 1 minus mu naught. In whatever the formula that I remember, here 2 sigma would come. In whatever the formula that I remember, 2 would surely come, but 2 will come only one time. One time here it is coming, one time here it is coming. There you go. Now after a long time, this formula also will become confusing to you. Probability of x greater than a. So you will say, sir, a minus mu, this much I remember, divided by 2 sigma, sir, or sigma? Because here again and again you will say mu 1 minus mu naught divided by 2 sigma. But here sigma would not come. Array, Q. Sir, I will say A minus mu, that I remember. But downwards, sir, 2 sigma comes or sigma comes. This will happen in a longer run. I am telling you that people tend to forget the formula, no? So you will also forget the formula. You are not different. So every problem would be with this 2 sign. So I am saying that in every formula 2 is coming only once. Lambda optimum, P probability of error minimum. 2 is coming one time. One time here, one time here. But this formula we already know from the random variable random process. So there 2 will not come. So A minus mu upon sigma. So 2 is not coming. So confusion will be with these formulas, so that I am already writing down. So this formula should be there in your mind. This formula should be there in your mind, and this formula should also be there in your mind. All good? All fine? Absolutely clear everything? Okay. Solve this question now. Very simple question, just based on simple formula, nothing else. Sir, here noise are different. Noise could be different, but my matter of concern would be the mean should be same. Sigma square, sigma square. Yes, mean is same. So if mean is same, my job is done. What they are saying? Here, probability of zero transmission and probability of one transmission are different. Map criteria you need to use. Find out the lambda optimum and minimum probability of error. So I will apply the formula here because we have developed the formula. What the formula says? Mu1 plus mu naught divided by 2 plus sigma square divided by mu1 minus mu naught ln of 0 transmission, 1 transmission. There you go. 0 transmission 0.75, 0.25. Okay. Now what this is given? This is the distribution of y such that 0 is transmitted. So this is not the distribution of noise. No. This is the distribution of y. Okay. So like read the question carefully. Distribution of y. So this mu naught value is mean of y such that 0 is transmitted. That is equals to 0. And this is your mean of y such that 1 is transmitted. That is equals to 2. So this is your mu naught and this is your mu1. Okay, so distribution of y is given, distribution of noise is not given, distribution of y is given. So these symbols are of no use. 0, 1 are of no use because distribution of y is already given. So mu naught, mu1 value is given, sigma square value is 1 only. So now you can apply the formula and get the answer. 2 plus 0 divided by 2. Zero transmission probability is 0.75, 0.25. 1 plus ln 3 by 2. .55. That's your lambda optimum. Okay, this is our lambda optimum that we are getting, and now I need to find the minimum probability of error. Probability of 0 transmission multiply with 1 received such that 0 is transmitted plus probability of 1 transmission multiply with 0 received such that 1 is transmitted. Okay, 0 transmission probability is 3 by 4. 1 received. When you will receive 1? When y is greater than, when you will receive 1? When y is greater than 1.55. So 1.55 minus mu of 0 transmission minus mu naught. What is the value of mu naught? Mu naught value is 0. Divided by sigma square, that would divided by sigma, that would be 1. I hope you know how did I do this. Simply this particular scenario I am putting. Lambda optimum minus mu naught divided by sigma. So lambda optimum minus mu naught divided by sigma plus 1 by 4 q of mu1. What is the value of mu1? 2 minus lambda optimum divided by sigma. Q of 0.45, probability of error minimum. This answer we are getting. Okay, so this was the answer of first question. Second is even easier. Why second is even easier? Because in the second, P naught equals to P1 equals to 0.5 you need to take, map criteria you need to take, lambda optimum you need to find, and probability of error you need to find. So you know that, sir, formula will be mu1 plus mu naught divided by 2. So mu1 plus mu naught divided by 2. So 2 divided by 2, lambda optimum will be 1, and your probability of error minimum for that would be mu1 minus mu naught divided by, sir, once 2 would come. So mu1 minus mu naught divided by 2 sigma, mu1 minus mu naught divided by 2 sigma. So what is the value of mu1? 2 minus 0 divided by 2 sigma. Sigma value is 1 only, no? Because sigma square is 1, so sigma value is 1 only. So divided by 2, so answer would be Q of 1. Okay, so this is the answer of second question. So this is also done. So first one was this one. What I feel is that this kind of question is probably coming in your examination. Okay, this kind of problem is coming. This kind of problem will not come. Which kind of problem? This kind of problem. The way we solved here. Like here everything is different, no? Everything is different. So everything different they will not make. They will make the easier cases. They can test that whether you remember the formula or not. If you don't remember the formula, then they expect you to derive it. But we are not going to derive it. We are just simply going to remember it. I don't think they will give this case because this will be very easy. Because everyone can remember mu1 plus mu0 divided by 2. So I don't think they will be giving this case. What I feel is that they will be giving this case. Because people blindly take probability of 0 transmission is equals to probability of 1 transmission. Blindly people take these two conditions. But you are not going to take it blindly. You will see the problem. If they are given different, then lambda optimum will be find out by this formula, and then I have to do the analysis. I will do the analysis. I will get this answer. And if both of them are given equal, then I remember the formula lambda optimum and probability of error minimum, that would be equals to Q of mu1 minus mu0 divided by 2 sigma. Okay. This is a gate PYQ only. You should solve it on your own. Solve it on your own. Very easy question. There is nothing difficult here. Very easy question. So you can see input, consider discrete time channel y equals to x plus z. That means this is the output of the channel or input of your threshold detector. Z is signal dependent noise. Okay. There are two kind of symbols, plus a, minus a, and noise sample Z is chosen independently from Gaussian distribution with mean, beta x and unit variance. What do you understand? That noise is based on your sample, right? Based on your symbol. So if minus a symbol is coming, if minus a symbol is coming, if your x equals to minus a, if your x is equals to minus a, then your noise will be Gaussian only. Noise will surely be Gaussian, but mean would be minus beta I and variance is unity. And if your symbol is plus a, then what about the noise? So noise will be having Gaussian nature with the mean of plus beta I, right? Beta plus a. So plus beta I and variance is 1. So can you find out the mean of y such that 0 is transmitted? Surely I can find out. That would be equal to the mean of x plus mean of z. Z I can surely see from here. And can you find out the variance of y such that 0 is transmitted? Yes. Variance of x, that would be 0. Variance of z, that would be 1. So variance of y such that 0 is transmitted. Basically from here I can tell you one thing. Variance of y such that 0 is transmitted would be equal to variance of y such that 1 is transmitted. Why both of them would be equal? Because, sir, for both of the noise mean might be different, but variance is 1 only. So in all the cases, everywhere variance is 1 only, nothing else. Variance is simply 1. What about the mean of y? Mean of y such that 0 is transmitted. That would be equal to mean of x. What is the mean of x? Minus a. And mean of z, what is that? Minus beta I. So mean would be minus beta plus 1 into a. That is equal to mu naught. So mean of y such that 1 is transmitted, a plus beta I beta plus 1 A is equals to mu1. Okay, this is the thing. So you know the value of mu0, you know the value of mu1, you know the value of sigma square. Probability of 0 transmission is equals to probability of 1 transmission. Is it given? No, it is not given. Okay, probability of 0 transmission is not equals to probability of 1 transmission. Nowhere it is given. Assume threshold detector with 0 threshold. So lambda value is given. Okay, threshold value is given, that is 0. So lambda value is already given. What you need to find out? You need to find out bit error rate. Bit error rate means probability of error only. Okay, probability of error. Bit error rate means probability of error. Okay, bit error rate is nothing but probability of error only. So we need to find out probability of error such that lambda is equals to 0. We need to find out probability of error such that lambda is equals to 0. So our threshold is 0. Basically, we are having threshold detector. Applied input is there, output would also be there, and threshold is there at 0. Lambda is equals to 0. So what I need to find out? I need to find out probability of error. So probability of error would be equals to probability of 0 transmission multiply with 1 received such that 0 is transmitted plus probability of 1 transmission 0 received such that 1 is transmitted, right? So all these things, this thing and this thing is not given, so I have to just keep it as, let's just say I will call this as P0 and this as P1. Again let me check if it is given or not. Unit variance, no, it is not given, so I will have to keep it as it is. The way it is, I will have to keep it as it is. Now my matter of concern would be to find out probability of 1 received such that 0 is transmitted. So when you will receive 1? When you will receive 1? When y is greater than 0, right? Because threshold is set at 0 only. Given condition is 0 transmission. So P0 Q of 0 minus mu 0. What is the value of mu 0? What is the value of mu 0? That is beta plus 1 A. So beta plus 1 A divided by sigma. What is the value of sigma? Sigma is 1. Okay, very simple thing. Q of 0 minus mu 0 divided by sigma 0. The sigma 0 value is 1 only. Mu 0 value we already know, that is minus beta plus 1 into A plus probability of 1 transmission multiply with Q of, so what I need to find? 0 received such that 1 is transmitted. So when you will receive 0? Given condition is 1 transmitted when it is less than 0. So Q of less than 0 it is. So mu1 minus 0 divided by sigma 0. So mu1 minus 0. What is the value of mu1? Beta plus 1 into A divided by sigma. Okay. Now what they are saying, when beta is equals to 0, the probability of error was found out to be Q of A, that is equals to 10 to the power minus 8. So this is your probability of error, that is coming out to be in function of beta. So now what I'm gonna do is that I will put beta equals to 0. For beta equals to 0, probability of error is coming out to be P0 Q of A plus P1 Q of A, right? But they are saying that it is equals to Q of A. What does that mean? They are saying that it is equals to Q of A, right? So again you cannot comment, like someone can say that sir P1 is 3 by 4, someone can say that sir P0 is 1 by 4, or can say that both are 1 by 2. So you cannot comment actually, right? So forget about it. They have just given the value of Q of A, that is 10 to the power minus 8. They have given the value of Q of A, that is 10 to the power minus 8 plus P1 into 10 to the power minus 8. And I know that if I take 10 to the power minus 8 common, I will get my answer as 10 to the power minus 8 only. Okay, so this is my probability of error when beta is equals to 0. But next case, what you need to find out? I actually need to find out probability of error when beta is equals to minus 0.3. For beta equals to minus 0.3. Minus 0.3. I need to find out the probability of error. That would be 0 transmission. Here if I put minus 0.3, what I will get? 1 minus 0.3, that would be 0.7. Plus, here I will put minus 0.3, what I will get? 0.7 only. Now I can say that if I take Q of 0.7 common, then P0 plus P1 would be 1 only. What I am saying? Q of 0.7 I am taking common, P0 plus P1. I know that P0 plus P1, probability of 0 transmission plus probability of 1 transmission would be equals to 1 only. So my answer is coming out to be Q of 0.7. So basically my probability of error for the case of beta equals to minus 0.3 is coming out to be Q of 0.7, right? That is the answer I am getting. Now they have given that you can take Q of x is approximately equals to e to the power minus x square by 2. So can I take this as approximately equals to e to the power whatever that is written inside square of that divided by 2. So e to the power minus 0.49 a square divided by 2, right? Now what was your Q of A? Q of A was given that Q of A was 10 to the power minus 8. It was given that Q of A was 10 to the power minus 8. That means e to the power minus a square by 2 was 10 to the power minus 8. Say yes or no? Because Q of A could also be written as e to the power minus a square by 2. E to the power minus a square by 2. That is equals to 10 to the power minus 8. So can I say a to the power minus a square by 2 into 0.49? A to the power minus a square by 2 in the power only into 0.49. So 10 to the power minus 8, 0.49. That would be approximately equals to half. So answer would be 10 to the power minus 4. So the probability of error when beta is equals to minus 0.3 is coming out to be 10 to the power minus 4. This was the answer. Okay. So this is the answer. Very simple question it was. Very, very straightforward. Here I did not need to apply the value of lambda optimum because lambda was given, that was 0 only. So lambda is given, I can find out probability of error. This is my probability of error was coming out to be, which was actually here only I could have taken P naught into Q of beta plus 1 into A plus P1 into Q of beta plus 1 into A divided by sigma. Sigma value is 1 only. So here as well I could have taken P0 and P1 common, right? P0 and P1. So P0, P1 would have gone. Basically I could have taken this common. So what I would have got? Q of beta plus 1 into A multiply with P0 plus P1. So P0 plus P1 would be equals to 1 only. So from here you would see that my probability of error is coming out to be Q of beta plus 1 into A. So this is your probability of error that is coming out to be. So you can put the value of beta equals to 0 and put the value of beta equals to minus 0.3. You could solve this problem and you would get this answer, that is 10 to the power minus 4. Well and good. Very simple question it was. Okay, so everything is done. Now what we will do? We will take the case of a 3 symbol transmission. As of now only 2 symbols were being transmitted, minus a plus a. Okay. Here also 0, 1. So whatever the example that we have seen in this lecture or in the previous lecture, only 2 symbols were transmitted. Now what if 3 symbols are transmitted? Then what will happen? So that case we are going to take in the next lecture. So we are going to take the case of 3 symbols transmission. So till this point we were saying probability of bit error, right? Probability of a bit error. In the next lecture we will say probability of symbol error. Okay. So what is the relation between probability of symbol error? What is the relation from symbol error to bit error? Everything we are going to see. In this lecture only I will add up that part, but I need to change the slides because it's been 45 slides here. So I will change the slide and then I will come back. We will study about probability of symbol error. We will simply solve the question. Okay. There is no theory. Problem solving will be there. Okay. So yeah, let's meet. Yeah, welcome back. So continuing our discussion on a decision threshold, right? So this time you can see in this particular problem, 3 kind of symbols are transmitted, minus 4, 0 and 4. Previously only 2 kind of symbols were being transmitted, -1, +1, -5, +5, 0, 1, whatever it is. But now you can see there are three kind of symbols. So first we will find out probability of symbol error. So till this point in the examination, this is 2025. So till gate 2025, whenever the question of symbol error has come, they always asked about probability of symbol error. But what I feel is that in the coming year, they will introduce three symbols like here -4, 0, 4, and they will ask you probability of bit error. So bit and symbol both are different things. So this is surely coming in 2026 or 2027. Just mark it up. Okay, either in 2026 or in 2027. They will ask you the same question, but this time they will do the changes. They will ask you probability of bit error, not the probability of symbol error. Surely it is coming. So this is a follow-up question, that is surely it is going to come in 2026 or 2027. Find out the probability of bit error. But as of now, our target would be to find out the symbol error. So what is the scenario here? Ditto same scenario is there. Same scenario is there. What is the same scenario? There is a threshold detector. There will be an input. There will be threshold value, and then there will be output. What is the input? Input is R equals to S plus W. R equals to S plus W. Then there will be threshold voltage, right? And then there will be some output. Now how the output will be decided and how your threshold will be behaving, nothing is given. What does that mean? It would be working on map criteria, and here they have written optimum symbol error. What is the meaning of optimum symbol error? Optimum means you are working on map criteria only, map or ML. Optimum means map only. Okay, and they have said that equal probability are there. So if equal probability is given, then map could be replaced by ML. Okay, maximum likelihood symbol error they are asking. So you know that there are three kind of symbol. I am saying that symbol S1 is -4, symbol S2 is 0, and symbol S3 is 4. Okay, these kind of three symbols are there. And map criteria I am saying, so ML criteria I am saying, and also it is written that equal probability. So probability of transmitting S1, probability of transmitting S2, and probability of transmitting S3 will be equal, and that would be equals to 1 by 3. Okay, noise is given. So W is our noise, which is 0 mean and variance 4. So what about the noise? Noise is normally distributed with 0 mean and variance 4. You need to find out probability of symbol error. So what do you think, what should be the formula of probability of symbol error? So I am writing down probability of symbol error. So PS I am representing by probability of symbol error. What do you think, what could be probability of symbol error? That you have transmitted symbol S1, but upon transmitting symbol S1, I should better write down that I have transmitted symbol S1, but upon transmitting symbol S1, S2 is received, or upon transmitting S1, S3 is received. Two condition could be there, no? That I have transmitted symbol S1, upon transmitting symbol S1, S2 is received, or upon transmitting symbol S1, S3 is received. Or what could be the case? That you have transmitted symbol S2, on transmitting symbol S2, S1 is received, or on transmitting symbol S2, S3 is received. This could be the this could be the case. Or you are transmitting symbol S3, upon transmitting symbol S3, S1 is received, or upon transmitting symbol S3, S2 is received. These could be the total criteria. So this will be your probability of symbol error. Is that okay for you or not? Very simple thing. Transmitted S1, receiving S2 or S3. Transmitted S2, receiving S1 or S3. Transmitting S3, receiving S1 or S2. Is that okay for you? Right? Now what could be your input? Input could also be of three kind, right? Input is R. So input such that S1 is transmitted. Input such that S1 is transmitted. What that would be? -4 plus W. Input such that S2 is transmitted. 0 plus W. And input such that S3 is transmitted. 4 plus W. -4 plus W, 0 plus W, 4 plus W. Is that clear to you? Now this thing I already know. I just need to find out these things. But first I need to find out lambda optimum, right? So what I will do? What about this one? If this is Gaussian, then this will also be Gaussian. This will also be Gaussian. And this will also be Gaussian. Now can you draw the PDF of input? Can you draw the PDF of input such that S1 is transmitted, PDF of input such that S2 is transmitted, PDF of input such that S3 is transmitted? Can you draw their PDF? Yes, because you know about W. W is Gaussian having 0 mean and variance 4. So what about input such that S1 is transmitted? So this will also be Gaussian having mean of -4 and variance of 4, because variance will not change. That is clear to you, right? We have seen a lot of questions. The previous video also you have watched. So mean of -4, because here the mean is -4, here the mean is 0. So mean of -4, variance of 4. Mean of 0, variance of 4. Mean of +4, variance of 4. Is that clear to you or not? So what I am drawing, I am drawing PDF of input. PDF of input I am drawing. Okay, such that S1 is transmitted or S2 is transmitted or S3 is transmitted. So first I am drawing PDF of input such that S1 is transmitted. So what that would be? Sir, mean is -4 and variance is 4. How mean is -4? It is clear to you, right? For this particular case, if I need to find out the mean of input such that S1 is transmitted, that would be mean of -4 plus mean of W, that would be 0. And what about the variance? Variance here would be 0 and here variance would be 4. So variance would be 4. So mean is -4 and variance would be 4. So mean would be -4 and variance would be 4. So this kind of graph you will be getting. Let's use a different color of pen. So Gaussian graph you know how to make. Well and good. Okay. Whatever the amplitude is there, as of now I am not caring about this amplitude. As of now I am not caring about this amplitude, but you can care about this amplitude as well. Not a big issue. The amplitude will be 1 upon under root 2 pi sigma x square. 1 upon, what will be the amplitude? 1 upon under root 2 pi sigma. Sigma value is 4. So 1 upon under root 8 pi. So that will be the amplitude, right? So amplitude will be 1 upon under root 8 pi. But as of now, let's not care about the amplitude. Then for the next one, mean will be 0, variance is 4. Mean will be 0. So peak value will be occurring here. Mean will be 0. So peak value will be occurring here. Mean value will be 0. Next one, mean value will be 4 and variance is also 4. So peak value will be occurring here. Is that okay for you or not? Now where the graphs are cutting? One point here, another point here. So graphs are cutting at these points. How the map criteria will be set up? Till this point the result will be given in which favor? So basically what I have drawn, I have drawn the PDF of input such that S1 is transmitted. This was for S1. Blue color was for S1. Now I don't even know the colors. So this was for S1, this was for S2, and this was for S3. So I have drawn the PDF of input such that S1, S2 and S3 is being transmitted. Now how the map criteria will be set up, that you will see where the graphs are cutting. So now you will see this graph is higher. That means the result will be made in favor of S1. Now where the graph would cut, we will talk about it. Now from here to here, which graph is higher? This graph is higher. So in this particular region, the result will be made in the favor of S2. And in this particular region, the result will be made in the favor of S3. So you have understood how the map criteria would be working. That is also clear to you, right? Now can you find out this point where two graphs are cutting? Yes. And secondly, when I am applying the map criteria, my matter of concern should be that I should multiply with the probability as well. But here luckily probability were same. All the probabilities are 1 by 3, 1 by 3, 1 by 3. So there is no change in the amplitude. So luckily probability is same. But I should have considered multiplying the probability as well. Can you just let me know what will be this point and what will be this point? This will be the middle point, minus 4 plus 0 divided by 2. This will be minus 2 only. Why is that so? Why it will be minus 2? Because do you remember the formula of lambda optimum? Or even if you don't remember the formula, what do you know? That sir, I need to find out the points where both of them are cutting. So what I will do? Sir, 1 upon under root 2 pi sigma x square. Both of them are having the same sigma. E to the power minus y minus, what is the mean value? 4 upon 2 sigma x square would be equals to 1 upon under root 2 pi sigma square e to the power minus y, what is the mean value? 0 upon 2 sigma square. So this and this will get cancelled out. You will do the calculation, you will get to know that actually y is coming out to be 2 or minus 2, sorry. And you can check here as well. If I put minus 2 here, what I will get? Minus 2 plus 4, that would be 2 square that would be 4 only. Here also minus 2 square would be 4 only. So y is actually coming out to be minus 2 only. That means this is the optimum value of lambda. And how it is coming? How did I directly say that it will be minus 2? Because I know the formula of lambda optimum, no? That is mu1 plus mu0 divided by 2 plus something would come, and ln probability of 0 transmission, 1 transmission. So when I consider only two graphs, then I know that both of these probabilities are same. So where they will be cutting? At mu1 plus mu0 divided by 2 only. So minus 4 plus 0 divided by 2, that would be minus 2. And what will be this point? This will also be a middle point. Because probabilities are same. 1 by 3, 1 by 3, 1 by 3. If the probabilities are same, then they will be cutting right at the middle point only. At the middle point only, no? Is that understandable for you? Say yes or no. Right? That is surely understandable. Okay? Now, how will you write down the probability of error? Probability of a symbol error. So you will move on the graph. I am moving on the graph of S1. Till this point there is no trouble. But just as I move here, I get starting the trouble. I am getting the trouble now. Because I am moving on the graph of S1, but the result is made in the favor of S2. That means this is the matter of concern. So matter of concern is there from probability such that value of y is greater than minus 2. Basically, first I will write down that how the output will be behaving. So how the output will behave. This is the output, okay. So output, you know that how output will be taking place. That it will be giving result in the favor of S1 when your input is between minus infinity to minus 2. Input is represented by R, not Y. So input is represented by R. So when input is there between minus infinity to minus 2, then the favor will be made in terms of S1. When input is there between minus 2 to 2, the decision will be made in favor of S2. And when input is there between 2 to infinity, the decision will be made in favor of S3. What I need to find? I need to find out probability of symbol error. That would be probability of transmitting S1 multiply with S1 transmitted receiving S2 or S3. Or I should write down not receiving S1. Is that okay for you? Can I write it down in this manner? Probability of S1 transmission multiply with S1 is transmitted and received symbol is not S1. That will be the probability of error. S2 is transmitted, S2 being transmitted but the received symbol is not S2 received, plus S3 is transmitted, upon transmitting S3 received symbol is not S3. So in short form, can I write it down in this manner? Surely I can write down in this manner. So my target is to find out this particular thing. What this is saying, that you are transmitting S1 but you are not receiving S1. S1 is not received. This is what I need to find. So when you will not receive S1, when your input R is greater than -2, say yes or no. When your input R is greater than -2, at that time you will not receive S1, right? When input is there between -infinity to -2, you are receiving S1. But if R is greater than -2, you are receiving S2 or S3. But given the condition that S1 is transmitted. So you need to find out the probability such that R is greater than -2. So do you know the answer? Answer would be -2 minus mean is -4 divided by sigma. What is the value of sigma? Unit variance is given. No, variance is 4. So sigma value will be here. Sigma square is given as 4. So sigma value will be 2. So sigma value will be 2. So what is the answer you are getting? Q of 1. Is that okay for you or not? Did you understand this scenario or not? Probability of S1 transmitted and not receiving S1. That means R should be greater than -2. So this is the scenario, or directly by the graph also you could have done. We are working on map criteria. If we are working on map criteria, I know that I can do the calculation by using the graph only. I will move on the graph. I am moving on the graph. Here will be the matter of concern. I am moving on the graph. I know that I am moving on the graph of S2, but result is given in the favor of S1. That means this will be the matter of concern. Now I am moving on the graph of S2. Result is also made on the favor of S2. No matter of concern. Now I am moving on the graph of S2. And I am moving on the graph of S2 and result is made in favor of S3. That means this will be the matter of concern. And what about S3 now? Moving on the graph of S3, result is also made on the favor of S3 only, no matter of concern. But moving on the graph of S3, but result is made in the favor of S2, matter of concern. So in S1, actually, in S1 this was the matter of concern. In S2 this and this was the matter of concern, and in S3 this was the matter of concern. So same area is being multiplied with 4 times. So what you will see, whatever this answer is, whatever the answer you are getting, that will be multiplied with 4 times. And also you need to multiply with corresponding probabilities as well, and probabilities are 1 by 3, 1 by 3, 1 by 3. So answer would be 4 by 3 Q of 1. So directly I would have clicked on option B. But again, we are in the learning phase. Did you understand? Like whatever this area is there, the same area will be this one only, no? And the same area will be this one only. And the same area will be this one only. We will find it out. It will come out to be same area. Let's check. Next, what I need to find out? Probability of not receiving S2 such that S2 is transmitted. When you will not receive S2? When you will not receive S2? When your R is less than -2 or when your R is greater than 2. Is that clear to you? R is less than -2 or R is greater than 2. R is less than -2. What that would be? What is the R such that S2 is transmitted, right? Given condition is S2 transmitted. So R less than -2, I don't remember the formula for this one, right? I remember the formula for which case? For probability of X greater than A. That is Q of A minus mu upon sigma. So if I need to write down X less than A, that would be Q of mu minus A upon sigma. So what is the mean? Such that S2 is transmitted. S2 is transmitted, mean is 0. Mean is 0. Yeah, for this one mean is 0. Here the mean was 4. So mean is 0. So 0 minus of -2 divided by sigma, that is 2. plus q of greater than formula I already know. So 2 minus what is mean? Mean is 0. What is the value of sigma? That is 2. So what you are getting? q1 plus q1, that would be 2 of q1. Now probability of not receiving S3 such that S3 is transmitted. So when you will not receive S3? When R is less than 2, right? But given the condition that S3 is transmitted, R is less than 2. So I don't remember the formula for lesser one, but I remember the formula for the greater one. So first I will write down the mean. What is the mean in case of S3 transmission? Mean is 4. 4 minus 2 divided by 2. That would be Q of 1. So here you are getting 2Q of 1, here you are getting Q of 1, and here you are getting Q of 1. And you know that PS1, PS1, PS2 and PS3 are 1 by 3, 1 by 3, 1 by 3. So what you are getting? Probability of symbol error is coming out to be 1 by 3 into Q of 1 plus 1 by 3 into 2Q of 1 plus 1 by 3 into Q of 1. So answer would be 4 by 3 into Q of 1. That was the answer. This is the probability of symbol error. So answer of this question was, this was asked in GATE 2024 examination. Answer was 4 by 3 Q of 1. But again, it will not take you this much of time in the examination hall. You will directly see map criteria is there, and here 0 mean variance 4. You will be directly making this graph. Then you will see that okay, there is a symmetry. This point will be -2, this point will be 2. Then you would know that where would be the error, this area would be the error, this area would be the error, this area would be the error, and this area would be the error. Same area is being multiplied by 4 times. So 4 into whatever the area you get. So this area you would know that I am getting Q of 1. So 4 into Q of 1, but each probability is 1 by 3, 1 by 3, 1 by 3. So answer would be 4 by 3 Q of 1. Although here I am writing down every single step, I am explaining every single step, that's why it is taking more time. In the examination, it will not take much of the time. Is that clear to you or not? Well and good. Now next I am asking probability of bit error. Probability of bit error. So let's write down the topic first. That what is the topic? Topic is relationship between probability of symbol error. Surely it is coming. It is coming in your GATE 2026 examination or 2027 examination for sure. Because this is the next thing that they are going to ask. Probability of symbol error versus symbol error and bit error. So what I am doing, I am representing probability of symbol error by PS. Probability of symbol error is nothing but PS, and I am representing probability of bit error as PB. Okay. Now let's just understand that there are 2 bits. There are 2 bits. That means if I am transmitting 3 symbols or you are transmitting 4 symbols, then how many bits will be required? 2 bits will be required, right? 2 bits will be required. Now when you can get error in the symbol, like one symbol will be of 2 bits. Let's just say that symbol is 0 0. Basically this is my threshold detector and my transmitted symbol was 0 0. Now my received symbol is 0 1. Will you say that your symbol is corrupted? What I am saying, let me make a clearer diagram, that this was my threshold detector. At the input of the threshold detector, what do you get? At the input of the threshold detector, transmitted symbol you are getting, because I am assuming that from the channel nothing is being corrupted, from the mesh filter as well there is nothing being corrupted. So at the input of the threshold detector, what you are getting? You are getting symbol 0 0. Now at the output of the threshold detector, if you get 0 1, that means first bit you are receiving correctly, but second bit is corrupted. Then also you will say that symbol is corrupted. If you receive 1 0, that means second bit is correct, but first bit is corrupted. That means in the first bit you are having the error. When I am saying bit is corrupted, that means you are having the error. So second bit is correct, but first bit is corrupted. Still you will say I am having the error in the symbol, or it might happen that both of the bits are corrupted. First bit is corrupted, second bit fine, second bit is corrupted, first bit is fine, or both of the bits are corrupted. In all these cases you will say that symbol error is there. So how you can write down your probability of symbol error? So probability of symbol error, I am writing down for 2 bits. For 2 bits. If a number of bits we are using 2. Okay. So for 2 bits your probability of symbol error would be given by, if first bit is corrupted, that means error is there in the first bit, but second bit is not corrupted, or first bit is not corrupted, but second bit is corrupted, or both of the bits are corrupted. So this will be your probability of symbol error, and these are your probability of bit error. So you can solve it. What you will be getting? 2 PB. This would be PB, PB minus PB square minus PB square, PB square minus PB square. So your probability of a symbol error is related with probability of bit error in this manner. Or let's write it down in the next page. So I will have to add a page. A very important discussion. I hope you have understood. So probability of symbol error would be 2 PB minus PB square. Okay. This is the relation, but for 2 bits only. Now for 2 bit only, let's write down another way of writing down the probability of symbol error. Method 2. For 2 bits only, I need to write down probability of symbol error. So what I am saying, my first bit is not corrupted and second bit is also not corrupted. That means my first bit is also 0 and second bit is also 0. This is I am talking about received signal. In the received signal, my first bit is also not corrupted, second bit is also not corrupted. That means there is no error. And if I subtract this probability from 1, what you will get? You will get the probability of symbol error. What I am doing, 0 0 is being transmitted. I am saying that 0 0 is being received. That means probability of symbol error is 0. Right? So what I am saying, first bit is not corrupted and second bit is not corrupted. So you are saying that symbol is not corrupted. Symbol is not corrupted, but you need to find out the probability of symbol error. But that means you need to find out this particular thing. So what you need to do? You have to subtract by 1. Is that okay for you? Very simple probability concept. Right? Probability of committing a mistake is 0.4. So what is the probability such that you are not committing a mistake? That would be 1 minus 0.4. So probability of bit not being corrupted, probability of both of the bits not being corrupted. What is this? Probability of both of the bits not being corrupted. And that is subtracted from 1. What you are getting? Probability of a symbol error you will get. I hope that is clear to you. Okay. A lot of times I am explaining the same thing. If both of the bits are not corrupted and you are subtracting it from 1, that means you are finding out the probability of symbol error. That means you are finding out the condition where first bit is fine but second bit is corrupted, or first bit is corrupted, second bit is fine, or both of the bits are corrupted. So that you are finding out. So what you are getting? PS is equals to 1 minus 1 by PB to the power 2. If you solve it, you will get the same answer. 1 minus 1 plus PB square minus 2 PB. So when you solve it, you are getting 2 PB minus PB square, 2 PB minus PB square. Can you generalize for capital N bits? Or can I say for M array scheme where m is equals to 2 to the power n, what will be your probability of symbol error? Probability of symbol error would be 1 minus pb to the power capital N. Why capital N? Because let's just say I am using 3 bit. This is going to my threshold detector. At the output I want these 3 bit only. So that means first bit is not corrupted, second bit is not corrupted, and third bit is not corrupted. First bit is not corrupted, second bit not corrupted, and third bit not corrupted. Then symbol will not be corrupted. But you need to find out the probability of symbol error. That means you have to subtract by 1. So 1 minus pb to the power n would be the probability of symbol error. This you have to remember. Okay, so in this question, although we are getting the answer in terms of q function, then probability of bit error will come out to be a bit strange, right? Like answer will be in the terms of a q function only. Basically what I will do, probability of symbol error is 4 by 3 q of 1. That would be 2 pb. Let's put it as x minus x square. So I need to solve this quadratic equation. So answer will come in terms of q function. So that you can do. I am not solving this particular problem, but my task was to explain you what is the meaning of probability of symbol error and probability of bit error. Because what people usually think is that, let's just say probability of symbol error you are getting as 0.3. So they will say that probability of bit error will be 0.3 divided by 2. Why divided by 2? Because this symbol is having 2 bits, no? So if you need to find out the bit error, then simply divide by 2. Absolutely wrong concept, right? Doesn't make any sense. When I was a student, I used to think in this manner. So you will not find any notes where this particular topic is discussed, and it is surely coming in your examination. Probability of symbol error, they will give, you need to find out the probability of bit error. So all the bits are not corrupted, minus 1. Sorry, all the bits are not corrupted, subtract that from 1. So 1 minus all the bits are not corrupted, that means this is the probability of symbol error. Is that okay for you or not? Right? So this will be the expression that you don't need to mug up, but you will be able to think. Probability of symbol error is equals to 1 minus probability of bit error to the power n. Okay, a very good concept that we have seen. And to write down the answer of this particular question, you can do it on your own, right? You will be able to do it on your own. Just put p of s equals to 4 by 3 q of 1. From there you find out pb. Answer will be a bit complex. It wouldn't look good. So that's why I am not writing down. But you can solve this question on your own, right? Let's move to the next problem. So this question is based on communication plus COA. I know that you haven't studied COA, so you can solve the communication part. COA part will be on me. I am just telling that to store the alpha byte of data, number of address lines required are log 2 alpha. Byte means 1 byte is equals to 8 bits. That means to store alpha into 8 bits, you need these much of address lines. So forget about this address line part. What is your question? What you need to solve? You need to solve that there are 3 symbols, -2, 0, +2, having the probability of 1 by 6, 1 by 6, 2 by 3. Okay. At the receiver, threshold device is working on map criteria. Noise probability density function is given. You need to find out the probability of symbol error, and then you need to find out probability of bit error. These 2 things you need to find out. Rest of the things I will take care, don't worry. But this part you can do on your own. Which part? Noise PDF is given, symbols are given. At the input, what will be received? Symbol plus noise, right? What will be the input? Input will be symbol plus noise. So input I am representing by R only. R is symbol plus noise. Working on map criteria, that means you will be working on lambda optimum. Output will have some error. So that you need to find out. You need to find out probability of symbol error, and you need to find out probability of a bit error. And both will be minimum only because we are working on lambda optimum. And you know that noise PDF is uniform for -2 as well, for 0 as well, for +2 as well. Okay. So you know that this is a exponential random variable. Exponential random variable only. And this will be a constant value which is -2 or 0 or 2. So can you draw the PDF of R? Can you draw the PDF of R? S1 I am calling as -2. S2 I am calling as 0. And S3 I am calling as +2. So can you draw the PDF of R such that S1 is transmitted? Can you draw the PDF of R such that S2 is transmitted? And can you draw the PDF of R such that S3 is transmitted? Can you draw these PDFs? Once you have drawn these PDFs, can you multiply with their corresponding probabilities? Because you know that probability of S1 transmission is equals to 1 by 6. Probability of S2 transmission is equals to 1 by 6. And probability of S3 transmission is equals to 2 by 3. So multiply with their corresponding probabilities, and then you see where they are cutting. At the point where they are cutting, that would be your lambda optimum, and then you see where is the error. So try doing it on your own. If you are able to do it, then those 4.5 hours of effort that you have already spent on threshold detector, that is fruitful. Otherwise, there is some error in my teaching if you are not able to solve this particular question. Okay, so try doing it on your own. So your input is symbol plus noise. So your input such that S1 is transmitted would be minus 4 plus n. Your input such that S2 is transmitted would be simply n only, and your input such that S3 is transmitted would be, okay, this is minus 2. Minus 2 plus n, 0 plus n, and that would be 2 plus n. So now I know the PDF of this guy. If I need to make the PDF of R such that S1 is transmitted, what will happen? It will be shifted by minus 2, it will be shifted by plus 2, and it will be shifted by 0. Okay, so try doing it on your own. I need to pause the video because someone has come on the door. Then I will come back and I will solve it with you. Yeah, so did you try making the PDF? So let's make the PDF. Actually आज मम्मी का एक पार्सल आएगा, ठीक है? And in our town, whenever the parcel comes, like I have to go to like at least 200 meters far away from me, from my place, to receive that parcel. They will not come to our home. So that's why, like, whenever someone knocks at the door, I feel like that parcel has come. So I have to go. So that's why I post the video. And if the parcel is of your mother, then you know, if you miss it, then you are not going to get the food, right? So probability of R such that, let's make the PDF of R such that S2 is transmitted. So what will be that PDF? That would be simply equals to the noise PDF. So for the positive x, you would see a to the power minus x, and for the negative x, it would be a to the power plus x. I hope you know how to make this graph. So this is how you would make the graph. This much graph making should be clear to you, right? 1 by 2 e to the power 1 by 2. So at x equals to 0, you are getting the value 1 by 2. So this portion is 1 by 2 e to the power minus x, and this portion is 1 by 2 e to the power x. Because at x equals to minus infinity, you will be getting 0. 1 by 2 e to the power minus infinity. So at x equals to minus infinity, you will be getting 0. At x equals to plus infinity, you will be getting 0. So this is the graph. PDF of R such that S2 is transmitted. Now I am making PDF of R such that S1 is transmitted. So now what will happen? The origin will be shifted by minus 2, right? The origin here, this origin, in place of x, what you are going to put? X minus 2. Sorry, not x minus 2. Basically, this is your noise PDF, and this is your PDF of R such that S1 is transmitted. So there, the middle point was occurring at 0. So when your n is taking value 0, your PDF will take value minus 2. Is that okay for you? When your n is taking value 0, if my random variable n is taking value 0, then my random variable r will take value minus 2. So that means my peak of noise was occurring at 0, but the peak of r such that S1 is transmitted, that peak will occur at minus 2. So similar graph will be shifted by minus 2. Similar thing we did here as well, no? In these graphs. So ditto same thing we are doing here. You know that it is linear transformation, and since it is linear transformation, I can just shift the graph. So peak value will be occurring at minus 2. So let's make this as minus 2. But when I need to find out my map criteria, so I need to multiply with probability as well. If I need to find out my lambda optimum, I know that they will be cutting here. So make sure to multiply with the probability as well. Although here the peak value was 1 by 2, but I will multiply with the corresponding probability. What is that? 1 by 6. So PDF of R such that S2 is transmitted, 1 by 2 multiply with the corresponding probability, that will be 1 by 6, right? Here as well I will multiply with the corresponding probability, 1 by 2 into 1 by 6. Now for PDF of R such that S3 is transmitted, so that will be shifted by plus 2. That means it would be starting from somewhere here. But always make sure that you need to multiply with the corresponding probability as well. So peak value will be 1 by 2, but that would be multiplied with 2 by 3. Okay. So 1 by 2 multiply with 1 by 6. If this is the peak point, then this peak point would be somewhat higher. I hope you are understanding how to make these graphs. It is not that difficult, and I hope you are getting how I am writing down the peak values as well. So this is the peak value, 1 by 2 into 2 by 3. Is that okay for you or not? And where the graphs are cutting? The graphs are cutting at this point and at this point. Okay. So graphs are cutting here and here. So sir, it will be the midpoint, minus 1 and 1. Absolutely not. Midpoint, that thing was there for Gaussian random variable. The lambda optimum formula that we got, mu1 plus mu0 divided by 2, that was there for Gaussian only, not for some other kind of PDF. This is exponential PDF, no? So you cannot say, sir, it will be minus 1, it will be plus 1. From the graph, it looks like that, sir, it will be a middle point. No. These are the rough graph, no? Right? So you need to find out where this graph and this graph is cutting and where this graph and this graph is cutting. Can you let me know the equation of this particular graph? Can you write down the equation of this particular graph? So that equation would be e to the 1 by 2 and 1 by 2 into 1 by 6, right? Because I am multiplying with respect to corresponding probability as well. So 1 by 2 into 1 by 6 e to the power minus x plus 2 whole square. Sorry, not whole square, x plus 2, that's it. The equation of this graph will be this one. Do you agree to this point? What was the equation of this graph? Sir, it was 1 by 2 e to the power minus mod x. But since x is positive here, so it would be opening with e to the power minus x. Along with that, I am multiplying with corresponding probability as well. So multiply with 1 by 6 e to the power minus x. Now what is this graph? This graph is this graph only, but shifted by 2. And it is left shifted by 2. If it is left shifted by 2, that means plus sign would come, no? If you know the graph of u of t, what will be the graph of u of t plus 2? So ut is this, u of t plus 2 will be shifted by plus 2. Shifted by plus 2, but in the left hand side. That means it will be starting from minus 2. Basically, here the peak is occurring at 0. And here the peak will occur at minus 2. Just put minus 2 here. Minus 2 plus 0. Sorry, minus 2 plus 2. What that would be? 0. E to the power 0 will be 1. So peak will be occurring at minus 2. So this particular point at x equals to minus 2, if you are putting minus 2 plus 2 would be 0. So what you are getting 1 by 2 into 1 by 6. Right? So equation of this particular graph will be 1 by 12 e to the power minus x plus 2. And when you go to infinity at x equals to infinity, what you are getting? E to the power minus infinity is 0. So yes, this graph is fine. So equation of this graph is 1 by 2 into 1 by 6 e to the power minus x plus 2. Is that okay for you? What will be the equation of this particular graph? Which graph? Equation of this graph. That would be, sir, 1 by 2 into 2 by 3. 1 by 2 into 2 by 3 e to the power x minus 2. At x equals to 2, what you will get? 1 by 2 into 2 by 3. Now at x equals to minus infinity, at x equals to minus infinity, it should be equals to 0. Yes, when you put e to the power minus infinity, it would be equals to 0. How did I get it? Because I know the equation of this graph. What is the equation of this graph? So the equation of this graph was 1 by 2 into 1 by 6. I am writing it down again. Now I am writing down the equation of this graph. So this graph was having the equation of 1 by 2 into 1 by 6 e to the power minus of mod of x. But since x is negative, so x will open with minus x. How do you open the mode? When x is negative, it will be opening with minus x, right? When your x is negative. So it would be 1 by 2 e to the power plus x. So this graph was 1 by 2 into 1 by 6 e to the power plus x. Now this particular portion is shifted by 2 and it is right shifted, and since it is right shifted, I will do -2. This much basics of signal system you know, right? This is nothing but mathematics. Communication has ended here. Just as you have drawn this graph, communication has ended. Now you need to find out the cutting point. That means you would require this equation, you would require this equation. Then you would equate both of them. Basically, this equation will be equated to this guy, and then this equation will be equated to this guy, and then you can find out the intersecting point. Intersecting points. Is that okay for you or not? I hope it is okay for you. Okay, done. So what we are doing, we will equate this equation with this equation. So 1 by 2 into 1 by 6 a to the power minus x plus 2, 1 by 2 into 1 by 6 a to the power x. Okay, you solve the equations, then I will come back. Finally the order has arrived. Okay, solve the equations. Yeah, so when you solve this equation, what you will be getting? X equals to -1, right? So basically this point is -1, this point is -1. Okay, now we need to solve this equation. That means we will equate this line equation with this line equation. So this is our first lambda optimum, you can say. This is lambda optimum only. Lambda optimum 1 I am saying. Another one would be 1 by 2 into 1 by 6 e to the power minus x, right? 1 by 2 into 1 by 6 e to the power minus x. 1 by 2 into 2 by 3. 1 by 2 into 2 by 3 e to the power x minus 2. So what you will be getting? 1 by 2, 1 by 2 will get cancelled out. 3 by 2 into 6, 1 by 4, 3 by 12, 1 by 4 e to the power 2x minus 2. So 2x minus 2 should be equals to minus ln 4. So 2 minus ln 4 divided by 2. That would be 0.3. So this is your another lambda optimum, right? This would be your second lambda optimum. This would be 0.3. This point would be 0.2. Let's check back the calculation again. 1 by 2, 1 by 2, 3 by 1 by 4, ln 4, ln 4, 2x minus 2. Okay, so 2 minus ln 4, 4 ln plus minus plus 2 minus ln 4 divided by 2, 0.3. So this value is 0.3. Now I am writing down probability of symbol error. Without writing down any definition, I will just write down the final answer. Map criteria, I will work on this curve. Till this point there is no issue, but just as I work here, the result will be made in terms of till this point the result will be there in the favor of S1. From here to here the result will be in favor of S2, and from here to here the result will be there in the favor of S3. So if I am working on the graph of S1, till this point there is no issue, but from here onwards the issue will start happening. So this will be the error, right? That means the equation of this graph is 1 by 2 into 1 by 6 e to the power minus x plus 2 integrating from -1 to infinity. Okay, when you are integrating from -1 to infinity, so 1 by 12 e to the power minus x plus 2 dot dx plus, if I work on this graph, till this point there is no issue, but from here onwards there is an issue, right? The issue is this particular portion and this particular portion. So these are the issue. That means 1 by 2 into 1 by 6 e to the power x from minus infinity to -1, minus infinity to -1, 1 by 12 e to the power x dot dx plus from 0.3 to infinity, from 0.3 to infinity, I am multiplying with the corresponding probability as well, right? That's why this 1 by 2 into 1 by 6. So 1 by 2 into 1 by 6, 1 by 12 e to the power minus x. So 1 by 12 e to the power minus x dot dx plus, if I work on this curve till this point there is no issue, basically till this particular point there is no issue, but here the issue will start taking place. So this will be start taking place. What is the equation of this line? 1 by 3, 2 and 2 will get cancelled out, 1 by 3 e to the power x minus 2 dot dx, and the issue is there between minus infinity to 0.3, minus infinity to 0.3. So you just need to solve this integration and your job is done. Is that okay for you what we are doing? Is this line clear to you? Without even doing any write down of without even writing down any equation of probability of symbol error, just by simple analysis I have understood what is actually happening here. From minus 1 to infinity in this curve there is an issue, 1 by 12 e to the power, 1 by 12 e to the power minus x minus 2. Okay, then where is the issue? The issue is in this curve from minus infinity to minus 1, 1 by 12 e to the power x, then from 0.3 to infinity 1 by 12 e to the power minus x, then from minus infinity to 0.3 1 by 3 e to the power x minus 2, then there is an issue. Okay, so what you are getting? 1 by 12 e to the power minus 2. Okay, 1 by 12 e to the power minus 2. So this will be e to the power minus x. Then you integrate it, you will get e to the power minus x only, and negative sign will also come. So that's why I can interchange the limit. I hope you are understanding what I am doing. And when you put the limit, it would become e to the power 1. So basically you can solve it, you will get e to the power 1. Okay, very simple integration is there. E to the power minus x from minus 1 to infinity. So e to the power minus infinity will be 0, e to the power minus of minus 1 would be e to the power 1 plus 1 by 12 e to the power x from minus infinity to minus 1, right, from minus infinity to minus 1. So I will put the limit, e to the power minus 1 would be e to the power minus 1 only, and e to the power minus infinity will be 0 only. So 1 by 12 e to the power minus 1 plus 1 by 12 e to the power minus 0.3. You can solve it on your own. E to the power minus x, then the limit will be from 0.3 to infinity, but negative sign would come, so infinity to 0.3. So e to the power minus 0.3, right, and plus 1 by 3 e to the power minus 2 will be outside, and in the bracket e to the power x would come, and that would be e to the power 0.3. So what you are getting? E to the power minus 1, e to the power minus 1, e to the power minus 0.3. So 1 by 12, 2 into e to the power minus 1 plus e to the power minus 0.3 plus 1 by 3 e to the power minus 1.7. So now you can solve this and you will get the final answer, probability of symbol error. So I will solve it. Into 2 plus divided by 12, 0.123 plus 1 by 3 e to the power minus 1.7 plus 0.123, 0.183. So final answer is coming out to be 0.183. So this is your probability of a symbol error. So what will be your probability of bit error? Probability of bit error would be, what I need to find out? Probability of bit error I need to find out. So probability of a bit error would be probability of symbol error 1 minus probability of bit error whole square. How did this come? You already know, right? So this will be reduced to 2 pb minus pb square 0.183. So pb square minus 2 pb plus 0.183 is equals to 0. So pb would be equals to minus b plus minus under root b square minus 4AC divided by 2A. Okay, so into 4 plus minus plus 4 under root. Now this particular thing is coming out to be 1.8. So can you say that, sir, it could be 2 plus 1.8 divided by 2? No, minus sign would be there, no? Because if I do 2 plus 1.8 divided by 2, then the probability will be greater than 1, which is not possible. So that's why I need to use the negative sign, right? So it would be 2 minus 1.8 divided by 2. So minus 2 divided by 2. So 0.0996. So this is your probability of a bit error, that is coming out to be 0.096. Why I did so? So till this point your communication system has ended. Now what this question is saying? This question is saying that this discrete memorial as source is transmitting 20 kilo symbols per second. Okay, what it is doing? It is transmitting 20 kilo symbols per second. So in 1 second it is transmitting 20 kilo symbols, and each symbol will have how many bits? Since there are 3 symbols, so each symbol will have 2 bits. Each symbol will have 2 bits. So 20 kilo into 2 bits, that means it will have 40 kilo bits. This much bits it is having. Okay, now all the bits are not corrected. Some bits are corrupted as well. How many bits are corrupted? 0.096. That means how many percentage? 9.6% bits are corrupted. 0.096 is the probability. If you multiply by 100, what you will get? 9.6% bits are corrupted. Right? This is what it is saying. So now what they are saying? Where each symbol is represented by 2 bits, the device operates continuously for an hour. So in 1 second, it is transmitting this much of bits. 1 hour means 3060 seconds. So how many bits it is transmitting? 40 into 10 to the power 3 into these many bits per second, right? So now this much bits it is transmitting. In 1 hour, this much bits has been transmitted. Okay. Now minimum number of address lines required to store all the corrected symbols. All the corrected symbols. So they are talking about symbols, not bits. So needlessly I am converting into the bits. Don't convert into the bits. They are talking about the symbols only. So 20 kilo symbols are there per second. Okay. So in 1 hour, 3600 seconds are there. That means in 1 hour, how many symbols would be there? These many symbols would be there, right? Symbols per second into second. So second and second will get cancelled out. So 72, 2 into 10 to the power 4, 72. So 72 into 10 to the power 6 symbols would be there, right? 72 into 10 to the power 6. Yeah, so these many symbols would be there. In 1 hour, these many symbols would be there. Now I need to store these symbols. So how many address lines would be required? Now I know that to store alpha byte of data required these many address lines. So now these many symbols I am having, but out of these symbols, how many symbols are corrected? So I am writing down corrected symbols. So total symbols are this much, and corrected symbols would be 1 minus 0.183. No, these many symbols will be corrected. Corrected, not corrupted. Basically, out of these symbols, 72 into 10 to the power 6 into 0.183 will be the corrupted symbols. But I am talking about the corrected symbols. So these many symbols will be corrected. No, so 1 minus 0.183 into 72. So 58.824. 58.824 into 10 to the power 6 symbols. These many symbols are corrected symbols. That means how many corrected bits would be there? Each symbol is having 2 bits. Each symbol is having 2 bits. So how many corrected bits would be there? How many corrected bits would be there? So 58.824 into 10 to the power 6 into 2. These many bits would be there. Right? Now in these many bits, how many bytes would be there? Divided by 8. 58.824 into 10 to the power 2, sorry, into 10 to the power 6 multiply with 2 divided by 8. Divided by 8. These many bytes are there. Look, if you have solved till this point that you have find out probability of bit error, you can drop this question. If you are not interested in COA, okay? If you are not interested in COA, you can drop this question. So directly we are getting these many bytes. That means we are having 14.706 into 10 to the power 6 byte. So these many bytes we are having, corrected bytes. Corrected bytes. These many bytes we are having. And now I need to store these many bytes. What you need to do? You need to store these bytes. So how many address lines will be required? Address lines required. How many address lines will be required? So that would be log 2 14.706 into 10 to the power 6. Okay. So now what you need to do? You need to take log 2. So answer is coming out to be 24. So 24 address lines would be required. That's the answer. Although these are also good questions that you will need to find out probability of symbol error and probability of bit error. Now you can see one thing that here probability of bit error is approximately half only. Because the value is very low, no? What I mean to say is that PS is equals to 2PB minus PB square. Now I know that PB will be very low. Looking at the PS value, I can sense that PB will be very low. That means PB square will be even lower. PB is 0.096. So if you do the square, it will be even lower. That means this I can neglect. So what is my PB coming out to be? PS by 2. So if your symbol error is coming very low, that means you would know that PB would come more lower. And if PB is coming more lower, that means PB square could be neglected. So PS would be approximately equals to 2PB. But in the examination, if I want to frame a good problem, I will make this value large enough. Because those who are not thinking straight, what they would do? Probability of symbol error. Okay, each symbol is taking 2 bits. So directly PS by 2. And their answer would also match if your PS value is low. But I will try to make the symbol error somewhat larger. That means I will try to make symbol error equals to 0.6. If I had made symbol error equals to 0.6 and I ask you what will be the bit error, then what would be the answer? 0.3? No. Then you have to solve this equation and the answer would be different. So in the examination, if I want to frame a good question, I will make sure that PB equals to PS by 2, this formula is not applicable because this is just a limiting case. Actual formula is this one. This is the actual formula. But since PB was very low, still we got the answer PS by 2 only. But that is only the limiting case. And did you understand after this analysis? After this analysis, the knowledge of COA is required, computer organization. If you don't have that knowledge, still it is fine. But very simple thing that in 1 second, these many symbols are transmitted. So in 1 hour, these many symbols would be transmitted. Now all the symbols are not corrected. Some symbols are corrupted as well. How many symbols are corrupted? 0.183, right? So how many corrected symbol would be there? Corrupted and corrected. So I am talking about corrected symbols. So 1 minus 0.183 into 72 into 10 to the power 6. These many corrected symbols are there, right? And to store one symbol, how many bits are required? 2 bits are required. So how many bytes would be required? These many bytes would be required. And now to store 1 byte, how many address lines are required? So these many address lines are required. Log 2 alpha, value of alpha is this much, answer would be 24. So 24 address lines would be required. A very good question. Okay. Now this was asked in 2025. This should be solved. You have to solve this particular problem. If you are not able to solve it, then I am needlessly wasting my time. You should be considering some other resource of study if you are not able to solve this particular question. That means there is something wrong in my teaching. I am not talking about you. You might be a good student, but if you are not able to solve this particular question, that means there is something wrong in my teaching. What would be the value of alpha? Okay, as far as I remember, answer was 4/3, but I am not pretty sure. Let's check that. What you need to find? Probability of symbol error. Again they asked probability of symbol error. I was expecting they would ask probability of bit error, because I am teaching from 2024 onwards only. So I was thinking that in 2025 probability of bit error would come, but again they asked probability of symbol error. Okay, so someday my wish will be completed. In place of symbol, bit would be written. Probability of bit estimation error. This is what they will write someday. Okay, so three symbols are there: S1 -2, S0 0, sorry, S2 0, and S3 +2. Noise is Gaussian, 0 mean Gaussian. They did not give the variance value, but noise is Gaussian. Okay, with 0 mean. Input is y equals to s plus n. If it is Gaussian, then this will also be Gaussian. And y such that s1 is transmitted will have the same variance y such that s2 is transmitted and y such that s3 is transmitted. All of them will have the same variance. Why so? Because noise is same, no? But their mean would be different. -2 is transmitted, so mean of y such that s1 is transmitted, that would be -2. Mean of y such that s2 is transmitted, that would be 0. And mean of y such that s3 is transmitted, that would be 2. But the variance would be same, and that variance I am putting as sigma square. So can I draw the PDF of y such that s1 is transmitted, PDF of y such that s2 is transmitted, and PDF of y such that s3 is transmitted? Can I draw that? Yes, I will draw it, and I will multiply with the corresponding probability, and ML detector is there. Maximum likelihood decoder is there. That means ML decoder is there, so I can multiply with the corresponding probabilities. So this kind of graph I will be getting, right? This is your PDF of y such that s2 is transmitted, PDF of y such that s1 is transmitted, PDF of y such that s3 is transmitted. Multiply with their corresponding probability. You can multiply with their corresponding probabilities, whatever it is. You will get the peak value as same only, because what will be the peak value? Peak value will be 1 upon under root 2 pi sigma square. What is the value of sigma square? Sigma square only. And their probabilities will be 1/3. So peak value will be 1/3 into under root 2 pi sigma square, right? So this peak value will be 1/3 under root 2 pi sigma square. So forget about it. Let's not write down the peak value. Now it is working on ML detector, and what will be the midpoint? Where they will be cutting? Where these graphs will be cutting? Probabilities are same. Sigma value is same. That means it would be right in between. This PDF is same, sigma is same, probabilities are also same. So what will be this point? Right in the middle, no? Mean of 0 and 2, that would be 1. Mu1 plus mu0 divided by 2. 2 plus 0 divided by 2. -2 plus 0 divided by 2. -1. Okay? So now where will be the issue? Till this point, symbol S1 will be accepted. From here to here, S2 will be accepted. And from here to here, S3 will be accepted. So here there will be an issue. And if you work on this curve, then here there will not be any issue, but here there will be an issue. And here also there will be an issue. And if you work on this curve, so till this point there will not be any issue, but here there will be an issue. Okay. So what will be your probability of error? Probability of S1 transmission multiply with probability of receiving any other symbol such that S1 is transmitted. So what that would be? Sir, Q of probability greater than -1. So Q of -1 minus mean divided by sigma plus 1/3 probability of S2 transmission multiply with probability such that any other symbol is received. That means greater than 1, probability such that x is greater than 1. So that would be 1 minus mu divided by sigma plus mu minus sigma. What is mu? P of x greater than a, that is q of a minus mu upon sigma. P of x less than a, q of mu minus a upon sigma. What is the value of mu? 0. A, x less than minus 1, x less than minus 1. So where is the issue? Here is the issue, x less than minus 1. So plus 1 upon sigma. 0 minus of minus 1, that would become plus 1, right? And here x less than 1. So what will be the answer? 1 by 3 q of x less than 1. So less than 1 means first I will write down mean, then I will write down the value divided by sigma. So this is coming out to be 1 by sigma, 1 by sigma, 1 by sigma. So total answer is coming out to be, this is your probability of symbol error, that is coming out to be 4 by 3 q of 1 by sigma. Okay, so this is the answer that is coming out to be, but they have given the answer equivalent to what? Alpha probability of n greater than 1. So probability says that n is taking value greater than 1. What that would be? Q of 1 minus, what is the mean? Mean is 0. N is Gaussian random variable here. N is the Gaussian random variable having mean of 0 and variance of sigma square. So 1 minus mean of 0, variance of sigma square. So Q of 1 by sigma. So this could be written as 4 by 3 probability of n greater than 1. And if you compare, what is the value of alpha? Value of alpha is 4 by 3. Value of alpha is 4 by 3. So answer is 4 by 3. So just as I would have made the graph, I would get the answer. Just as I make the graph, I would get the answer. How, sir? Because I know that graph is completely symmetric, 1, 2, 3, 4. And these kind of problems I would have surely solved. Because in 2024 as well, no, this kind of question has been asked. Similar answer you were getting, 4 by 3 q of 1. Here sigma value was 1. Ditto same question came. Ditto same question came. It is ditto the same problem. So just after making the graph, I could have written down this particular analysis and I would have get the answer. Alpha would be equals to 4 by 3. Okay, very simple. No formula, nothing. Very simple, very straightforward solution. Let's go to the last question. So this was asked in 2020. A very good question. Try solving it on your own. And important line is this one. What is the meaning of this pi? So rest all the things you will be able to understand. 4 symbols are there, minus 3, minus 1, plus 2. Symmetricity is gone. Minus 3, minus 1, plus 1, yes sir, symmetricity is there. But minus 3 and plus 2, symmetricity is disturbed now, right? Working on ML criteria? Yes, working on ML criteria. That means all the probabilities are 1 by 4, 1 by 4, 1 by 4. Noise is normally distributed, 0 mean and unit variance. Independent of S. What is PI? PI denotes the conditional probability of symbol error for the ML decoding when transmitted symbol is S equals to SI. What does that mean? So PI is denoting, PI is probability of error such that SI is transmitted. What does that mean? Let's just say P1. What will be a P1? Probability of error such that S1 is transmitted. What does that mean? Probability of error such that S1 is transmitted. What does that mean? That means probability of receiving S2, S3 or S4 such that S1 is transmitted. So can you let me know what is P1? P1 is probability of not receiving S1 such that S1 is transmitted. such that S1 is transmitted. What will be your P2? Probability of not receiving S2 such that S2 is transmitted. S2 is transmitted. And so on, you can write down P3 as well and P4 as well. So we need to find out this particular thing. And we already know probability of S1 transmission, S2 transmission, S3 transmission, S4 transmission. So they are not asking probability of symbol error. They are asking probability of conditional symbol error. So Pi is representing probability of error such that Si is transmitted. That means if you are transmitting S1 symbol, then when you can have the error? When you receive S2 or S3 or S4. That means S1 being transmitted but received symbol is S2 or S3 or S4. This is what you need to find out. So let's make the graph. Will you be able to make the graph? Surely, sir. Y is equals to S plus W. Symbols are -3, -1, +1, +2. Mean is 0. So now Y such that S3 is transmitted. Sorry, Y such that S1 is transmitted, mean will be -3. Y such that S2 is transmitted, mean will be -1. Y such that S3 is transmitted, mean will be +1. And Y such that S4 is transmitted, mean will be +2. So you will be having 4 Gaussian PDFs. One is having a mean of -3, other one will be having a mean of -1. Next one will be having a mean of +1, and next one will be having a mean of +2, right? So this mean will be -3, -1, +1, +2. So let's make the means -3, -1, +1 and +2. All are having the same variance. Variance is 1, 1, 1, 1 only. All are having the same variance 1, 1, 1 only. So -3, -1, +1 and +2. Now let me know if ML detector is there, what will be this point, what will be this point, and what will be this point. So this point will be -2, this point would be 0, and this point would be 1.5. So now can you find out P1? P1 is probability of not receiving S1 such that S1 is transmitted. Not receiving S1 such that S1 is transmitted. So till this point the decision will be made in favor of S1. Till this point decision will be made in favor of S2. Till this point decision will be made in favor of S3, and till this point decision will be made in favor of S4. Or did I write it down opposite? S1, S2, S3, S4. So where will be the issue? Here will be the issue. That means probability of x greater than -2. What that would be? X greater than -2. So -2 with the mean of -3 divided by sigma. Answer would be Q of 1. P2 not receiving S2 such that S2 is transmitted. So here there will be two issues. Till this point there is no issue, but there would be issue here. Let me make a different way of sign. There will be issue here and there will be issue here as well. Not looking good. There will be issue here and there will be issue here. So probability of x greater than 0 with the mean of -1. So that would be x greater than 0. Greater than 0. So 0 minus mean would be 1 divided by sigma. So 0 minus of -1 divided by sigma plus q of x less than -2. X less than -2, right? Less than -2. That means first mean would come. So -1 plus 2. -1 plus 2 divided by sigma. Sigma is 1 only. So what you are getting? So here also Q of 1, Q of 1, 2 Q of 1. You should be able to write down all these things on your own, right? Probability of x less than minus 2. Less than minus 2, that means first mean would come. Mean minus the value, that is minus 2. So minus 1 minus of minus 2, that would be minus 1 plus 2. 1 divided by sigma, that would be 1 only. So you should be able to write down all these things on your own. What will be P3? P3 will be not receiving S3 such that S3 is transmitted. So where will be the problems? Problem will be in S3, this much will not be any issue, but here there will be an issue, and here also there will be an issue. So x less than 0, x greater than 1.5. So x greater than 1.5 I can easily write down. So 1.5 minus 1, 0.5 divided by 1 plus q of 1 minus 0 divided by 1. So q of 0.5 and q of 1. What will be P4? Not receiving S4 such that S4 is transmitted. That would be this issue, right? Because till this point there is no issue, but here there would be an issue. X less than 0.5. So 2 minus 1.5. So that would be 0.5. So you know that these guys are gone. What you need to find out? The index I for which conditional error probability is highest. So you need to find out the value of I. That means which value is highest. P1 is highest, P2 is highest, P3 is highest, or P4 is highest. What do you think, which one is highest? Do you remember the Q function? Q of x decreases when x increases. That means if x increases, Q of x decreases. Do you remember the graph? The graph goes like this, from minus infinity to plus infinity, right? You remember the graph, right? Graph goes like this, from 1 to 0. So if x increases, then Q of x decreases. Now you know one thing, that this value is double of this one. That means this will be surely low. Let's just say Q of 1 was 0.2. Q of 1 was 0.2. So this will be 0.4. That means P2 is surely greater than P1. P2 is surely greater than P1. So P1 is gone. And Q of 0.5. Q of 0.5 and Q of 0.5 added with Q of 1. Let's just say Q of 1 was 0.2. So Q of 0.5 would have been, let's just say 0.4. I am just taking any approximate value. So if this was 0.4, then this would have been 0.6. So this guy is also gone. From here also you could have understood that your P4 is lesser than P3. And now Q of 1 and Q of 0.5. 0.5 is lesser. That means this value will be larger. So P4 would be greater than P1. Are you able to understand this point? 0.5 is lesser, x is less. That means this value will be larger. You remember the graph, no? This kind of graph you will be getting. At 0 the value was 0.5. So at 0.5 some value you would get, at 1 some value you would get. So Q of 1 would be lesser, Q of 0.5 would be larger. So from here you could have understood that P4 is greater than P1. Now what is the relation between P2 and P3? 2 of Q1. So this is basically Q of 1 plus Q of 1. Q of 1 plus Q of 1. Now you know that this guy and this guy is same. But Q of 0.5 is larger. Q of 0.5 is larger than Q1. What does that mean? This guy is larger. So this total summation will also be larger. That means P3 is larger than P1. Did you understand this point or not? So these relations I can get. Sir, what will be the relation between P4 and P2? You cannot tell actually. What will be the relation between P4 and P2? You cannot tell. Sir, which will be larger? I cannot tell. Because I don't know the value of Q1, no? Are you able to understand how I am comparing? P3 will be the largest one. Now what will come at the second? I cannot tell. At the second, P2 can also come, P4 can also come. I am not sure. But I was confused between P2 and P3. I know that P3 is greater than P4 for sure. and P4 is greater than P1, that means P3 will be greater than P1 as well. Why P3 is greater than P4? Because this is Q of 0.5 added with something more. That means P3 will be greater than P4. And P4 is already greater than P1. Why so? Because X value is greater here, that means Q of X would be lower. So this relation I already know, that P3 is greater than P4 is greater than P1. Now I need to find out the relation between P3 and P2. So P3 is greater than P2 as well. And I know that P2 is greater than P1 as well. P2 is greater than P1 as well. But I don't know what is the relation between P2 and P4. Why P3 is greater than P2? Q of 1 is same. This value and this value. So this value is larger. That means this value is lower. So this summation will be lower. That means this addition will be larger. So P3 is the highest. So value of I is equals to 3. That's it. This is the answer. So these two relations you can tell, but you cannot tell the relation between P2 and P4. P1 will be the lowest, P3 will be the highest, but I cannot tell the relation between P2 and P4. Which one will be larger, I don't know. So you can get the value of Q of 0.5, you can get the value of 2Q of 1, and then you can comment. Okay. So I need the values, then only I will be able to comment. As of now, I don't know. 2Q of 1 would be larger or Q of 0.5 would be larger, I don't know. But these relations I have got. And if I need to find out the probability of error, what would be the answer? Answer would have been, sir, 1 by 4 Q of 1 plus 1 by 4 into 2Q of 1 plus 1 by 4 Q of 0.5 Q of 1 plus 1 by 4 Q of 0.5. That would be the probability of error, probability of symbol error. So you can solve it, you can get the value of probability of symbol error as well. So very simple question, not very simple, like when it came it was a tougher question only, but as of now we know all the concept. We know what is P1 is saying, what is the meaning of P1, P2, P3, and then we know how to make this graph, and then we know how to find out the corresponding probabilities, and we will be able to solve these kind of problems. Look, this particular topic is considered as one of the toughest topic of whole electronics and communication engineering. Basically in the question paper, if these kind of questions are coming, people will be dropping it. But we have built up the concept in a very good manner because we did not focus much on theory. We focused more on problem solving. A lot of questions we have solved. Whatever the kind of problem they wanted to ask, they will ask from here only. So we have solved a lot of problems. Now this particular topic is completed. Our next target would be, we have completed basic digital communication system, sampling we have completed, quantization we have completed, and threshold detector we have completed. Right? Next would be receiving filter, but before that we will introduce another topic. So here we are going to discuss digital communication technique, baseband and bandpass. In the first lecture I told you there would be two kind of transmission, baseband and bandpass. So we are going to see the techniques. We have seen PCM technique, right? Pulse code modulation. Similarly, there is PAM, pulse amplitude modulation, and then when we go to bandpass signaling, so there we have BASK, BPSK, BFSK, QAM. These modulation technique you can say, or these bandpass communication technique we are having. So whatever the communication techniques we are having, that we are going to see in the next lecture, and after that we will move to receiving filters. Okay, because whatever that we have studied till now, from here to here, till this point, did I ever say that we are using baseband communication or bandpass communication? No, I did not even take the name of baseband communication. I did not even take the name of bandpass communication system. Right? In the last 3 lectures, did we take the name of baseband or bandpass? No. For both of them, the analysis will be same. But here, analysis will be same only, but expressions will be different. So that's why first we need to discuss the baseband communication, bandpass communication, and then we will move to this particular chapter. Okay, analysis would be same only. In this topic as well, analysis would be same, just the expression would be different. But when the question is coming from these topics, they will not even mention whether you are talking about baseband communication or bandpass communication, because we are talking about the input of the threshold, or we are talking about quantization. So their baseband and bandpass both are similar only. So this topic is done. Threshold detector, we spent roughly around 5.5 hours. I hope you enjoyed this topic. Next we are going to study about some communication technique, and then we will move to receiving filters. Okay, yeah, thank you very much. Happy learning. Let's meet in the next lecture.